Hello friends, hope you are having a fantastic day today. This is going to be a 50-hour long course that contains everything there is to know about technical interviews, data structures and algorithms. There are about 20 concepts that I have created that comprise the entirety of technical interviews, and that contains different data structures, different algorithms and different coding patterns. We are going to cover each and every one in very much detail. We will understand the concept for them, and then we would solve lots and lots of interview problems associated with that. By the end of this course, you would have solved close to 200 most asked, most liked and most popular interview problems, and you would be able to solve majority of technical interview problems out there, and then it's just a matter of sheer practice that you will have to do on your part. I can guarantee you that this is going to be a very high quality in-depth course where it is completely beginner friendly, and we will go deeper and deeper into the most advanced topics, and I will try to explain it in as much detail as I can, so you can be absolutely prepared for anything to come in your technical interviews. Now a quick introduction about myself. My name is Parth Vyas and I have bachelor's and master's in computer science. I have been in the IT industry for close to 10 years now, and I have worked at companies like Microsoft, RBC, Nokia, and currently working as a solutions architect for Cineplex. I have joined my career as a junior developer and have gone through multiple transitions. I have been absolutely blessed by a lot of important mentors who have guided me correctly in my career, and this is something me giving back to the community. Now, I also run my own YouTube channel named Destination FAANG, and I would highly encourage you if you can go and support me on that channel as well. I teach about how you can go ahead in your career and how you can ace your technical interviews, behavioral interviews and system design interviews, and your support matters a lot for me, so it can motivate me to keep making more videos like this. On top of it, you can stay up to date on the latest and greatest things that I'm currently working on. Few fun facts about me: I love going on hikes, I love watching movies, and I love playing with my twin daughters. I am based in Canada, and this is a beautiful country, so if you get a chance to visit, please come and see it anytime. Now, I would not deviate from the main topic, that why we are here. So without any delay, let's get started. Now, what is DSA? DSA stands for data structure and algorithm. Now, everything in computers is made out of data. These are the bits and pieces of zeros and ones that hold all the information. It can be a text or a book or a PDF or the video you are watching. Anything can be represented as data, and the way we store and organize the data is referred to as data structures. Now, there are many different ways of storing data. You can store them in a straight fixed given format that can be defined as array. You can have one bit of data live over here, next live over here, and after one the next lives over here, but this guy does not know where this guy exists, and that's an example of linked list. And there are bunch of other different ways to understanding different data structures. Now, there are linear data structures, non-linear data structure, hierarchical data structures, hash based data structures, and they all have different purposes, which we will learn more in the classification of data structures. Now, let's understand that what is algorithm. Algorithm is nothing but following step by step to complete certain procedure and achieve an expected outcome. Now, this can be anything. If we strictly talk about from the perspective of computer science, there are algorithms that do certain things really well, like sorting items, searching any particular item in the existing given data structure, recursion, dynamic programming, greedy approach, divide and conquer, and these are all the strategies that we typically use in our day-to-day operations as well. We just don't realize that these are algorithms. And then there is the combination of data structure algorithms that help us solve many complicated problems. So that's why the companies that are substantially large in the IT industry, these are the FAANG companies or top tier IT companies, they usually build products that scale up to millions and billions of users, and they want to have the most efficient, most optimal approach to any given problem. And that's why they love asking these questions to understand the technical prowess and proficiency of any candidate, and that's where you need to be learning about these things. Now, how does a solution can be defined as optimal? Well, there are two things that defines that, and that is called space complexity and time complexity, and they are usually referred by big O notation. Now, we will understand the full theory on that in one of the sections, but how does companies typically evaluate your solution? They are looking for number one, whether you can reach to the optimal solution or not. That's a basic criteria, but that is not just the only criteria. Now, in a typical interview process, you are expected to go through somewhere between 3 to 5 rounds of technical interviews. each lasting about 45 minutes to 1 hour, and for each of the interview you are expected to solve anywhere between 2 to 3 medium to hard DSA problems. Now you are being judged based on your thinking abilities, your communication, whether you are a good person to work with. Can you think of different scenarios, different edge cases? Are you able to come up with the optimal solution? What does your approach looks like? If you have a suboptimal solution, can you reach to that optimal solution? Can you ask for proper hints? Can you convince your recruiter or interviewer about your solution? Can you walk through it? Can you code it out? And you know, the complicated part is they typically don't give you a full IDE or editor. They typically ask you to solve this problem on a whiteboard if it's in person, or on a Google Doc if that's going to be a virtual interview. So that's why there are a combination of skills that you will have to accumulate throughout this course and your preparation journey to be able to clear multiple different technical interviews. And we will learn that in the next section. Now, how do we even judge an algorithm? Well, there are three things that we are looking for. First one is the accuracy of algorithm. That is quite straightforward, that if I expect my algorithm to generate pizza or find the shortest number out of all of these given numbers, if it is exactly doing that, which means my algorithm is accurate, and it needs to do that for all the different edge cases and all the different scenarios. Second thing is time complexity, and third thing is space complexity. So first let's understand that what is time complexity through an example by these deck of cards. Time complexity is nothing but how much longer will it take for you to complete your algorithm or your task if the number of inputs keeps on growing larger and larger and larger. Let's try to understand that currently I have these deck of cards and they are currently just randomized. If I lay them flat on a table, and let's say that for simplicity I'm trying to figure out that where does heart of 6 lies amongst these cards. Now I don't know, but I can keep on opening all the different cards randomly until eventually I found out to a card that is heart of 6, and notice that I found heart of 6 right here. But how many cards did it took me to find this value? It's just like finding a needle in a haystack. You need to go one by one, and if I had like million cards and all different unique entries, it might take me like million attempts before I reach to the card that I'm particularly looking forward. So in this case, we can notice that the time it takes for me to complete the expected task increases linearly with the increase in the number of inputs. So we can call this time complexity of big O of n. Now big O is the definition or a way we write the time complexity and space complexity, and we are going to talk all about that in a separate topic. But now let's just say focus towards this. Now let's see that how does time complexity change based off of how we have our data being scattered or how we change our algorithm. Let's take an example. Now in this case, we are going to sort all of these cards in ascending order, and then we are going to lay them flat once again on our card. So this is going to be the smallest value, and then we are going to keep on adding all of these values on this table. Now notice that in this scenario, once again we are trying to find that where does heart of 7 is present in this deck of cards. Now I don't know, I can't see them, but I know for a fact that this one is the smallest value, this one is the largest value, and if heart of 7 is present, let me just open the middle value. So middle value is heart of 6. So I know for a fact that all of these cards are definitely going to be smaller than 6 because it's already sorted. So I don't even need to look at these cards. I can ignore all these 4 cards, and then I only worry about these 3 cards. Once again, I'm going to open the middle card, and this one is heart of 8. Now I know because this is sorted, so these two values are always going to be greater than heart of 7. So this card has to be heart of 7, the lucky card, and that is what we currently have on our table. Now notice that once again we had again 8 or 9 cards, but we only needed to open 3 cards in order to find the card that we were looking for. This one is an example of logarithmic n time complexity. Why it's logarithmic n? Because with every single task or every single step we make, we are essentially eliminating 50% of all the inputs in one go. So here we eliminated 4 cards, then from the remaining 3 we eliminated 2 more cards. If we had million cards, in just one opening of a card, we would have eliminated 500,000 cards. In the second opening, we would have eliminated remaining 250,000 cards. So even if we have like 10 million cards, we can very quickly find the value that we are looking for, and that is an example of big O of log n time complexity. Now let's talk about some other time complexities and other examples. Now the most basic time complexity is a constant time complexity. Constant time complexity means that if it takes us, let's say, 1 second to do a one job for 10 inputs, it will once again take us like 1 second even if we had 100,000 inputs. What's an example of that? Let's presume that we currently have this ice tray where we have bunch of different black chickpea beans associated with that, and they are currently placed in a sorted array in a sorted bucket, and for each number it corresponds to total number of chickpeas being present. So like this one is first one, so it only has one chickpea. This one is second one, it has two chickpeas. Now in this case, if I have to figure out that show me 5 chickpeas, let's say that that is what I want from my algorithm, I can very quickly say that this fifth number is going to contain 5 chickpeas. So I can quickly take them out and then start counting that there are going to be 5 chickpeas in my hand. Now, even if I had million of these, and presumably I have like hands longer that can reach up to all of these million associates, I can very quickly find any number of chickpeas I want from this given example. So this would be a scenario where the time complexity is going to remain constant. Next one is logarithmic time complexity that we already saw an example using the sorted cards. And next we also saw an example of big O of n time complexity where the time increases linearly with the given input size. Now let's talk about big O of n square time complexity. Now for this n square time complexity, let's presume that we currently have these two decks present. What we are going to do is we are going to find a card from this deck, and this corresponds to, let's say, number 8. Now we are going to keep on scanning this deck until we find number 8. So we found number 8, that's great. Once again we are going to repeat the same process, and this is going to be 3. So this one is 3. Once again we found the match. Now this one is a joker, so let's just ignore that. This one is 7. So now for the 7 we will try to keep on shuffling through the deck until we find the appropriate 7, and in this case it took us slightly longer, but we eventually find it. It's basically a matching between two separate decks. Now notice what is going to happen. For every single card that is currently present in this deck, worst case scenario, it could be possible that we might have to scan this entire deck before we can reach to that end conclusion. So for each of these n values, we will have to do n work. It's loop within a loop in order to find the established goal, and that is an example of big O of n square time complexity. Now for n cube time complexity, basically we are just going to have 3 set of decks where we will take value from one deck, then we will try to find a matching pair from the second deck. Maybe it could take us as long as it takes, and then we will try to find another matching from the third deck. So this can take substantially longer, but overall this is what n cube time complexity means. It's once again loop within a loop within a loop. Now let's talk about some really large time complexities. So first one comes to mind is 2 to the power n time complexity. 2 to the power n complexity means that if you have an input that increases, the time it takes for you to generate the output multiplies by 2 every single time. And what is an example of that? Let's say that we currently have a coin. Now this particular coin only has two possibilities. If I flip it, it can either be heads or it can be tails. That's it. But the thing is, what if I add one more coin into the mix? Now the number of possibility are multiplied by 2 again, because we can have two heads, we can have one head and one tail, we can have one head and another tail, or we could have two tails. So in this case we have four possibilities. If we add one more coin, the possibility once again multiplies by 2. We could have 8 possibilities. If we have one more coin, it once again multiplies by 2. We could have 16 combinations of heads and tails. If I add one more coin, the possibility multiplies by 2 again. So we could have 32 combinations. So notice that when we started merely with just 2 possibilities of flipping a coin, it has very quickly grown to 32 possibilities just with the addition of 4 input values. If I keep on adding the input values like 10, it's going to be 1024, and so on and so forth. So it's going to become very large very quickly, and these are the time complexities that we are typically trying to avoid, or it becomes very tricky to work with them. So do you think that this would be the worst time complexity? Well, you might be mistaken. There is also some more time complexities that are more complex than this, and that could be in the factorial time. So what does factorial time? Let's try to understand it with a simple example. Let's say that we currently have these three cards. Treat it as like three seats in a bus or an aeroplane or a movie theater. And then we have three friends who are currently trying to have a seat on these three different places. What are the different combinations we can have them seat in these places? Well, in the first seat, potentially all three can sit. That's very fair. Now, amongst all three can sit, if one sits, then for the second seat, the number of possibilities are two, and for the third seat, the number of possibility is one. So if we have to quantify that, what are all the different permutations and combinations? There are three possibilities that can have a seat on the first position. There are two possibilities on the second position, and there is one possibility on the last position, and it's a multiplication of them because it's permutations and combinations of all the different people trying to have a seat on the first, on the second, and on the third. So it's going to be 3 multiplied by 2 multiplied by 1. So in total we can have 6 possibilities. If I add one more card into the mix and if I add one more person, now the whole dynamics change, because on the first position potentially all 4 people can sit, on the second position potentially 3 remaining people can sit, 2 and then 1. If we do the multiplication, it comes up to 24. If I have one more card, and once again if I am trying to have one more person have a seat over here, now it becomes even more complicated, because on the first position any of these 5 people can sit, so it's 5 possibilities, then 4, then 3, then 2 and then 1. So it's a multiplication of all of these, and this comes up to 120. If I add 6 value, it's 720. So notice that how quickly the number grew from just having 6 for the 3 time complexity to having 120 possibilities for the remaining 2. So this is how exponentially the time complexity grows for a problem that involves factorial time complexities. Now there are some real cases where we actually do deal in factorial time cases, and we try to improve upon them using dynamic programming, and we are going to see a lot of examples of that. Now let's try to understand that why do we use the terminology big O to define time complexity or space complexity. Whenever we are defining the speed of an algorithm, we would say that it runs in order of the growth rate based off of given input size. What I'm trying to say is that if my current input is 10, it runs in, let's say, 10 seconds. And if my given input turns to 1000, it runs into 1000 seconds. So we can say that there is a linear connection between the input size and the time it takes to execute the algorithm. So we can say that this algorithm runs in the order of n time. So that's why the O in the big O refers to as the order of whatever the component it is that defines the growth rate. So we are trying to calculate the upper bound of growth rate for the given algorithm, and that's why we use the terminology big order of whatever the input size it relates to. Now I know that you must be getting confused that about all of these different terminologies and big O of n and big O of 2 to the power n and n square and whatnot. So let's try to see very small brief code blocks that I'm going to explain one by one, and then we will try to see that why we call it as whatever time complexity it is made off of. And that way it will clear some concepts for you, at least at the basic level. And don't worry if you don't understand some terminology, it would be covered throughout this course, so just stay with me. So now we are going to be seeing bunch of examples of different big O. So we will see different code blocks like this, and we'll try to figure out that what is going to be the big O for this particular code block and why that is the case. In the very end, we are going to see that for each of different time complexities, what does the impact or the growth rate is for that particular type of time complexity. So that would really put the things into the perspective that why these numbers matter so much. So let's try to understand this very simple code block. Basically, we have a very simple method that is called get first element, that takes in an array as an input, and it just simply returns the very first element present inside the array. Now we know that if we are given an array like this, it's only going to take like x amount of constant amount of work in order to fetch the values, even if it's an array of size 5 or if an array of size 5,000 or 5 million. It's always going to remain the same amount of time it takes to run this code. So we can call this as big O of 1, or constant time complexity, for this code block. So this is a very simple example of that. Now let's try to understand more nuanced example. So in this case, we are basically doing a binary search. Now, if you are not familiar with this term, don't worry about it. This is basically the same stuff we did with the sorted cards we had, where we were finding the middle card, and then based off of that, we were either eliminating like one side of the cards, or we were eliminating the other side of the cards, and then we were doing some other work. This is exactly the same stuff. The idea is that we simply go in, we fetch a mid value, and for that mid value we check that if the given target value, if that is equal to mid, we return it. If that is not equal to it, we either check the left side of the array or right side of the array, and then we simply return the answer. So basically we are running this code in big O of logarithmic time, log n time, and that is what this is an example of. Same way for this particular code base, if you check, we are doing a linear search. Basically, we are given an array, so that contains bunch of different values present within an array, and a target value we are trying to find from this given value. Now we don't know, target can be at this location, or at the very last location, and in the worst case scenario we might have to iterate over the entire array before we find the appropriate value. That is what we are doing. So we are running a loop through this given array, and then we are trying to find the appropriate value, and then we can return its position basically. So in this case we can say that this is going to run in big O of n time, or a linear time, because basically if we have 1 million input, then it might take us like 1 million more times compared to if we only had just one input or two inputs. Now let's try to see this example. This is basically a very popular algorithm that we will be using quite a lot in a lot of the lead code problems. All it is doing is basically it's merge sort. So if the idea is that we are given bunch of different random numbers, they are currently present in any form, but once we run this entire algorithm, basically we would have a sorted array where all the values are going to be sorted in ascending or descending order depending on how we structure that. The idea is that we first take this unstructured value, we take each individual value, and then we start putting that within the given array, and based off of the value coming in, we will appropriately adjust our remaining values. So if the first value is 5, currently the array is empty, so we would simply just put 5 wherever, so in the first position. Next value is 3, so we know that the 3 is the smallest value compared to the 5. So in this case we are going to have the new iteration, where again this happened where we did the middle value swap, or basically binary search, and we were able to come up with the result like 3 and 5. Then we had the value 1, so once again we would repeat the same process, and we would have 1 over here. Once again we would repeat the same process, and eventually we would have 1, 2, 3 and 5. The idea is for each of the value over here, find an appropriate value to add in this new array, but this new array is always going to be empty, and then it is going to be sorted. So we are going to be doing binary search over here. So for each of these characters, because we are doing binary search on all of them, basically we are doing n work, and then for each of this n we are doing binary search, that is log n work. So this code block is an example of big O of n log n work. And this is like, you will see a lot of examples where we are multiplying the time complexities, we are adding the time complexities, so on and so forth. So again you would be able to figure it out, so don't worry about it. Now notice that this one is slightly different. Basically we are trying to find like the result of pairs within this given array. So what we are doing is we are running a for loop, and for each of the value within that for loop we are also running another for loop, and then we are just simply printing the pairs or the results of the value. But because we are doing like the combination of each of the value with its other subsequent parts, basically we are doing big O of n multiplied by n work. So for each individual items, repeat this n times. That is what this code block is basically doing. So we can call this big O of n square time complexity. Now big O of n square If we take it like a notch further, this is like a for loop. So we have ith value, then for each of the ith value we have the jth value, and for each of the jth value we have the kth value, and we are simply repeating like a triplet pair for this one. So this is just an extension of the previous code block we had, where we have a loop within a loop within a loop. So for each n we are doing n work, and for each of that we are also doing an n work. So basically this is going to be big O of n cube. Now let's do some examples of really large time complexities, and this is where we are trying to calculate the Fibonacci of this given through this given code block, and we are doing some recursive calls back to the same function. Now let's try to understand that what this code block is doing. Basically we are taking in a value n. We are checking that if this value n is 1, then we simply return whatever the value of n is, which is 1 or 0. And if that is not the case, then we are calling this Fibonacci function again for n minus 1 value, and we are calling this Fibonacci function again for n minus 2 value. Let's see that how this is going to go. So basically let's say that we have n is equal to 4 and we are trying to calculate the result for this. Now 4 is definitely not 1, so this condition would not work. So we will have to go over here, where we are going to be calling the same function, Fibonacci function, for the value 3 and for the value 2. Okay, and we are going to be doing summation of these two. Now for this Fibonacci of 3, we are going to call this function again with Fibonacci of 2 and Fibonacci of 1. Now Fibonacci of 1, we already know that this value is 1, so that's good, we already have one result. Now for Fibonacci of 2, once again we are going to call it with Fibonacci of 1 and Fibonacci of 0. But for Fibonacci of 0, we know the value is going to be 0, and Fibonacci of 1, the value is going to be 1. So now we have this 1 and 0, so combination of these two is going to be 1. So now we have this 1. So now 1 plus 1, we have this value as 2. So now this value we received as 2. Okay, and now we also have Fibonacci of 2. So Fibonacci of 2 is once again going to be the value 1, and once again this is going to be basically 0. So this is also going to be 1. So the sum of this is going to be 3. So this is the answer we are going to return. But notice that instead of this being 4, if we had value as being 5, so this whole stuff would basically increase. Now we are going to be calculating for 4 and for 3. And for 4 we would be repeating all of these things, and for 3 we would be repeating all of these things. So it grows very large, because we are going to have a very large calculation over here and very large calculation over here. If this value were to be 100, then once again we would be calculating for 99 and 98, and we will keep on repeating, so on and so forth. So this is a highly inefficient solution for a very legitimate problem, and the input size doubles every time, because notice that for this each number we are essentially calculating or repeating the multiplication of same calculation again and again. So this is an example of big O of 2 to the power n time complexity, where with each size or each increase in n, the time it takes for us to calculate this result doubles. So this is a very expensive time complexity. And now we have one more that is even more expensive, and this is an example of basically a factorial time complexity. So let's see that why this one is a factorial. Basically we are trying to calculate all the different permutations and combinations possible between given string as str and get given string an answer. And now what we are going to do is we are checking that if this is 0, then we can simply return the answer. But if that is not the case, for every single character present in str, we are going to compare that with every single remaining value within this substring of answer. So this is going to become like very large very quickly, and that's why this is a factorial based time complexity. So this is like the most expensive one. Now let's try to put things into perspective, and we will see that how things change from like basically big O of 1 to all the way to big O of n factorial. Okay, so let's say that if we have big O of 1 time complexity, we are going to run a comparison table where we are going to compare the value of if given input size is 10 if it is 100 and if it is 1000, and we are checking that this is basically the time it takes to run the algorithm. Now for simplicity's perspective, let's just make sure that they are all of these numbers are in second, so we can have some way to comprehend or understand the results. For constant time, even if we had 10 results, 100 results, or 1000 results, it's always going to take us 1 second to calculate the result, because that's what it is, a constant time complexity. But for logarithmic n, with the increase in the size of n, there would be an increase in the time it takes to compute. But notice that for 10, basically 10 inputs, it would take us 3 seconds to compute. For 100, it would take us 6 seconds. For 1000, it would take us 10 seconds. So not a substantial increase. Meanwhile, our input actually like increase three folds. So 10 multiplied by 10 multiplied by 10. For n, it's linear, so 10, 100, and 1000. For n log n, it basically takes us like multiplication of these two. So 33 seconds, 664 seconds, or 9000 something something seconds. For n square and n cube, it's essentially just the square value of all of this 100, 1000, and 10,000. And notice that how large it gets, especially for like n square time complexities or n cube time complexities, that the number keeps on growing larger and larger. So this is a good cue to ourselves that if we have n cube, can we bring it down to n square? If we have n square, can we bring it down to n or n log n, something like that? So the better we can do in this regard, the faster our algorithm is going to be. And for 2 to the power n and n factorial, the numbers are just out of this world. Like even for 10 input sizes, it takes us 1000 seconds to solve the problem in 2 to the power n. For n factorial, it takes us like 3.6 million seconds just for 10 inputs. And for these, this is like 10 to the power 30 and 10 to the power 301, which is like huge numbers. And these numbers are even larger than that. So we should always try to avoid these time complexities no matter what. And we can, there are some ways of doing it using like dynamic programming and greedy approach and being creative about different things. So we are going to be learning that throughout this course. Just this is just something to keep in mind. Now let's try to understand that what is space complexity. Once again, space complexity is denoted by big O notation, and it is the amount of space required in order for us to accomplish our expected goal. So let's try to understand it with a live scenario. In currently, I have two containers. This container contains bunch of different white chickpeas, and it is a white container. And I have a black container that contains bunch of different black chickpeas in a black container. Now my aim is to move all of these black chickpeas into this white container and move all of these white chickpeas into this black container. How would I do that? If I only had these two containers available, and if I have to do one by one, what is going to be the algorithm that sequentially or individually I'm going to pick and choose all of these black chickpeas from this one and keep on adding them, and then at the same time I'm going to be adding the white chickpeas over here. Again, it's going to become extremely excruciatingly difficult because there are so many chickpeas that looks pretty much the same, and it's going to take me a lot of time to do it. But if I add the space complexity, or if I add one more container in between, if I just move all of these black chickpeas like this, all of these white chickpeas like this, and once again all of these black chickpeas like this, notice how quickly I was able to flip between the all the chickpeas amongst these two containers, because I had to use this extra container, and how quickly this whole algorithm was able to be finished, because I'm no longer doing any kind of addition or subtraction in this case. And that is how powerful space complexity can be. Many times we are going to be seeing that if a problem is going into the realm of big O of 2 to the power n time complexity, or factorial time complexity, or even n square time complexity, we might use an extra data structure to store the previously computed results, and that is going to allow us to very quickly flip between our inputs and retrieve the answer very fast, and we will be able to solve problems much quicker. And that is the whole idea of space complexity. Once again, it gets denoted by big O, and we are going to learn a lot about them in each of the lead code problems we are going to solve. Now let's talk about the $1,000,000 question. How do you even get good at DSA? Now, number one thing is practice. Second thing is to be able to understand all the different data structures and all the different techniques we have, and then try to look for important patterns that repeats in many cases, which we are going to be doing through lots and lots of interview examples and understanding different patterns. And third thing, you need to follow the simplest strategy of understanding the problem in the most basic terms as a non-IT, non-computer graduate person would do. Just try to think that how does a simple problem that is being thrown at you, how would you try to understand it in your own words, build some basic examples, and try to solve it using the most simplest terms or even the brute force approach, even if it is not optimized for speed or anything else. Next, you will try to see if applying different data structures in any particular questions you are given, can they be helpful in speeding up some repetitive process. And number three thing, if you have a brute force solution that has, let's say, big O of n cube time complexity, your immediate aim should be to make it better than big O of n cube. Can you make it like big O of n square? Can you make it big O of n? Can you make it log n? So on and so forth. So once understand the problem in the most basic terms, come to the most basic, most rudimentary solution, and then see if you can improve upon that. And whenever you are doing this throughout, keep your interviewer engaged in the conversation communication. Just let him know that, hey, this is what you are thinking, this is what you are doing. Just be as transparent as you want. They are judging you based off of, do you have like proper communication skills and problem solving abilities, and how does your thinking works. If they see that you are tackling a problem that you have never seen before, and you are building like a brute force solution, and then you are correcting yourself, and then you are making a better solution, and if your thinking is correct, there is a very high likelihood of you being selected for that next interview or for that next job. So that is what we are going to learn. So now let's move on to the next topic. So let's try to understand that what is the classification of different data structures. We can broadly divide data structures into three main categories: linear data structure, non-linear data structure, and hash-based data structure. So let's try to understand each one of them. A linear data structure is a data structure where basically all the elements are typically sequential. So it comes into the data structure one after the another. Think of it, all the elements being present in some sort of a line. So what are the linear data structures? First one is an array. Array is a fixed size linear data structure that we are going to see a lot of examples of. Basically, in the memory of the computer, we allocate a fixed size block where we can enter elements and where we can remove elements. And all the elements are going to be accessed by the index position of that particular element. Next one is a linked list. Linked list is completely different compared to array, where we don't have a fixed size. So basically it's a dynamic data structure. And for this dynamic data structure, we can basically have two items. We have the head of the linked list and we have the tail of the linked list, or the last element inside the linked list. Now head of the linked list points to what is going to be the very first element inside the linked list. And in this very first element, basically this element is made out of two chunks in the memory. First one contains whatever the value this linked list persists, so it can be integer, boolean, whatever you want to imagine. And in the remaining portion, it shows that what is going to be the address of the next element inside the linked list. And next element is also formed similarly, next element is also formed similarly. And the last element, that is going to be the tail of the linked list, this refers to, or this points to the null variable or null pointer, and that's where the linked list ends. So basically linked list can shrink and grow in the size depending on how many elements are there, and it can all happen dynamically, so we don't have to worry about it. Now stack and queue, they both can be formed using arrays or using linked list. Basically these two contain some special properties. So stack is a kind of last in first out data structure, where you can imagine this as being stack of plates or stack of books, where if you have to access the books, you basically put books from bottom all the way to top. But when you want to get any book out, first you have to get the top book out before you can reach to the next book. So it's always going to follow this property, and this can become helpful in a lot of different scenarios, and this is an example of stack. Now queue is again a complete different or opposite concept of stack. A queue is typically the queue that we typically follow in any place like bank or movie theater or anywhere, where we follow first in first out principle. So let's say that if this is the queue and we are entering from this end and we are exiting from this end, so basically whichever the element was the first to come in the queue is also going to be the first to get out of the queue. So this is separate compared to our stack example, but basically both stack and queue also follow the linear property, where one element comes in after another element, and that element comes in after another element in some fashion. So basically this is an example of linear data structure. Now let's try to understand non-linear data structure. Now a non-linear data structure is a data structure where we don't have any sort of sequential line or sequential property that we need to follow. Basically, elements that are present inside non-linear data structure, they typically follow some sort of hierarchical data structure, or they follow some kind of networking related data structure, where one element can come in after another element, that comes in before some other element, that comes in after some other element. There can be all the different kinds of jumbled up relationship, and we need to follow that. And some elements are not attached to the existing set, but they're still part of the given data structure. So this is an example where this is going to be dynamic data structure, that's for sure, because it can grow and shrink in size, and there are many different ways to implementing that we would see later in subsequent courses. But overall there are two main non-linear data structure. First one is graph, and second one is a subset of graph that is defined as trees. So let's first talk about trees, because this is like kind of slightly smaller compared to graphs. Tree is not your typical tree. This is a different kind of tree where we have a root variable. So this root variable is going to be the entry point into the key tree, and from there it can have sub children, or it can have children of its own. And there can be many different type of trees. There can be binary trees, ternary trees, AND trees, unique trees, red and black trees. So there are many different concepts, but overall the principle is that each element is going to be differentiated based off of its level. So all the elements that are currently present at the bottom level, these are referred to as leaf node because they don't have kids of their own, and all the elements above leaf are going to be the parents of that subsequent level. So these nodes are going to be parents of these nodes. Once again, this root node is going to be parent of these nodes. So overall we follow some sort of hierarchical property when we are talking about trees, and it can be useful in many different scenarios, and that we will see for sure. Now one thing important in the tree is that all the nodes are connected. So we don't have a scenario where there can be a node of tree that is part of this tree but not connected in some sort of edge. So it is always going to be connected somewhere along the tree, and also there cannot be any cycles. So all the nodes are going to be uniquely defined, and there cannot be cycles present inside a tree. So these are the two main things that differentiates trees from the graphs. Now let's talk about graphs. So in the graph, basically we have two things. We have nodes and we have edges. And these nodes and edges have some sort of connection between them. So there can be two nodes where it's possible that only one node has edge going from one place to another one, but other one does not. Some places both of them have edge going towards each other, so we can define it as two separate edges. There can be a connected graph. So this is an example of connected graph where all the elements are connected with each other. There can be non-connected graphs as well, where some nodes are connected and other nodes are not connected. Some clusters can be connected and whatnot. So there are many different examples of graphs as well. There are directed graphs, non-directed graphs, there are weighted graphs, there are unweighted graphs, cyclic graphs, non-cyclic graphs, and so on and so forth. And we can do all sorts of things using graphs. It can be used very heavily in applications such as social networks, where you have a bunch of different people who have some sort of relationship with each other. So someone is friends with someone else, someone is following someone else, and you need to define that. Or it can also be very helpful in defining some sort of maps, where you have a bunch of different places or cities, and then there are roads going between those cities. So how you can connect that, how you can find the shortest path and things like that. So again, graphs is also very powerful and very useful in a lot of different cases. And last data structure we have is going to be hash based. Now inside the hash based data structure, we have some sort of hash that defines every single element that is currently present within the hash map or hash set in very quick manner. So we can identify and pick out elements very quickly in basically near constant time. So why this is useful? Because if we talk about some data structure, let's say array or trees or anything, if we have to find any particular element, worst case scenario, we might have to iterate over entire array or entire tree before we can find that element. But if we have a hash map or hash set, we can virtually find that element in big O of one time. And why this works? Well, basically, let's first try to understand hash map. So in the hash map, we have something called key value pairs. So anything or any value that we try to insert within the hash map is going to have two elements, a key associated with that and then a value associated with that. Let's try to understand a very simple and basic key. So we will try to determine that what is going to be the starting alphabet of any particular character. So let's say if element starts with A, we are going to define key as A and then add the value as apple. And for simplicity, we are making sure that we can only have values from A to Z and each are going to have just one unique value. So same way for B, we can have a value for ball and whatever and whatnot. Now, if I am trying to determine that whether bat is currently present inside this hash map or not, I don't need to scan all 26 values that are present. I can very quickly go to this element where the B is present and check that what is the value associated with that. And currently, because this value is ball and it's not bat, I know for a fact that bat is not present. So I can return this answer very quickly. This is the advantage of hash map. Now it could be possible that if we just have one key and we want to add multiple value, we can put some sort of linked list over here, but there are going to be advanced concepts that we can think about it. For simplicity, let's try to understand that we have some sort of mathematical formula that that uniquely defines any single element within the hash map. So for each key, like in theory, we only have one value associated. If that's the scenario, no matter if we add million keys over here, basically we can find any particular value in very quick time and very quick fashion. What are some of the downsides? Well, we cannot have duplicates values because all the duplicate values are always going to end up within the same key value pair. So we can't have duplicate values being inserted within a hash map, and that is also true for hash set. Now the difference between hash map and hash set is that again for all the elements that are present in the hash set, they also get stored, but we don't store any particular key for them. We only store the value, and we can check that whether this value is currently present inside the hash set or not, or we can add the value inside the hash map. And all the operations are very quick. They happen in virtually big O of one time. But again, there are differences and some trade-offs we will have to make sure if we are working with hash map or hash set, and we are going to be seeing plenty of examples of these as well throughout the courses. So don't worry about it if you don't understand. So I hope this all makes sense to you, and now you have some clear understanding that what each of these data structure means. So now let's try to do a quick recap. We first understood that what is data structure and what is algorithm. Then we understood that how to judge an algorithm, what is time and space complexity. Then we understood that what are the different categories of different data structures. And now we will start getting into the meat of the actual course. So we are going to go with the 20 topics that I discussed earlier. For each of the topic, we will understand that what that topic is, what are the different common operations, patterns, use cases associated with that topic, and then we will start solving many most tasks, most like and most popular lead code problems or technical interview problems associated with that problem. That is how you get good at solving technical interviews and building your intuition for solving the problem. So I know it's not going to be easy. It's definitely not going to be entertaining. It's going to be very boring in some cases, but you just have to have the perseverance because if you go through this whole process and actually become better at your technical interviews, you can change your lifestyle within 3 to 6 months. Like completely different compensation, completely different bracket, different country, different company, whatever. So motivations are huge, benefits are tremendous, and it's just a long journey that you have to endure. So I wish you best of luck. Now, if you made until this part of the video, just comment the word pineapple because I like pineapple. I hope you also like pineapple. Who doesn't? And without any delay, let's get started. Hello friends, hope you are having a fantastic day today. So now we are going to learn an entire full course on array as a data structure. By the end of this course, you should be an expert in all the questions related to arrays. First, let's try to understand that what an array is. Array is nothing but a continuous block of memory that is currently stored inside your computer. Now inside this continuous block of memory, you can store integer data type or boolean data type or string, character, whatever you want to put. You can store these values, but arrays have some restrictions and some properties. Number one restriction in an array is that it is a fixed type of data structure. So whenever you are storing the information, you need to define that what is going to be the size of this array. So currently this array that I have provisioned can only hold up to 5 distinct values. Second thing is, everything inside the array is defined by its index positions. So in this case, for this array, the index values would be defined as 0, 1, 2, 3 and 4. On top of it, because this is a fixed size and also all the values are continuous in nature, I can fetch any particular index position values in constant time. One of the other thing is computer knows that what is going to be the memory size for each of these blocks. So let's say that this block cost 8 bytes of memory to be stored inside the computer. Also, computer knows the starting position of this particular memory location. So let's say that inside the memory of computer, this one is defined by 1600. So logically, if we have to access this value, the position is going to start from 1608. Same way, position for this is going to start from 1616 and so on and so forth. So that's why this makes array unique and fast in terms of nature. Now let's learn that what are the different array operations that we can perform and also what are going to be its time complexities. So first operation that we would like to see is access. That let's say that if there is some element that resides at position number 2 or position number 3, how quickly can we access? We just explained that this can be done in big O of one time and fetch the value that we are looking for. For the insertion, typically in normal scenario this works in big O of one time, but worst case time complexity can be big O of n because we are trying to find a space where we need to insert the value. So if it is a random insert that we don't know that whether we have an empty space or not, or if we are trying to make frequent modifications, we might have to shift values inside the arrays as well. Same goes for the deletion, that because we are deleting some elements from the array, we will have to shift the cells here and there. So in that case, worst case scenario, it can be big O of n, but typically most of the languages handle these scenarios in relatively simple fashion, and average scenario is going to be big O of 1 for both of them. Now traversing an array is very straightforward. You simply start from the starting pointer and keep going in one direction until you reach to the very end of the size of the array, and this can typically be done in big O of n time, where n is the total number of elements present, because you will have to iterate over every single element in order to access them. Searching is also quite an interesting one. Let's say that currently this array contains 5 different elements and you're trying to search that whether any particular element resides inside this one or not. Let's say that you are trying to see that whether element number z is present or not. So in this case, if this values are not sorted and these are random values, then you must do a linear search. And a linear search is only going to yield big O of n result, because you will have to reach or search every single value. Or you can do something called a binary search if the given values are sorted. So you can see in this case the given values are sorted lexicographically, so we can actually apply binary search in this case, and we can solve this problem in big O of log n time. And don't worry about these things, you are going to see tons of examples of these things in action, so it would become a second nature to you. And last one is an update. So if you have to update any particular element, let's say that instead of this x, I want to update this value to be m. So I can do this instantly because I can reach or fetch that element. So number one benefit of an array is that we are dealing with random access time complexity of big O of 1. So if we have to access multiple values from the array, we can do it in big O of 1 fashion. That this is going to be really helpful in certain scenarios. Next thing is, array is a wonderful cache friendly data structure, which means you can see lot of different operations where array becomes a supporting data structure for the main problem we are trying to solve. We can use array very heavily in dynamic programming problems. We can use array with graphs, trees, and all the other data structures to in order to store some valuable information that we are trying to memorize or using it by tabulation. Next thing is, we can very easily sort values inside the array. And next thing is, array is very popular in implementing other data structure. You can implement heap, you can implement tree, you can implement linked list, you can implement stack, queue, all of these things using different ways to modify and manipulate arrays. So arrays are overall very diverse data structure. Now let's see some limitations. Number one is, because arrays are fixed size, there is only so much you can do. If you are dealing with some dynamic problem where the value are continuously increasing, and if you are trying to use array, then it becomes obsolete, because every time you are going to be facing an issue where array runs out of the size. So you can only use array until you know for sure that the size is going to be fixed. If you have to deal with dynamic scenarios, you can use something called array list, where inside the array list it helps with like dynamic nature, but there is a whole separate discussion on its own. Next thing is, for typical insertion and deletion, worst case scenario, it can go into big O of n if you don't know where you are trying to insert those elements or delete those elements from. And next thing is that it is very inefficient in terms of frequent modifications. Now let's see that what are some of the common use cases where you should start think about using array for various different purposes. Number one use cases that I just explained is to implement other data structures, because array is simple and can be modified in many different ways. Next thing is, whenever you see any kind of caching or tabulation or memoization item that you need to perform, you must start to think about using an array. Third thing is, whenever you are dealing with graph problem or tree problem and you need to keep track of visited nodes, then you can also think about using an array. Then whenever you need to do some sort of mathematical computation, you can also use an array. And one good thing about array is that it has lot of popular coding patterns. So coding patterns such as two pointers, sliding window technique, then a fast and slow pointer, and all of these things can be used in many different ways that can become really helpful. And we are going to see all of these in action when we do our 25 most popular most asked questions. Now arrays also comes in multiple dimensions, not only one dimension. So far we have seen all the arrays that typically looks like this, where we can define this as one dimensional array, where you can notice that every single cell only is being defined by one particular index position. Now there can be scenarios where we need multiple categorizations to define any particular cell value, and for that we can actually use multi-dimensional array, where this is this would be an example of 2D array. Same way we can have a 3D array, we can have a 4D array. So let me give you a common scenario. Let's say that I just want to say that whether any particular student is present or not. So I can create an array like this, where I'm storing a boolean information, and in each of the scenario I am marking all of these values based on the student roll numbers or ID numbers. So this becomes a one-dimensional array problem that I can solve easily. But now I want to create a matrix of information such as grades for every single student, on top of it their roll number. So I want to define each of the cell based on their grade and roll number. So I can create one entire section of grades starting from A to F, and same way I can have another section for a roll number starting from 1 to 3 all the way up to n students. Now any particular cell in this position is going to define that this cell defines that for roll number 3 whether that student got B grade or not. So this can be another way of categorizing values, and this also contains the same property of fast access and all of the good stuff that array has to offer. So typically for any DSA problem and technical interviews, we are only going to be dealing with 2D arrays, but in theory and also in practice, we see all the time 3D and 4D arrays as well. 5D arrays very rarely, but this is something to just understand. The lead code problem we are going to solve now is called 2sum. This is the number one problem on the lead code, and we can see that this one is an easy problem and also the most like problem on lead code. Let's understand the statement. Basically, we are given an integer array nums and we are also given an integer called target. Now we need to return the indices of the two numbers within the nums array such that they are the sum of target. So basically they add up to the value target, and we are guaranteed that there is always going to be one solution, and we can return these indices in any order. So let's try to understand this with an example. We are given an input array nums over here, and we can notice the values are 15, 7, 2 and 11, and we are also given target value to be 9. Now in this example we can see that the 7 and 2 sums up to target value number 9. Now if we see the index positions of the 7 and 2, they are located at basically 1 and 2 position. So we can return the answer as 1 and 2, or we can also return 2 and 1, whichever like sequence we want, but basically this is what we need to return. Now let's understand that what are the different ways we can actually find the sum of these two values. So first let's understand the brute force approach. Basically for the same example, let's say the values we are given, we are going to try every single permutation and combination. So what we will do is, currently this value is 15 and the target we wants to make is 9. Okay, so this value is 15, so we cannot use any other value to basically form the target value as 9, so we can just ignore this case. Okay, now this value is 7. So because this value is 7, the total target we wants to build is 9. So what we'll do is we'll do 9 minus 7. So we will check that if the value 2 is present inside the remaining array or not. And lucky for us, the value 2 is present. So we can just return basically the index positions of these two. Now notice that in the brute force approach, what we are essentially doing is, for every single character, in the worst case, we might have to iterate over all the remaining characters to see if any particular value is present or not. Let's take an example that if this value was to 1, then we would have to check that whether 8 is present. So for that we might have to basically go over all of them. So the time complexity would have been big O of n square. That is a bad time complexity. Now let's see that if there is any particular way we can improve upon that, and the answer is yes. If we do sorting, basically things would become slightly better and easier. How? Let's understand that for the same example, if the values are 15, 7, 2 and 11, once again if we sort these values, we would be left with value 2, 7, 11 and 15. Now we are at value number 2. Okay, so notice that if the target we want to generate is 9, if we already have value as 2, which means if we do 9 minus 2, the answer becomes 7. Now all we need to do is to check that whether 7 is present inside the remaining array or not, same as our brute force approach. But in this case, because we know that this is already sorted, instead of using linear search where we are iterating over all of these values one by one, we can use binary search, and that would help us alleviate a lot of questions. But because in the binary search, remember that we will find the middle value. So let's say we find middle value is 11 in this case, and from 11 we know the value we are trying to build is 7. So even if there were like 100 elements on the right of 11, they will all be greater than 7. So we cannot use them, so we will just ignore the entire right portion and only limit our search to the remaining piece, and we would be able to find the remaining value in essentially log n time, which is exceptionally fast. So this, if we see like the sorting approach of sorting the original input array, things becomes quicker, and we can actually solve this problem in big O of n log n time, and this is the time to basically sort the given input plus log n time to find any particular character. But the thing is, generically we can just write it big O of n log n as the overall solution. Now the question is there a way to do things quicker? And the answer is yes. We can even do things faster if we use an additional data structure in this case. And let's see what are the considerations for us to understand any particular data structure. Number one thing is, whenever we see a value, we are trying to basically determine that what is going to be the remainder. So in order to quickly look up that do we have that remainder or have we already passed that remainder or not, what we can do is we can use a hash map in this case. Now notice hash map contains two properties. First thing is a key, and second thing is an appropriate value. Now as part of the key we would put whatever the array item that we currently have. So let's say that we are given once again this array as an example. Okay, now in this case we once again need to return the target value of, let's say, 9. So now in this case what the algorithm we are going to use is, first we'll iterate over any particular character inside the given nums array. For that character we will see that what is the remainder value we are trying to generate. So for this value number 1, we know that the remainder value should be 8. The question is 8 present inside the hash map or not? If it is not present, that's it. We simply add this value 1, saying that it could be potentially a match for some future target value that we are trying to generate, and continuously we will keep on doing that. So as a key we will add value 1 over here, and as its appropriate value we are going to store the index position. So index position for this 1 is going to be 0, so we will store value 0 over here. Now let's repeat the same operation. Now next value is value number 7. So for if we already have a 7 to be part of the 2 sum that we are trying to generate, we will need to have 9 minus 7, which means value number 2 as part of the hash map. But currently hash map does not have value number 2. So what we'll do is we'll simply add value number 7 with its index position as 1. Same way we have value number 3. If 3 were to be part of the answer, we need to find value number 6. 6 is not present inside the hash map. So we will simply add 3 over here with its appropriate subsequent value, that is index position number 2. Now we are at value number 2. For 2, we need to find value number 7. And lucky for us, 7 is present within this hash map, and we already know its subsequent value is 1. And since we are already at 2, we know the index position of 2 as well. So in this case we can return the answer as, let's say, 3 and 1, or we can also return like 1 and 3, whatever we want. But basically this is the index position of the values that basically sums up to total value number 9, and this is the fastest way to solve this problem. Now let's analyze the time and space complexity. Time complexity is going to be much faster big O of n. Why? Because we are iterating over all of these elements just once and we are coming up with the solution. Because remember, searching that whether any particular value is present inside the hash map or not happens in big O of one time, which is significantly faster than everything else. Let's analyze the space complexity. So space complexity is going to be big O of n as well, because we have to use an additional hash map to store the results. But needless to say, this is much quicker than both our brute force and also our sorting approach. So now let's see the coding approach for this one. So the coding solution is quite straightforward. First, we are going to initialize a hash map to store all the values and their index positions. Then we are going to iterate over the given input array nums. And for each of the array, we are going to calculate that what is the remainder value in a variable called complement. Then we are going to check that if that complement is already present inside the hash map or not, which we can do in big O of one time. If the value is present, we simply return a new array that contains the value of that particular key and the current ith position. These are the two index positions. If we do not find that value, we simply add this current number that we are iterating over within our hash map using map.put. And in the end, we simply return an empty array if no solution is found. But this wouldn't happen because in the problem, we are already told that there is always going to be exactly one answer. We are just putting this return statement so we don't get into a compile time error. Okay, let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And we beat nearly 99% of all the other solutions, which is awesome. And in terms of memory usage, we can improve if we use some other solution, but this is also, needless to say, a very good time and space complexity. And this is the most popular problem, so you must know it by heart. Once again, the coding solution is present in our GitHub repository, so feel free to go and check it out from there. Thank you. So the lead code problem we are going to solve now is called contains duplicate. We can see that this one is a lead code easy problem and also an extremely well-liked problem. The statement is quite straightforward, that we are given an integer array called nums. Now we need to check that if there exists any particular value more than one times, at least twice, then we need to return true, saying that yes, there exist duplicates in the given array, and if it does not exist, we need to return false. So let's try to understand this with an example. Suppose this is the input array we are given. Now we can notice that value 4 appears twice in this case, which means there exist duplicates in this given input array nums. So we need to return true in this case. Now if, say for an example, we are given one more nums array and all the values are unique, or we don't see any duplicate values, so basically in this case we can return false, saying that there does not exist any duplicate values. And the statement is very simple to understand. Let's see that what is going to be the most common brute force approach we can use to solve this problem. We will take the first value and we would check against every single other value possible, that whether 1 is present or not. We identify that 1 is not present, so in this case now we would move on to the next value 2 and once again repeat the same operation. For 3, repeat the same operation, and at the 4 we would realize that there exists one value 4 that is being repeated. So basically found a duplicate, so we will return true in this case. And say for example, if we don't find duplicates and we reach to the end of the array, then we can simply return false, saying that there does not exist any duplicate values. Straight away you can see that what is the issue with this approach. Well, the idea is that for any particular n value or any particular work, we will have to repeat the same operation for every single other values, which means the time complexity is going to be big O of n square, which is definitely pretty expensive, and there are ways to make it faster. So the first optimal approach that comes to our mind is basically sorting. If we can somehow sort the given input array, then things would become much easier. Let's say that we are currently given an input nums and the values are scattered all across the place, and we can find that there are some duplicate values over here as well. If we sort this given input array, then the sorted input is going to look something very similar. And then for the sorted input, all we need to do is just keep checking all the values with its next value or previous value. And over here after 1 we find value number 3, which means it is not possible to have 1 in the remaining array because this is a sorted array. Same way for 3 we found value number 5, which means there is not possible to have another 3 inside the remaining array. But for 5, because there exists a duplicate, it has to be very next to it. We found a duplicate and we can simply return true in this case very easily. Now this is a much better approach than our brute force approach, but let's see that what is going to be the time complexity. Well, it is going to be big of n log n, because it takes n log n time to sort the given input array. And the question is there a way we can do something better? And the answer is yes. The fastest approach in this case is going to involve something where we need to keep track of all the elements that we have already seen, and we should be able to access them quickly. And these are the two basically conditions that we need to follow. And for that, the best data structure in this case is going to be a hash set, that it cannot contain duplicate values, and it basically finds any particular element inside the hash set in big O of 1 time. So suppose this is the array we are given as an input. Now what we will do is that we will iterate over this array, and for every single value, first we will check that whether this value is present inside the hash set or not. If it is not present, we will simply just add it to the hash set and it move to the next value and repeat the same process. So let's see that how would that work, and let's say that this is going to be our hash set. Okay, so first we are at value number 3. Currently value number 3 does not exist inside the hash set, so we will simply add value number 3 and move on to the next value. Once again value number 1 does not exist, so once again we would add value number 1. Now 4 also does not exist, and now once again we would move to value number 1. Again at value number 1 we would check that whether this exists inside the hash set or not, and yes, it does exist inside the hash set, and we can check that in big O of 1 time, which is awesome. So in this case we can say that because there exists a value that is already present inside the hash set that we are trying to add to the hash set, which means the given array contains duplicate. So in this case we can simply return true, and say for some reason this value 1 is not present over here, and let's say that this value is maybe 6. So 6 currently does not exist inside the hash set, so we will add 6 over here. Once again we are at value number 5. 5 also does not exist, so we will add 5 to the hash set, and now we have reached to the end of the array. So if we reach to the end of the array, we can simply return false, saying that there does not exist any value that is duplicated. If we see time complexity, in this case the time complexity is going to be big O of n. Why? Because we are simply iterating over the given input array once, and for every single value, even though we are checking that whether it's present inside the hash set or not, it can be done in big O of 1 time. That is the power of hashing functions like hash set and hash map. And if we see space complexity is going to be big O of n as well, because we will have to use one more hash set to store all of these variables. But still this is much better compared to our brute force approach that had the time complexity of basically big O of n square. So now let's see the coding solution for this one. So the coding solution is going to be quite straightforward. First of all, we are going to initialize our hash set that we are going to keep track of the scene numbers. Then we are going to iterate over every single element that is present inside the nums array. And for each of those elements, we are going to check that if our hash set contains that particular number or not. If it does contain, then we can simply return true, saying that we have detected a duplicate. If it does not contain that number already, then we will just simply add that number. Say for an example, if we end up iterating over every single element in the array and we reach to the end of the array, which means there are no duplicates, so we can simply return false. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And as expected, code runs beautifully. It beats nearly 90% of all the other solutions that are present on the lead code, which is pretty awesome. And the solution of this code is present in our GitHub repository, so feel free to go and check it out from there. Thank you. Okay, so as an example, we are trying to solve the contains duplicate to problem. Now, this is a very popular lead code problem that has been asked in some of the popular companies like Amazon, Facebook, Adobe, Microsoft, Uber, Google, Bloomberg, Airbnb, and Palantir. So these are all tech giant companies who love asking this question. So that is why I considered this one. Let's try to see the problem statement. The problem statement is actually quite simple, and this is a lead code easy problem and also a very well-liked problem on lead code. Basically, we are given an integer array called nums, or we are going to denote it as n, that contains array values. We are also given a value k, and k can be anything like 1, 2, 3, 4, any single integer value. So suppose k is equal to 3. Now we need to return true if there are two possibilities. The first possibility is there exist any two values I and j that are exactly same. So if there exist two duplicate values in the array. And the second portion is that the difference between I and j, so I and j refers to the index positions of every single value inside the given array. So the index position should be actually less than the value of k. Let's try to understand this with few examples. So suppose our given input n is equal to 1, 2, 3, 1, 5. If this is the input we are given, and we are given the k value to be 4. If this is the case, does it satisfies these two properties? So first let's see. Okay, so we need to check that between the window 4 there needs to be two duplicate values. Currently we can see that there exists a duplicate value 1 and 1 over here. Let's see the index position 0 and 3. So if we do the difference 0 minus 3, so basically we need to do the absolute difference. So the answer is going to be 3. 3 is actually less than the value of 4, which means this one currently contains the duplicate value that is not far away from 4 elements from each other. So in this case, we are going to return true. Let's try to understand it with one more example. Suppose our given n is equal to 1, 2, 3, 1, 0, something like this. And our given k value is equal to 2. If this is the case, again, same scenario. We have the values located at index position 0 and index position 3 that contains the same value. but current k value is equal to 2. And if we do the difference between these two values, the current difference between indices is 3. Meanwhile, our given k is equal to 2, which means in this case we need to return false, because there does not exist any two duplicated values that are two steps away from each other or between two elements of each other. So this is the whole ask. Now let's see that what is going to be the simplest approach we can take. Okay, so suppose this is the input we are given. Now let's see the brute force way to solve this problem. That we pick any element, then we check the next k elements. So in this case, currently we are allowed to check up until this point. So between these portions, we check that whether 0 is present in any other value or not. If 0 is not present, we can define that 0 would not be a duplicated entry in any of the window, because we are strictly told that we can only check next 3 elements. So in this case, we can get rid of 0 because 0 is not present. Same way, we are going to check for value number 5. So currently value number 5 is located at index number 1, which means we have the ability to compare between these portions. So again, for value number 5, we are going to check this value, this value, and this value, and bingo, we find value number 5. So we can return true in this case because element number 5 exists and the difference is less than 3. But this is like a very inefficient approach. Why inefficient approach? Say for an example, this entry does not contain any duplicated values and all the values are unique, and at the same time what we would do is, for every single element we would compare it with the next 3 elements, and we would keep on repeating the same process until we reach to the end of our loop. And that would be an inefficient approach because the time complexity would be big O of n. So n is the total number of elements multiplied by k, and this is not what we want. We want something more efficient. So let's see a more efficient and better approach. A better approach is that we know that for any single value we need to check in the remaining portion whether that value is present or not. So currently we can break it down in this sequence. So currently we can create a window like this, 0 and then 5 2 7. Currently we are at this position number 0. Now we need to check that whether 0 exists in the remaining 3 entries or not. First approach is to do binary search. So for binary search, what we would need to do is we would need to sort this given input. And if we sort this input array, the sorted result is going to look like this: 0, 2, 5, and 7. And then all we need to do is check any two consecutive values. If we identify that there exists like a back-to-back entries that contains the same value, then we can return true. If it does not contain, then we can move on to the next window. And again, in the same way, we would repeat the same process for this next window that is currently comprised of the values 5, 2, 7, and 3. And again, okay, so let me fix this one. So this one should be 5, not 7, and 5, 2, 5, 3. So again, if we sort this window in this case, the answer we are going to get is 2, 3, 5, 5, and we found two back-to-back values that contains the same value. So in this case, we can return true. But the thing is, even this approach is also not very efficient because if we see time complexity in this case, the time complexity is going to be big O of n, then log of k. Why log of k? Because for any given input, we will actually have to sort this, and sorting it cost us a lot of time and energy. And this is better than the brute force approach, but still there can be improvements made. So what is one improvement we can make? And again, remember, we are using sliding window because we know that we need to do this in any subsequent values and we need to find the answer. So definitely you understand by seeing the problem that why we need to use the sliding window. But let's see that what would be the improvement we can make. First thing we need to check is that in the binary search approach, what we had to do is we need to check that whether in the remaining portion does the same element exist or not. And also at the same time, we were considering that every single time we need to create a new window, we would have to do the entire sorting calculation again. So we need a data structure that can very quickly like get rid of elements and add new elements, at the same time very quickly search that whether the existing element exists or not. And the wonderful answer for this type of scenario is a hash map. So we can create like a hash map or a hash set inside our input, and hash map and hash set are wonderful at doing two things. like doing the search and remove and input operations in big O of one time. So hashing is really good in that. Also at the same time, it does not allow duplicate entries. So no duplication is allowed, which means we can identify duplicate entries very quickly, very efficiently in any sort of hashing input. So we are going to use this property combined with sliding window approach to solve this problem in the most efficient manner. Let me quickly show you. So first we are given the value of k, which means we are going to create our window. So currently let's just create a window of size k. Okay, so starting from value number 0 to value number 5, and then we will have all the values 0, 5, 2, and okay, let me just put down some different value over here, and let me put 5 over here. Okay, and then this is going to be 4. Okay, so this is these are the current values at the moment. We are going to initialize a hash map. Now inside this hash map, we are going to store two items. We are going to store the value as the key, and we are going to store the indices based on its value inside the hash map. So first we are going to check, okay, this one is value number 0, and currently the index values are 0, 1, 2, 3. So 0 is not present in the hash map. We will add entry 0 over here, and its index value 0 as well. Again, 5 is also not present, so we will add entry 5 over here, and its index value 1 over here. 2 is also not present, so 2 and 2. And again 4 is not present, so 4 and the index value is 3. So we add these 4 entries in our hash map. At the same time, we can check that currently, since the value of k is equal to 3, we already added 4 elements, and still we were not able to find any duplicate entries, which means we will have to update our window. So in order to update our window, rather than getting rid of all the items, what we can do is we can just get rid of the first element, and then we can just shift our window to include one more entry inside our input, and that is going to be value number 5 for the index value position number 4. So again we add 5 over here. At the same time, since we got rid of the first index value, we are going to also get rid of that inside our hash map. So we are going to get rid of the first entry, and currently we have 3 entries. Again, we will try to check that whether 5 exists or not. So we will try to input 5 inside our hash map, but we would be able to immediately find that 5 is already present as a value inside our hash map, and immediately we can return true, saying that this contains duplicate inside a k window. And see, what we did is that initially our window was consisting of this value number 0. We got rid of the only 0th value. We kept the remaining values inside our window, and we simply added a new value inside our hash map. And then we were able to immediately identify that whether this is the correct response or not. And say for an example, if somehow this value is not value number 5, this is value number 11 or something else, this does not contain any duplicate entries, what would happen is that every single time we would get rid of the last element from our hash map, and we would keep on adding new values to our window, and eventually we would reach to the end of our input, and if we don't find any answer, we can simply return false in this case. So if we see time complexity in this scenario, the time complexity is actually going to be big O of n only, and since for this case we had to use a hash map of size k, the space complexity is going to be big O of k. But this is a very wonderful and beautiful approach to solve this problem. So that is why the sliding window technique is really powerful, because you are already building your solution upon the already calculated computed values. You are not doing everything from scratch, and that is very powerful in making your inputs more efficient. Okay, so for this problem, I'm not going to write the entire code. I'm just going to give you the explanation. So first we are going to initialize our hash set, and I mentioned that we can use hash map or hash set, anything. In this case, we are using hash set. Now we are going to iterate over the given input array using a for loop. First thing we are going to do is to check that whether our set contains the current value, current ith position of value we are at. If that is the case, we can return true immediately. If that is not the case, we would add that entry to our hash set. At the same time, we would check that if the current size of hash set, if that is greater than our given input k, if that is the case, then we need to remove the earliest entry inside our hash map, and we can calculate that using the number of ith index that we are currently at minus the value k. and then if we remove that value from the hash set, our hash set is only going to contain only the k elements, and then we can keep on repeating the same process until the very end. If we haven't returned true by then, we can return false in the end, and this is going to be the whole solution. Let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently compared to a lot of other solutions. And I would be posting this in the comments so you can check it out from there. Thank you. So the lead code problem we are going to solve now is called valid anagram. We can see that this one is a lead code easy problem and also an extremely well-liked problem. Basically, we are given two strings s and t. Now we need to return true if t is an anagram of s and false otherwise. Now, what is the definition of an anagram? Basically, if every single character that is currently present in t is also present in s, then they are anagram of each other, not more, not less. So let's try to take an example. Suppose in this case we can see that currently s has the words cat and t has the word tech. Now we can see that c is present on both, so that's good. Same way a is present on both, and same way t is present on both. So we can say that in this case s and t are anagram of each other, so we can return true in this case. Now if we take one more example, we can see s contains r, t also contains r, so that's good. S contains a, t also contains a, but the thing is currently s has m that is not present inside the t. So in this case we can say that t is not an anagram of s, so we can return false. And basically this is what we need to return. So let's try to see that what is going to be the most common brute force approach to solve this problem. Suppose we are given s is equal to rat and t is equal to tear. Okay, so in this case, as part of the anagram, what we'll do is we'll take a character inside the s. For this, we will iterate over every single other remaining character inside the t to make sure that whether that character is present or not. If it is present, we can remove it from here, from both sides. Same way, we will repeat the same operation for all of the different characters, and we will come to the solution. Now, if you see, this approach would yield correct result. But the thing is, if you see time complexity, basically it's going to be big O of n square, because for every single character present inside the s, we will have to check against all the remaining characters inside the t, which can be quite expensive. So this is like a bad approach. Now let's see that what would be the optimal solution in this case. And the logic is that first of all, we will have to check that if the given s and t, if they are to be anagrams of each other, basically their length has to be same. So first thing we will check is that if the length of s and t, if they are same, that's good. Then only we will proceed. If they are not same, we don't even have to check that whether they are anagrams of each other. So this would eliminate like all the bad examples. Okay. Now let's see that what is going to be the logic for the given subsequent s and t. Let's say that the current s has the word cart and the current t has the word rat, RATC. Okay, they are the anagrams of each other. Now we already know the pre-existing condition on what defines an anagram, that the frequency of any particular character present at s and t are going to be same in no matter what. So this fact we are going to use to basically come up with a clever solution. Now first approach is that we actually use a hash map, or second approach is that we basically use an array. Now why we are able to use an array in this case to solve the problem? Because we know for a fact that English language only has 26 characters. So we can actually initialize a character, an array with 26 size in it, and based on the index position we would mark like subsequent positions within the characters. So let's say that if we are dealing with character a, then a has to be present on the first index of our array. Same way b has to be present on the second index of the array. Okay, once we have an idea on how we are going to keep track of the frequency, now what we need to do is that frequency has to match both on s and t. So for that, what we will do is we will start iterating over for s and t at the same time. We know that they are both at the same length, so we can just use one for loop or one loop to iterate over them. For every single character that we find, we are going, and for each of them we are going to initialize values with values 0. Okay, and now let me just arbitrarily mark values like C, A, R and T. So C, A, R and T, these, let's assume these are the values. Like actual values would be different based on their character positions. I'm just putting it here so that it would be easier for us to visualize. Okay, so first we have character C at position number S. All we are doing is that whenever we find a character in S, we are going to increment the counter within the array. And if we find a character inside the T, which means we find like a subsequent reciprocal character, so then we are going to decrement the counter. And how it is going to work is, first we identify character C over here. So we are going to increment the counter to value number 1. So let's just mark this as 1. Subsequently, at the first position, the value is R. So once again for R, we are going to decrease the counter. So this is going to become -1. Okay, now for A, once again, we are going to increase the counter based on this S, and we are going to decrease the counter because this is also A, so that this would become -1. So basically overall this value would become 0 after this change. Okay, now next we have R. So in this case we are going to increment R. Now notice the value of R is already -1, so we will turn it back to 0, and this value is T. So currently T is 0, so this value would become basically -1. Okay, and last one is T. So in this case, notice that T is going to become 0. So let's just mark T as 0, and this value is C. So we will have to reduce the value of C. So if we reduce the value of C, basically this is going to become 0 as well. And now notice that after iterating over all of this, we found out that every single character that was present inside the S is also present inside the T. And what is the way for us to check it? We simply iterate over this given array once. If we find for any particular character that there exists some value that is other than 0, then we can simply return false, saying that they are not anagrams of each other. And let's take that as that example as well. That let's say over here inside the input, let's say that this value is still cart, and this value is over here, it's, let's say, RATO. So notice in this case, this C would have remained 1 because we had C over here that was not present inside this T. And notice that for this character O, let's say that this is the character O, this value would have been -1. So overall, we would have like more than one values that does not contain value 0. And we can explicitly say that because this is the case, we can simply say that they are not anagrams of each other. So this is a very fast and beautiful approach. Now let's try to calculate time and space complexity in this case. Time complexity is going to be big O of n, where n is the total number of characters present inside the S or T. And in terms of space complexity, well, this is still going to be constant space complexity, because even though we are initializing an array, the maximum length of that array is going to be 26 characters only, which is a constant space. It is not continuously growing, and it doesn't change with the given original input. So that's why this is a beautiful time and space complexity. And now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. First, we will check that whether the length of S and T are equal or not. If they are not equal, we can simply return false. If that is not the case, we will initialize our array called character counts, that is going to be of size 26. Then we will increment the count for every single character that is present in S, and decrement the count for every single character that is present in T. And we can just simply update the character counts array that we have just initialized. And after that, all we need to do is to check that if in the character count array, are there any other values that are not 0? The moment we find a non-zero value, we can simply return false, saying that S and T are not anagrams of each other. If we do find all the values are 0 and get out of this loop, which means they are anagrams of each other, and we can simply return true. So let's try to run this code. Seems like our solution is working. Let's submit this code. And the code beats nearly 45% of all the other solutions, which is pretty good. If we see memory, it beats nearly 80% of all the other solutions, which is awesome. So once again, the coding solution is present on our GitHub repository. Feel free to go and check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do group Anagrams lead code problem, and this problem has been really popular at some of the companies where I want to get a job. There are companies like Amazon, Microsoft, Facebook, Apple, Google, Affirm, Snapchat, Goldman Sachs, Uber, Bloomberg, Netflix, Instacart, ByteDance, and Twitter have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given an array of different strings and we need to group the anagrams together. Now we can return the answer in any order, so which is good for us. And we are also given the definition that what is an anagram. Anagram is a word or a phrase that is formed by rearranging the letters and then it turns out to be a different word. So if we take an example, suppose we are given a word like bat, then we can say that these all are actually anagrams of this original word bat, because the B, A and T, they are all occurring in all of them in the same number of occurrence that it is present in this bat. So now after understanding that what an anagram is, let's try to see some examples to understand that what this question is asking us to do and what is the expected answer we need to return. If we take this first example, essentially we are given S is equal to array of string that looks like this. Now over here I have clearly marked all the groups that can be potentially done in separate colors, so you can clearly look at them. But the thing is, let's try to understand. So first of all, we are given this word EAT, eat. If we see what are the number of occurrences of characters, there are characters E, A and T occurring 1 times each. Now same thing happens for this word TEAT and for this word ATE8, which means we can conclude that all of these 3 words are actually anagrams of each other and we can group them together in one single group. So that we are done with all of these 3 elements. Now next item we see there are 2 words tan and net. Again TAN, this all 3 of them are occurring once, these 3 characters for both of these values, so we can also group them together. Now for this BAT bat, we actually don't have any other value that we can consider it as an anagram, so this particular string will be a group of itself, which means in this case we can return an answer that looks like this, and we can return this as an answer. So clearly you would find that this answer, actually the sequencing is done slightly bit different than what is the answer given in this output. And the reason for doing that is that I wanted to show that we can return answer in any order. So that is the important part over here, that is specified in the question, that we can return the answer in any order. So that's why I ordered them differently, but as long as the groups are correct, we are good to go. One better way to solve this problem is actually by using sorting. And how we are going to use the sorting is that we are actually going to create another array for every single entry that is present inside this original S, and for all the elements that are present over here, we are going to actually sort them in alphabetical order. And then all we have to do is just we will have to iterate over this newly created array once, and we only need to find that what are all the similar pairs or all the similar values, and then we can simply return them as answer, and that makes our life much more easier. Let me quickly show you what I'm suggesting. So based on this array, we will actually create a sorted array, and the sorted array is going to look something like this. So now we have created our sorted array, and which we have derived from this original S. Now all we will have to do is we pick up any word or any string, then we just have to compare with all the other strings and find that which strings contains the same value. Whichever string contains the same value, we will take their values from the original string, because we know that they're index values, and then we can group them together. So the idea is, first of all, we'll take this string AET, then we find that okay, this and this, both of them, so the strings located at position 0, 1 and 3, they are all part of this original string that should be in the single group. So we will group them together. So in the answer we will mention eat, T and 8 as one group. Then again we will repeat the same process. So we find this ant and ant, so again we will group the whatever values located at this string at this index 2 and 4, and we find the values 10 and net, and in the end we will return this bat because it's the single one. So this solution would work fine. We will get our desired answer. If we see the time complexity, in this case the time complexity is actually going to be big O of n log n, just to create this original sorted string, multiply by k, and this k is actually the biggest length of the string that we will have to compare, and this would be the final time complexity. So this is much bigger improvement than our brute force approach, which was giving us the big O of n cube time complexity. Now let's see that can we improve any further in this one as well. Okay, before we come to the optimal solution, we will have to ask a very important question, that how do we determine that any two words are anagram of each other or not? Suppose we are given two words like ABC and CBA. We can clearly see that they are actually anagrams of each other, but how can we explicitly define that, yeah, they are truly anagrams of each other? Well, we can define that based on the number of character repetition in each one of them. That any character that is present in this ABC, it is also present in the CBA in the exact same number of occurrences that both in both the words. So in other words, A, B and C is present exactly once in this particular word, and it is also exactly once present in this particular word, though the arrangement is different, and that makes them anagram of each other. Now you will ask that why am I dragging so long on this pretty trivial question that we already know the answer to? Well, we are actually going to use it to our advantage, and the good thing for us is that English language only has 26 characters. So because English language has the 26 characters, we are actually going to use it to our advantage. We are actually going to create an array of all the values that are initially located as 0, and that is going to be of size 26. Now any character that we identify in any single string, we are actually going to add it to our array, and we are going to increase the value of that particular character sequence, and then whatever the answer of that array is, we are going to put it in a string, and then we are going to use it as a key for our hashing hash map, and then we are going to do some interesting things. So let me quickly show you that what is the full plan. Suppose over here we are given an array that looks like this, right? Now we have this given word ABC. So what we are going to do is, initially all of these values, they are defined as 0 by default, but now we are given this ABC. So first of all, we take this A, we increase its value to 1. Again we get this B, we increase its value to 1. Again we get this C, we increase its value to 1. Now all the other values, they are 0 so far. So for this particular character, we can actually create a string based on this given array of 26 words. So string would be maximum of size 26, which means it is a defined finite number, which means we can create that. We will get a string that looks like this, 111, and then remaining 23 zeros. Again we are given this word CBA, right? So again what we are going to do, first of all we identify this character C, so we are going to mark its value as initially this was 0, so we are going to mark it to 1. Again this B, again we will mark it to 1, and again this A, we will mark it to 1. All the other values would be 0. So even for this one, the string that we are going to generate is going to look like this, 111 and 000. Now the idea is that we will create a hash map. Now inside this hash map, as a key part, we are actually going to keep track of whatever the string that we are building. So let's just name this as string builder, that we are building a new string, that would be our key. Now in both the cases, notice that for this ABC and for the CBA, this string value is actually going to be the same, that it would be 111 followed by 23 zeros in both the cases, which means that they both have actually same key value, which means that over here, okay, this is 111 23 times. But in both the cases, as the value, we are actually going to keep track of a list, and inside this list we are going to store original words that were presented as an input for this original array string that we built. So over here, first of all, we will have an entry that looks like ABC, and then we will have an entry that looks like CBA. Now we already have both the values that is part of the same group, or they are, and which is an anagram of each other, would be in the list value, which means that makes our life much more easier. That in the end, all we need to do is just we need to return this whatever value we have stored in the list. Let's do this with one of the example that we have been following so far. So I'm not going to show you the whole ordeal with the array because that is too time consuming. I'm just going to show you that what would happen inside the hash map. So this is our hash map. Now as a key, we are going to have some string value. So first of all, we get this value eat. So suppose for this value number eat, we get a string that looks something like this, right? Whatever the value is. Now this same value is going to look for this t and for this 8, which means that these values eat, then t and 8 would be a part of the same value group inside this hash map for the same key. Again, same thing will happen for this tan and nat. So even again for this tan and nat, suppose we get some value, that string that looks like this, right? I'm just drawing a bunch of gibberish, but you get the idea. and we will add an entry for tan and net because they both will have the same number of occurrences of characters. And in the end for bat we won't have any entry, so we will have a new entry over here and where we will add the value bat. Now in the end all we have to do is just iterate over all the values that are present inside this hash map and return it as our answer, and this would be the optimal solution we are going to use. If we see the time and space complexity for this one, the time complexity is actually going to be big O of n times whatever the maximum length of k is. In terms of space complexity, we are actually creating an additional hash map, so that's why that is going to take some additional space, but this is also going to be big O of n times k, where k is the longest length of any given string and n is the number of strings that are present inside the given input. So first of all, we are going to check an edge case that if the given string is empty, we are going to return an empty array list immediately. Okay, if that is not the case, we are going to initialize our hash map and we are going to take string as key and list as value. Also, we are going to initialize our array of size 26 and we are going to name it as count. Once that is done, we are going to run a for loop across the given input string. So first of all, we are going to initialize our array with value 0. After doing that, we are going to iterate over this given string s and we are going to add all the characters inside this given array by adding their value from 0 to 1. After doing that, we are going to initialize a string builder to store the string value that we have retrieved inside this character array. Now we are going to run across the count array and we are going to add all the values to our string builder. Also at the same time, we are also going to add a hash before all the elements inside this given count array, and that is something per language trick that changes. For Python you won't have to do it. Once this is done, we are going to assign this new string that we created as a key for our hash map. Now we are going to check that if this entry for this given key already exists inside the hash map. If it does, we are simply going to add whatever the string s that we are iterating over, and if the entry does not exist, we will create one value inside the hash map and then we will add this value s for this given key. And we are done for this for loop. Now all we will have to do is return all the values from this answer map and return it in the manner that is asked inside this given question. So we will have to return a list of lists. Let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit this code. And our code works as expected. I will be posting the solution in the comments so you can check it out from there. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do product of an array except self lead code problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Apple, Uber, Bloomberg, Lyft, Google, Goldman Sachs, IBM, Twitter, TikTok and LinkedIn. So that's why I am paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well like problems on LeetCode. Basically we are given an integer array called nums and we need to return a new array called answer array such that every single value of that particular index position inside this answer array is actually equal to the product of all the other values that are present inside this given nums array except that particular ith element. So suppose we are given an input array that looks like this. In this case, we will have to create an answer array for the answer, and that would be of the same size of whatever this input array we are given. Now in this answer array, suppose we want to enter the value at this second position or corresponding to the second index value. What we are going to do is we are actually going to take the product of this value number 1, 3 and 4, and whatever the product of these three values are, we will actually put it as the answer for this value. Same thing we are going to do for this next value, where we are going to take products of these two elements and this element, but we won't take the product of this element from this original given input array, and whatever the answer is, we will actually put it over here inside the answer array. In order to enter this first element, we will actually have to do the product of these three values. So then the product of these three values is going to be 24. Now for the second element, we will have to do the product of this first element and this last two elements, so that is going to be 12. For this third and fourth element, we will again repeat the same process, and we will get subsequent values like 8 and 6 by doing the corresponding products. And at the end, we will have to return this as the answer array. And basically this is what the problem is asking us to do. Even the name is also self-explanatory, that we need to return the product of an array except self. But we are given a very specific declaration over here, that we need to use it in big O of n time without using the division operator. And why it is asking us to use solve this problem without using division operator? Because if we were allowed to use division operator, suppose we are given an input, we can just do the product of all of these value and we will get an answer called 24. And then all we have to do is, for this answer array, we will take this value 24 and then we will iterate over this input array and start dividing it with this 24. So even in the answer we will get, if we divide 24 by 1, we will get the value as 24. If we divide 24 by 2, we will get value 12. If we divide 24 by 3, we will get value 8. So on and so forth. So it would become very easy for us to solve this problem. So that is why they are explicitly asking us that we should not be using the division operator. Now the most basic brute force way to solve this problem is, actually we take any single value and then we iterate over all the remaining values and do its product and put it in the answer array. So we will create an answer array that looks like this. We will first take this value, so we will iterate over this given nums array, and for all these three values we will do its product and we will get the value as 24. Now again we will repeat the same process, but this time we will be iterating over the second element. So because we are iterating over the second element, we will take this first value and we will take these two values and we will do that sum, so we will get value number 12, and again we will repeat the same process. So essentially this is bound to give us the correct answer and we would get it in this case. But the thing is, this would not be the correct way. Why? Because if we see the time complexity in this case, the time complexity is actually going to be big O of n square. Why n square? Because we will have to iterate over this array. For every single character we will have to iterate once, and even for any particular character we will have to iterate over all of the other values again just to find their product number, and that takes n square time, and we are explicitly told that we will have to solve this problem in big O of n time. So let's see that what would be the way to achieve that. Okay, so now for the better approach, we will actually have to put down one intuition to use. And the intuition is, suppose this is the element we want to get the product for in the answer array. So the idea is that we are actually going to take the product value of first two elements and we will take the product of this last element. Again, if we take this portion, this value number 2, we will take the product of all the elements that are present on the left of this value number 2, and we will take the product of all the elements that are present on the right of this product number, this value number 2. So that is the idea, that for every single location we will have to take product of all the values that are behind or pre to that particular level. So we can call it as prefix, and all the values that come after that value, and we can call it postfix. So now the idea becomes quite simple. What we are going to do is, we are going to have two arrays called prefix and postfix, and we are going to iterate over this nums array once, and for every single position we are actually going to keep track of all the values that come before it and after it, and we are going to put down their values like their product values, and at the end we will just do a multiplication between this pre and post arrays, and then we should get our answer. So let's see that in action. And also one more thing, that because for this particular element that are at the edges, so for this value number 4 there is nothing on the right side, so like we can't do anything. But for the simplicity purposes, we will consider that anything on the right side is actually 1, because anything multiplied by 1 remains the same. And same thing we are going to do for this left edge as well, that because for this value number 1 there is nothing in the prefix, so again by default we will treat this as value number 1 as well. So that will help us in doing some counting, right? So let's see that in action. So first of all, for this value number 1, we are calculating the prefix values. So this 1 actually has nothing on the left, but it only has 1, so we will do 1 times 1 and we will get the answer as 1. Now for this value number 2, actually all we need to do is, whatever the left element is, we just need to do the product of all of them. So the left element in this case is only 1, and we will just put it over here as well. Now in this case, the value number 3, we will have to do product of all these elements. So one way to do it is to do this like 1 times 2. So do the product of all these two elements, but that is actually time consuming. One better way to do it is that if we take this particular element value number 2, this already contains the product of all the values that are present before that. So why are we doing the effort of doing the product of this value number 1 and 2? That is just costing us additional resources. The better approach is that we, for this value number 3, we are over at this position, all we have to do is we just take whatever the value we have stored over here, which is the prefix of all the values before this value number 2, multiply by whatever this value is present, and that would be the prefix sum for this value number 3. So what we are going to do in this case is we will take this value number 2. So we will take this value number 2 and we will take this value number 1 from here, from the prefix array that we have already calculated, and we will do 2 times 1. In this case we will get value as 2, so we will add 2 over here. And again for this value number 4, again we are going to repeat the same process. So now this time we are going to take the value before 4, that is 3. So we will take 3 and we will multiply it by whatever value we have already found in this prefix array, which is 2. So 3 times 2 is actually going to be 6. So now we are done with this prefix array. Again we are going to repeat the same thing for the postfix array. So this is the edge value, so we can simply do 4 times 1. So we will add the value 4 directly over here. Now this is value number 3. For this value number 3, all we will have to do is just take product of this value. So this is already 4, so we will again add 4 over here. Now for this value number 2, all we have to do is we will take the value, this whatever value that is present over here, 3, multiply by whatever value we have already calculated in the postfix over here, which is 12. So we will have a value called 12 over here for this element number 2. And now again for this element number 1, we are going to repeat the same process. So we will take this 2 and multiply it by whatever value we have calculated inside our postfix array, and this is going to be 2 times 12. Okay, now we are done with both of our arrays. Now the task is actually quite simple. Now we will create our answer array, and we are going to simply do the multiplication of every single one of these values. So this becomes 24 times 1, 24, this becomes 12, this becomes 8, and this becomes, oh, I made a mistake over here. This has to be 1, not 4, because we are actually doing the multiplication of all the elements that are present on the right side of this value. So this would become 6, and this is the solution that we are going to do. This solution actually works perfectly fine. There are no issues with that. If we see the time and space complexity in this case, the time complexity is actually going to be big O of 3 times n. Why 3 times n? Because we will have to iterate over this n to first of all create this prefix array, then we have to iterate over n times to create this postfix array, and then again we will have to iterate over both of them to create this answer array. So we are doing like 3 times n work, but in general we can write this as big O of n. And in terms of space complexity, we are actually creating a couple of arrays, so we also have to do big O of n as space complexity. So the idea is, can we do something better? And the answer is yes. There is one way to actually do this, both prefix and postfix array in a single array, and that too inside the answer array that we are planning to create. Okay, so let's keep the same example, and we want to find the optimal solution for this one. Well, the idea is that rather than doing two separate prefix and postfix arrays, we are actually going to create an answer array, and we are going to add all the values, and now we are going to do prefix and postfix multiplication inside the same answer array. And let me quickly show you how. First of all, we are going to use a couple of variables called prefix and postfix. So let me add their values, and by default they are going to have value as 1. Now what we are going to do is, first of all, we are going to iterate over this given input nums, and we are going to calculate the prefix for every single element inside this answer array, and we are also going to update the value inside this pre function or pre variable. And then again we will iterate in the reverse order, and we will keep on updating the postfix values inside the answer, and by the time we are done, our answer array should have been completely filled out. Let me quickly show you that in the action. So first of all, for this value number 1, this is actually the prefix of every value that is present behind this 1, and the multiplication of all of those values. So because there is nothing over here, we can consider this to be 1 by default. So I'll not write it over here. I'll just write over here that for this first element inside this answer array, the nums actually does not have anything on the left side, so we can consider this to be 1. Now we are going to we are at this second position. For the second position, what we are going to do is, we are going to take the multiplication of whatever the value we have on the left side, right? So even on the left side we only have value 1, and even the prefix value is also 1 so far by default, so we are going to add 1 over here again. Now we are at this value number 2 or 3. So for this value number 3, what we are going to do is, we are actually going to take the value that is before that, which is 2, and we are going to multiply it with whatever the pre variable we have. So we were also doing the same thing for this value number 2 as well, but because both the values are 1, we were not getting any other result. But in this case we will actually get a result of 2, and because we are getting a result of 2, the result of pre is also updated, also being updated to value number 2, because it will help us to know further down for the next elements that what is the value of prefix. Now we are at this value number 4, so again we are going to repeat the same process. We will take this value number 3 and we will take whatever the value of this prefix we have, which is 2. So 3 times 2, the value is 6, so we'll add value 6 over here. Okay, and now we are done filling up this prefix portion, and we have taken the prefix of every single element inside this answer array. Now we are going to do the reverse order. Now inside the reverse order, again for this value number 4, actually there is nothing on the right side of this value number 4, which means there is nothing on the postfix, so we can consider it as 1. Now because this is already 1, what we are going to do is whatever value we have calculated so far, we are going to multiply it. So if we multiply 6 by 1, the answer we get is 6. Okay, so far for this value number 4, the answer is 6. Now we are at this value number 3. For this value number 3, what we are going to do is we will have to calculate everything on the postfix side. So this value is 4, so we are going to take value 4 multiply by whatever value of this postfix variable we have, which is 1. So 4 times 1 becomes 1. So now we have the value as 4 for this postfix. So we are going to update the value of the postfix to be 4, and we are also going to multiply this 4 with whatever the value we already calculated for this value number 3, which is 2. So 4 times 2 is going to be 8, and this is going to be answer for this value number 3, that this is the product of all the numbers for this value number 3 except itself. Now we are at this value number 2. For value number 2, we are going to take value number 3 multiplied by whatever the post variable we have. Post variable is actually 4, so 3 times 4 is actually 12. So we are going to update that value over here first of all. So now we have the value 12 over here, and we will have to take this 12 and multiply it with whatever value we have already stored over here, which is 1. So 1 times 12 is also 12. And now again we are at this last position. So again for the last position, we are going to repeat the same process. We will take whatever the value that is after this value number 1, which is 2. So we'll take this 2, we will multiply it with whatever value we have stored inside this post variable, which is again 12. So 2 times 12, and this becomes actually 24. So we will do 24, and we will take 24 multiply by whatever value we have already stored inside this answer array, which is 1. So 24 times 1 becomes 24, and this is the answer. And if you look closely, this actually becomes the complete answer that we are looking for, and we have actually done everything in place without using any additional data structure or any additional array, and we don't have to use basically any extra space. So this is the best way to approach this problem, and this is the solution that any interviewer would want to see. If we see the time complexity, in this case the time complexity is actually going to be big O of 2n. Why 2n? Because first of all we are iterating over from left to right, calculating this pre variable, and then we are iterating on the reverse order, calculating this post variable and updating the values, but still, which is good. If we see the space complexity, in this case, well, space complexity is actually constant because we are not using any additional space. For this answer array, we are given inside this question statement that we have to create a new array, so that we are anyways going to create, but apart from that we are only using couple of variables to store some data, and that's why this is a very good approach. Now let's move on to coding. First of all, we are going to create a new array called result, and by default we are going to set all the values as 1. We are going to initialize the two variable called prefix and postfix, and we are going to assign the value as 1 for both of them. Okay, now we are going to run our first for loop to iterate from left to right, and we are going to update the value of prefix inside our answer array. So first of all, we are going to update the value inside our result array, and then we are going to update the value of our prefix variable. So after this loop ends, basically we should have prefix values filled out for every single position inside our result array. Now we are going to run another loop, and we are going to come in the reverse order. And first of all, we are going to update the value inside the result array. So any single value inside the result is actually going to be multiplication of whatever the value we already had, multiply by postfix variable. We'll also have to update the value of postfix variable. We are good to go. Oh, actually I made a mistake. This should be pre only, not prefix. Okay, and after this second loop ends, essentially our result array should have been populated, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. and our code runs pretty efficiently compared to a lot of other solutions. So that's why this is really good approach. I would be posting the solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do top k frequent elements lead code problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Microsoft, Google, Uber, Apple, Bloomberg, Snapchat, Twitter, Tesla, Netflix, ByteDance, LinkedIn, eBay and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a lead code medium problem and also very well like problem on lead code. Basically, we are given an integer array called nums and we are also given a separate integer called k. Now we need to return the k most frequent occurring elements from this nums array, and we are also told that we can return the answer in any order. So first let's try to understand this problem with this example. I have actually drawn it much bigger over here. So this is the array nums that we are given, and we are given k is equal to 2, which means we need to return top 2 elements that are present inside this given nums array, right? So if we see in this case, well, over here this 1 is actually present 3 times, this 2 is actually present 2 times, this 3 is actually present 1 time. Now if we see, we are given that k is equal to 2, which means we need to return top 2 elements, and clearly we can see that the top 2 elements in this case is this 1 and 2. So we can return the answer to be 1 and 2, or we can also return 2 and 1, because remember we are told that we can return answer in any case, and this is the answer we need to return. So let's try to see that what is going to be the approach to solve this problem. Now let me make one clarification. There are actually 2 different approaches to solve this problem. One approach, or the first approach I'm going to show you in this video, is actually sufficient for your interview. Any interview would be more than satisfied with that approach. But the thing is, the second approach I have is actually the golden key approach for any like top k element problems, right? Any heap problems, you can use the second approach, and I'm actually planning to make a separate video on that, depending on whether you want to learn it or not. So let me know in the comments that whether you want to learn this second approach. If you do, I'll make a separate video. We are actually going to use the combination of a hash map and a heap in order to achieve the top k elements. So I have created a custom example over here, and I have given the value of k is equal to 3. Now remember, whenever we need to define that, we need to return top k elements or top 3 elements in this case. How can we define that? Well, we first of all need to iterate over this given entire array. We need to find that how many times any single character is occurring, and depending on that answer, we will have to iterate over that whatever the list we create, where we have the number of occurrences for each character, and then we can conclude this answer. So one thing is clear, that we need some way to store the information that how many times any particular individual character occurs. For that, we are actually going to use the hash map. In the hash map, as the key, we are going to denote the distinct value of this given array, and as its value, we are going to note the occurrence of that particular character. So first, let me quickly create a hash map for this given input, which contains the distinct values and their occurrences. So based on this given input, this is the hash map we can create. Now we need to select k is equal to 3, which means we need to provide top 3 elements. Now one approach to find the top 3 elements is that all the distinct values we have in this hash map, if we just simply create a sorted array, and in the sorted array we sort the arrays based on the descending values, which means the most occurring value to be first, and then we put down all the remaining values, we can actually generate a sorted array that looks like this. And now for this particular sorted array, we can simply return the top 3 elements. So we can return the answer to be like 4, 3 and 5 easily. And this is the solution that would give us the correct answer. But thing is, you would quickly ask me that why did I mention priority key over here? Because over here, what I'm doing is I'm taking this hash map and I'm actually just sorting it, and we are able to generate the array. Well, first of all, in order to understand that, first of all, let's understand the time complexity of this approach. The time complexity of this approach is, first we need to iterate over the given entire input. For that, it takes big O of n time to generate this hash map. After generating this hash map, we will have to create the sorted array that takes n log n time to generate that answer, and this n log n is going to be the ultimate time complexity. So the thing is, this you would say, hey, n log n sounds reasonable, but the thing is, from n log n, suppose we have like 1 million distinct characters or 1 million characters, and we are given k is equal to 3, which means that we would have done like 1 million times log 1 million work. Meanwhile, the value of k in practice is supposed to be much smaller than whatever the input size is going to be. So the other approach is that if we create a priority queue, and remember, the concept of a priority queue is that inside the priority queue, basically we add the values and we remove the values, just like any queues. But thing is, the values that we are entering, they have some meaning behind them, and depending on their valuation, we actually store the value. So whenever over here, suppose this is the priority queue and I have provided different weight to those elements. If I want to create, or if I want to enter an element that is in higher weight, then I would get rid of only the lower weight elements and add those over here. I would not be repeating everything. So based on that concept, what I'm suggesting is that rather than sorting this array, we get rid of it. Okay, so let me clean this up a bit. And over here, from this actual hash map that we have created, we actually create a priority queue. And this priority queue is going to be of whatever the size we are given of the k value. Okay, so k in this case is 3, so we are going to only have 3 values in our priority queue. Now for our priority queue, first of all, we are going to check that, okay, we only enter the values based on the number of occurrences they have, and we only keep the higher number of occurrences. So first we add the value number 1 over here because we don't have anything. Now we add value number 2 over here because we still have room and 2 has 2 occurrences. Then we add value number 3 because 3 has 3 occurrences. And remember, we are using the occurrence to add the value, not the actual distinct value, right? This is the key part. Okay, now we have this value number 4. 4 actually has 4 occurrences, right? And so far, if you remember, this 1 had 1 recurrence, this 2 had 2, and this 3 had 3 occurrences. Now we have a value that is 4 that has actually 4 occurrences, which means it is greater occurrences. So we are able to insert that value inside our priority queue, and in that case we are actually going to get rid of the smallest value. So smallest value in this case was 1. Now we are not going to add 4 over here, but we are also going to maintain the ascending order in terms of the values that we are being added. So we'll just shift these values. Okay, so 2 will come over here, 3 will come over here, and 4 will come over here, and then we will have those subsequent values. Now after adding this, we still have value number 5 that we need to add. So 5 occurs 3 times. So 5 occurs 3 times. Currently we have 2 occurring 2 times, 3 occurring 3 times, and 4 occurring 4 times. Now 5 occurs 3 times, so 5 is able to enter over here because it occurs more times than this 2, and we can actually put 5 over here because it is also occurring 3 times, and this 3 is also occurring 3 times. So we are good up until this point. After that, all we will have to do is just convert this result into an array. So for that particular array, we are actually going to store the results, and remember, we can return result in any manner. So we can return like 5, 3, 4, or we can also return like 3, 4, 5, or whatever result we want to return, we can return. And this is going to be the solution. If we see time complexity in this case, the time complexity is actually going to be a bigger improvement than our sorted array approach. Why? Because okay, over here this takes big O of n time to generate this hash map. That process remains same. But now from generating this hash map to this priority queue, it takes n log k times because we are only maintaining k elements. This is the important part, and this is what your interviewer is going to focus on. So in this case, the time complexity is actually going to be big O of n log k, which is good. And in terms of space complexity, well, you must have guessed it correctly. It's big O of n because we are using a couple of additional data structures. We are using a hash map, and we are also using a priority queue. And this is a very good time and space complexity. And that is basically the ideal approach. Now let's move on to the coding. First of all, we are going to take care of an edge case that if the given k is equal to whatever the length of this nums is, we can simply return nums. That is not the case. We are going to initialize our hash map. Now we are going to iterate over all the elements that are present inside this given nums. So we are going to run a for loop, and after the for loop ends, we are basically going to populate the values inside our count hash map that we have just created. Now we are going to initialize our priority queue, and inside our priority queue, we are going to assign the method of insertion. So we are inserting based on the number of occurrences based on this count hash map. So let's put the condition for that. So now everything is set up. Now all we have to do is just iterate over all the keys that are present inside this count hash map that we have created, and for every single key, basically we are going to add that value to our heap priority queue, and whenever the priority queue gets full to the size of this k, we are basically going to pop the element, and the element that will get popped is going to be the least occurring element. So we are only keeping higher occurring elements inside our heap. And now we check that if the heap size becomes greater than k, we remove the value from heap. That's it. So now all we have to do is just simply initialize a new array variable called answer, and we are going to populate this answer array. So we will run a for loop for k times, and we will keep on pulling the values from our heap. Then we can simply return the answer, and let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs pretty efficiently, and I will be posting this solution in the comments so you can check it out from there. Thank you. So we are going to solve a very interesting lead code problem today called Roman to integer. And if we see some of the popular companies who have already asked this question, there are companies like Amazon, Adobe, Apple, Google, Microsoft, Bloomberg, Facebook, Uber, TikTok, LinkedIn, and Goldman Sachs. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code easy problem and also a very valid problem. If we understand the problem statement, it's quite simple. We are given a Roman language number and we need to convert into a decimal system integer. Basically that's what it is asking. Suppose we are given a value that looks like XX, then in this case we need to return 20 as the answer, because that is what it means in the normal decimal system. Suppose we are given the value of like I, we need to return 3 as the answer, because 3 is what represents as I in the Roman numericals. Now we are given a very extensive definition that what every single symbol means and the Roman to its subsequent value, and also what are the different symbols and what are the rules of the Roman language. Now these things are pretty easy to comprehend. There is only a little bit complication when this condition comes in, where it says that suppose a smaller value is placed right before the larger value. In that case we need to make a subtraction. So I in this case means 1. I is a smaller value and v is a bigger value, which means 5. Now typically if we put any values like vi, what we are going to do is we take the value of v, so which is 5, and we take the value of I, which is 1. So 5 plus 1, it is 6. So we need to return 6 as the answer. But the thing is, when we are in a condition where the smaller value comes before the larger value, so say for an example iv, this is one of those scenarios. So in this case, actually we are going to subtract the value of I from the larger value, and that is how Roman numerical works. So in this case, the answer is going to be 5 minus 1, so 4. 4 is what we need to return. And there are 6 such cases where these numbers can happen. These 6 cases are, so these are 6 new values that we have been able to identify based on the rule of a smaller value being placed exactly before the larger value. Okay, so I have drawn the value conversion table over here, and now first we will try to understand that how does a numeric system work in the decimal formula. Suppose we are given a value like 1521. How does this value is being generated? Well, this is a decimal format. So in the decimal format, the value is being generated by 10 to the power of whatever the number of values that are present after it, and multiplied by that particular value. So let me explain to you that how does this value has been formed. This value has been formed by doing multiplication of 1 multiplied by 10 to the power of 3, because there are 3 values present after 1, plus 5 multiplied by 10 to the power 2. So if we do sum of these two, we get the answer of 1000 plus 500 plus 20 and plus 1, and sum of all of these is actually leads us to the value of 1521, and this is how this value has been actually broken down. Now in this case, if we see, the largest value is always presented first, then the second largest value, then the third largest value, and then the smallest value, and this is how the numeric system works. Same logic applies
to the Roman integer for the most of the parts. And the logic is quite simple. So suppose in the input we are given the value of, how do we know that what integer does this value represent? Well, the answer is quite simple. All we will have to do is we will have to see in this table, fetch its value, and then keep adding the values by itself. So in this case, okay, this m is represented by 1000. Then this d is represented by 500. Then we have x and x. So we know x means 10 plus another x means 10 and plus I means 1. So if we do sum of all of these values, the answer we get is 1521. And this is how this value is being represented. So this seems pretty trivial so far. No issues with this. And also this is also following the methodology where the largest value is present before its small value and before its small value. The problem comes when we have to deal with these 6 items. So let me also draw these ones as well. Okay. Now suppose we are given this as an input, and these are the values that are anomalies in the Roman integer system. These are the values that operate in the same way as the decimal system operates, but when we have a smaller value, so in this case, if you look closely, okay, m is the greatest value and that is why it is presided at the first. D is second greatest and it is presided at the second value. But the thing is, in this case, x is actually a smaller value because x means 10, meanwhile L means 50. So in this case, though x is a smaller value, it comes before L, which means we will have to do a subtraction in this case between these two values and addition with all the values before that. So in this case, let's see what is going to be the answer. So this is going to be m is going to be 1000. Then same way this d is going to be 500. That is okay. But when this x and L comes, so basically now what we will have to do is we will have to do minus 10 plus 50. So in this case, the answer is going to be 1540. And this is how we need to represent. So the logic is actually quite simple in this case if we try to understand. What we can simply do is we can simply create a hash map with all of these values combined in a single hash map, and this is going to be the key, and its subsequent values are going to be the values. Now every single time whatever the input we are given, the logic we are going to follow is quite easy. Okay, so for an example, this is the input we are given. Now let's see that using these as the hash map, how we are going to solve this problem. The idea is every single time we will take two values. So in this case, okay, these are the two values. We will try to see that whether they are present as keys inside our hash map or not. If they are present, we directly take its value. If they are not present, we break them down and individually take their values and do addition, and keep doing that till we find the answer. So in this case, first we will try to see that, okay, first two values are MD. Is MD present as an input? No, MD is not present as an input, which means we will have to take M and D separately. So first we will take M. So M's value is 1000 and plus we will take D. D's value is 500. So now, okay, we have taken care of these two values. Now again, we will keep on repeating the same process. So in this case, okay, we will take these two XL as 1. So is XL present? Yes, XL is present over here and its value is 40. So we can directly add 40 over here in this case for this XL and directly jump to this I. So okay, once this is done, now we are again at this IX. So again, we directly try to see that whether IX is present or not. So IX is present. Awesome. Good for us. So in this case, we can directly take 9. And now we do not have any more values to iterate over inside our input. So we can actually just do sum of all of these values and return as the answer. So in this case, the answer is going to be 1549. And this is the whole logic behind our operations. So see, if we just create a hash map with all the possible values, it becomes quite simple for us to solve this problem. And that is why this is a LeetCode easy problem. If we see time complexity, in this case, the time complexity is actually going to be big O of n, there where n is the length of all the values inside the Roman integers. But the thing is, in this case, the input we are given a finite number. So because it is a finite number, it is a finite time to calculate that. So that's why I'm putting the time as constant, and even in terms of space complexity, apart from using a couple of variables, we don't have to use anything. So this is also going to be constant. First of all, we are going to initialize our static hash map. and assign all of the values we mentioned. After having all the values, we will start implementing the Roman to integer method. So first we are going to assign some variables. So first variable is sum. The initial value is going to be 0, and we are also going to have an I to iterate over the given input, and initial value is also going to be 0. Now we are going to run a while loop. First thing we are going to check is that if the given I, if is still less than string dot length minus 1. Basically, we will first try to check that whether the given string for two values does its value exist or not. So now we will check that if this two symbol strings, if that is present inside our hash map, we are going to add the value of sum. Also, we are going to update the value of I by values of 2, because we are already taking consideration of two values, and then we will move on to the next value inside our loop. And say for example, for some reason that is not the case, in that case all we will have to do is we simply need to add one value. So once our loop ends, we should have our answer populated in the sum variable, so we can simply return sum. And now let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, and it is also very efficient in terms of time complexity and space complexity. So I would be posting the solution in the comments so you can check it out from there. Thank you. We are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do verifying an alien dictionary problem, and this problem has been really interesting problem, and it could be a prefix to a lot of other kind of problems that I would be posting in the future. If we see the number of companies that have asked this question, it's not too many companies, but the thing is the companies that do, they are one of my dream companies, so that's why I'm paying my utmost attention to it. We can see that Facebook, Uber, LinkedIn, Amazon, Apple, eBay, Bloomberg, ByteDance, they have all asked this question, so I'm not gonna skip it. So we are given an alien language, and we are told that they are using all the English lowercase letters. Now we are given some words in that alien language, and we are also given the order of alphabets that those particular alien language follows, and we need to see that whether those words that we are originally given, are they sorted lexicographically or not. Lexicographically means essentially how we are going to store them in a dictionary. Suppose we are talking about the plain English that starts with A, B, C, D and ends at Z. So if we are given two words, something like bat and cat, so question is, are they lexicographically sorted? Yes. Why? Because B comes before C, so that's why if we want to put this in a dictionary, we would have stored bat before storing cat. So this is lexicographically sorted. Let's take another example. Suppose we are taking an example of bat, cat, dog, elephant. Are all of these words sorted lexicographically? Well, we just need to check that what is the order. So in order to check the order, first we only need to compare the first element. So B comes before C, so we are good over here. Now C comes before D, so we are also good over here, and D comes before this E, so we are also good over here. So we check all the words and we check that they are sorted in lexicographically. We can return true in this case as well. Well, suppose we are given another example. Suppose we are given bat and Batman. Well, in this case, if we check the first letters, they both are same. Even if we check the second letters, they both are same. The third letters, they both are same. But the thing is, now over here we find an empty list where there are no elements, and over here we still have some values, which means we can say that this word 1 is actually prefix of word 2, because this bat is actually common, and then we have some additional elements, which means that word 1 is actually prefix of word 2. And in this case, even if we want to put this in a dictionary, bat will be first one to be in the dictionary, and Batman would come later down in the dictionary, because this is actually this is how language works, this is how dictionaries work. So in this case we will also return true. But the thing is, if the reverse was given, if we were given something like Batman and we were given bat, we wouldn't have returned true in this case. Why? Because this particular element we check bat, this is good. But the thing is, over here we have M, and over here we would have an empty string. So that's why at this particular location the words are not sorted correctly. So this is one scenario where we would return false. What could be more scenarios where we need to return false? Well, of course, if the words are given something like suppose we are given the words like ESPN and DSPN. Well, in this case, if we analyze the first element, we can clearly see that D should come before E. But the thing is, in this, the words are put in the reverse order. So over here we would return false. If we take another example, suppose we are given another two words like Batwoman and Batman. Well, in this scenario, first we will compare the first two letters. B is common, A is common, T is common, which means up until this point we cannot determine, like they seem to be in order, right? But the thing is, over here we find this W, and over here we find this M. Essentially in English language, W comes later than M. But the thing is, over here we had this W come in first before this M, which means in this case we cannot return true because we find a mismatching pair. So we can return false. Okay, so now we have exhausted all the possibilities where we can return false. We can return false if the words are same, like if one word is prefix of another word, but thing is the smaller word comes later in our sequence than the first word, we can return false in this scenario. If we find at any point that there exist mismatching pairs at the beginning, we can return false. Or at any point somewhere in the middle, if we find a mismatching pair between two words that are adjacent to each other, we can also return false. Now these are the scenarios where we need to return false. And if that is not the case, if all the words are sorted lexicographically, we can return true. And this was true for plain English. The thing is, even the same thing applies to the alien dictionary as well, that in the alien dictionary the order of words we are given, and we only need to see that whether the words that are given, do they follow this particular order or not. So if we take an example, over here we are given two words hello and lead code. So if we see, we only need to compare the H and L because both words are not same, which means we can compare them. And over here we see their order. So H comes before L, which means that these two words, they are in correct lexicographically sorted order. If we take the second example, over here we are given the word, and over here we are given the word world. Now W, they are both same. O, they are also both same. R, they are also both same. Now what is the first differing character? The first differing character over here we have is D, and the first differing character we have over here is L. Now we check in this particular sequence that where is D located. So D is located over here and L is actually located over here, which means L comes before D. But thing is, over here that is not the case. Over here we get D come before L. So that's why in this scenario, since the moment we find the first differing word, we immediately return false. We don't even have to worry about checking out this row word. So this is how this problem is to be understood. And let's see that what would be the approach to solve this problem. Okay, so suppose we are given an example like this, and these are the number of words that we are given that we need to compare. Now the first approach we can do is that in this particular order, the most important thing is to find the position of words, that where the words are stored. And the best thing we can do is we can create an additional data structure, something like a hash map. And in the hash map, as part of the key, we are going to store whatever the letter is. And in the value portion of the hash map, we are going to state that what is the position of that particular letter inside this given order list. Now what we are going to do is we are going to iterate over this order, and we are going to fill up this hash set first. Now First of all, so if we start filling it up, we will see something like this, that this W is at 0th position. This second element C is on first position. This the next element A is on second position, and B is on third position, and D is on fourth position, and so on and so forth. Now, since we have this available to us, all we need to do is we need to iterate over all the words. What we are going to do is, first we are going to check whatever the adjacent words are. In the adjacent words, first we are going to check that what is the first letter. Are the first letter same or different? If they are different, then we need to check their position from this hash set. So what we are going to do is, over here the first two letters we are given are W and C. So we check that this W, what is the position of W? The position of W is 0. And what is the position of C? The position of C is 1. So 0 should come before 1. That is okay. Which means that this will is actually in correct position by the reference of this Chris. So we can ignore this case. We can say that, okay, will is at correct position because W is less than the value of C. But the thing is, we cannot return true immediately because there are still words that we haven't checked. So again, we are going to check with Chris with this bat word. So first we'll check that, okay, what is the first letter over here? So first letter over here is C. What is the first letter over here? The first letter is B. So they are not same, they are different, which means we need to check their position. So the position for C is at value number 1, and position for B is at value number 3, which means 1 is less than 3. So that is also good, which means now we can say that this Chris is in correct position. Now we will check this bat with this Batman. Okay, so first we will check for this B and B. So they both are same, which means we can't compare. Again, we are going to check this A with this A. Again, they are same, we can't do anything. This T with this T. Again, they are same, we can't do anything. Now over here we have reached the end of our request, but over here we still have some words that we need to compare to. So we can define that this first word is actually a prefix of the second word. Since this is a prefix, which means that this is in correct position in terms of lexicographically sorted manner goes. So we can ignore this case as well. We can say that, okay, this bat is also at correct position, and now we need to check this Batman with this Batwoman. So again, we repeat the same process. We check the first element. So B is at correct position. Now again, we check the second position. This A, they both are same. So there is no point in comparing them. Again, we check this T. They both are also same. So there is no point in comparing them. Now comes the interesting part. Now we are at this position M. So over here, the word is M. Over here, the word is W, which means that M and W, they are both the first differing word. The first letter amongst these two words, they are not the same. So which means we are going to check their position in this hash map again. So we know that this position of W is actually 0, and this position M, so I haven't mentioned it over here, but it falls somewhere over here, which means that this value would be somewhere at least over 10 to 15 letters, somewhere around that. But the thing is, we know the position of W is at 0, and this position is actually much greater than whatever the position of 0 is. So let's say it's 13, something like that. So we can declare that this M is not in correct place compared to this W, because this W is 0, which means that this Batwoman should have been in this place rather than this Batman. So because we have found this, we can clearly say that there is a mismatch between the adjacent words where the first differing letter is different. So in this case, we can simply return false. And if suppose we were given an example like this, over here we would have compared this bat and they were same, so we wouldn't have done anything. And now we would be comparing this W with this M. So we would say that, okay, W is at 0th position, M is at 13th position, so 0 is less than 13, so this is also good. And now we have reached the end of our loop. So because there are no other words to compare to, we can say that, okay, now we have reached the end word, which means that over here we can return true. So if this was the sequence given, we would have returned true, but that was not the case, and so over here we would have to return false. This is the most basic approach that we can take, and this is the most optimal approach as well. If we calculate the time and space complexity, for time complexity, essentially, first of all, we are iterating over this entire order. So we are doing n work, and then we are iterating over all the words, which means again that is also we can consider as n work. So time complexity would be big O of n, where n is actually the number of words that are given. And if we calculate the space complexity, that would also be big O of n, because we will have to create an additional data structure where we are storing all the letters and their corresponding positions. And this is a very effective solution. Now the thing is, this was an easy problem, and of course we can clearly see that this was an easy problem. But the thing is, most of the companies, they don't ask this problem only, they ask this problem in tandem with another verify alien dictionary problem that requires graph theory knowledge. So I would be making video on that soon, so you can check it out from there, that how can you keep both the questions in tandem, because most of the top level IT companies, they are only going to ask you question first, and then they are going to ask some follow-up questions that would be more difficult than the original question. So first of all, we are going to create a new hash map, and we are going to name it order map. Now we need to iterate over the given input order, and we will be filling out the position for every single character in our order map hash map that we have just created. Okay, after this loop runs, our order map hash map would be filled, and now we will have to iterate over all the words, and inside every single word we will have to compare it with its adjacent word, character by character. So notice over here I'm choosing length -1, because if at any point we reach to the last word, we don't need to compare that. And since we are comparing two adjacent words, we don't want to go out of bounds, so that's why we will check one word less in our for loop. And now I'll create another for loop, and that is to iterate over every single character between two adjacent words. Okay, so first of all, we are going to check that if at any point the current j we have, if that is greater than or equal to whatever word the adjacent word's length we have. If that is the case, which means that we have found a prefix where the next value is actually lesser than the previous value. So if we take an example, this would be the scenario if we are given Batman and the word bat. So in this case, eventually we would reach to this m, this particular m value, where the length of the current j would be greater than length of whatever the next value we are at, and if that is the scenario, we will return false. Okay, if that's not the case, we need to compare letter by letter. So first of all, we are going to see that whether the current word we are at if that is same as next word or not. Okay, if that is the case, and if both the words are not same, we will have to compare their positions. So first I'm going to create two parameters. So one is for current letter, and I'm going to fetch the value from the hash map we have created. And for the next word, we will also get the position. And now we simply need to compare that if the next letter, if that is less than the current letter, if that is the case, which means we have found a mismatch and we can return false immediately. and if that is not the case, which means that we have found a matching pair and we can break out of the current word. And after this loop ends, and if we are at the last word, and if we are able to successfully get out of the loop, we can simply return true. And let's try to run the code. Oh, we need to return false. I is less than order dot length. Silly spelling mistake. Okay, seems like our solution is working. Let's try to submit the code. Okay, our solution works pretty efficiently, and I would be posting this code in the comments. You can check it out from there. Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest consecutive sequence problem, and this problem has been asked in Google, Microsoft, Facebook, Apple, Goldman Sachs, Uber, Twitter, ByteDance. So it's a lot of companies and a lot of huge IT companies that have asked this problem. So I'm going to pay my most attention. I hope you also do it. And I just have one request for all of you guys. Like my YouTube channel, if you see, most of the people, they are not even subscribed, and it takes a lot of time and a lot of effort to make these videos. So I would really appreciate if you can just subscribe. Like basically we are given an unsorted array of integer nums, and we need to return the length of longest consecutive elements inside the sequence. Also, there could be possible that there might be duplicates in our given unsorted array, so we just need to take care of those as well. And let's try to understand this with an example. So the example we are given over here is, and over here, if we find that what is the longest consecutive sequence we can find, the longest consecutive sequence we can make is 1, 2, 3, 4 amongst these values. And we can ignore just this 100 and 200 because there does not exist any consecutive sequence from those values. So over here, since we found 4 elements, we can return the length of this as 4, and this would be our answer. Same way, if we take another example, over here we are given 9 elements, and all 9 elements are actually part of the longest consecutive sequence. So in this scenario, we are going to return 9. So in the brute force approach, we are not going to do anything clever. We are just going to take the most basic approach that we can and try to find the longest consecutive subsequence. So suppose at any moment we are given an input like this, we are given an empty list. We can say that there exists 0 longest common subsequence elements, and suppose we are given an element like this, suppose this is 100, we can say that there exists exactly 1 longest common subsequence element in this given input. So that is a given, right? That even if with a single element, we can at least define that there exists 1 single longest common subsequence element. Now over here in this example, since we know that there are at least more than 0 elements in this given input, and initially we are at this 100th position, which means that we can say that the current longest consecutive subsequence we can find is 1. And now if we want to find a subsequence in the remaining group that consists this 100, how can we do it? Like we can only do it in one scenario, that in this remaining portion, in this remaining elements, if there exists element 101, if this exists, we can say that 100 is also part of the or could be part of the longest consecutive subsequence. So this would be our basic approach, that at every single position we will try to find that whether the next elements could they be in the remaining input, and if they do, we will update our longest consecutive subsequence, and whatever the maximum value we find, we are going to return it as our answer. So we will also create another variable called current subsequence, and that would take care of what is the current subsequence that we are trying to find. Let's just name this current. Okay, and initially the current subsequence is also at also 1 over here at this 100th position. Now we'll try to see that whether this 101 exists in the remaining portion, and it does not exist, which means we will move forward. So we'll move forward with the element 4. Now for this element 4, we need to see that whether element 5 exists or not. So element 5 also does not exist, so we'll move on with just 200. For 200 we'll see whether 201 exists. This also does not exist. For this one we will try to see that whether 2 exists. So 2 exists in the remaining array. Now because 2 exists, the current subsequence we had was of value 1, we will update it to value 2. Now because this 2 exists, we can not break right now. We'll try to find more values. So we'll again try to see that whether 3 exists, and 3 also exists, which is over here. So again we will update this value to 3. Again because 3 exists, we'll try to see whether 4 exists. 4 also exists and it is present over here. So we will update the current value of longest consecutive subsequence we have found to 4. Now we will try to see whether 5 exists. Now 5 does not exist, which means that 4 is the longest we have found so far, and then we will try to update the value of longest consecutive subsequence we have found to whatever the current value is, because previous value of this was 1 and now this new value is 4. But we are not done yet. We have only checked up until this 1. So now we will check for this 2. So again for this 2 we will, and by the way, we will re-evaluate this value back to 1 because now we are starting with the new element. So again for this 2, 3 exists, so we will update the value to 2, and 4 also exists, so we will update the value to 3. But we cannot update the longest common subsequence because 4 is greater than 3. And now we again check for this value number 3. So for value number 3, 4 also exists, which means that this value would become 2 for this value number 3, but we won't update, and in the end we are going to return this 4. So this is our brute force approach. Like, this solution works, we get the desired answer. But the thing is, we get the desired answer at a very bad cost. Like, even if we just try to calculate the time complexity, in this case the time complexity would actually be O of n cube. Why n cube? Because we will need to iterate over every single elements at least once to find the longest common subsequence. So that is n amount of work. Then suppose over here we are initially at this position 100. So we wanted to check that whether 101 exists. So in order to do this check, we will also have to iterate over the entire loop. So then in that case we will have to do n more work. And at any given moment, suppose over here we identify that for this one, 2 also exists, right? And once we identify that 2 exists, we will again check whether 3 exists. Again we will check whether 4 exists. Again we will check whether 5 exists. So even to do these checks, we will have to do n more work. So again we will do n work. So in total we are going to do n times n times n. So n cube work to solve this brute force approach, and this is a very disastrous solution. Now one better approach we can think of is, suppose that with the given input, if we do some sort of modification, can we come up with better solution in faster time complexity? Like, of course we can. So remember that what we are needed over here is that we need to find the longest consecutive subsequence of this given input. And we are going to see with this custom example how can we modify the input and how can we come closer to solution. So suppose in this given example, rather than keeping the input just like this, if we do sort the given input, things become much easier for us. And let's see that what would be the sorted result. Okay, so now we have our sorted result. Now in the sorted result, we simply need to find that what is the longest common subsequence that exists, longest consecutive subsequence that exists. And it's pretty simple to find now, because all we need to do is that at any point we know that the definition of common subsequence is that, suppose we are currently at the value I, then I plus 1 would be a common subsequence, then I plus 2 would be a common subsequence, and this is the only condition we have to take care of. And the only other thing we need to worry about is having two duplicate values right next to each other. If at any point we encounter two duplicate values, we simply ignore one of those values and move forward. So in this example, we are only going to do two checks with the sorted input. First check we are going to do is, at first position we are going to check that whether this position is exactly same as whatever the previous position we had. If that is true, we would skip over because we don't need to do anything with that, because there are two same values. And if that is the case, so which is the case in this scenario, that both values are same, which means we would skip over. So we would go to the next element. And now we are at this next element. Again, we are going to check that the value we are currently at and the value before that, if they are same or not. So in this case, they are not same. If they are not the same, we are also going to check one more thing, that whether the current value of a of I. So suppose this 0 is actually a of I, and minus whatever the value of a of I minus 1. So a of I minus 1 in this case is minus 1. So if difference between these two values, if it becomes exactly 1, which means we can conclude that these two values are part of the longest common subsequence, and we could update their value. Again, like brute force, we are going to use two variables. One variable to keep track of longest common subsequence we have found so far, and second one is to keep track of the current subsequence that we are working on. So let's see that how it would work. And both the values would be set up as 1 initially. Now initially we are at this 0 and 1 pair, and because they are sorted, we know that they are always going to be adjacent to each other. So this is the only condition we need to worry once we identify that the both values are not same. So in this case, we can say that the current subsequence we have found is actually size 2. So we can update the value over here, that this is 2. Now again we check with this value. Now this value, again, it's 0, and it's the same as this one, so we ignore it. We don't need to do anything. Now again we check with this value. So this value is actually 2. Now with this 2, if we put down this equation, so 2 minus 0, this is not equal to 1, which means that this 2 and 0 are not part of the common subsequence. If they are not part of the common subsequence, we check that now we can't update this current anymore. So we check between the current and longest common subsequence we have so far, and the current is actually greater, which means we will update the longest consecutive subsequence to 2 as well. And now current, we will put it back to 1, because we will repeat our search again. Now we are at this position 3. So 3 and 2 are not same, and 3 minus 2 is actually 1, which is true, which means we update our current. So current would become 2. Now we are at this 4. Again, 4 minus 3 is equal to 1. So again we update our current to 3. Again we are at this 5. So again we need to update our current. So current would be updated to 4, because all of these values 2, 3, 4, 5, they are in a common subsequence. Now we are at the 7. So 7 minus 5, they are not equal to 1, which means we can't update the current. So we will need to reset the value of the current. So before resetting the value of the current, we are also going to check that whether the longest common subsequence needs to update, and this needs to be updated to value 4, because this one was 4 before, because of these 4 values. And now we can set this value to 1 again at this position 7. And now we are at this position 200. So 207, they don't have any correlation, so we can't do anything about it. And in the end, at the end of the loop, we are simply going to return whatever the longest common subsequence or current subsequence, whatever the maximum value we have found between these two. And in this case, the maximum value we have found is actually 4. So this would be our solution. Now this solution works pretty efficiently. It's pretty neat. And if we see the time complexity, we can complete everything in just one single iteration. So we are only doing n work. But the thing is, the time complexity in this case would be go of n log n, because initially, remember that from this given input, we will actually have to sort the array as well, and sorting takes n log n time. But overall, if we still compare it with whatever the brute force approach we had, brute force was actually big O of n cube. So this was really bad time complexity, and this is much more and much bigger improvement upon our scenario. Now in the optimal solution, we are actually going to try a couple of things. First thing we are going to do is we are going to create an additional data structure called hash set, and in the hash set we are going to enter all the values that we have found from this array. So suppose we create a hash set, something like num set. Now in this hash set, we are going to add all of these values. Now because we have our hash set ready, what we are going to do is when we are going to iterate over this hash set, and we are only going to start checking for the longest consecutive subsequence from the elements that could be at the start of the longest common subsequence. And what elements can be start of the longest common subsequence? Well, so if we take this example, we can actually see couple of common subsequences or consecutive subsequence. One consecutive subsequence we can find is 99 and 100, which is at these two positions. And second consecutive subsequence we can find is actually 1, 2, 3 and 4. Now in the what we were doing in the brute force is we were checking at every single position that what would be the longest common subsequence we can find. The thing is, we can only find the longest common subsequence from the first element of the start of this consecutive subsequence. Same goes over here, that whatever the subsequence we can find at this value number 100, the subsequence that we can find at value number 99 would always be greater than whatever we can find over here, because this by itself is already a subsequence. So we are going to use this logic. Like over here, if we put this 3 to 3 4, we will only find the consecutive subsequence of length 2, but this 2 3 4 would be of length 3, and this 1 2 3 4 would actually be of length 4. So we can only find the maximum consecutive subsequence at the start of the any subsequence, not somewhere in the middle. And the only way to check that whether we are at the start of the subsequence or not is by just checking one very simple condition, that at any point we check that whether the exact value before that value, like one value before the value we currently are at, if that exists, which means that we are not at the start of the common subsequence. Let's take it by an example over here and let's see that what would be our approach. So first of all, we are going to be at this position 100. We are going to check that whether this 100 is a start of any consecutive subsequence or not. So we check that whether in this given num set does the value 99 exist. Now we know that 99 exists. So because 99 exists, 100 cannot be at the start of the common consecutive subsequence. So we are going to ignore this case. We don't have to do anything with this 100. We come up at 99. Now we come up at this 99. We check that whether there exists a value before 99. So 98, does it exist in this num set? 98 does not exist, which means that at 99 we can be at the start of any common consecutive subsequence. So we start a subsequence at 99, and now we will initiate our logic. And in our logic, we are simply going to check that from this 99, how many consecutive numbers we can reach. So we are going to check that, okay, 99 by itself is a common subsequence of length 1. So we know that. Now from this 99, we are going to check that can we reach value number 100. So 100 we can reach, and because we are using a hash set, we can do all the operations in constant time. So we are not adding any strain in our time complexity. Now we can find the value 100. So we can reach 100, which means that whatever the longest common subsequence longest consecutive subsequence we found, we will increase its value to 2. Now again, we will try to see that whether we can find 101. Like 101 does not exist, which means we would break out of over here, and the longest common subsequence we have found up until this point is actually of length 2. Again, we are going to repeat the same process. So now we are at this position 4. We check that whether 3 exists in this set or not. So 3 exists, which means we ignore this 4. Now again we are at 200, so we check that whether 199 exists. So 199 does not exist, which means 200 can be start of the any consecutive subsequence. So we again check that whether 201 exists, but 201 does not exist in this given example. So we ignore this 200 as well, because the longest consecutive subsequence we find at this value number 200 is always going to be 1, and we already have a value that is greater than 1. Again, we check at this position 1, that can 1 be start of any consecutive subsequence. So we check that whether the 1 minus 1. So we check whether 0 exists in this example or not. 0 does not exist, which means 1 can be start. So now we set our current subsequence to value number 1, and now we check that from this value 1, how many other values we can reach to. So first we check that can we reach the value number 2. Yes, we can reach value number 2 because 2 already exists. So we update whatever the current subsequence we can find to 2. Now from this 2 we check can we reach 3. Again we can reach 3, so we will update the current value to 3. Again we check that whether from this 3 can we reach 4, and yes, we can reach 4 as well. So again we will update the value of our 4. value of the current subsequence to 4, and from 4 we check whether we can reach 5. So 5 we can't reach, which means we are at least able to reach this 4. So we are able to see that the longest current subsequence we have found is 4 and previous value was 2. So we will update this, so this will become 4. And now again we are going to check the same thing for this value number 2, so that for value number 2 does 1 exist and 1 exists, so we will ignore this. Again we check for 3, does 2 exist, 2 also exists, which means we are going to ignore this 3. And now since we have reached the end of this hash set, so we are going to reach whatever we found in the as the longest consecutive subsequence, and this would be our answer. Now if we calculate the time complexity, the time complexity would actually be big O of n in this case, because we are only iterating over the entire input just once through this hash set. So this is a very efficient time complexity. And if we see the space complexity, the space complexity is actually big O of n, because we will have to create this additional numerical set, and we are going to store n memory for that. And let's see the coding. I will be showing the hash set solution in this code, but I'm going to post both the codes in the comments so you can check it out from there. So first of all, we are going to check that whether we are given an empty list or not. If that's not the case, first of all, we are going to create a hash set. We are going to name it num set. Now we'll run a loop across the given input, and we are going to store all the values to our hash set. This is going to do two things. It's going to eliminate all the duplicates values, and it will only add unique entries in the hash set, because hash set has a property that does not allow it to store duplicate values. Now we are going to create a parameter to store the longest subsequence, and we are going to initialize it with value 1. Now we are going to run a for loop across the given num set. So initially we are going to check that whether we are starting from the middle of any longest consecutive subsequence. If that's the case, we are going to ignore that number. So if this condition is true, we are going to continue and go to next element in the loop. If this is not the case, we are first of all going to mark the number we are at as current number, because this is the beginning of any longest consecutive subsequence. We are also going to create another parameter called current sub, that is going to take care of the current maximum consecutive subsequence we can find, and we are going to initialize it to 1. And now we are going to put a condition that while our hash set contains the current number plus 1, while this condition is true, we are going to increase the number, and we are also going to increase our current subsequence. And after this loop ends, we need to check that whether we have found the longest common subsequence or not. So once this loop ends, we should have our answer in the longest sub variable, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And seems like our solution works pretty well, and it is faster than a lot of other solutions. I will also post the sorting algorithm solution as well, so you can check it out from the comments. Hello friends, I'm a cloud solutions architect at Microsoft, and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting lead code problem called first missing positive, And if we see some of the popular companies who already asked this question, there are companies like Amazon, Microsoft, Google, Apple, IBM, TikTok, Hudson River Trading, ByteDance, Twitch, Facebook, Uber, and Snapchat. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also very well like problem on LeetCode. Basically, we are given an unsorted integer array called nums, and we need to return the smallest missing positive integer. So the problem statement is really small and easy to understand. The tricky part in this problem is that we are being asked to solve this problem in big O of n time with a constant extra space. So time complexity has to be big O of n and space complexity has to be big O of 1. So this is the difficult part that we are trying to achieve. Now first let's try to understand this with few examples that what does this problem is asking us to do. So in this case we are given a numbers array, and in this case the values are these. Now we are trying to find the first missing positive number. Okay, now what is the first positive number? First positive number is going to be 1. Then what is the second positive number? It's going to be 2. What would be the next one? It would be 3. Now in this case, since 1 and 2 both are present, 3 is the first missing positive number, so we need to return 3 as the answer. If we take a look at the second example, again in this case we have 1 present, but we do not have 2 present. So because 2 is going to be the first missing positive integer, so in this case we don't even need to check for all the remaining ones. 2 is going to be the answer that we need to return. And same goes with this example. In this case, since we don't even have 1 as the answer, we are definitely going to return 1 as the answer because 1 is the first missing positive number. Okay, so the problem statement is really easy to understand. Now let's see that what could be the possible different approaches we can take in order to solve this problem. Well, the first approach that comes to our mind is a brute force approach. In the brute force approach, what we are going to do is we will try to find the first positive number. So first positive number is going to be 1. We will see that whether 1 is present in this or not. Okay, so 1 is currently present. So now we will move on to 2. 2 is also present. So then we will move on to 3. So value number 3 currently is not present. So we can say that 3 is the first missing positive number and we will return 3 as the answer in this case, right? But the thing is, what is the issue with this brute force approach? Well, the issue is quite simple. Time complexity is actually going to be big O of n square, which is disastrous. So we will have to do something better than this. Let's try to find another approach and see if we can do something better. So say for an example, suppose this is the given input. The idea is that if for this given input, if we somehow sort this input, we would actually able to do something better. So let's just see the sorted result. All we need to do is go to the first positive integer. So in this case, first is 1, 1 is present over here, and then move to all the other elements until we find a place where the next element is missing. So in this case, we can clearly see 3 is missing. So 3 is again going to be the answer for the sorted approach. So sorted approach works better than the brute force solution. But the issue with the sorted approach is that from given input, in order to generate the sorted array, it takes us the time complexity of big O of n log n just to generate this sorted approach, and then we will have to iterate over it once. So the thing is, this time complexity is still more than what we want. So this approach is also not going to work. Let's try to see some better approach. Okay, now before we go to the next approach, first let's try to make things much easier to understand. Suppose if we are given any input, and if all the values are starting from 1, only positive values that are incrementing in sequential order, what would happen in this case? What would be the first missing positive in this case? Well, definitely the first missing positive in this case is going to be value number 5. Why value number 5? Because currently the given input n only has 4 characters and all the characters are like 1, 2, 3, 4. So the minimum possibility is that the value could be 5, or it could be any single value from starting from 1 to 4. So basically all the values that are concerned of us is that the first missing positive will only be between the given n plus 1. So from 1 to n plus 1 is the possibility where the first missing positive value lies. In any other values are no use of us. So say for an example, if we are given input n where the values are such as like -1, -6, then +8, then 1, 2, something like this. If this is the possibility, definitely the first missing positive in this case is going to be value number 3. But the thing is, since here there are only 5 values, the first missing positive number can only lie between the values of 1 to 6, nothing more than that. So if that is the case, why are we even concerned with all the values that are not between 1 to 6? If say for an example, values like these three, we are not concerned with them. And I already explained you why we are not concerned with them, because we are actually going to use it in one of our next approaches. So say for an example, if this is the input we are given, previously for the sorting and also for the brute force, what was the issue happening? The issue was happening that if we want to search that whether value number 1 exists inside this given input or not, it was causing us a lot of time. So what if we speed up this process? We can actually speed up this process by creating a hash map. And what would we do inside this hash map is that at any given position, we will first try to identify whether 1 exists or not. And 1 is not, if 1 is not existent, definitely we are going to return 1 as the first missing positive. That is going to be our answer. That is going to be the most simple case scenario. But if 1 is present, then we are guaranteed that the value of first missing positive is going to be between 2 to 6. So any value that does not lie between the values of 2 and 6, we can simply denote their value as 1 inside our hash map, and then we will do something tricky with our hash map. So let's apply this logic to our hash map. Let me quickly draw the hash map from given input. And by the way, for any particular value, this is going to be the key, and its subsequent value is also going to be same, except for these three values where the value is going to be 1. This is the hash map we have been able to generate from our given input n, where the key is the same value as the values inside our array, and its subsequent value we have done some modification, and all the other positive values, they are equal to whatever their subsequent values are. Now all we need to do is, we know that the answer could only be lying between 1 to 6, nothing more than that for the first missing positive. So we will run a loop starting from value number 1 to 6, and we will try to see that whether all the values between, like including 1 and 6, between 1 to 6, are they present inside this hash map or not as key. And we would be able to do this in constant time, because that is one of the property of the hash map, and that is going to make our lives much more easier. So first we will try to see that whether 1 exists inside the hash map or not, and definitely 1 exists over here. So we can simply go to the next element. So we will check whether 2 exists or not. 2 also exists, so we can simply go to the next element and we will check whether 3 exists or not. Since 3 does not exist inside the hash map, we can immediately say that 3 is going to be the answer that we need to return. And this is a very good approach. This solves a lot of our problems that we were facing in terms of time complexity. Why? Because it takes big O of n time to generate this hash map. Okay, so in order to generate the hash map, it takes big O of n time, and then in order to run this loop and to come up with the answer that whether the value exists or not, that also takes big O of n time. So if we see time complexity, basically we have been able to complete this problem in big O of n time, and this is going to be great. This is a wonderful result, and any single interviewer would be more than happy with this approach. But the thing is, in this problem, if we see space complexity, this is where the problem lies for this approach, because space complexity in this case is also going to be big O of n. Why? Because we are creating an additional hash map. Meanwhile, we are explicitly told that we need to complete this in big O of 1. So can we do that? And the answer is yes. Okay, now let's see that what would be the optimal solution where we also do constant space complexity in order to solve this problem. The logic we are going to keep are same, that any values that are too great or negative or 0, we are actually going to convert them to 1. Now let's see that in this given input, how many elements we are given. We are total given 8 elements, which means that the answer has to lie between 1 to 9 for the first missing positive integer, which means any value that does not fall in this range, we will actually have to change it to value number 1 inside this given input. So let me create a new array. This is the new array we generated. Now let's do a quick recap. Basically, we first check that whether 1 is present or not. Since 1 is already present, we iterated over this given input array, and from that we converted this for all the values that were not falling between the values 1 to 9. Okay. Now we are going to do things a little bit interesting way. What we are going to do is, since we already know that 1 is present, which means we are not worried about value number 1. We are simply going to iterate over this values whenever we find a value that is not 1, a value that is not 1, which means, say for example, we find this value number 5. So we will go to its subsequent index. So in this case, we will go to index number 5, and whatever the value is, we will just convert it into negative. Nothing more than that. This is a very simple approach. So let's just quickly do another array, and we will follow the methodology I mentioned. In this case, the first value is 5. So because first value is 5, we will try to find subsequent value and convert it into negative. So this becomes -3. This is value number 1. So we don't need to do anything. Again 1, again 1, and again 1. So since these 4 are 1, we are not going to do anything. Now this value is -3. So because this value is -3, we will go to third index, because this used to be a +3 value. And remember what I said, anything but 1. So in this case, we will go to this value and convert it into negative as well. So this becomes -1. Now we are okay. Again, this value is 1, so we don't need to do anything. This value is +2, which means we will go to second index and convert it into negative. Awesome. Now, what are the things we have been able to dictate? We already know that 1 is present, which means that the answer has to lie between the values 2 to 9. Now in this case, since we will start iterating over from value number 2 to all the values remaining inside the given input array, because we already know that 1 is present, so we don't need to do anything. And now all we need to do is to check that whether that value is negative or not. And the moment we find the first positive value, that index value is what is going to be the first missing positive integer. Yes, this is the whole logic. Now in this case, since this is -1, this is -1. So these two values, we have been able to dictate that why they have been turned into -1, because that subsequent values were present at some point inside the given input array. That is why we converted them to -1. So we can ignore these two. For this particular value number 4, this is a positive value. The moment we identify a positive value, this can only remain positive if there was 4 nowhere to find in this given input. Say for example, we found that this value was 4, then we would have definitely converted this to -1. But the thing is, we did not find anything, and that's why we left it as positive, and we have not been able to find 4 as the first missing positive. So we need to return 4 as the answer. And this is the optimal solution. If we see time and space complexity, in this case, the time complexity is actually going to be big O of n. Why? Because first of all, it takes big O of n time to generate this, and then it takes big O of n time to find the first missing positive integer. So we are satisfying on that aspect. And if we see space complexity, well, apart from using couple of variables, we are not using any additional space, because all of these things are being done on the given input array nums. We are not creating an additional new array. This is a very good time and space complexity and a great approach to solve this problem. Because if you see in this problem, what are all the things we have been through? We first saw the brute force solution, then we saw the sorting solution, then we saw a hash map solution, and then we saw the optimal solution. So we actually went through 4 different approaches, and every single time we started to improve upon something. And this is what any single interviewer would want to see, that how you have been able to do things. And that is why FAANG companies love asking this question. So now let's move on to the coding. So for the given input, first we are going to check that whether 1 is present or not. If 1 is not present, we are simply going to return 1 as the answer. Okay. Now the logic we are going to apply is that any single value that is not falling between our given range, we are going to convert it to value number 1 inside the given nums array. Now all we need to do is we will need to go over the given input array where we have already changed the values with 1. And anytime we identify the value is different than 1, we will go to this array and change its subsequent index location to a negative value. Okay. Perfect. So now with this loop, we have been able to convert all the values to the negative value wherever we find a subsequent positive value, any value apart from 1. Okay. Now all we need to do is run a for loop from int I is equal to 1 to the last element, and we simply need to check that at any given position, if we identify a positive value, we are simply going to return that index character, and that is going to be the answer. Now we are also going to check for a couple of edge cases as well. Somehow if we are not able to return the answer, which means we have found the perfect sequence, so we will need to return the last value inside our first missing positive integer, which is going to be n plus 1. And this is the whole code. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which means this is a great solution. And I will be posting this in the comments, so you can check it out from there. Thank you.
So now the next topic we are going to talk about is very closely associated with arrays. It's called sliding window. Essentially, we are going to have a subset in the current array that we are going to slide across the array to fulfill some conditions. Let's try to see a visual explanation before diving deeper into the more questions associated with that. So at a conceptual level, sliding window is very straightforward. Basically, we have given a sort of an array and we are trying to find a piece of information that is located somewhere within this given entire spectrum of array, but we don't know what. So it can be an example where we are given to find some value associated with a subset of array. Let's say that this array contains total n elements and we are being told that find a subset k such that uh, essentially maybe they all sum up to a target. So that can be an example, or it can be like a smallest substring or a largest substring that means something, or that we need to find some value associated with that. So in all of these cases, let's say that if we are given an array and we are trying to find a subset of an array of size 3, where for each of the subset basically we need to find that what is going to be the maximum sum of this subset. If we take the brute force approach, we would basically end up calculating every single possible different arrays or different outcomes, and we would have created bunch of different nested loops in order to achieve that. Now this is very expensive. A better way to do it is that we can clearly define that this is going to be the window that we are going to slide over in the existing array, and this window is initially residing between these two elements. And let's say that some of these three elements turns out to be 30. Let's say each of these values are 10, 10 and 10. Now next value we currently have is, let's say, 5. So in this case, instead of just recreating all the calculations or reiterating over these two values, because we already know that they are part of the window, we can just simply change the position of the window and now only include these three elements. And now all we need to do is, from the previous sum of the existing window, we can just reduce whatever the value this was. So 30 minus 10, because we eliminated this element from the window, and then add this element, so plus 5. So this sum is going to be 25, and we can say that okay, this sums to 25. Then same way for next window we can repeat the same operation. And this is an example on how changing window can create some interesting results. Now there are some very popular questions associated with this, and one of them is my favorite question, that is the best time to buy and sell stocks. So that would be coming in our most popular lead code problems that we would be doing. So let's try to solidify our concept for the sliding window now.
Today we are going to do best time to buy and sell stocks lead code problem. This question has a very real life practical application. That is why it is very famous amongst IT companies as an interview question. If we see some of the companies where I want to work at who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Google, Goldman Sachs, Apple, Uber, Snapchat, Yahoo, ByteDance, DoorDash, eBay, Netflix and Reddit. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is the LeetCode easy problem, and you can see that it has been one of the most liked problems on LeetCode. If we try to understand the problem statement, basically we are given an array called prices, where any single value inside this given array indicates the price of that particular stock and on that particular day. Now we want to maximize our profit by choosing a single day to buy the stock and choosing a different day to sell the stock sometime in the future, and our aim is to maximize our profit. So if we try to see it with an example, suppose this is the example that we are given, where we are given 6 different prices for a stock and we are told that we need to maximize the profit. So I have drawn it on a graph over here so it makes things more easy to understand. And we know that at any given position it shows that what is the price of that particular stock. So initially the stock price on first day was price 7. Now on the second day the price fell down to price 1. So we are not making any profit, we are actually going down and we are losing the money. But if we see over here, so this day it's 1 and this day the price is 5. So if we see over here, between these 2 days we actually made a profit of $4. Again price fell next day to $3 and then again price rise to $6. So over here we lost $2, over here we again made some gain of $3, and at the end the price was 4. So over here again we lost $2. So the thing is, if we just do it like this, we don't get the maximized profits. Why? Because we are only seeing that what is the difference between every single day. But if we see that if we do something, if we buy the stock on this particular day, which means that we are buying the stock when the stock price is at 1, and if we sell the price when the stock price is at 6, so which means if we sell when the stock price is at 6, we can actually make a profit of $5. This is the answer we need to return, that this is the maximum profit we can make based on these stock prices. So let me show you that what would be the brute force approach, and then I will show you that what would be the optimal approach. So for the brute force approach, one thing we can do is that we take every single position of a buy and sell price for these given stocks, which means that we make every single pair. So first of all, we see that if we buy the stock at price 7 and we sell at price 1, again we sell at price 5, again we sell at price 3, and so on and so forth, what is the maximum profit we are getting. And we will create a variable called profit, and we will keep track that what is the maximum number we have found so far. Once we are done with this value number 7, we would ignore this case, and then again we will repeat the same thing with value number 5. So we start buying, so we start that our buy price is at value number 1, and again we start checking all of the comparisons that what would be the profit, and eventually we would find a pair where buy value is 1 and sell value is actually 6, which means that we would gain profit of $5, and then we will return this as our answer. Like, this solution would work as expected, we will get the desired result. But the thing is, this is not the most optimal approach. Why this is not the most optimal approach? Because if we see the time complexity in this case is actually going to be big O of n square. Why n square? Because for any single entry we will have to take a look at every single entry in the remaining array, and we will iterate this process. So that is why it is a very time consuming process, and we need to find a way to do something better. And let me quickly show you that what would be the optimal solution in this case. So for the optimal approach, what we are going to do is we are actually going to see that when do we get the maximized profit. We only get the maximized profit when we buy at the lowest value and we sell at the highest value. So this is the logic we are going to apply over here, that we are going to buy the stock at the lowest value and we are going to sell the stock at the highest value. But the thing is, it is not as easy as finding like the maximum value and the minimum value, because in this case maximum value is actually 7 and minimum value is actually 1. We don't need to get the difference of these two values, because if we do that we will get an answer of 6. But the thing is, we are actually dealing with stocks, so we can only buy stocks in the past, which means that if we decide to buy a stock over here, we can only sell it afterwards. We can't sell it to some value in the before. So that's why that is one thing we need to keep track of, that we have to make sure that this linear property of buying and selling is maintained in this case. So what we are going to do is we are going to have a variable called buy, and that is going to keep track of what is the minimum value we have stored so far. And we are going to see that at any given moment, whatever the minimum buy value is, if on that particular day we try to sell a stock, what is the profit we are getting. So let me quickly draw 3 variables over here. So we are going to have 3 variables called buy, sell and profit. Now first of all, we are at this position number 7, which means that we are buying the stock at 7 and we can't do anything about it because we don't have any way to sell it. So we will start with the second position. So now on the second day, the stock price fell down to 1, which means that if we have already bought this stock at value number 7. If we try to sell it at value number 1, 1, it really does not give much progress. But one thing we can do over here is that because today the stock price is actually low, we can reduce that whatever the buying price is from 7 to 1. So we will do that. So now the buy price is actually 1, and we are not selling anything, or we are not doing anything again. Now the next day the price of the stock is 5. So we'll try to do that. Okay, what is the 5 minus 1, which is the minimum price we have bought stock so far, and 5 minus 1 is actually 4, which is the maximum profit we have made so far. And we don't need to update this buy value because we have already bought it at a lower price than whatever the current price of the stock is. Now we will move on to the next value. So next value, the stock price is actually 3, which means 3 is still greater than value number 1, which means we don't need to update this value number 3, but we will have to check that whether we are making any greater profit or not. So again we will do 3 minus whatever this buy value is. The buy value is 1, so 3 minus 1, so the current profit we make is actually 2. But the thing is 2 is actually less than 4, which means we don't need to update the profit we have made so far. Now again we will ignore this case, we will move on to the next value. So the next value, the stock price is actually at 6, so stock price is now at 6, and now again we will do 6 minus 1. So 6 minus 1, selling price would be actually 5, and because this is 5 and this profit is actually greater than whatever profit we have achieved so far, so the current maximum profit we have made so far is 5. Now again the stock price is at 4, so again the selling price on this day would be 4, and we don't need to update the buying price because the buying price is already at 1, which is lower than 4. And now we will do 4 minus 1. So 4 minus 1, if we do, we still make profit, but this profit is only $3, and $3 is actually less than whatever the maximum profit we have made so far. Now we are at the end of our loop, and now we don't have any more values to iterate over inside the given array, which means whatever the result we have stored inside the maximum profit variable, we will just return that. And in this case we will return answer as 5, and this answer would work perfectly fine. This is like the most desired answer we need. If we see the time and space complexity, in this case the time complexity is actually big O of n. Why big O of n? Because notice that we are completing everything in a single iteration. And in terms of space complexity, for the space complexity we are not actually using any additional space apart from storing couple of variables, so that's why space is also constant. So that's why this is a very good approach. We are solving this in big O of n and big O of n time and big O of 1 space complexity. So first of all, we are going to initialize a variable called min, and we are going to give it the first value of the given prices. We are going to create a variable called profit to note down the maximum profit we can achieve, and initially we are going to mark it as 0, and then we will update the value inside our loop. So now we are going to run a for loop across the given array. Now inside the given loop, first of all we will check that whether we need to update the value of min or not. So we will check that if the current min value is less than whatever the value of I is, then we will update the value of min. And also we will check that whether the current profit we can make by selling the stock on that particular day comparing with the min value, we will choose the maximum profit we can. And once this loop ends, we simply need to return the whatever value we have stored in the profit variable. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit it. And our code is actually pretty efficient. It runs faster than a lot of other solutions, and I would be posting this code in the comments so you can check it out from there. Thank you.
Hello friends, hope you are having a fantastic day today. So once again, we are going to do an awesome lead code problem that has been asked at tons of companies. So without any delay, let's get started. So the lead code problem we are going to solve is called permutations in a string, and we can see that this is a lead code medium problem and also extremely well-liked problem on lead code. The problem statement is very straightforward, that we are given two strings s1 and s2. Now we need to check that if any of the permutation of s1 is present inside the s2 string, then we need to return true. If that is not the case, we need to return false. Now let's try to see this with an example. Say for an example, we are given s1 is equal to value a and b, and we are given a string s2. Now there can be two permutations and combinations of a and b. It's a and b itself or either b and a. Now we can see that in this string s2, ba is actually present. So because it is present, we can actually return this as true, saying that a permutation of ab or string 1 is actually present inside the string 2. Now let's take one more example. In this case, we have ba as partial permutation of the string 1, but we does not have anything like C, or we have, in this case we have AC, but there is an X in between. So we do not have any direct permutation of string 1 present inside the string 2. So in this case we can return false. Now even though we have A, B and C, all three present inside the string 2, but they are not present together. So that is the main problem. So now let's see that how can we actually solve this problem. And the number one approach is very simple brute force approach. So for the brute force approach, what we can do is we can take string 1, suppose the values are A, B, C, and then we can take string 2, suppose the given values are once again B, A, X, C, D, Z, something like this. So we can take every single possible permutations of S1, and then we can check that whether those are in any given moment present inside the string 2 or not. So this is going to be very inefficient approach. So we need to do something better. Now the question is, in any given case, suppose the string 1 is ABC, then what are the different permutations and combinations possible? In either case, you can notice that instead of keeping track of all of these permutations and combinations, we can say that currently for the string 1, we actually have 3 different characters, and the frequency of each of these 3 characters is actually 1 time. So we have A present 1 time, B present 1 time, and C present 1 time. So at any given moment inside the string 2, if we identify that, suppose string 2 is, let's say that X, B, A, C, D, Z, something like this. And if we identify that amongst any given moment, we can identify these 3 occurring in any subsequence in the same amount of frequency. So I'm not talking about order that A has to come before B has to come before C. I'm talking about the frequency, that at any given moment we wants to check that whether all 3 A, B and C are present in the same number of occurrences, which we can see over here, that if we take a look at this portion, we can actually see that we can also make another frequency map that contains once again characters A, B and C, and each occur 1 time. So because there is a match in this regard, we can actually say that this string 1 is actually present inside the string 2 as one of the permutations or combinations. So this is the approach we are going to use. Now, in order to use this approach, we actually need 2 things. Number 1 item we need is that we need a way to create a frequency map to contain that how many times any single character is present inside the given string 1. Then we need to create the window of that exact same size and then iterate over every single possible windows of the string 2. And once we do that, all we need to do is just compare 2 different frequency maps. So what are the efficient ways for us to compare frequency maps and create frequency maps? Well, there are actually 2 ways. So number 1 way is that we can actually use a hash map, because in the hash map we know that it is a key value based pair data structure. So as a key we can set up the character, and as its subsequent value we can set up the frequency. So once we have the hash map or frequency map for string 1, we can do that. And same way, the existing window we have for string 2, we can actually create a very similar frequency map for the string 2 as well. So that is option number 1. The option number 2 is that we actually create an array with 26 characters, and we create 2 arrays. So one array is for string 1, one array is for string 2 for that specific window. And let's assume that in string 1, the value is ABC. So we can mark ABC as 111, and for rest of the characters we can mark them as 0. And this can be also an efficient way for us to check that what is the frequency and how many times it is present. So same way for S2 we can also create an array. So both ways would yield the same space complexity. So what I'm going to do is in the example I will explain it to you using hash map, but in the code we will use the array method. Okay. Now let's try to understand the approach I'm suggesting using couple of examples. So suppose we are given our string map is equal to value ABA, and we are given our string 2 as the values A, B, C, D, E, F, E, X, then A, B, something like this. Okay. Now we know that what is the approach we are going to do. For string 1 we will have to create a hash map. So let's quickly create a hash map. The idea is
that string 1 hash map is going to look very simple, that it only contains 3 characters that are A and only 2 characters, A and B. Now A is present 2 times and B is present 1 time. Now we have the hash map for string 1. Now for the string 2, what we are going to do is that we are going to create an exact same size window, and then we are going to keep sliding that window over from left to right. And using that approach, we would be able to solve this problem very easily. So let me tell you what we are trying to do. So initially the string 2 does not have a hash map. So let's create a frequency map for string 2 as well. Okay. And I'm marking 3 values. So now let's see. Okay. Currently this one does not have anything. So we are going to consider these 3 values as our first window. Now we are going to create a frequency map. And the idea is that we can keep on comparing the 2 frequency maps, or if you don't want to create 2 maps, you can actually start deducting values as well. But in either case, you will have to remember that what was the original state. Okay. So that's why for our simplicity, I'm creating 2 maps. So now for this A, we have this A and it is occurring once. Once again, we have this B, it is also occurring once. And then once we have C, that is also occurring once. But if we compare these two, then we can see that A and B is partially there, but C should not be there, and we are still missing one A. Okay, so in this case, this is not the correct approach. So now we will have to migrate our window one step forward, which means previously we were considering this ABC. So now we will get rid of this A and we will treat as if this A is currently no longer needed. And now we are going to be dealing with this particular window. Now the thing is, when we are dealing with this window, the question is, do we need to create another same window for this new portion? The answer is no. We can actually do something very simple. The idea is that whatever the value was present over here, we can actually get rid of that value because we are moving to the next step inside our sliding window. And then whatever the new value is, we can simply add that new value to the hash map. So now we are going to get rid of A, and we are going to add one other value D, and we are going to mark its frequency. So D is also present once. But once again, this window also does not yield us the correct result, and these two are still not equal. Okay, so now we will have to consider this window. So once again, we will keep on repeating the same process. We will get rid of B. Once again, we will get rid of B. We will include value E again. So now E is present one time, but also this window does not work as well. So now we are also going to get rid of this value number C. Now C is no longer present. But now we are going to include value number X. So X is present one times, but once again, this is also not correct. So we will get rid of D and we will have this window to consider. So now we are going to get rid of D and we are once again going to add value number A one times. Now, once again, this is not the correct approach. So we will once again get rid of value number value number E, and the new value is A. So because new value is A is already present, which means we do not have to add A again. So we can just increase the value of A second time. Now, currently we are considering this window, but this is also not the correct window. So we will also get rid of this one. We will kick X out and then we will add value number B. So adding value number B would allow us to add one more value B inside over here. And now this is our final window. But in the final window, we can see that both string 1 hash map and string 2 hash map are same. The frequency of character occurring is exactly same, which means we have found our optimal solution, and we can say that currently one of the permutation of string 1 is actually present inside string 2. So we can return true as the answer in this case. And in case, say for an example, this one was not B and this one was something else like character D. So the moment we reach to this value and we have a string that looks like D1, something like this, then there is no longer a window possible for us to move forward, which means we have exhausted every single possibility in string 2. Still, we did not find the same set of frequency of character present inside the string 1, which means we can simply return false in that case. And this is the whole approach. So this would be the optimal solution. If we see time and trace complexity in this case, the time complexity is very simple. It's going to be big O of n, because number one, in order to create this hash map, it takes us big O of n time. And then using a sliding window, we simply have to iterate over this given array. So this is also big O of n. In terms of space complexity, so this can be big O of 1. Why?
because we know that there are only 26 characters inside the alphabet. We are not dealing with any special characters or any extra elements, which means there is only a finite number of characters we can store inside our hash map or frequency maps. So that's why space complexity is going to be 1. So this is a very good time and space complexity, which yields us very good results. So now let's quickly see the coding solution for this one. So first of all, we are going to check that if the given string 1 is actually greater than string 2, which means we can directly return false. If that is not the case, we are going to initialize two arrays with the size 26, which we are going to use as frequency maps. Then we are going to initialize the frequency map for the string 1 and also for the first window of string 2. And the first window of string 2 is going to be the length of a string 1. Okay. Then we simply have to slide the window through S2 and compare it with the frequency map of string 1. If both match, then we can simply return true. If that does not match, we are going to keep on updating the window of the given string, which means we are going to drop off the left side of the element and we are going to add the right side of the element. And then we can once again keep on repeating the same process until the very last window. If we do find that there is a match, then we can simply return true. At any given moment, we find that we are able to reach to the very end, then we can simply return false. And we are creating a helper function to compare the frequency of two maps, which is going to be just running for loops across both the arrays and check that at any given moment, whether the frequency is deviating away from a single character or not. And then we can simply break out of that loop. Okay, so let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast in terms of time complexity and also very efficiently in terms of space complexity. So you can find this code in our GitHub repository and the link is in the description. Thank you.
Hello friends, we are now employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest repeating character replacement lead code problem that contains very important properties related to string based problems. If we see the companies where I want to get a job and that have already asked this question, there are companies like Google, Amazon, Uber, Adobe, Facebook, Apple, Bloomberg and Microsoft. So some of the top tier IT companies. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given a string s and we are given an integer k. Now we are told that inside this given string s, we can replace any character with any other character in the English language, and we can repeat this operation k times. Now, after repeating this operation, what is the main purpose of this question is that we need to return the length of the longest substring that contains the same letter by doing this replace activity, and we need to return that length. Okay, so now we'll try to understand this problem with this example. So suppose we are given our s is equal to a, b, a, b. And we are told that k is equal to 2, which means we can replace any two character with whatever two characters we want. So in this case, we have two options. Either we replace these two b's with value number a, then we will get a string that looks like a, or we can replace these two a's with the letter b, and then we will get a string. Our concern is we don't care what is the value of the string. Our aim is to find the longest substring that contains all the repeated character, and we need to find the length of it. In both the cases, the length of these two is actually 4, and this would be the answer we need to return. So this is what the problem is asking us to do. Let's take one more example to make our understanding more clear. So suppose our given s is equal to HP. If this is the case, and our given k is equal to 2 again in this case. So now if we see the options we have, we can replace like these two p's with the value h. So that will give us a string like h. And so if we see the longest substring that contains the same letter, the length in this case becomes 5. Second option we have is that we choose any two h value, suppose these two, and we replace it with value number p. If we do that, we will get a substring that looks like this. So in this case, if we see that what is the longest length of the subsequence that contains the same letter, it's actually 4. So this is 4 and this is 5, and we need to return the longest. So that's why this is the most optimal way to approach this problem in this case, where we are going to replace these two p values with the letter h, and we don't do this p operation. So there are few ways to solve this problem, and there is also a brute force way to solve this problem. So first I'll show you the brute force way, and then we will see that what would be the optimized approach. First of all, we identify that what is the thing that we want to find. We want to find a substring, and then we want to replace the characters, and then we want to find a substring that contains the longest length with the same characters, right? So first approach we can take in the brute force is that we take every single substring that is possible. So even if we just see that substrings that starts at a, we will get substrings like a b, a b a, and a b a b, something like this. Again, if we see substring that starts with b, we will get b a b a b, and so on and so forth. So we would end up with bunch of different substrings. Then we will start this replace operation on all the substrings, and eventually we would find some substring that will look like this a or this b b b b, and in any case we would be able to return the length as 4. Like, okay, this solution would work and we will get the desired result, but there are a lot of issues with that. Even if we just see that for a single character, we end up with like so many substrings, and we still have more substrings to go to. So this is a very inefficient approach, and we should avoid doing it at all costs. Okay, before we come up with the optimal solution, first of all, we will have to identify that what is our need. Our need in this case is that we are given this string, and we are told that we can replace any two characters inside this given string with any other characters because k is equal to 2. Now we need to find a substring where all the characters contains the same value, and because they contains the same value, we need to return the length of it. So first of all, we will have to identify that what is the substring where we can actually create all the characters of the same length. So first of all, let's see that can we apply this thing on this whole substring for this entire string of all the 5 characters, and this given k is equal to 2. So first of all, we will try to identify that what is the number of occurrences of every single character. So a occurs 2 times, b occurs once, c occurs once, and d also occurs once. So which means that because a occurs most of the time, our logical or rational conclusion is to create a substring where all the characters are a, because in that case we will actually have one additional character. If we try to create all the characters with value b, c, or d, obviously we are always going to fall short by one character, because the value of a actually appears twice, which means these 3 things, they have less significance compared to this a, because a is the most repeating character. And why I'm putting so much emphasis on most repeating character, because this along with this k and the length of the string or substring defines that whether any substring we can convert it to all the repeating characters or not. Let me show you how. Suppose in this case we consider all these 5 characters. Even if we replace any 2 characters, in this case we have 3 characters to replace from. If we replace any 2 characters, no matter what happens, we won't be able to create a substring where all the 5 values are actually a. Why? Because we only have the option to replace 2 elements, and there are 3 different elements that contains different values. So how we come up with this value that there are 3 different elements that contains different value than a? Well, what we did was we took the length. So length in this case for this substring is 5. So we took the length of this substring minus we subtracted the most occurred character. So most occurred character in this case is a. So length 5 minus a 2, and this we get 3. So at any case, this value, if that is greater than or equal to this value number k, which means that this particular substring we cannot do anything about it. We cannot convert into a valid or legitimate substring where all the values contains the same character. But if we just shorten our search, if we try to search in these 4 characters, okay, now what is the breakdown of the number of occurrences of every single character? Well, a still occurs twice, b occurs once, c occurs once, but d is not appearing, so we ignore this one. Now in this case, the length of this is equal actually 4, which means that if we apply the same formula, that length minus whatever the maximum occurred value, so maximum occurred value is still a, which means that we do 4 minus 2. So 4 minus 2 is 2, and this 2 is actually equal to whatever the value of k is. Because this is equal to k And in this case we can define that for this particular substring we can actually convert it to all the characters being same by using this replace function. And if we just replace this value b and c, we will get actually a substring that is all the a's, and this is the answer. So basically this is the critical part. Now remember that in order to generate this, what are the things we needed? We actually needed that what is the current length of the subsequence that we are following, or what is the length of the substring that we are doing. We actually need to know that what is the maximum occurrence of any particular character in any given subsequence. And we also needed that what is the value of k. Based on it, we were able to identify that whether any subsequence can it be converted to having all the characters to have the same value or not. And based on this concept, so formula we can create is that a valid subsequence is a subsequence where the length of the subsequence minus the most occurred character. If this one is actually less than or equal to whatever the value of k is, if this is true, then we can say that this is a valid substring, and the length, whatever the length of this particular substring is, that is also the length of the substring which contains the most repeated characters. Let's see it with an example. Okay, suppose this is the example that we are given and we want to solve this one. First of all, we are going to see that what is the formula that we have to use. Well, the formula we have to use is that for any subsequent to be valid, what we are going to do is we are going to do length minus whatever the max occurrence in that particular subsequence, and we will see that if that value, if that is less than or equal to k, if that is less than or equal to k, whatever the length is, we can treat it as our answer, and whatever the maximum answer we find so far, we will conclude it as our solution. We already know this formula. Now we need to see that how can we implement that. Basically we are going to use a sliding window plus 2-pointer solution. And inside this solution, what we are going to do is we are going to have two variables called left and right to be initialized at the first position. We are going to update the right value to the next element. Then we will check that whether the substring is valid or not. If the substring is valid, we will calculate that what is the answer. We will update the answer. Again, we will move the right value, and again we will move the right value. Again, we will move the right value until the point when the substring is not valid. The moment the substring is not valid, we can conclude that now we need to shrink our substring. So basically, suppose the R is now at this position, we will have to update the value of left. So we will ignore this element and we will move our left value over here, and then subsequently we will keep moving on, and every single time we will keep track that what is the maximum answer we have found so far, which is the longest repeated character substring, the length of it. And whenever the R reaches at the end of the list or at the end of this string, we can conclude that whatever the value we have stored in the answer, we can return it as the answer. So now, because we are using this 2-pointer approach, we know that at any given moment, what are the things we need? Well, we need a couple of things. First thing we need is we need this length. So length we can identify based on the difference between this left pointer and right pointer. That gives us the length of the current substring. Now we need to know that what is the maximum occurrence at any given moment of any particular element. So we don't know that, right? So what we can do is we can actually create an array of size 26. So one for every single character in the English language, because we know that there are only 26 characters. And whenever we find any value on the right side, we will add that value to our array. Or if we move any character on the left side, we will reduce that value from our array. So at any given moment, we would always know that what is the maximum value we have at any given position. And let's see by an example that how we will complete this operation. So let me quickly show you an example that how we will iterate over for this given example. Let me clean this up a bit. Okay, so initially our left value and right value are located at these two positions. We are also going to have an array to store the maximum occurrence of any single element. So currently I'm just showing you the elements that are coming in, but that is the idea that we will keep in mind. So first of all, currently the value is p. So we will add p over here, and we will notice that okay, the occurrence of p is one time. Just this is for understanding purposes. When we do the code, it would be slightly different, and I will explain it to you when we would be coding. Now so far this list has to be valid because there is only one character, right? Now we will update the value for r. So this is x, and x is also present one times. Now we will see, so current length of this string, so now r is located over here. Okay, so current length is actually 2, and what is the k value? K value is also 2 because that is constant, so that won't change. And what is the maximum occurrence of any character so far? So maximum occurrence is still 1, as we can see over here. So maximum occurrence is 1. So if we apply this formula, 2 minus 1, so 2 minus 1 is actually 1, and 1 is less than or equal to value of k, so that is true. So because this is true, we can say that the length of at least 2 characters can be part of the answer, so we will mention that in the answer. Now again we will update the value of r. So now r comes over here. Because r comes over here, we will update the value of q over here, and we know that it occurs one time again. So the length, so the current length is actually 3, and the maximum character is still 1. So we will do 3 minus 1. So 3 minus 1 is again 2. 2 is still less than or equal to value of k. So this is also true. Because this is true, the current length can be part of the answer. So we will update our answer to have the value 3. Now we will again update the value of our r. So now r will go over here, and this is x. So for x value, we already have 1 as its occurrence. Now x has the occurrence 2 times. So we will update the occurrence of maximum number over here called 2 times. The length also increases, so length will become 4. Now again we will try to see that what happens with our equation. So we will do 4 minus 2. So 4 minus 2, this is 2. 2 is still less than or equal to k, which is 2, which means that we can update the answer to the value 4. We will update the answer to be 4. Now again we will update the value of our r. Now r moves one value to the right. Now this is y. Y is occurring 1 times. Now the current length is 5, and the maximum value we have is x, which is 2. So far we are good. Now we will try to do 5 minus 2. So 5 minus 2 is actually 3, which is greater than k, which means that this condition is not satisfied. So because this condition is not satisfied, what we need to do is we need to update the left element. So we will update the left element over here. So now left comes at this place, but because we are updating the left element, we will also have to remove this 1p over here. So we will remove p from here, and now we will update the value. So now length will become 4. Again maximum occurrence is still 2, so 4 minus 2, that is 2. 2 is still less than or equal to k, which is good. So far we are good. Now again we will update the value of our r. So now r comes at this place. Because r comes at this place, the occurrence of x comes to 3. Now because this comes to 3, we will update the value of maximum occurrence to be 3, and we will update the length to be 5. Now we'll do 5 minus 3. 5 minus 3 is 2. 2 is still less than or equal to k. So because 2 is still less than or equal to k, we can update our answer as well to the whatever length we have found, which is 5. So we will update our answer to be 5. Now again we will update the value of our r. R comes over here. Now this is a. We don't have any entry, so we will add an entry for a, and we will call it as 1. Now in this case the length is 6. Length is 6, but maximum number of occurrence of x is still 3, which means that now we can do is 6 minus 3. So if we do 6 minus 3, 6 minus 3 is equal to 3. 3x is actually greater than k, which means this condition is not satisfied. So now we will have to update the value of our L over here. So now we will get rid of 1x. So because we are getting rid of 1x, the current maximum occurrence we have so far is 2. Okay, now our left is located at this position. Now the length is 5, and the maximum we can make, maximum occurrence is 2. So again 5 minus 2 is still 3, which is greater than k. So again we will have to update the value of our left. So now this time left comes over here, and we will ignore this q, which means the value of q becomes 0. So I'll just remove that entry. Now again this time the length is actually 4, and the maximum occurrence is 2. So 4 minus 2 is still 2, which is actually less than or equal to k. So because this is less than or equal to k, we know that okay, length 4 is can be our answer, but our answer is already 5. So there is no point in updating length to be 4. Okay, next what we are going to do is, now this time we will have to update the value r. So when we update the value r, we actually reach to the end of the string, and because we reach to the end of the string, whatever the value we have stored in the answer, we can return it as our answer. So in this case the answer is going to be 5 from this sequence, and we can mention that after doing 2 word replacement, the maximum substring we can make that contains all the same characters inside this given original string is actually of length 5, and that is the solution. If we see the time and space complexity for this one, the time complexity will actually be big O of n
where n is the number of characters that are present inside given s. Now you will think that, okay, in order for us to find the maximum occurrence, actually we will have to iterate over this entire array, and it might take like there are 26 entries, so we might have to do this work 26 times. But the thing is, we are actually going to use a clever trick over here. What we are going to do is, at any moment we update our right pointer, at that moment only we are going to update our maximum occurrence, because remember, our maximum occurrence can only increase when we update the value of our right. Whenever we update the value of our left, we essentially decrease the whatever the maximum count we have, which means that our maximum count is never gonna go high. So that's why by using this clever trick, we can actually reduce the time complexity to big O of 26 times n to only big O of n, and you will see it in the coding. Also, in terms of space complexity, we can conclude this actually two times. We can either conclude this to be big O of 26 because we are storing an array of 26 characters, or we can consider this as big O of 1 or constant space, because this 26 is a finite number. This is not an infinite number. So that is why depends on your interviewer how he wants to treat it, and that way you can take it forward. Now let's move on towards coding now. First of all, we are going to create an integer array to store the occurrences, and we are going to name it as occurrence. Now we will create few variables. So first of all, we will create variable left and right, and we will initialize it to value number 0. Now we will create a variable called answer, and we will initialize it to 0 as well. Also, we will initialize a variable called maximum occurrence. Now we will run a for loop on all the characters of given string. So first of all, we will calculate that whether we need to update the maximum occurrence or not. So now we will check that whether the current substring, if that is valid substring or not. So we are going to use an if condition. First of all, we are going to check that whether the length, so in this case, length is going to be right minus left plus 1. So if the length minus whatever the maximum occurrence is, if that is greater than k, which means that if that is greater than k, which means that the current substring is not valid. If that is not valid, we will have to update the value of left variable. And we will also have to decrement the value that is located at current left counter on the given string. Once that is done, for every single update, we will have to check that whether our answer is the longest string or not. So we will check that what is the value of our answer. That should be it. So after this loop ends, basically we should have our answer stored in the answer variable, so we can simply return that. Let's try to run this code. This should have been occurrence. Okay, seems like our solution is working as expected. Let's submit this code. Oh, our solution is not working. Oh, we need to decrement the value first before we update this left pointer. So let's try to run the code again. Okay, let's submit it again. Seems like our solution is working as expected. Hello friends, we are still not employed by FAANG companies or of lead coding till we get there. Today we are going to do longest substring without a repeating character lead code problem, and this is actually number 3 problem in the lead code, and also very popular problem. As you can see, the number of companies that have already asked this problem. So if I just check the companies where I want to get a job and I have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Apple, Google, Spotify, Uber, Goldman Sachs, Yahoo, Walmart, eBay, Lyft, ByteDance, Morgan Stanley, and Paytm. So that's why I am paying my utmost attention to solve this problem. I hope you also enjoy the video. So this is a lead code medium problem, and also one of the most liked problems on lead code. Basically, we are given a string s, and we need to find the length of the longest substring without a repeating character inside this given string. So suppose in this example, we are given a string like this.
And in this case, if we check that what is the longest substring without a repeating character, that is this one ABC, and the length of this is 3. We can also conclude this one as well. This has also length of 3, and we can return either of them, but the answer in this case we are going to return is actually 3. Let's see that what would be the different approaches to solve this problem. So suppose this is the input that we are given, and let's see that how can we solve this in a brute force manner. Well, the most basic idea is that we can take this input and take every single substring that is possible, and then check on all of those substrings that whether there are any repeating characters or not, and whichever the substring with the longest length we found without any repeating characters, we will just present it as an answer. So if I just show you by an example, in this case the number of substrings we can make is, okay, let's start from this A. So from this A we can make a substring of A, we can make a substring AB, we can make a substring ABA, we can make a substring ABAT, dot dot dot, and so on and so forth. We can make all of these substring. Next substring we will make starting from this value number B. So from B we can make B, BA, BAT, BATM, and so on and so forth. So in this case, the longest substring we would be able to make is actually this one, BATM, that is of length 4, and this is the answer in our case. So even if we use the brute force approach, eventually we would have found this substring by comparing all of the bunch of different substrings that we would have created, and then we would have written 4 in this case. But what is the issue with this approach? Well, the issue is actually quite trivial, that we are actually doing a lot of unnecessary work, and we are trying to find a lot of different substrings. Even if we just see the time and space complexity in this case, the time complexity is actually going to be big of n cube. Why n cube? Because we are going to do n square work to find all the substrings, and then we will have to do n work for every single one of them to find that whether there exists any repeating character or not. So this is a really bad approach. Let's see that what is the improvement we can make. To optimally solve this problem, we are going to use very important concept called sliding window, and in addition with 2 pointer. What we are going to do is we are going to have 2 pointers called left and right, and these left and right pointers, we are going to have them to follow a very important property, and that property is that between these values of left and right, all the elements has to be unique. If at any moment we encounter that there is a duplicate entry, which means that we will update the value of L to the point where the duplicate entry is mitigated or it's eliminated, and then we will again keep on progressing with this right pointer. Let me quickly show you how we are going to do that. So first of all, left and right both are going to start at the same position. Now we are going to make our right pointer move to the next element until the point where we find a place that is actually repeating. So we are now, our right pointer is at this position, our left pointer is at this position. So far we have 2 elements in our substring and both are unique. So because both are unique, we are good up until to this point. Also at the same time, we are going to have an answer variable where we are going to store the length of the maximum substring we were able to find with all the unique characters. So far initially this value was 1, but now we have found that there are actually 2 elements for this substring that has all the unique elements so far. Now we are going to update the value of our right pointer again. So right pointer will come over here. Now again right pointer is here, but at this point, okay, we need to check that, okay, amongst this A and B, does A exist somewhere? And we know that A exists over here. Now you will quickly ask me that, okay, in this case, since we only had 2 elements and we were comparing this A, it was really easy for us to identify. What if we had like 10 elements like this, and then we are comparing this A, and we need to check that whether at all these 10 positions does this A exist or not, and that would make things really inefficient, and that would be big of n square time complexity. So what we are going to do is we are going to have a visited hash set, and inside this visited hash set we are going to store all the characters we have found so far between L and R, and we are going to keep on adding until the point we find a repeating character. So initially this only had the value A when we are at this point, then we added a B. So far inside our hash set we actually have A and B, and now when this R pointer comes at this position A, first of all we'll check that whether A exists or not, and we realize that, okay, A exists inside this hash set, which means that amongst this substring we cannot add this value A because A exists over here. So now what we are going to do is we are going to remove A from this our set, and we are also going to update our left pointer to remove this value A. So okay, we ignore this a, and now our left pointer is at this position, our right pointer is at this position. So far the values are b and a, and now we are again going to add this value number a over here because this right pointer is here. Okay, what is the length so far? So the length is still 2. So because length is 2, we are not going to update in our answer, because in our answer the length is also 2. Now we are going to update our right pointer to come to the next element, and when we update the right pointer, it comes over here. So this t does not exist inside our hash set, so we will add entry t over here, and our we will update our answer as well. So now our answer becomes 3. Now again we will update our right pointer to come over here. So when the right pointer comes over here, we will have an entry m. So again we will add the value m over here inside our hash set because it does not exist before, and we will also update our answer to be of length 4 so far. Now again we will add our right value over here. So when we add the right pointer over here, and at this moment this is a, so we try to check that whether a exists in our hash set or not, and we can realize that okay, a exists already. So immediately, because a exists, now we will have to move this left pointer up until the point where we encounter this a. So okay, this b, we can ignore this, and we'll jump our left pointer. Okay, left pointer comes over here, and again this is a. So again we will ignore this, and then we will come for the left pointer to be over here, which means that left pointer is going to be here and right pointer is going to be here. And also at the same time we will have to remove this b and a from our hash set that we were currently visiting. So currently the entries we have is t and m only, and then because this right is at this position number a, so we are going to add an entry for a. Now we are going to update the, and so far the length of this one is actually 3, so we don't need to update in our answer. And then again we are going to update the right pointer. So right pointer comes over here, this is n does not exist inside the hash set, so we will add an entry called n over here, and then this length is actually 4, so answer is 4, so we don't need to update so far. And then if we try to do next to this right pointer, we come to the end of the list, and the string is empty now. So because we are done iterating over the entire string, now all we need to do is return whatever the answer we found in this case, and the answer we found in this case is 4, and that would be our final solution. So if we see the time and space complexity in this one, it's actually really efficient. So in terms of time complexity, we are actually completing all of these things in a single iteration, so it's actually big O of n. And in terms of space complexity, we are using this additional hash set to store the value, and the space complexity at any given moment is actually going to be big O of whatever the answer we have, or whatever the longest increasing subsequence we have. Because remember, at any moment we are only having that whatever the maximum number of unique characters in the substring we have. The moment we increase the moment we encounter a repeating character, we are actually getting rid of all of them. So that's why the space complexity is going to be big O of whatever the longest repeating character we have found so far. So first of all, we are going to check couple of edge cases, that if the given string is empty or if it only has one character, then we will return. So now we are going to initialize couple of variables called left and right, and we are going to initialize its value to 0. We are also going to initialize a variable called answer, and by default we are going to have the value as 0, and we are going to initialize a hash set of characters. So first of all, we are going to run a while loop till the point where right reaches to the end of the string. First of all, we are going to initialize a character variable, and to find the value of that particular index. And then we will check that whether this value exists inside our hash set or not. So if the value exists inside our hash set, we are going to remove it from our hash set, and we are also going to update the value of our left pointer. And if the value does not exist, we are going to add it to our hash set, and then we are going to calculate that whether the current answer we have is actually greater than whatever the answer we had before. And we are going to do right minus left plus 1. And at the end we are going to update the right pointer as well, and that should be it. So when both of these loop runs and after it ends, we should have our answer inside the answer variable, so we can simply return that. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit it. And our code runs as expected. I will be posting this solution inside the comments.
Hello friends, hope you are having a fantastic day today. So in this video, we are going to do an awesome lead code problem called sliding window maximum. This problem has been asked at tons of different companies. It is extremely well liked and also a lead code hard problem. So without any delay, let's get started. Now let's try to understand the problem statement for this problem. We are basically given an array of integer called nums, and we are also told that there is a sliding window of size k, which is moving from the very left of the array to the very right of the array. So which means sliding window is moving constantly. Now we are told that we can only see the k numbers of the sliding window, and each time the sliding window moves one step to the right position, now we need to return the maximum sliding window for every single sliding window that we have been able to find. So let's try to see some example for this given problem. So initially the window is going to be located at this position. Then window is going to keep on moving one step towards the right, which means this one is going to get eliminated and we would have a new window created like this. Same way, this 3 is going to get eliminated and we would have a new window created like this. For every single moment, we need to return the maximum sliding window. Okay, is that for this? We will have to create another array where we are going to note that what was the maximum character for every single sliding window that we have been able to make. So the very first sliding window is going to be this portion 1, 3 and -1, which means the maximum value in this one is value number 3. So we are going to add value number 3 to our answer. Next, this one gets eliminated from the given input array, and then we will have a new window that appears of this size, which means once again the maximum value is going to be 3. So we are going to mark 3 as the maximum value. Next, for this window, now we have this value number 5 that is going to be the maximum window for the current given input. So now we are going to add 5 to our answer. Same way, we will also have 5 for this particular window as well, and we will add 5 once again. Now we also get rid of this element, and now we have this window to look after. So in this case, we have a new maximum value that is 6. And then in the end, we will have this last window where it contains 7 as the maximum value. And this is the answer that we will have to return in order to understand that what is going to be the maximum sliding window. So this is what is expected of us to return. For the brute force approach, the way we are going to do is that we are first of all going to create a window of size k. So suppose even in this case we are given k is equal to 3. We create this window, then we iterate over every single element and we try to find the maximum element. So we found maximum element as 3, so we mark that as the answer. Then we get rid of this one, we create another window and once again repeat the same process until we reach to the very end, and then we would be able to find the solution. Now in this case, the answer works perfectly fine, but the issue is for every single element we will have to iterate over 3 different elements to find the answer, and every single time we are creating a new window, which means the time complexity is going to be big O of n cross k, which is an expensive time complexity. So let's see that how can we improve on this one. One major improvement that we can make for this our given input is that instead of every single time creating a new window, what if we just use this logic of this existing window we already had and try to find the maximum value that we have already identified and then move forward and then play around with that maximum value. That is one of the option, and this is going to be an intermediary step that we are going to use in order to generate the optimal solution. So that's why I'm explaining this approach. The idea I'm suggesting is that, let's say in this case, first of all, we have an element called max. This max element is going to keep track of the maximum character that we currently have inside our array as the window. Okay. And let's say that first, okay, currently we are at value number 1, which means we can only start adding the value after we have reached to the index value 2.
So any value before that should not be added to the answer or should not be treated inside our answer array, but we can still keep track of the maximum element we have been able to find so far. So the idea is that first the value number is 0. Okay, currently maximum value is null, so we can add the maximum value we have been able to find so far as this value 1. Then we are at value number 1. Now once again this value is 2, so because 2 is greater than 1, so we will add value number 2 as the maximum element we have been able to find so far. Then we are at this third value, that is minus 5. So once again the maximum element we have been able to find is 2. So we are amongst, for this first window we will have to add one answer, and that answer we can directly take from our maximum element, so we can take value number 2. Next we will have to add one more element. So now we are at this value number 6. After at value number 6, this 6 is definitely greater than the current maximum value we had, so we can add value number 6 as the answer for this one. Okay, and now once again we will have to add the maximum value, so we can add value number 6 over here. Once again we find value number 7, so that is going to replace our maximum value, and then value number 8, that is also going to replace our maximum value, so we can add value number these values like this and build an answer. So you must be thinking that, hey, this looks quite straightforward, then why is it even this a hard problem? The thing is, we actually intentionally I chose an input like this because this is a very simple input where we don't have any particular issues. But if we are given an input, let's say now in this case, currently we are going to put our maximum value as this value number 3. Okay, and then now we are iterating over for this first sliding window. We will have to choose value number 3, but the thing is we are not sure which value number 3 we picked, and in this case let's assume that this becomes value number, instead of this being 4, this is 1. Okay, so let's assume that in this case so far we know that this is the 3 that we added, but it could also be this 3. And now when we do move to the next element, which 3 do we have to remove, because we are not keeping track of the index value of the maximum element, and that's why when our sliding window moves we would be confused with this element. So that is a problem number 1. The second problem that we can think of is that we are not dropping the elements as we are moving forward. So every single time we move forward we will have to drop all the elements that have already passed the given existing window, which means the approach that we found is to use the maximum element is correct, but the problem is that number 1, we are storing the value. That is an issue because we don't know that what is the index position. That can be fixed by storing the index position. But second issue is that we are only too much focused on just one character. Meanwhile, we should be focused on an entire window rather than just one character. And the approach of this window is very simple and very straightforward, that at every given moment, whichever the first element that entered inside the window would be the first element to be kicked out of the window when we move to the next window. So using these two approaches, what I'm suggesting is that instead of using a maximum variable just to store the value, I'm suggesting that instead of this, number 1, instead of storing value, we store index values. So index values will allow us to calculate that whether we are at the current window or not, which means it would help us to kick elements out. And second thing is that instead of only using one variable, because we are using an input of a window where we are continuously removing the previous elements, which means we are using the concept of first in first out for the current to maintain the current window, which means we can have a queue where we can keep track of the values that are currently present inside the given window. And we know the concept of queue is very simple, it's first in first out, so we can manage that. On top of it, inside the given existing window, we don't have to worry about storing all the 3 elements. We only have to worry about that what is the maximum element in any given window. So what we can do is that for our given queue, we will always keep track of the maximum element that we have been able to find at the very first location, so that we don't have to iterate over the entire queue to find the value. We can simply do a peek operation to see that what has been the maximum value inside the given sliding window. And now this should be able to solve a lot of the issues we were facing previously. So let's understand the approach I am suggesting. The logic is quite simple. Let's quickly take one example. Okay, so let's say that this is the given input that we are dealing with, and we are given that the value k is equal to 3. Now I have created an array to store our answer, and I have also created a queue where we are going to store all the values of the given current window inside the ascending order, and we are going to maintain the maximum value as going to be the very first element inside the queue. That is going to help us out a lot. Once again, I'm iterating. We are going to store the index values inside the queue, not the actual values itself, so we can quickly navigate that what should be the current window size. Okay, so I hope these things makes clear. And remember that since our given k is equal to 3, we can only able to start adding values after we reach to the index value 2 onwards. Okay, and I'm also creating one more variable I, just to understand that what is the current variable we are iterating over. So let's say that currently I is equal to 0 we are iterating over, which means this value. Now currently our queue is empty, which means we don't have any maximum values. So let's quickly add one value. So currently our queue contains just one element, that is 0, and I'm also writing the corresponding value 1 just for our sake of understanding. Okay, now we cannot add anything to the answer until this point, so we are going to move forward. Now once again we identified index value number 1 that contains value number 3. So this value is actually greater than the current value of the index position we have inside the queue, which means that we need to add this 3 over here. So we are going to add value number 1 as an index value, and which has the corresponding value 3. And we are simply going to remove this value number 1 or this index value 0 all itself. Why? Because for any given window size that we are able to create, it is always going to be that this is going to be the maximum element. So why do we even keep the non-maximum elements inside the queue? So the moment we are going to identify any maximum element, we are going to iterate over the given existing queue to remove all the elements that are going to be smaller than that for that particular sliding window. That is going to help us out a ton. Okay, so now we got rid of this element. Okay, now still we cannot add anything to the answer. So now we are at I is equal to 2 position. So currently this is value number -1. So -1 is actually not greater or smaller than the current maximum value we have inside the queue, which means we are still going to add it inside the queue as index value number 2, which contains value -1. But this would not be the first position. And now since at this I is equal to 2 position is equal to k is equal to 3, which means we are at our first window. Now whatever the maximum element we have inside our queue, at the very first position, we are simply going to peek that index value and then go back to our actual given input array and find that maximum element and put it in the answer array. So now we are going to put value number 3 first. Okay, now we are at index position number 3. So once again, index position number 3, the value is -3. Now what is the current maximum value we have inside our queue? That is index number 1, which means for our ith position, what is the sliding window? It is value 1, 2 and 3, which means the very first element inside the queue we have is still inside the valid window. So we don't have to kick that value out. That is number one thing we need to check. Next, we need to check the value for index I is equal to 3. So this value is -3. So because this value is -3, it is less than the current maximum value we have. We are going to add it normally inside our queue. So we are going to add index position number 3, which corresponds with the value number -3. Okay. Now, and once again, we will have to add the maximum value, because now for every single value, we are going to add one value inside the answer. And once again, for maximum value, we are simply going to do a peek on very first element. That is our maximum value. And we are simply going to add it inside our queue. Okay. Now next we are at I is equal to position number 4. So now we are at I is equal to position number 4. For this one, the window size is going to be 2, 3 and 4, not 1. So 1 should be removed. And currently in the very first element of the queue, we have value number 1. So which means we are going to remove value number 1 right here and now. Okay. Now after this, we are going to compare the value that we currently have for this value number 4. That is this value number 5. and we are going to compare it with very first element. So since 5 is greater, which means the moment we identify that the 5 is greater, we are going to check every single element that are smaller than 5 and we are going to remove all of them. We don't need them inside the window because we are only keeping track of the maximum elements. So now we are going to store index number 4 that contains value number 5. And after doing this, we are going to once again add it to the answer. So we are going to add value number 5 to the answer. Next is element number 5 that contains value number 3. So once again, this particular value inside our queue, index number 4, is still part of the current sliding window. So now we are going to check the values. So 3 is obviously less than value number 5. So we are going to add value number index number 5 or value number 3 inside our given queue. And then once again, we are going to add value to the answer, that is once again going to be value number 5. Now we are at this position where the value is value number 6. And once again, I just for our understanding, we are dealing with this window. So index values 4, 5 and 6. Okay. Now for this I is equal to 6, we will first check that whether 4 needs to be removed. No, it can stay there for now. Now we compare the value. So currently this value number 6 or the index I is equal to 6 contains the value number 6 that is greater than the index position 4 that contains value number 5. So we are going to get rid of this one and we are going to check all the values that are smaller than 6. So currently all of these values were smaller than 6 and we are only going to store index number 6, answer number 6, once again marking 6 as the answer. And lastly, we are at I is equal to 7. So if I is equal to 7, then the valid queue or the valid window becomes 5, 6 and 7 index values. So the current index value we have inside the queue is 6, which is still valid. Then we compare the value. So 7 is greater than 6, which means we are going to replace 6 with value number 7, and which also coincidentally have the value number 7. And then because this is the maximum value we are able to find, we are going to also mark it to the answer. And in the end, we are just simply going to be done with our existing loop. And that's it. This is the whole approach and this is the whole solution that gives us the desired answer in a single iteration on the given input array. And all we are doing is just sometimes we are doing repeated work inside the queue to change the value of the array. But apart from that, we are not doing anything. So this is a wonderful approach to solve this problem. And this is actually the optimal solution. If we see time and space complexity for this approach, the time complexity is actually going to be big O of n because we are simply going to be iterating over this given input array once, which is pretty awesome and pretty convenient. So yeah, that's it. And in terms of space complexity, because we are using an extra queue, so that is going to be big O of k, because at max this can be of size q, nothing more than that. So let's try to run this code. And so now let's try to build the coding solution for this one. Okay, so this is the coding solution. First, we are checking for some edge cases, that if the given input is equal to null or if the given k is equal to less than 0, then we can just simply return a blank or an empty array. If that is not the case, first we initiate a variable to store the length of the array. Then we also create a new value to store the result of the given array. And then we are also initializing a dequeue to store the queue values that we just discussed in the solution. Now we are simply creating an array to iterate over the given list. Very first, we are checking that are there any indices inside the current window that are exceeding or that needs to be kicked out. For that, first we check that if the given queue is not empty and the very first element or the largest element inside our given queue, if that is less than the value of I minus k plus 1, if that is the case, then we simply poll that element out. If that is not the case, then we simply iterate over all the values that are smaller than the given current value. If we identify that scenario, we simply keep on iterating all the values and keep on removing them. Then we simply have to add the value to the queue, and we need to find the maximum value that is currently located at the very first location inside the queue to our array, and we simply add it after the value I becomes greater than the value of k minus 1 that we just explained. And in the end, our result array should have been populated, so we can simply add all the values and return that. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast compared to a lot of other solutions. Once again, the coding solution is present on the GitHub repository that we have created, so you can go and check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do minimum window substring problem, and if we see some of the companies where I want to get a job, there are companies like Facebook, Amazon, LinkedIn, Microsoft, Lyft, Airbnb, Apple, Adobe, Google, Snapchat, Flipkart, ByteDance, Spotify, TikTok, Bloomberg, Uber, Pinterest, and Goldman Sachs, who have already asked this question. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a lead code hard problem, but it is also a very well liked hard problem. Basically, we are given two strings called S and T, and we are given the lengths M and N respectively for each S and T strings. Now we need to return the minimum window substring of given string S such that every character in T, including all the duplicates, that is the key part, is included in the window that we have created from this S. And if there is no such window, then we need to return the empty string. So if we try to understand this with an example, if we take this example, for instance, we are given a string S that looks like this, and we are given a T that looks like this. Now we need to return a substring in this given S such that this A, B, C is present. Now we don't care about the order of this A, B, C. They can be in any order in the new substring that we are trying to create, but we need to return the smallest substring. So if we see one of the substrings that where this A, B, C is present, we can find a substring that looks like this. If we see this particular substring, for an instance, we can see character A, B, and C is being presented. But the thing is, the question is this the minimum window substring? No, this is not the minimum window substring. Why? Because there exists actually a smaller substring where A, B, C is also present, and we can take one more substring that looks like this. So this substring is smaller than this first one, where also A, B, and C is also present, though they are in different order. But this is again not the minimum substring. There is actually a substring which is B, A, and C, where all the values of A, B, C is present. That is continuous substring of this S, and this is the minimum substring where we can find all the characters that are present in T, and we need to return this as an answer. If we see couple of more examples over here, suppose we are given S is equal to A and T also equal to A, we can simply return A as the substring because that is the only substring we can create. Now if we are given S is equal to A and T is equal to double A, which means that there is no way possible for us to create double A from this single A. So in this case we need to return an empty string. So now since we have understood the problem, let's see that what would be the different approaches to solve this problem. So first of all, I'll show you the brute force approach, and if you directly want to check that what is the optimal solution, I have already provided the timestamp, so you can directly jump onto the optimal solution as well. Okay, suppose this is the S and this is the T we are given. We are looking for a substring inside this given S which contains all the letters of this T, and we need to find the minimum length substring for that. Now we can clearly see that there is one substring HBPO which contains all of the elements that are present in T, but the smallest substring we need is actually OBH, which contains all the elements of this T, and that contains the smallest length. The brute force way to solve this problem is that we actually start creating every single possible substring out of this given string S. So we can create substrings like, we will check that okay, this can be a potential answer, we will put it as a potential answer, and we will mark its length. Now eventually we would find a substring that looks like this OBH, that is the correct answer, and then we would return this answer as our solution. So this solution will also guarantee to provide us the right answer, but this right answer is actually very costly. Why very costly? Because we know that it takes big O of n square to actually create all the substrings, and for every single substring we will have to check that whether it contains all the elements of T or not, which means we will have to multiply this by the whatever the length of T is, which is let's say M in this case, which means that we are actually essentially doing big O of n cube work to solve this problem, which is very expensive. Okay, suppose this is the example that we are given, and we are trying to find that what is the minimum substring inside this given S where all the characters of this T is present. So to optimally solve this problem, we are actually going to use sliding window technique with two pointers. So now I have presented the input in a slightly different format, and I have also created that what is the answer we are going to store, because remember in the answer we need to return that what is the minimum substring, and for any minimum substring we need the left pointer and right pointer value, and we also need the length, and we will only choose the minimum length. Now initially we are going to have our left and right both pointers starting at the first position, and now what we will have to check is that we are going to have our right pointer go on the right side until the point where we create a substring where all of these A, B and C are present. The moment we do that, we will note down that what is the answer we have found so far, what is the minimum length, what is the left pointer, what is the right pointer. Once we do that, we will start updating the value of the left pointer to go on the right side until the point when this condition is no longer true and we are not able to make A, B, C in the given left and right string. And again we will update the process on our right portion, and then again we will try to see that whether we can find a better substring or not. So let's see this approach in action. So now to achieve this approach, what we are going to need is that we already have our 2 pointers left and right over here. Now we need to check that at any given substring whether this T is present or not. So if we for every single substring try to check that whether all of the characters of T is present or not, it takes a lot of time. One quick way to do it is that we actually create a hash map for all the characters that are present inside this value number T, and inside the hash map we note that what is the elements and what are the number of occurrences they have. So in this case, for this T hash map we actually have 3 characters only, and we have 1 occurrence of each of them. So we are going to note it somewhere so it becomes easier for us to record. Now at the same time, for any substring that we create, we will also have to check that whether we have all the satisfied words inside our substring or not. So again we are going to create a hash map for our substring that we are creating as well, and inside the substring hash map we are going to keep on adding the values as we move forward. Now to check hash map every single time is not a very good approach. A better approach in this case could be that we already know that what are the number of unique characters we need inside this hash map. So why don't we just create 2 variables called the number of unique characters. So we just name it as unique that are present inside this T hash map from this given original input, and whatever the substring inside the substring, whatever the unique characters that we have already been able to create. So let's just say that this name is create, and we will keep track of it, right? I'll just show you that how we are doing everything when we keep moving forward on the with our example. So initially left and R both are at this position, and currently we will note that okay, A is not present inside our given substring, so we will add an entry for A, and so far we have received 1 occurrence so far, right? Now originally this T hash map had 3 unique characters, so we are going to note that there are 3 unique characters that we have to find in any given substring. And so far, because this current right position is at A, we have already found one of the characters of the required occurrence, right? So we will note down that okay, we have already received one of the characters. Now our right pointer is going to the next element because we haven't satisfied our full condition. So now we identify that okay, this value is actually B, so we are going to add an entry over here inside our substring hash map, and we are going to say that we have found 1 occurrence of B, and this 1 occurrence of B is already also required inside this given hash map as well. So we can note down that okay, out of this 3 required, we have actually found 2 unique characters that are needed, right? We are good so far. Now next thing we are going to do is that again over here we are going to update the value for right pointer. We encounter that this value is actually A, so we are going to add one more entry to our required pointer. So over here we have found 2 occurrences of A, but that does not solve our problem because our unique and create are still not same. So now we are going to update the value of our R again. So now again R is at this position X is not present over here, so we will add an entry for X is equal to 1, but this X is actually not present in this T hash map, so we can't do anything about it. Now again we will going to update our value of R. So R is at this position. Now because R is at this position, remember that this is the value of C is actually 1. C was the remaining value inside this T hash map. Now we have 3 unique characters that were needed, and we have already created 3 unique characters inside this given hash map. So now we are going to treat this substring as our answer, because remember we needed to have the values A, B, C, and A, B, C are actually present over here. This is A, this is B, and this is C inside this given left to right substring. So we have found one potential answer. So first of all we are going to check that okay, what is the length of this one. So length in this case is 0, 1, 2, 3, 4. So length is actually 5, and the left pointer is at 0 position and right pointer is at 4 position, and we are able to add this entry to our answer because we don't have anything before. So that's why we were able to add an entry to our answer. Now we are going to update our left pointer until to the point when this condition is no longer true. So now because previous value of left pointer was over here, and now we jump to this place. So now left pointer is at here, but the moment we updated the left pointer, we will also have to remove the value of our reduce the value inside our substring hash map. So now there is only one occurrence of a. So far this condition is already true because both this 3 and 3 is matching, right? Now again we are going to update the value of our left pointer to one more character. So now left pointer is over here. Now this b is actually 0. So we are going to remove the entry for b. Now because we remove the entry for b, we have only created two elements that are needed inside this substring from this position 2 to position 4, which is a and c. We don't have b entry, which means now we will have to update the value for right pointer until we find the b. Now lucky for us, b is actually very next to this right pointer. So now right pointer is over here and b is actually over here. So b is 1. We will add an entry over here, and now we have already created all of 3 elements needed rather than 2, and we are done with this case, right? So which means we can say that this new substring is also a potential answer. And let's see that whether this substring is actually better than our previous answer or no. How can we determine that? Remember, the aim of this question is to find the minimum length of the substring. So we are going to compare the length of this one. So length of this one is actually 4, and the current answer we had was actually of length 5, which means it is in our interest to update the length over here. And the moment we update the length, we will also have to update the left and right pointer over here. So left pointer currently is at 2 position and right pointer is currently at 5 position. Now we have found a potentially better answer. Now again we are going to update our left value because we have already found the answer. So now left comes over here, which means we will have to reduce this value of a. So again we are going to reduce the value of a. So a is now 0. So there are no occurrences of a. Because there are no occurrences of a in this new substring, we have only created 2 elements out of this 3 unique characters that we are needed, and which we can see in this particular substring from this position number 3 to position number 5, that we only have c and b, we don't have a. Now we are going to update the value for right pointer. Now again when we update the value for right pointer, lucky for us, we are actually able to find 1a. So we will add an entry inside our substring hash set that okay, now we have found one character. Now we can say that we have created all 3 characters that were needed. Now this is also potentially a new substring, and can this be a better answer? So we'll check. Okay, in our length we already have an answer of 4 inside our answer array that we have stored, and this is also an size of 4. So which means that there is no point in updating our answer. We already have the same answer with the same length. So we are going to go to the next case. So now again we increase our value of left. So now left is again at this position. So we will have to ignore this x because we already got rid of it, which means that we have already traveled all the values so far. And now we are at CBA. Now CBA, again this is all of these 3 elements that were needed, and we already have that, which means that this is also potentially a better substring that we have found, and the length of this is actually 3. So because the length of this is 3, this can be a better answer. So we will note it down. So this is 3. Now left pointer value is 4 and right pointer value is 6. So we have found a potentially better answer. Since we have already found an answer and we know that this is a valid substring, now we will have to update the value for left pointer. So once we update the value for left pointer, we are actually going to ignore the c. So now we get rid of the c inside our hash set. Now we also get rid of this l, and now we have taken care of all of these elements so far. Now that we only have ba, which means we only have 2 elements out of 3 that we needed. Now again we will have to update the value for right pointer. So again we update the value of our right pointer over here. We find that okay, this value is actually c occurrence is 1, which means we have created this element actually 3. All of this is successful. Now we check that okay, length of this is actually 3. We already have an answer of length 3, which means there is no point in updating that. Now we will update the value for left pointer. We will ignore this b. So if we ignore this b, now we only have 2 elements out of 3 needed. So because we have 2 needed, we will have to update the right pointer. So now when we update the right pointer, we are actually going to be at the end of our string, and because we are at the end of our string, we can actually break out of the loop. And the moment we break out of the loop, which means that whatever the value we have stored inside the answer, we have the left pointer, we have the right pointer. So all we need to do is we need to return the substring. So if we return the substring in this case, we will have to return the substring that looks like this. So the answer in this case is actually going to be CBA, which is the minimum substring that we can achieve, that contains all the elements of the T that are present over here. And remember, over here we are using hash map and substring hash map to find the answer. In order to make our lives easier, we have created 2 elements to know that what are the unique characters that we need to compare. In case, because this was a string and we know that there can be only a finite number of unique characters, which is 26, we were able to use this technique. But your interviewer is for sure going to ask you that rather than having a string and having finite number of unique characters, you are actually going to have millions of hash code characters or something like that. In that case, you will not use this technique, and you will actually just simply have to check over the hash map for every single substring that you are going to make. So this is one of the approach where we can find the optimal solution, and it works as expected. If we see the time complexity is actually going to be O of whatever the length of string is plus whatever the length of T is. And why we are able to achieve this time and space complexity? Because we are using this technique, so that makes our lives a little bit easier. If we see the space complexity is also going to be actually O of the whatever the size of S is plus whatever the size of T is, and this also works because we are creating 2 additional hash maps and we need to take care of that space into account. But overall, this is still much bigger improvement in compared to our brute force approach. Now there is one more approach to solve this problem, that whatever the input that is already given, first of all, whatever we create the same hash map we create for this element number T, which means that we actually use the same hash map that I have drawn over here to compare all the values of T. But for this value number S, actually remember that we only need to find the substring of characters that are present in T. But so if that is the requirement, why do we even bother checking this element X or any other element that is not one of these values? So a better way to solve this problem is to create another hash map where we ignore this X and we only keep character inside this given string that are also present in the inside this given T. And in this particular hash map, we also identify that what is the index value for every single element. So in this case, we will determine that okay, this A is actually present at 0th position, then again we have a B that is present at 1st position, again we will mention that there is an A that is present at 2nd position, and so on and so forth, and then it will make our lives a little bit easier and we can solve this problem. But I don't think in an interview, even if you show this approach, they are going to completely reject your suggestion. So that is why I am choosing this one. Let me know in the comments if you want me to solve the other approach as well, where we are only going to use the unique characters that are also present inside this given T. So first of all, we are going to check some edge cases. If the given string is empty, or if the length of the given T is actually greater than length of S. If that is the case, we can simply return as empty string. Now if that is not the case, we will create a hash map to store the value of this T string inside the hash map for all of its characters. We are going to name it as map T. Now we are going to run a for loop across this given string T, and we are going to add all the entries to our map T. After the loop ends, we are going to create a variable called required that gives us the number of unique characters that are present inside our given map T hash map. Now we are going to initialize bunch of different variables to keep track of different things. So first of all, we are going to initialize variable called left and right to keep track of our 2 pointers. Once that is done, we will create a variable called create that defines that what are the number of variables that we have created so far that are also present inside the given T. and we are going to initialize an integer array to store the value of answer, and we are going to initialize the first value as -1 inside the answer, where we are going to keep track of the length of current substring, and we are going to have two more entries to store the value of left and right pointer, and we are going to initialize those values as 0 as well. We will also create a hash map to keep track of all the values that we have found so far inside the current substring. And now we are going to run our while loop across the string s, and we are going to run it until the right pointer reaches to the end of the string. So inside our loop, first of all, we are going to add an entry to our hash map for any particular given substring. After adding a value to our substring, now we will check that whether all the elements we have added in the substring is that element also present inside our map t as well. If that is the case, we can increment the value of number of characters that we have created in our substring that are also required inside our map t as well. So if this condition is true, we will update the value of our create variable. Now after updating that, we will also have to check that whether the current substring, if that is valid or not, and by valid I mean that whether the required and create has the same value. If that is the case, we will have to update the left pointer, and we will have to shrink our size. Also we will have to add entries to our answer array as well. So we are going to run another while loop, that while left is less than or equal to right, and the required is and created are same. We are going to check that whether we need to update our answer or not, and we are also going to update the value of the character c variable to help us in doing a lot of other things, and we are going to assign it the value of the current left pointer. Now we check if we need to update the answer. After updating the answer value, we will also have to remove the entry from our substring map because we are updating the left pointer. And after removing the entry, again we will have to check that whether the value of our entry that we just removed, did it caused us to reduce our create variable, which means that have we removed any entry which was also present inside our map t hash map as well, which was required for us. If that is the case, we will have to reduce the value of our create variable, and it could make us break out of this loop as well. In any case, we will have to update the left pointer, so we'll update the value of left pointer, and after that is done, we are done with the inner loop. In the outer loop, we will have to update the value of right pointer, and that's it. So basically, after this loop ends, essentially we would have taken care of all the scenarios that are needed for this loop, and now we will work on returning the answer. So for the answer, we will have to check that if the value of answer of 0 is equal to -1, which means that we are not able to find any value that were suitable to create as a valid substring. If that is the case, we will return an empty string. If that is not the case, we will return the value inside our answer array for this left and right pointer value, which means answer of 1 and answer of 2. But we will have to do right +1. Why +1? Because the indexing works from 0 to r, so that's why we will have to add one more entry to our right. Let me try to run this code. Oh, we made some mistake in generating the answer. Okay, seems like our code is working. Let's try to submit this code. And our code runs as expected, and I would be posting this solution in the comments so you can check it out from there. Thank you.
Now let's try to understand that what is two pointers pattern. It is very closely associated with array, and it's slightly different from sliding window. So let's try to understand that what we are talking about. So basically, in the sliding window technique, we typically have a kind of window associated that we move forward most likely in the left to right fashion, and we keep on adding an element and removing another element. Now in the two pointer technique, typically we are going to have two pointers where one begins at the start position, another begins at the end position. This is just an example, but this is the most likely scenario, and they both are going to slowly come towards each other, eliminating these numbers in some fashion depending on certain condition. This is the whole concept of two pointer problems. Now there can be other examples where we are also going to use two pointers in the future, that is with the linked list. So it's a pretty common scenario where in the beginning of the linked list we start with two pointer, where one is going to be a fast pointer, another is going to be slow pointer, and then we can see some interesting results. But I'm not spoiling anything at the moment. So let's dive deeper into interview questions that would give us the best idea about what this technique and topic is. You might have seen some examples, but let's just dive deeper into the interview questions.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid palindrome lead code problem, and if we see some of the companies where I want to work at who has already asked this question, there are companies like Facebook, Amazon, Microsoft, Apple, Bloomberg, Spotify, Adobe, TikTok, Google, and Uber. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a lead code easy problem, and basically we are given the definition of what a palindrome is. We are told that after converting all the uppercase letters into lowercase letters and removing all the non-alphanumeric characters, if the string reads same as forward and backward, then we can determine that any given string is a palindrome. Now we are given a string s and we need to return true if the given string is palindrome. If not, we need to return false. So let's try to understand this with an example. Over here we are given a string that looks like this, where you can see that there are some alphanumeric characters as well, which we will have to get rid of. This is only put there just to add some sort of additional complexity. Apart from that, it serves no purpose. This is the original string that we are given. Now if we convert all the uppercase letters to lowercase and remove all the alphanumeric characters, we will actually get a string that looks like this. And if we see for this particular string, if we start going from the front and even going from the back, we will see that all the characters that are present from the front, they are also present from the back in the same order. So that is why we can determine that this string is actually a palindrome, and we will return true in this case. We are given another example that looks like this. Over here we can also see that there are some alphanumeric characters which are the two space values, so we will have a string that looks like this. And over here, if we try to see that whether this is a palindrome or not, currently this R matches, A matches, C matches, but this E actually does not match over here, and over here actually we have an A. So that's why this is not a palindrome, and we will return false in this case. So let's see that what would be the approach to solve this problem. Now suppose this is the example that we are given, and we need to determine that whether this given string is a palindrome or not. The approach I'm suggesting is, first of all, we iterate over this given string, we get rid of all of these characters that are alphanumeric. Once we do that, then we will create a new string that is actually reverse of this original given string. And now we have two strings at our disposal. All we have to do is compare both the strings. If they are same, we can determine that they are actually palindrome and we can return true. If they are not the same, we can return false immediately. So let's see that in the action. So first of all, we are going to create a string from this original input string, where we are going to get rid of all of the non-alphanumeric characters. Once we are done that, now we are going to reverse the string. So we are going to create a new reverse string from this original given string, and we are basically reversing whatever this given input is. In this case, if we compare this given reverse string and whatever the string we are given, they both possess the same value, which means we can determine that this given original input is actually a palindrome, and we can return true in this case. So this is one of the solutions where we can work with, and this solution would work as expected, no issues with that. Let's see that what would be the time and space complexity over here. So for the time complexity, actually first of all we are iterating over this given string to remove all of the alphanumeric characters, and then again we are iterating over this given string to create a new reverse string, which means that we are essentially iterating over this original string 2-3 times and comparing it, and basically we are doing big O of n work, but actually we are doing like big O of 2 times n work. In terms of space complexity, because we are creating this new original reverse string, so that is why we are also consuming some space. So that's why the space complexity in this case is also going to be big O of n, where n is the number of characters that is present inside this given string. So this approach is okay, it's justified, it works as expected, but the question is, can we do something better in terms of space complexity and even in terms of time complexity? And yes, there is a better approach, and let me quickly show you how. Okay, so for the optimal solution, what we are going to do is, suppose we are given an input that looks like this. Now over here we are actually going to use a 2-pointer solution, and we are going to have a left pointer and a right pointer, and initially the left pointer is going to be located at the leftmost position and right pointer is going to be located at the end of our string. Now at any given moment we are going to compare that what is the character value of left and right pointer, and we are also going to check that whether this given left and right pointer, if there is that like a non-alpha numeric value. If that is the case, we will just like increase the value of left or right pointer, and if both the values are same, essentially we will move the left pointer on the right side and we will move right pointer on the left side, and we would keep on doing this process until left and right are adjacent to each other before right crosses the left. And if we are able to reach to that point, we can determine that this is actually a true and valid palindrome. If that is not the case, we will basically return false at any given moment if we identify that left pointer and right pointer character values are not matching up. So let's see that in action. Suppose this is the string we are given. Currently the left is located at this m and right is located at this small m, but in both the cases we are only dealing with lowercase English letter. So even if we encounter an uppercase English letter, we would convert it to lowercase English letter. We would treat it like this. So this m is equal to m. So far we are good, which means we will have to update the value of left and right pointer. So now this left pointer is going to go to the next value, which is over here, and this right pointer is going to go to a previous value, which is over here. Now at this position right, we actually identify that this is not an alphabet, so we would again update the value of right pointer and we would ignore this case, and this time right pointer comes over here. Now because both of these are valid alphanumeric value, we will try to see that what are their values, and both are located a, which means they are same. So if they are same, again we are good up until this point. Again we will update the value of left and right pointer. So now left pointer is at d and right pointer is actually located at this column over here. So because this is not an alphanumeric value, again we are going to ignore this and we are going to update the value for right pointer. So now right pointer would end up at the same position where left pointer is. If we again compare the value, both are going to be dd. So again we are good up until this point. Now we don't have to do it, but because in our algorithm we are specifying that we need to check before right pointer crosses the left, and in this if we do one more iteration, essentially right would come and left would come over here, which means that they would be crossing each other, and which is not what we want. So we have already concluded that all the characters inside this given string, they are actually part of a palindrome, and we can return true in this case, and this is the approach we are going to take. Now if we see the time complexity in this case, the time complexity is actually going to be big O of n only, because we are completing everything in just single iteration. We are having our left pointer move to the right side and we are having our right pointer move to the left side, and we stop when they meet. Now in terms of space complexity, we are actually doing it pretty efficiently. We are only using couple of pointers to store in our space, so that's why it's only a constant space that we are consuming, and this approach is much better approach, and we will conclude this as to be an optimal solution. Now let's move on to coding. First of all, we are going to initialize couple of variables called left and right, and we are going to assign the left to be value 0 and right to be value to the end of the string. So now we are going to run a loop that while left is less than right. So now first of all we are going to check that if the current value on the left side, if that is not alphanumeric, we will have to update the value of left pointer. Same thing we are going to do with the right pointer, but we are actually going to reduce the value for the right pointer. And if we identify that both left and right are correct letters, we are going to check their values, and if they are not same, we can return false immediately. If they are same, we will continue updating the loop. So if that is the case, if the characters are not matching after converting them to lowercase, we can return false immediately. And if that is not the case, we would update the values of left and right pointer. And once this loop ends, essentially if we get out of the loop without returning false, we can simply return true. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. and our code is actually pretty efficient. I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do two lead code problem where input array is sorted. And if you see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Apple, Uber, Google, Facebook, Bloomberg, Microsoft and Goldman Sachs. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a lead code medium problem and also a very well-liked problem. This 2 sum 2 problem is actually very similar to the 2 sum problem which we originally solved over here. So you can check it out, that solution, if you want. Now let's understand this problem statement. So basically we are given a one index array and this is only given one index just to add some additional complexity, nothing more than that. And we are also given an array of numbers. Now we are told that all the numbers, they are already sorted in non-decreasing or ascending order. Now we need to find two such numbers that they add up to a specific target, and we are also given this target value as the input for our method as well. Now we need to provide the index values for those two numbers as the answer. So let's try to understand this with a couple of examples. So if we take this example 1 and 2 over here, I have drawn it much bigger over here. So first of all, we are given a nums array like this, and if you notice that the indexing is actually starts from 1 rather than starting from 0. We are also given some target values. So in this case the target value is 9. So now we need to find any two values that sums up to 9. So we can clearly see that 2 plus 7 equals to 9, and in this case we need to return the index value of this 2 and 7. So the answer in this case is going to be 1 and 2 as the answer. If we take second example, over here we are given the target value to be 6. So clearly we can see that 6 is going to be the sum of actually 2 plus 4. Now remember, we can also do over here like 3 plus 3, but the thing is we cannot repeat the same character again. So in this case the answer has to be 2 plus 4, that equals to 6, and we need to return the index value. So index values in this case is going to be 1 and 3, and this is going to be the answer. So after understanding the problem statement, let's see that what are going to be the different approaches to solve this problem. So the first approach that comes to our mind is the brute force approach. In the brute force approach, what we can do is we can simply take every single possible two pair that we can make and try to see that whether we can come up with the target value for those two pairs. If we do get the target value, we simply return their index numbers. So in this case, we are given the target to be 11. Now we can make different pairs that looks like this. That first of all, we'll take the first number and then we will make all the possible pairs. We don't find any sum that comes up to 11. So we can ignore this one. Now we will start with the second value and keep on repeating the same process. So the moment we do that, when we do the sum of this 5 plus 6, we get 5 plus 6 to be 11, and this is the answer. So in this case, we can return their index values. So in the index values in this case is going to be 2 and 3, and that would be the answer we can return. Now this brute force solution leads up to the correct answer in terms of the index values that we are looking for. But the thing is, this is not the most efficient way to do it, because we have to deal with lot of different sub arrays or sub pairs. So if we see time complexity for this brute force approach, it is actually big of n square, because for every single value we have to compare it with all the other remaining values, and that is pretty disastrous. So let's see that what is going to be the better approach. Okay, so the next approach that comes to our mind is a binary search. Why binary search? Because remember, we were originally told that this input array we are given, that is already a sorted array, which means all the values that they are sorted in ascending order. So we can actually use binary search to our advantage in order to find the target value pair. The approach I'm suggesting is that first of all we take any value. Okay, so the current value in this case is 2, right? So if 2 is supposed to be part of this answer, let's imagine that 2 is part of this answer, then 2 can only be part of the answer if the value 11 minus 2 equals to 9. If this 9 is somehow present inside this given input array, we can clearly determine that 2 and 9 can be part of the answer that leads up to the target value 11. So all we need to do is once we identify the value number 2, we come up with the remaining value that is needed to generate the answer, that is 9, and then we can simply do a binary search in this case to see that whether 9 exists or not. We can find this immediately in log n time because this array is already sorted. So at any given moment, all we have to do is just calculate the middle value and see on which side of this middle value does this 9 falls, and eventually that would lead up
to the correct answer. So first of all, if we see for this value number 2, 9 does not exist, right? So because 9 does not exist, we can ignore the case for this value number 2, and we can define that 2 is not part of solution that leads up to the target value 11. Now again we are going to repeat the same process. Now the next value we have is 5. So now if the value is 5, all we have to do is to see that what is going to be the remaining value, and remaining value in this case is going to be 11 minus 5. So 11 minus 5 is equal to 6. So now we only have to check that whether the 6 exists inside the remaining array or not, and that we can do using the binary search in log and time. So now what we will do is we will try to find the middle value. Let's say that middle value in this case is 12. So 12 is greater than 6. So because 12 is greater than 6, we only have to compare between these three values. So again the middle value is 8. Again 8 is still greater than 6. So now we only have one value on the left of the 8 and right of the 5, so which is already 6. So immediately we can find that value, and because we find both 5 and 6 to be existing, so 5 plus 6 equals to 11, we can simply return their index values to be 2 and 3. So 2 and 3 is going to be the answer in this case. If we see, binary search actually works pretty better than our brute force approach. Why? Because if we try to calculate the time complexity in this case, the time complexity is actually going to be big O of n log n. Why n log n? Because in the worst case we might have to iterate over every single character in order to find the target value, and for us to find the remaining value we have to do log n work. So again, if we see this solution is much better compared to a brute force approach which had the time complexity of big O of n square. Now the question is this the most optimal way to solve this problem? And the answer is no. There is still one more solution that can give us the answer in big O of n time. Okay, so the optimal solution I am proposing is actually using two pointers. So suppose this is the array, input array we are given, and we are given the target value to be 13, right? Now we already know that 6 plus 7 is going to be the answer. But let's quickly see the approach I'm suggesting. Basically, we are going to have two pointers, left and right. Now remember, all the values that are on the right side of this left pointer are actually greater than this value of left, right? And same way, all the values that are on the left side of this right pointer is actually less than whatever the value at right pointer we had. So the idea is, originally we are going to do the sum of this left pointer and right pointer. We are going to compare that sum to this target value. Now if the sum is actually greater than target value, which means we need to lower the sum. How can we lower the sum? We can only lower the sum if we move this right pointer on the left direction, because remember, all the values that are on the right that are on the left of this right pointer, they are actually less than this right pointer. So if we reduce the values, automatically sum is supposed to go down, and that would lead us near the target value, right? Again, same way, if we identify that sum somehow is actually less than the target value, if sum is less than the target value, which means we will have to increase the value of the sum. How can we increase the value of the sum? By increasing the value of the left pointer, because all the values on the left pointer are actually greater, and right pointer will remain constant in that case. And if we keep on repeating the same process until we come up to the sum that equals to target value, eventually we would get the two pointers located at the correct position that would lead us to the correct answer. How? Let me quickly show it to you. And by the way, let me also mark the indexes in this case as well. So now we have our left pointer and we have our right pointer, and we have the variable sum, right? Currently left is equal to 2 and right is equal to 42. If we see sum of these two, sum is actually going to be 44. 44 is definitely greater than 13. So because 44 is greater than 13, we will have to somehow reduce the values. So what we are going to do is we are going to update the right pointer to move one point to the left side, right? So now our new right pointer is going to be this one. So now our right pointer value is 21. So 21 plus 2 is still going to be 23. Now 23 is again greater than 13. So because of that, we are going to shift our right pointer again. So now right pointer is at 12. 12 plus 2 is 14. 14 is still greater than 13. So again, we are going to switch our right pointer. So now right pointer is at position number 10. So now the right pointer value is 10. So now 10 plus 2 is equal to 12. So 12 is not greater than 13, is actually less than 13. So now we will have to update our left pointer. So if we update our left pointer is going to become value number 5, right? So now this value is 5. 5 plus 10 is again 15.
So 15 is again greater than this value number 13, right? So now again we are going to switch our right pointer to go one point to the left. So now the right pointer value is actually 7. So if we do 7 plus 5, 7 plus 5 actually gives us the answer to be 12, right? So now this 12 is still less than the value number 13. So because this is less than the value number 13, again we are going to update the value pointer of the left pointer. So now left pointer is at position number 6, right pointer is at position number 7. 6 plus 7 is equal to 13, which is exactly equal to whatever the target value we had, and that is the correct solution. So now basically the positions of left and right pointer, we simply need to return that as the answer. So the answer in this case is going to be 3 and 4. And this is the correct way to solve this problem. Now, what is the benefit of this approach? Well, if we see, we are actually computing everything in just single iteration. We are not doing multiple repetitive work. So if we see time complexity, in this case, the time complexity is actually going to be big O of n, which is a much better improvement compared to our brute force approach and also our binary search approach. If we see space complexity, in this case, the space complexity is actually going to be constant because we are not using any additional space apart from storing a couple of variables, which is also a good sign. Now let's move on to the coding. So first of all, we are going to initialize the two variable left and right. Now we are going to run our while loop, that while left is less than right. Now inside the loop, first of all, we are going to check that whether the combination of left and right, if that is greater than the target value. So if that is the case, we will have to reduce the sum, which means we will have to reduce the value of the right pointer. So right is going to become right minus 1. Else if we are going to check that whether the sum is actually less than the target value. If that is the case, we are going to update our left pointer to go one step to the right. That is not the case, which means we are actually at the correct position. So we can simply return the index values. But remember, we are presented with one index array, so we are going to add one value to the left and right, and this was just the additional small complexity they added to the problem. Otherwise it would have been too simple. And basically in this loop we are taking care of everything, so we should have gotten the answer. If somehow we get out of the loop without returning the answer, we can simply return null, that we were not able to find the answer, and that should do the trick. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently compared to a lot of other solutions in terms of time complexity. In terms of space complexity, it's actually pretty efficient because we are not using any additional variable to store the sum. And that's it. I would be posting this solution in the comments, so you can check it out from there. Thank you. Today we are going to do three-sum lead code problem, and it is a very interesting problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Apple, Facebook, Uber, Bloomberg, Google, Tesla, ByteDance, and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem and also a very well-liked problem on lead code. Basically, we are given an integer array called nums, and we need to return the triplets. Now we need to return the triplets such that the sum of all of those triplets is actually equal to 0. And we are also given the definition that the elements has to be unique. So I, j and k is supposed to be the triplets, and they should not be the same. They should be different values. We are also told that the answer set must not contain any duplicate triplets. So this is an additional set of complexity that we will have to take care of. Now let's try to understand this problem with a couple of examples that are provided over here, and I have actually broadened these examples. So let's try to understand them. So suppose this is the input array nums we are given. We need to find the triplets such that the sum of each of all the triplets is equal to 0. So if we see that in this example, we can actually find the sum of these three values to be 0. So first of all, we are going to add these three entries into our answer, that -1, 0 and 1. This triplet equals to 0, so we can add that to our answer list. Second triplet we can find is the value -1, again -1, and value +2, because -1 plus -1 plus +2 is also equal to 0. So again we can add it to our answer set, that 2, -1 and -1 as the answer. And now apart from that, we cannot find any more triplets, so this is the only answer we are going to return. One critical thing to understand over here is that this -1 is actually using 2 times in 2 different answers. That is perfectly fine, but we cannot have an answer where we already have the value like -1 0 and -1, and again we have the value -1 0 and +1. This should not be the answer. So this is one of the conditions that is given. Second condition is that all the values of I, j and k has to be unique, so they are located at unique positions, because we cannot use the same value again and again. We cannot do something like 0 plus 0 plus 0 equal to 0 and return that as the answer of the triplet, because in this case we only have one 0, not three zeros. So just keep all of these things in mind. If we take a look at the second example, over here we actually do not have any pair that equals to 0, right? So in this case we are only going to return an empty array as the answer, and basically this is what the problem is asking us to solve. Now there can be two potential solutions for this three-sum problem that we are trying to deal with. First solution is actually a two-sum problem solution. That is also another lead code problem where we use hashing to generate the solution for this two-sum problem. Second solution is two-sum 2 problem where we actually use two pointers to come up with that solution. And in this case we are going to see that how using hashing we can solve this three-sum problem, or how using two pointers we can solve this three-sum problem, because both of this concept can be useful. We can choose either one of them. Now I'm going to show you the theoretical knowledge of both the problems, but I'm only going to show you coding for this two-sum 2 problem. Let me know in the comments if you want to see the code for this two-sum problem as well, and I can show it to you. Okay, so first let's see that what is going to be the optimal solution using the solution we used in the two-sum problem. Now, if you want to know more about two-sum problem, you can check out my video over here, and that is going to give you much more clarity. Okay, now let's get back to our question. So if we suppose this is the original input that we are given, and we are trying to find a set of triplets that sum up to 0, right? Which means we are trying to find three different values where I plus j plus k is equal to 0. Okay, that is the whole idea. The technique we are going to use is that, okay, suppose this is the first value, right? Suppose if we consider I is equal to -5. Once that is done, what we will have to do is we will have to try to find that if j plus k is equal to +5, if that exists inside this remaining array. If that is the case, then we would actually have a triplet called I plus j plus k that sums up to 0, because I is equal to -5, j plus k is equal to +5. And now we simply need to see that inside the remaining array, do we have a pair j plus k that is equal to +5? And that was actually the original question for this two-sum problem. So that is how everything is linked internally. The idea is, okay, that we can find it easily using a hash map or a hash set, and then we would be able to get this answer. The problem that would come in this case is that because we are trying to avoid duplicates, and what would happen with this approach is that, okay, suppose if we consider I is equal to -5, right, we would actually have an answer where the values of -5, 0 and +5 exist as one of the answer, and we are able to generate this. Okay, so now we are able to say that, okay, this -5 we have already taken care of and we found the correct answer. But if we look somewhere inside the remaining array, we would also find another -5. So when we try to repeat the same logic, basically even for this -5, we will also have the I is equal to -5, and we will try to find j plus k is equal to +5. Then again we would have another answer that also looks like -5, 0 and 5. And remember, these is going to be the duplicate value that we are trying to avoid. So in order to make our lives easier, what we can simply do is, if we take this input array and if we sort this input array, and because when we sort this input array, we are going to have the same looking values right next to each other. So we can only have a condition that the moment we find out that two adjacent values, they are same. If that is the case, that if we find the two adjacent values to be the same, then we are simply going to ignore that case and move on to the next value. Okay, so now after this whole explanation, let me clean this up a bit and create the sorted array. So now we have our sorted array, right? Now we will try to see that what could be the potential I, j and k values. Now based on the I value, we will also have to determine that what should be the j plus k value, and based on the jth value, we will also have to determine that what should be the kth value, right? That is how we are going to do the things. So first let's try to see that if I is equal to -5. If I is equal to -5, we will have to find j plus k is equal to +5. If we have to find j plus k is equal to +5, we will try to start iterating over this remaining array. Again, we are going to create a hash map or a hash set over here. So let's create a hash set first. Okay, now we are going to start iterating over all the remaining values. Okay, so suppose this value is -5, so we'll try to consider j to be -5. If j is equal to be -5, then k has to be +10. And now we are trying to see that, okay, we'll see that if this k is equal to 10 exists, if that is the case, we will return that. If it does not exist, we are going to add that value to our hash map. Okay, so because k is equal to 10 does not exist, we will have to add all the values to our hash map. And remember, there is a property of a hash set where it does not exist duplicate values, so we will only have unique values inside over here. So since j is equal to -5 didn't work, we'll try to see that whether j is equal to -3 works or not. So if j is equal to -3, then in that case we will need the kth value to be +8. +8 also does not exist, and we can look that up immediately because of this hash set, right? Now we'll try to find another value. Okay, so if that didn't work, we'll try to see that whether j is equal to 0 works or not. Okay, so if j is supposed to be 0, then the value of k has to be +5. Okay, that we can look up immediately, and we would be able to find that k is equal to +5 already exists inside our hash map. So immediately we found that we are actually going to have an answer list where we are going to populate the values of I, j and k we found. Okay, so we are going to add the values -5, 0 and +5 immediately. Now we are going to repeat the same process for all the remaining values, right? So, and for every single value, we will also have to create the new hash set and new I, j and k values. So we will empty this one. Okay, now the new I value is actually -5. The thing is, this is a track because we already had a value -5 that we already iterated over. So we will not have to use this one, and that is how we are going to avoid duplicates. Now suppose if next I value is -3. Okay, so if I value is -3, then j plus k has to be +3. Okay, so if j plus k has to be +3, let's see that what could be the potential remaining j plus k values over here. Okay, so over here currently jth value is 0. So if jth value is 0, then kth value has to be +3. Okay, so we'll try to see that inside the remaining array whether +3 exists or not. +3 does not exist, but that is going to help us fulfill our hash. So we are going to add all the entries to our hash map, and we couldn't find k is equal to 3. So now we are going to try the new value of j is equal to 0. So again, because this 0 we already consider for j, we should not be considering this 0, so we can just simply jump over. Okay, so now next value is j is equal to 1. If j is equal to 1, we will try to see that whether k is equal to 2 exists or not. And k is equal to 2 already exists, that we can clearly see over here. So because it exists, we are actually going to have j and k values properly set up, and we are also going to add one more triplet to our answer, that is -3, 1 and 2. Okay, now we can ignore this one. Okay, now current ith value is 0. Okay, if ith value is 0, then j plus k has to be 0. Okay, so now we'll try to find j plus k to be 0. Now inside the current method, okay, now this next value of j, potential value of j, this is the 0th value. So we'll try to add this value, and by the way, I forgot to clear the hash, but it would be cleared. Okay, now if j is equal to 0, then k also has to be 0. Okay, so currently k is equal to 0 does not exist inside the remaining array. So because it does not exist, we will try to jump on to the next value of j, if j is equal to 1 can work or not. So if we try to put j is equal to 1, it is definitely not going to work, and we won't be able to find a pair j plus k is equal to 0. So I is equal to 0 is also not going to work. Because I is equal to 0 not going to work, and we have already taken care of this 0, so which means we don't have to see for this 0. Now we will try to see that whether I is equal to work or not. But the question is, do we really want to check whether I is equal to work, 1 is going to work or not? Because inside the remaining array, all the values are actually going to be positive values. So because these values are going to be positive values, j plus k is always going to increase the value of whatever the sum of I, j and k is going to be, because this I is positive. So immediately we can stop our search, and whatever the answer we have found, we can actually return that as the answer. And that is the whole approach. Now, and if we see time complexity in this case, the time complexity is actually going to be big O of n log n, that is to sort the array, plus big O of n square. Why? Because for any single ith value, we will have to find j and kth value, which means for every single one of them, we will have to iterate over the entire list of all the arrays. So that takes like big O of n square, and that is the best we can do. If we see space complexity is also going to be big O of n, because for this sorting operation, it takes big O of n time, and plus we are also creating this hash, so that also takes big O of n space. Okay, now we will try to see that what is going to be the optimal solution using the 2 sum 2 problem. Now if you want to learn more about this problem, you can check it out my video over here, and this is a very good explanation for that. Now we are going to use the same example as the input, and as mentioned for the reasons explained before, basically we are going to use the sorted array in this case as well. So from this original input we are actually going to create a sorted array first, so that is going to help us avoid duplicates. Now the again idea is that currently we are going to consider the one value to be I. Okay, so suppose we are going to consider I is equal to -5. If that is the case, j and k value could be potentially possible where j plus k is equal to +5, right? And inside this remaining array we will have to find the +5 value. So what we are going to do is we are going to initialize couple of variables. So first is going to be left pointer, and second is going to be right pointer. Now every time we are going to do left plus right. If left plus right is equal to 5, then basically we are good, our life is set, and we can simply add it to our j plus k values. If that is not the case, if we somehow find that left plus right is actually greater than 5, if that is the case, then somehow we will have to reduce the sum of this left plus right. How can we reduce the sum of left plus right? By shifting this right pointer on the left hand side. Why? Because all the values on the left of this right pointer are actually less than whatever this right value we had. And if somehow we identify that okay, this left plus right is actually less than the answer 5, if that is the case, we are going to update our left pointer to go one step on the right side. So then we would be able to increase the sum that we are trying to achieve, and that is how we would be able to generate the correct j and k values. So let's try to see the approach in action. So suppose currently the ith value is equal to -5. Okay, I is equal to -5, j plus k is equal to +5 we are trying to find. Okay, so once we have the j plus k value we are trying to find, we are going to initialize two variables, left and right. Okay, so currently our left pointer and right pointer, we are going to be concerned with that, and we are also going to be concerned with left plus right sum, and that is referring to whatever the value we are trying to find. Okay, so currently the target value is 5. Okay, now the current left position is -5, current right position is +5. So left plus right is equal to 0. 0 is actually less than -5. So because 0 is less than -5, we will have to update the value of our left pointer to go one step on the right. So now the current left pointer is -3. -3 plus 5. So if we do -3 plus 5, the value we get is 2. 2 is still less than 5. So because 2 is less than 5, again we are going to update our left pointer. So now the left pointer is at 0th position right over here. And currently the sum we are going to get is that okay, this is 0, this is 5, so 0 plus 5 is equal to 5. So currently left plus right is equal to 5. 5 is exactly what we are looking for based on this remainder value we have created. Okay, so now this left pointer can be assigned to this j value and right pointer can be assigned to this k value, and we can actually populate our answer. So inside our answer we are going to have the first entry called -5, 0 and +5 as one of the answer. Okay, now we are done with taking care of this -5. So now we'll have to take care of this another value, but again same thing, this value is also -5, same as the previous value. So again we are going to ignore this case as well, and now currently our I is going to be -3. Okay, so now if we put our I to be -3, our j plus k sum has to be +3 in this case. Okay, so j plus k has to be +3. Again, if j plus k has to be +3, we will also have to update our left and right pointer. So currently left pointer is also going to be at the position 0, right is going to be position number 5. Okay, and we will also have to update this value as well, that this has to be 3. Okay, now currently 0 plus 5 is actually 5. 5 is actually greater than 3. So because 5 is greater than 3, we will have to reduce the value of our right pointer. So currently our right pointer is going to come over here. So now the right pointer value is actually 2. Okay, so if we do 0 plus 2, 0 plus 2 is actually going to be 3. So so now if we do 0 plus 2, 0 plus 2 is actually going to be 2. 2 is now less than whatever the value of 3 is. Because of that, we will have to update our left pointer to go on the right side. Now the moment we do that, okay, this value is also 0, same as the previous value. So because of that, because we have already calculated this 0, we are actually going to ignore this 0 as the left pointer, and our left pointer is going to come over here. Okay, so now the value of our left pointer is actually 1. So 1 plus 2. So 1 plus 2 is actually 3, and 3 is what we are looking for, that we already find the answer. So we are also going to populate the values of left and right over here, and inside the answer we are going to have one more entry called -3 plus 1 and plus 2. Okay, now okay, now we have taken care of all the cases. Now again this value I is equal to 0. If I is equal to 0, we will not be able to generate the answer, and now in this case I is going to be 1, so that is going to be the positive value. So because of that we are actually going to break out of it, and simply whatever the answer we have found, we are able to return that as the answer using this 2-pointer solution. And even for, if we see the time and space complexity, in this case the time complexity is also going to be big O of n square plus big O of n log n. Why? Because we will have to do the sorting operation. If we see space complexity, the space complexity is also going to be big O of n. That is going to depend on the implementation for the sorting we are using. So that is how we are able to generate the solution. If you see, in this case we are actually not using any additional hash set, so that is a plus benefit in my opinion. And if you show both the approaches in any interviewer would be like more than happy with you. So first of all, we are going to sort the given input nums, and we are also going to create a new variable called result to store the list of lists that is needed over here. Now we are going to run a for loop across the given input nums. Notice inside the for loop we are only running it up until the point where the value of nums of I is actually less than 0. And the moment it gets greater than 0, there is no point in continuing with the loop, so we just simply ignore that. Now inside the loop we are actually going to call our toSum2 function, but for that we actually have a couple of conditions that we are going to take care of. So first condition is that if the given value of I is equal to 0 or the starting position, then we do it, or we check that whether the two adjacent values of I and I minus 1 are they same or not. If they are not same, then only we call our toSum2 function, otherwise we ignore that particular entry. Inside the method we are going to call the toSum2 method where we are going to pass in the value of the given input integer nums, the current ith position, and the result variable. And basically that's it. Once this for loop ends, basically with the help of this toSum2 method, our result should have been populated, so we can simply return the result. Now it's time to create the new toSum2 method. First of all, we are going to initialize two pointers called left and right. Now we are going to have our while loop that while left is less than right, we are going to do some interesting things. First of all, we are going to have a variable called sum that is going to calculate the current total sum. Now we are going to check that if the given sum, if that is less than 0, if that is the case, we will have to increase the value of the left pointer. Else if we are going to check that if the given sum is greater than 0, if that is the case, then we will have to reduce the value of our right pointer. And if both are not the cases, which means our current sum is exactly 0, so first of all we are going to add a new entry to our result variable that we have created. After adding the values to the result, we will again have to update our left pointer until the point that whether the two adjacent values of left pointer, they are same or not. Basically that's it. This should have taken care of all the scenarios, and this should be working. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently. Today we are going to do container with most water lead code problem. And if we see some of the companies where I want to get a job, who already asked this question, there are companies like Amazon, Apple, Google, Microsoft, Facebook, Goldman Sachs, ByteDance, Bloomberg, TikTok, Uber, and Tesla. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a lead code medium problem and also very well liked problem on lead code. And like any lead code problem, we are given some input and we are expected to get some results from this particular input. But before we start understanding this problem, first let's see this concept that I'm trying to explain. Okay, so suppose we are given a container that looks like this, and we are trying to see that how much water can we fill in this container. Well, the logic is actually quite simple. We can only fill water up until this point inside this given container. Anything more, if we try to add water over here, that water would simply spill out. We won't be able to fill our water above this line. So that is a given fact, right? That is a very simple explanation. Now, if I ask you that how much water is present in this container, so then in that case, the answer is simple. There can only be water up until this point, nothing more than that. So in this case, for this particular container, rather than considering this container to be a container, if we consider this to be a rectangle, things becomes easy for us, because we know that the surface area of rectangle is the amount of water we can store in this particular container, and we know the formula to calculate the area inside any given rectangle. Suppose this is the height of the container and this is the width of the container. If we are given these two values, basically if we do h times w, height crosses height multiplied by width, we will get the amount of area, and that would equivalent that how much water we can hold in any given container. Now let's try to understand another scenario. Suppose we are given a container that looks like this, or we are given a container that looks like this. In these two cases, how much water can we store? Well, the answer is again simple. We can only fill water up until this point, till the lower edge on any given container, not more than that. So now in this case, we are actually given two different heights for each sides of the given container, right? So suppose this side is h1 and this side is h2, and same goes over here. This one is h1 and this one is h2. If that is the case, if we try to calculate the area in this case, the area equation for the water is gonna change. Why? Because we are not going to use h1 over here, because this is the higher side. We are actually going to use h2, which is the lower side. So in this case, the area is going to be h2 times width for this particular container. But for this particular container, the equation is actually going to be h1 times width, because this h1 is actually smaller in this case. So these are the two concepts that you will have to understand. And now let's go back to the problem. Okay, so now in the problem, we are actually given an array called heights of length n. And now if we try to plot this array of height on a graph, we can consider that based on the x-axis, we can actually create a container. And then we need to find that what is the container we can create that contains the most amount of water. And then we need to return the amount of water that the maximum container can store. Now, I know that the wording may sound confusing, so it would be better by understanding with this example. Suppose we are given an array heights like this. So if we try to plot this array heights on a graph, we can actually get a graph that looks like this. Now in this graph, you can see that there is a difference between lines, and based on these line differences, we can actually create some sort of containers between any two vertices. And the amount of water we can fill will depend on the lower side of the height rather than higher side of the height. So in this case, we can actually create a container that looks like this. So if we try to consider this index number 1 and index number 4, the container we can create is going to look like this, where this is the amount of water we can fill, nothing more than that. Now remember, as mentioned earlier, that for every single time, if we want to calculate that what is the amount of water we can find, we need to calculate the area of the presumed rectangle, and for that we need the height, which we already have based on these values, which we can derive from the array, and we need the value of the width. So width we can achieve by calculating the difference between any two places on the x-axis, and these values we can determine depending on the index values of the given input array. So it makes our lives easier. So in this case, if we try to see that some of the containers that we can make a container that looks like this amongst these two values, and then we can calculate its water. So I'm just showing you for an example. So in this case, the minimum height is actually 5. So height is going to be 5, and the width in this case is actually going to be 2. So 5 times 2, we can say that, okay, there is 10 units of water we can put in this container if this was to be the container. The thing is, we are trying to find the maximum water we can make amongst any given container. So in this case, the answer is actually going to be this container, where the current height is 7 amongst 7 and 8. So we are going to choose 7 as the height. Okay, so h is equal to 7. So okay, it's going to be 7 times the distance. So distance in this case, okay, this value is 2 and this value is 9. So distance is also 7. So in this case, 49 is the maximum unit of water we can contain, and that is going to be stored between this container. Basically, I hope that this makes understanding this problem easier. And after understanding the problem, now let's focus on different solutions that we can achieve. The first approach we have is the brute force approach, and suppose this is the input we are given. If we try to plot it on a graph, we can actually create a graph that looks like this. Now the idea is, we are actually going to check every single container that we can possibly make, and depending on that we will try to see that what container contains the most amount of water. So basically we are going to have two variable. First variable is called area to calculate the water at any given container, and second is going to be the max variable that is going to be update its value whenever we find a better area or maximum water we can contain, right? So first we will start with this first index, and we will try to see that okay, what is the container we can make with between the index 1 and 2. We can make a container that looks like this. What is the container we can make between 1 and 3? We can make a container that looks like this, and say so on and so forth. We will keep on repeating our graph. After being done with this value number 1, we will ignore that, and we will start focusing from value number 2. So from value number 2 we can make container that looks like this, and then again a container that looks like this, and blah blah, so on and so forth. And eventually we would find an answer in this case between this value number 2 and 7 indexes, that if we make this container that is going to hold maximum amount of water. And in this case the answer is going to be okay, so for this area height is going to be 4 because that is the smaller amongst these two, and the width is actually going to be 5 because 2 minus 7 is 5. So maximum area is going to be 20, and 20 is the answer we are going to return. So this solution would work as expected, but if we see the issue with this solution, the issue is actually time complexity. Why time complexity? Because for every single value we are comparing it with all the other values to see what is the container we can create, and we are not doing things efficiently. So basically the time complexity in this case is big O of n square, which is very bad, and we will have to do something better. So let's see that what is the better approach we can get. So for the optimal solution, we are actually going to use two pointers to our advantage, and we will try to see that what is the optimal container we can make. So we are going to have a pointer left located at the first position, and we are going to have a pointer right located at the last position. The idea is both pointers are going to come towards each other until they meet or cross each other. Now every single position we will try to see that depending on the values of left and right, what is the container we can make. And then we will try to calculate its area, and after calculating the area we are going to compare the heights between left and right, and whichever has greater height we are going to keep that height, and then we are going to update the remaining counter. So left counter will go on the right side, or right counter will come on the left side. So let's see the solution in action, and it will make more sense. So basically initially first, if we see currently the height at left is 3 and height at right is 2. Okay, so if we want to calculate the area, we are going to calculate the smaller amount. Okay, so currently the smaller height is actually 2, and if we see the width in this case is going to be 7. Okay, so current area we are able to calculate is 14. We are also going to have a variable called max area. So currently the max area we have been able to find is 14. Okay, so far so good. Now we will try to compare the heights between left and right. Okay, so currently left height is actually greater, so it is in our interest to move right counter one step to the left rather than moving the left counter. Okay, so in this case right counter is going to come over here. Now again we are going to repeat the same process. So now currently the height at right counter is 6 and left counter is 3. Okay, so now if we will have to calculate the area again. So we are going to choose the smaller value amongst the height. So currently this is going to be 3 as the smaller height, and width is going to be 6. Okay, so currently the area we can get is 18. 18 is greater than 14, so we are going to update the maximum area, maximum water we can contain to 18. Now we are going to compare the height between left and right. Now in this case the height at right is actually greater than left, so we are going to update our left pointer to go one step to the right. Now this left pointer is located over here. Currently the height is 2. Again we are going to calculate the area. So this height is actually going to become 2, and the width is actually going to become 5. So 2 times 5 is actually 10. So because 10 is less than 18, we are not going to update the maximum value we have been able to find. Again we are going to calculate the heights between left and right. So again right height is greater, so we will update the left pointer to go on one step on the right side. Now currently the height over here is 7, and currently the other height is 6, so we are going to choose the smaller height. So the height we are going to choose is going to be 6. 6 times the width is going to decrease. Okay, so currently the width value we have is going to be, okay, this is okay, this is left pointer, so 3 minus 7 4. Okay, so 6 times 4, so this area becomes 24. 24 is actually greater than 18, so because 24 is actually greater than 18, we are going to update the maximum area we are being able to calculate. Okay, so this is 24. Now again we are going to compare the heights between the left pointer and right pointer. So currently right pointer is actually less, so now we will have to update the value of the right pointer. So currently this becomes our right pointer. Now this value is 3, this value of left pointer is 7. So again the height is actually going to be 3 and the width is going to be 3 as well. So this is going to be 3 times 3, so this is 9. We don't need to update the max value. Again if we compare the heights, the right is actually smaller, so again we will update the value of the right counter. So now this time the right counter is reaching at this value number 1. So if we calculate this container, the area is actually going to be 2. So 2 times 1, so 2 times 1 is only 2, so we don't need to do anything. Again we will update the right counter. So currently the value of right counter is 4 and the left counter is 7. Okay, so we are going to have a container that looks like this. So 4 times 7 4 times 1 is going to be 4 as well. So then we, in this case, we don't need to update the max value. And if we try to update the left or right variable again, that they would cross each other. So because they would cross each other, now we can get out of our loop. So whatever the maximum result we have found so far, that is going to be the solution we need to return. So in this case, the answer is actually going to be 24, as that this is the maximum units of water we can contain between basically this container, this water container, and that is the answer we need to return. If you see the beautiful thing about this solution, this whole solution gets completed in a single iteration between these two pointers. And if we see time complexity, in this case the time complexity is actually going to be big of n only, which is much better improvement compared to our brute force approach, which had the time complexity of big of n square, which was really bad. So we can avoid that. If we see space complexity, the space complexity is also really good, because apart from using couple of pointers, we are not using any additional space. So space complexity is actually constant space, which is wonderful. This is a very good approach and a very good way to learn two pointer problem. And I hope you understood it. Now let's move on to the coding. First of all, we are going to initialize couple of variables. So first variable is going to be max, and that we are going to initialize it to 0. Then we are going to initialize two pointers, left and right, and left is going to have the value of 0 and right is going to have the value of whatever the length of heights array is. So we run our while loop, that while left is less than right. Now first of all, we will have to calculate the width. So width is going to be right minus left. So now we have the width and we already have the height from this heights array. We will calculate the area. So this equation should give us the area. We are selecting the lesser height amongst right height and left height. And now we will see that whether we need to update the max value as well. And now we will have to update our left or right pointer. So we will check that, okay, if the current height of left is less than or equal to the right height, we will update the left counter. If that is not the case, we will update the right pointer to go one step on the left side. And in the end, we can simply return the max variable that we have calculated. And that should be it. Let's try to run this code. Okay, seems like our solution is working as expected, and our solution runs pretty efficiently compared to a lot of other solutions. And I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. We are going to do trapping rainwater problem today, and if you want to see that what are the list of companies that have asked this question, that comes later in the video, so you can directly check it from there. Let's understand the problem statement. We are given an array called n, where all the integers are non-negative, and any single integer represents actually the height at that particular position inside the array. We are given that the width at any two positions is actually 1, so we can consider that. And we need to see that how much water can we trap when it rains. We know that it's going to rain a decent amount, so all the cells that could trap water would trap water. And our aim is to see that what is the maximum unit of water we are going to store. So let's try to understand this with an example. Over here we are given an elevation graph, and all of those values are represented as bars inside the given graph. And we notice that because there are some height differences, due to the height difference, there exists an empty space inside this given input. And because that empty space exists, rainwater can actually fall in and be stored on those particular positions. So if we see over here, like this first position is actually 0, but and suppose the rain falls, can any water be stored over here? Well, it cannot be stored, because in order for water to be stored, we need a vessel like this or like this or something like this, where at least water can be stored. Like over here, if we see, water can be stored for all of these positions, because all these three edges were covered with some sort of solid material. Same goes over here. Like over here, we can only fill water up until this point, because on the left side the edge is only up until this point, not more than that. Like though on the right side the edge is actually higher, but if we try to fill in more water, or if rain falls and more water falls on top of it, all the water is gonna spill out, and no amount of water is gonna be stored. So that is one key important part, is to understand that how water is stored. And second is that we need to iterate over this given input height, and at every single position we are going to basically calculate that how much water can be stored due to this height difference. So if we see in this example, at this first position no water can be stored, so like there is no water pointed with over here. Like this is a bar by itself, and in this particular bar, this is the boundary, that is a solid surface that cannot store any water, and we cannot store any water on top of this one, because all the water that gets stored on top of this one will also spill out, because on the left side the boundary is actually non-existent. Now if we look at this third position over here, actually because of there exists a height difference between these two positions, we have a scenario something that looks like this, where water, when the rain falls, on the left side we have a bar of height 1, which is represented over here, and on the right side we have a bar of height 2, which means that we are creating some sort of value over here, where on the left, at this particular position on the left side, the bar is actually of one size, so this is of one size, and this is bar of two size, so this is actually two size, which means that there exists an empty vacuum where water can fall in and water can be stored. So this becomes our point, and we can check that over here we can store 1 unit of water. Now the question comes that why can we only store 1 unit of water? Why cannot we store more than 1 unit of water? The formula is actually quite simple. Like at this particular position, we see that on the left side there exists some height, on the right side there exists some height. So suppose this one is left height, this one is right height. There are two heights that exist at any moment, and this by itself can have some height, as mentioned in this input, that there can be some height that can be located at this position. And suppose this position is actually the height we are currently at, so we just name it as height. Okay, now how can we determine that in this scenario? In this scenario, if we see does all these values, so left height is actually 1, okay, right height is actually 2, and the height we are currently at, which is this position, is actually 0. And over here we were able to store only 1 unit of water. So why we were only able to store 1 unit of water? Basically we were following this condition, that first of all we need to check that what are the bar height difference between on the at any given position on the left hand side and at the right hand side, and we need to take the minimum out of both of them, because over here, though on this right hand side the bar is actually of height 2 units, because on the left hand side the bar is only of at a height 1 unit, we cannot store water more than this height, because the water is gonna spill out. Now that is one condition. Now second condition is, in this case we got lucky that over here there is no height at all, so that's why we were able to store 1 unit of water over here. So basically we can say that at any given moment the amount of water we can store in 1 unit is actually following this formula, that the minimum of whatever the right height is, whatever the left height is, so whatever the lower value of both of these minus the height we are currently at. And if this is greater than 0, then only we can say that we can store some water at any given position. Like let's say for an example that y at this first position we are not able to fill out any water. And if we see both both the values, so on the left at this particular position, I'm referring that on the left side the left height we had was actually 0. The height at current position was also 0, and the right height was actually 1. So if we apply this formula, we can clearly see that on the amount of water we can try to fill in this space is actually going to be minimum of these two. So minimum of left height and right height is actually 0 minus the height we are currently at. So current height is also 0, which means that we cannot store any water, or we can store 0 units of water at this particular position, or at this first position, because there exists height difference. And same formula can be applied for all these places to calculate that what is the amount of water we can store. Like if we see over here, the bar height is actually 2. Now for this particular position, if we want to check that what is the amount of water can be stored, we know that over here we can store 1 unit of water. And why we are storing 1 unit of water is because if we see the left height over here, that is 2. Now on the right side, the right height, there is no right height over here. There is no right height over here which is greater than this one. Like this, there is some right height over here, but that is less than this height. So there is no point in us to treat it as valley up until this point. But over here we know that the height is actually greater than whatever height we currently had over here. So this right height is actually 3. So we are going to check, so we are going to apply the same formula. So we are going to check the minimum out of 1 and 3, one minimum out of 2 and 3. So this is left height, this is right height, and we are going to minus whatever the height we are currently at. So current height is actually 1. And if we apply this formula, we get 2 minus 1, so we get 1, which means that over here we can store 1 unit of water. Now let's try to understand this one with another example, and I'm spending a lot of time in this one because this is the actual crux of the entire example. So over here, if we want to calculate that how much amount of water we can store, we are again going to repeat the same process. So what is the left maximum height we can find for this particular unit? Like the left maximum height we can find is actually 2 units. So we can say the left height is 2, the right height is this one, so right height is 3, and minus whatever the height currently we have at this position. So this position we don't have any height, so which is 0. So if we apply the same formula, we can get 2 minus 0. So we can say that over here we can actually store 2 units of water, and which is what is presented over here. Like that's how we can store 1 unit of water over here, and that's how we can store 1 unit of water over here. So at any given position, for any particular element, we are only going to need 2 things, because height we are already given. So we remember that in this equation we are actually comparing 3 items: the right maximum height, left maximum height, and height we are currently at. So height we already know, and our aim is to find that how can we find this right maximum height at any given element, left maximum height at any given element, and then it would be piece of cake for us to identify that how much water can be stored at any particular position. So we can have a brute force approach where at every single position we iterate over the entire left array and entire right array, and we find that what is the maximum left height we can find at any given position. We can also find what is the maximum right height we can find at any given position, and we already know that what is the height we are currently at. And once we have both of this information, we would calculate our result, and we would try to calculate our output. The thing is, this scenario is pretty darn bad, like at any single position. So even over here we will have to iterate over the entire left array and entire right array in order for us to calculate these two values. And yeah, this is brute force. So brute force is tend to be dumb. like we are not doing anything clever over here. So that's why we would end up with the time complexity of big O of n square, because at any single position we are going to iterate over the entire array to find these two values, left height and right height. Now can we do something better over here, and how can we find a better approach? Like so for the given input example, we can actually do something clever. What we can do is whatever the input we are given, we can actually iterate over it from the left side, and at every single position we can see that for any single element, what is the leftmost value or left max value we can store. Again, we are going to iterate over the given input example on the reverse order, and then we can find that at any single position what is the right max value we can find. And then it becomes pretty simple for us. We can just simply apply this formula on the entire input that were at any single position. So at any single position we only need to find the minimum value of right max and left max minus whatever the height we are currently at, and if this becomes greater than 0, then we will add it to our whatever the output we have, and this would be our answer. So let's iterate over first on the left max side on this given input. So on the first element, the maximum left height can be 0. Over here it can be 1. Again over here it can be 1. Now over here this value is 2. So left max height at this position would actually be 2. This would actually be 1, but thing is we have already find a greater value. So again we are going to keep it as 2. Again we are over here, this one is 0. So again the left max height we can find is 2. Over here this one is 1. So again this would be 2. Now this is 3, which means that left max height we can find is actually 3. This is 2. So left max height we can find is actually 3. Again 3, again 3, and again 3. So this is how we can fill out this left max table. Same way we are going to fill out the right max table, but we are going to do it in the reverse order. So over here the right max edge is actually 1, and we are going to repeat the same process. Now we have both of these tables filled out. It becomes pretty easy for us to find the solution, and we can actually do it everything. Now this approach would work perfectly fine. The thing is, what is the issue with this approach? Like if we calculate the time and space complexity, the time complexity for this one is actually big O of n, because we are doing everything in just a single loop, and we are running this loop 3 times. Like first we are running this loop, so we are doing n work. Again we are running this loop, so we are doing n work again, and then we are running the n work to find the output. But thing is still time complexity is going to be big O of n, and the space complexity for this one is actually going to be big O of n as well, because we are storing these two additional data structures. So this is much better improvement than our brute force approach, where in the brute force we are doing everything in big O of n square time. So we are gaining significant improvements over here. Now this question has been really popular with a lot of different companies, and if we just look at the number of companies that have asked this question, and if we just see the amount of frequency that they have been asking this question, I wouldn't be daring to skip this problem. Like even if you see up until 2 years, almost all the companies that are like one of the biggest companies in the world, they are continuously asking this problem. Just look at the numbers, like Amazon, Facebook, Goldman Sachs, Bloomberg, Microsoft, Google, Adobe, Uber, Apple, Tesla, Lyft, Expedia, Morgan Stanley, Swiggy, ByteDance, Databricks, Walmart, Flipkart, ServiceNow. These are the companies that pay you in gold bricks, and getting job or getting employed at any of these companies at least for 2, 3, 4 years is going to change your financial situation drastically. Like it's going to be 180-degree turn, and you only need to clear the technical interviews just once. Like after that you are sitting on top of gold. So if you are also dreaming to changing your life completely, like make sure to focus your utmost attention to this problem, and try to solve it as many times as possible, because it has been asked in so many companies. So that tells you something. Okay, now for the optimal solution, we can actually observe something pretty interesting in this given left max and right max that we have calculated. If we notice in the given input, this is the biggest bar of height that is possible, and we know that at any moment, at any location, if we want to find the height, the equation is this one, that the minimum of whatever the left max and right max we have minus whatever the height at current position we have. This is the equation to find that how much amount of water we can trap at any given unit or any given elevation. Now the thing is, if we notice in these two values, left max and right max, we are actually finding something pretty interesting. And the interesting thing we are finding is that the tallest part that we have, it actually divides the given input in two parts. And it divides how? That if we observe the left max portion, the left max portion is always less than whatever the right max portion is up until this point number 7. Because notice all of these values. In all of these values, the value of left max is actually less than whatever the value of right max is. And over here it's equal to right max because of this particular tallest bar that divides two arrays. And all on the right side, actually the R max is less than left max. And we can see those things over here, that over here these are all the values that are smaller than whatever the left max there is, because for these four values actually this particular, the tallest bar actually becomes the left max element. And using this we can actually use it to our advantage, because remember, at any moment if we want to find that what is the amount of rainwater we can find, we only need to find the minimum value of amongst this left max and right max, which means that this tallest bar can actually be used in our help, and we don't even need to calculate this whole left max and right max array by itself. We can actually use a very beautiful concept that is present inside the given array traversal problems, and that is two pointer solution over here. In the two pointer function, we are going to have two variables, left and right, initially located at first and last position. And at every single time we are going to check that whatever current element we have, so whatever height at element left or pointer left, and whatever the height at pointer R, we are going to compare these two. So suppose the height at left pointer is actually less than right pointer. What we are going to do is, first we will check that whether the current left pointer we are at, does it contains the left max height, and we are going to initialize the left max variable to 0 at the beginning. And at any point we are going to check that whether we need to update the value of left max. So for left max we are going to check two things. We are only going to check one thing. We are going to check that whether the left max should be the maximum value out of whatever the left max we have stored and whatever the height of left we are at. So this will always make sure that we have the most updated left max value. Once that is done, we only need to use one equation in this scenario, and that equation is left max minus whatever the height we are currently at of pointer L. If this is greater than 0, we can actually add it to our total. So we can just say that total is whatever value we already had for total, plus we can add this whole function to it. And once that is done, we will need to update our left pointer. So on the left side we will move towards the right pointer and we will do left plus plus. And again, suppose at any point we find out a scenario where the height at right is actually, so height at right is actually less than height at left. If that is the case, we are going to repeat the same process. Let me use a different color, but this time rather than doing it for left max, we are actually going to do for the right max. So again, we are going to check for right max that what is the maximum amount we can find. So we are going to take maximum of whatever the right max we already have and whatever the current right height we are at. And once that is done, again we are going to use the same equation, but rather than using left max, we are going to use right max minus whatever the height we are currently at for this R pointer. And if this is greater than 0, we are simply going to add that value to our total variable, whatever we calculate for this one. And once that is done, our right variable is actually going to move towards left side. And we are able to achieve this because there exists some bar that actually divides the array in two portions. because over here up until this bar always left max is going to be minimum value, and over here always right max is going to be minimum value. And at any single position, whenever we are at any left and right, we always check their heights, which means that suppose we reach this right before, still in the left side we will have to calculate all of these values before we get here. And once we get to a point where left is actually greater than or equal to right, then we can simply break out of the loop, and whatever value we have stored in the total, we can simply return that. This is a very beautiful approach, and notice that we don't even have to use the full equation over here. We are only comparing any one variable at any point in time, a left max and right max, and every single time we are keeping track of whatever the left maximum or right maximum value that we have been able to find. So if we use this approach, if we use two pointer approach, and if we calculate the time and space complexity, basically the time complexity for this one is actually going to be big O of n. So that is same as it is, because in any case we are going to traverse over the entire input array, but the thing is we are only doing it once, we are not doing it more than that. And if we see the space complexity, actually we are only storing couple of additional parameters like right max, left max, and we are storing two pointers, left pointer and right pointer. So we are not doing any additional data structure, or we are not storing anything else, which means that our space complexity is actually going to be big O of one constant time. So this is really amazing solution compared to all the other approaches. This is the most optimal approach. So first of all, we are going to initialize our two variable left and right. Left is going to be 0, right is going to be a height length -1. We are also going to initialize a variable total, that is going to be total amount of water that can be stored, and we are going to initialize it to 0. We are also going to have two variables, left max and right max, and left max would be the first element in whatever the height we are given, so height of 0, and right max is going to be the height of last element, so we can say height of right pointer. And now we are going to run our loop. So while left is less than right, first we are going to check for the height difference, and whichever side has the lower height, we are going to work on that side. If left pointer has lesser height, we are going to work on the left side. So we are first of all going to see that do we need to update the left max. We are going to check that whether we are at any valley where we can store some value. So we are going to check that if left max minus whatever the height we are currently at on the left pointer, if that is greater than 0, then we know that we are at a valley and we can store some water over here. So we will update the total amount of rainwater that can be harvested to total plus whatever the height difference we have found over here, which means that left max minus whatever the height we have found over here. And once that is done, we need to update our left pointer to move towards the right side. And if that is not the case, which means that we need to repeat the same process but now on the right side. So first we'll try to see if we need to update the value of right max. If we don't need, and now again we are going to check that are we at the valley on the right side where we can store some rainwater. If this is greater than 0, then we can update the total rainwater. And once that is done, we will need to update the right pointer to move towards left direction. Okay, I think that is it. Once this while loop ends, the total variable should have all the entire result, and we can simply return that, and this should give the total amount of rainwater we can harvest. Let's try to run this code. Okay, seems we made some small mistakes. Seems like our solution is working. Let's try to submit the code. And you can see that our solution works pretty fast compared to a lot of other solutions. That is because we are using the most optimal approach. I'm also going to post this solution in the comments. Also, I have created the solution where we need to use two separate arrays to store the left max variable and right max variable at any single position. And you can check it out, that solution as well, from the comments.
For this one, the lead code problem number 26, if we see some of the popular companies who have asked this question, there are companies like Apple, Facebook, Amazon, Microsoft, Google, Bloomberg, LinkedIn, and Intel. They have all asked this question. So that is why this is a really important question. And let's just quickly go through that what is the problem statement, and then we would try to make the solution. Now in this case, if you want, you can again read this whole thing. I'm just going to explain it to you quickly. The problem we are given is that we are given a sorted array. That is cool. Always love when the array is sorted, makes things life so much easier. Now in this case, we are told that it could be possible that sorted array can have duplicated entries. So the moment we identify duplicated entries, we don't care about all the duplicated entries, but the thing we care about is that in the initial portion of the array, all the distinct values has to be present. All the other values, we can mark them as anything like X or underscore or hash or whatever you want. We don't care about those values. So in this case, we are given an input array with 7 characters. But if we see the number of distinct characters we have, we only have 0 as a distinct character. Then we have 1, 2 and 3. So 0, 1, 2 and 3. These are the only distinct characters we have. Now for these 3 characters, we don't care anything. So we are not going to mark them. Basically, they were duplicate entries and we are not concerned. But in this case, we are concerned with the distinct characters. And the moment we find the distinct characters, we need to put them at the beginning and then return whatever the solution we have been able to find. So what is the brute force way to do this problem? Again, brute force way is pretty simple. We just take one value and we will try to see that, okay, how many duplicates there is one, and then we add that. Then keep on repeating the same process, and then if this is a duplicated entry, again we move on to the next value. So this approach is guaranteed to give you the answer in big O of n square solution. So brute force is always not a good way to go. The next way to go is that we can actually try to do something smarter here. And what we are going to do is, obviously, this is a 2-pointer solution, so of course we are going to use 2 pointers. But since we are using here 2 pointers, we are also going to find a way to store the index value. So we are going to have an index value and we are going to initialize it with starting position 1. Now this first value is guaranteed to be a distinct value because we are told that there is at least one value in the array, and that value has to be part of the original distinct value. So we are going to directly put it over here, and that is why we put the index pointer at value number 1. Now index pointer is just a way for us to iterate over. And also these 2 pointers, what we are going to do is, initially they are both going to be located at the same place, but the end pointer is going to move few steps ahead till it finds a new distinct value. That is what it is going to do. So in this case, currently starting and ending pointer, so this value is same as this one, so we need to skip this part. So we are not going to care about this value. We are going to move to the next value. Now our starting and ending values both are located at this position. This is a distinct value. The moment we find a distinct value, since we find the first distinct value for this index position number 1, we are going to add it over here. So we add value over here. The moment we add the value to our array and we find like a new distinct value, we are going to do index plus plus. So now our index value is going to be 2, and the next distinct character we find, we are going to add it to position number 2, which we find immediately.
Immediately we find it because this is a new one, because the end pointer went there and it didn't find any duplicate values. So again 2 comes over here and our index value gets updated to value number 3. Now we currently the scenario is that our starting and ending values both are at the same position. So currently the starting pointer is located over here, ending pointer is located over here. Now this ending pointer is going to go one step further. So currently ending pointer is at value number 2. Again, this value number 2 is the same as the previous value. Since it is the same value, starting pointer is going to remain here. Ending pointer was here. It didn't find anything. So now ending pointer will go to the next value. Next value is a distinct value. Again, distinct value, starting and ending pointer becomes at the same position. Index value becomes 4 and the value we added to our input. So we added value number 3 to our answer. Now again at position number 3, ending pointer go to the next. This is already 3. Now ending pointer tries to go to the next. Array ended, so we can't do anything about it, and this we can return it as the answer. We don't care about these values because that is none of our concern. But you see, even in this case, rather than coming on one side, starting and ending pointers were working in tandem to go from one step to the other step to find the answer. This was an easy problem, and in this case I intentionally chose this problem because we are at the same, apart from using 2-pointer solution, at the same time we are also using sliding window technique, because we are creating a window between starting and ending pointer, and the moment we find some solution, reasonable solution, we shift our window depending on the conditions. And this is a beautiful way to solve this problem, and that is why I decided to keep this solution at the last.
So let's see the coding solution for remove duplicates from sorted array problem. Basically, as mentioned, we are going to initialize a variable called insert index, and this is going to mark at value number 1 because we already have the first value stored inside our given input array, because that is unique for sure. Then we start our for loop from the first position, not from the 0th position, because we already took care of the first value. And then all we need to do is we need to keep on incrementing this value number I until we find the duplicate entries. And if the entries are not duplicate, which means we found the distinct value, then at that time we are going to add that position of nums of I to our insert index, and which is located initially it would be 1, and at the same time we would increase its value, and then we would keep on repeating this process till we reach to the end of the loop. And basically in the end we simply need to return the insert index value, and this is going to be the whole solution. This is going to give us that how many number of distinct elements are present inside the given array. And let's try to run this code. Okay, seems like our solution is working. Let's submit this code, and our code runs 100%, nearly 100% faster than all the other solution, which is pretty good. If you want, I'm going to post the solution of this code in the comments of this video. Also at the same time, you can check out my GitHub, where I have solution for every single video I have done so far, and there are a lot of lead code problems, so this could be a good resource. I'm going to post this link in the description as well. Thank you.
Hello friends, we got a job at Microsoft, but the thing is we are not going to stop lead coding because I like making these videos. The video we are going to do today is next permutation, and if we see some of the popular companies who have asked this question, there are companies like Facebook, Amazon, Google, Apple, Microsoft, Bloomberg, ByteDance, Uber, Goldman Sachs, DoorDash, TikTok, and Snapchat. So that's why I am paying my utmost attention to make this video. I hope you also find this entertaining. So this is a LeetCode medium problem and also a very well-liked problem on LeetCode. If we just want to understand the problem statement is only consist of one line, that we are given an integer array called nums and we need to find the next permutation for this nums array. Now the question comes, which is very obvious, that what does this next permutation is being defined as? Well, one thing to find out is that you can actually try to read this whole definition and try to understand that what does it mean, or you can check out the example I'm trying to show you. Suppose we are given integer array that is like the value 1, 2, 3, right? So this currently there are 3 separate values. The thing is, let's try to consider and let's try to create like a lexicographical value out of these 3. So we can create a value that is like 123. Now if we want to create like a sorted ascending thing using these three elements, like obviously the next sorted element is going to be like 132. Why? Because okay, this value is 123. Using these three characters, what is the next value we can make that is in the ascending order? We can make value 132. Now if we want to make the next ascending value, the value we would be able to make is going to be 213. The next value is going to be 231. The next value is going to be 312. Value after that is going to be 321. And after that, we won't be able to make any values. Now, if you look closely amongst these values, all the values are sorted in ascending order. For every single value, we are only picking the value that is going to be in its right place. So for 123, we are not going to put like 213 after 123 because this value is going to be smaller than this one. So that's why we are putting this 132 first. Same way, this 231 is also at the correct place compared to this 213 and 312. So that is the main logic behind it. So suppose in the question, if we are given the value that is like 123, then in that case, the next permutation has to be 132. But the thing is, we don't need to return 132 as the answer. We need to return answer as like 1, 3 and 2. So I think this explanation makes a little bit of sense. Let's try to see some examples to try to understand that what does this problem is actually asking us to find. So in this case, okay, currently we are given the nums array with the values 1, 5 and 6. So again, lexicographically, we will be able to make value 1, 5 and 6, right? So logically, what should be the next value in line? So next value has to be 165 because any value after that would be would definitely be greater than this one. So this is going to be the next permutation. Again, same way if we are given the value 651. Now this is a tricky case. Why? Because if we try to do like permutation of this 651, so originally the whole permutation is going to look like this. So this is going to be the whole permutation. So if the initial value is like 156, these are going to be the subsequent values. So this value 651 is representing this value 651 over here. Now if we see, there is actually no next permutation in this case. So if that is the case, basically we will have to return the smallest possible value, and the smallest possible value in this case is going to be 156. So basically we are going to return 156 as the answer in this case. Again, if we take another number, okay, so this is like 4 characters long. So in this 4 character long number, the next permutation is going to be. So I know this is a very complicated question to understand, but the thing is, once you get a grasp of how the permutations are being made, you can simply know that what is the answer going to be. So let's see that what are going to be different approaches to solve this problem. Okay, so the first approach we are going to try is going to be the brute force approach. Suppose this is the input we are given. So in the brute force approach, what we are going to do is, depending on the input, first of all, we will try to make the smallest value possible. So smallest value possible in this case is going to be values 1, 2, 3 and 4. Okay. Now after making the smallest value possible, we are going to try to explore every single values we can make inside the ascending sorted array. So the values we are going to get is, so just based on the few values, we were able to make like these permutations, and eventually we came to the value that exactly matches this value, and basically the next permutation after this is going to be the answer we need to return. So in this case, we are going to return this as the answer 2143. The question is, okay, this approach gave us the correct answer, but the thing is this the right way to do it? And answer is definitely no. Why? Because even for a small example of 4 characters, we ended up exploring a lot of possibilities. Like if you try to calculate the time complexity in this case, the time complexity is going to be disastrous. It's going to be big O of n factorial. That is like the worst imaginable time complexity. So we have to find a way to do something better. So before we come up with the optimal solution, we are going to take these 4 cases. We are going to see that what is going to be the next permutation for every single one of them. And depending on the answer, I would be able to show you that what is the pattern that we have been able to establish. And using that pattern, we would be able to create our optimal solution. So first, let's start with this most initial case. In this case, all the values are actually ascending order, increasing order, which means that this is currently the smallest possible value we can make out of the values 1, 2, 3, 4, 5. Now the next permutation in this case is going to be where this 5 shifts on this left side and this 4 shifts on the right side. So basically the answer we are going to get is this is going to be the next permutation for this value. Notice that currently we had value 45 and we flip it to 54. We kept these values the same way they were because they were not needed to be changed right now. If we take this example, this is the exact opposite of this one. Why? Because this is the maximum possible value we can make. In this case, if we want to see the next permutation, basically there is no next permutation, which means we will have to go back to the very first value. So this is going to be the answer. Using these two answers, we are not able to establish much of a pattern over here. But the thing is, now let's try to see some middle cases. So in this case, if we see, we are given value like 25431. So lexicographically, we have been able to make a value like 25,431. Now in this case, for the next permutation, we can either like try to see that, okay, what is going to be the value, but I'm showing you a different logic here. And the logic I'm trying to establish is that typically we always follow from the left hand side to the right hand side. Until the point we see continuous increasing elements. Again, I am talking about how to find next permutation, and for that we will have to observe the current case that we have been given. So over here so far 1, 3, 4, 5, they are all currently in increasing order, which means that they are at the correct locations. The thing is, the moment we reach to this value number 2 is actually smaller than 5, which means that the increasing order that we have been building up so far is no longer true. So because this increasing order is no longer true, we will have to do something with this value number 2. Now we need to put it in some place where we are going to put it. The logic I'm suggesting is that now we have this value number 2. We know that we will have to put it somewhere over here. Now where we are going to put it, we are trying to find the next permutation, which means the immediate next value that is greater than this value that we can make. So logically what we are going to do is we are going to scan all of these values. We are going to see that, okay, what is the minimum value from this 2 that we have. So currently there is only one value that is less than 2, and that is this value number 1. Now for this value number 1, we are not going to do anything with this value number 1, but the thing is, the very next value that is before value number 1 has to be the most immediate greater value that is compared to this 2 amongst the remaining portion. Again, let me clean this up a bit and explain you again, because this is the most important topic. We check amongst these portions that, okay, what is the first minimum value we can find out that is less than this value number 2. So that is value number 1. What that means is we already know that all of these values, they are ascending in increasing order, which means that the very next value has to be the value that is greater than 2 but less than all the other elements before that. Again, if you don't understand, just rewind it and see it again, what I'm trying to establish. So basically we found the value that is immediately greater than 2 but less than this remaining values. So what we are going to do is we are going to swap these two values. If we swap these two values, the answer we are going to get is, and this is the answer we are going to get. The thing is, you must be saying that, hey, this is not the correct next permutation. I know this is not the correct next permutation, but what this is that we actually found the first element that needs to be on the right place in order to generate the next permutation, and for all the remaining values we simply need to reverse them in the other way around. So if we reverse them, we will get a value that is 3, 1, 2, 4, 5, and this is going to be the next permutation answer for this original input that we were given. So basically we can just ignore this case right now, and thing is, this is going to be the very next permutation. Now again, let's go back on the logic that how we were able to generate this value. Well, definitely we notice that all of these values 5, 4, 3 to 5, 4, 3 and 1, they have already been at the correct place, which means we have exhausted all the possibilities for these values where we can make some adjustments and create like a greater value, but that still remains smaller than the next value. That means we will have to do something with this element. So we will have to replace this element with some other element, and the only way to replace that is to find the value that is immediately greater than this 2, because remember, apart from 2, if we try to add 4 over here, then that won't work. Why? Because there is still going to be a permutation that we missed, and that is the answer. Let's try to do the same logic over here again. So in this case, if we try to see currently this 3, 4 and 5, they are increasing order, right? But we find this value number 2. Now 2 is immediately decreasing value compared to this remaining 3 values. Sorry, compared to its previous value, which means we will have to find some way to replace this 2 and make the changes amongst these values to generate the next permutation. How we are going to do it is that, okay, we will have to find a value that is greater than 2, but there is still exists some value less than it. The question is, all these values, they are all greater than 2. So we are trying to find the immediate greater of 2. So which means we will have to swap the values, and you guessed it correctly, between this 2 and 3. And that is exactly what we are going to do. So if we swap that, we are going to get an answer that looks like this. Now in this case, again, this is not the correct, but the thing is, these two portions, they became at the correct position. And for the remaining part, we will have to just reverse that. So if we reverse that, the answer we will get is, it would be the immediate next permutation for this answer. So logic we are applying is that basically we scan through the any given number. So in this case, suppose this is the number we are given. What we are going to do is we are going to jump through all the values till we find a value where the current value is actually less than its previous value. So in this case, that value we can find is 4, which means we will have to replace 4. So these 3 places, they are already in the correct place. We don't have to do anything with them. Now for this 4, what we are going to do is we are going to see that what is the immediate greater value of the 4. So one way to do it is to find like the lesser value than 4. So lesser value than 4 is for 2. So one value before that is going to be the immediate greater value compared to 4, that is 5. So we will get a value that looks like this. And after that, all the values, so currently now these 4 elements are in the correct place. All the other values we will have to do a reverse. This is the answer we need to return. In my personal opinion, this is a very hard question because without major hints, you won't be able to solve it in an actual interview if you haven't seen it. But the thing is, we are planning for a FAANG. So basically we will have to be vigilant and we have to make sure that we are able to crack these kind of questions. Let's calculate the time and space complexity in this case. The time complexity is actually going to be big O of n because we only have to iterate over the given array like couple of times. This is space complexity. Apart from using couple of variables, we won't have to use any extra space. So we can also complete this in like in place in constant space complexity. Before we implement the next permutation method, we are actually going to initialize couple of helper methods. So first helper method we are going to create is going to be a swap method where if we are given any 2 elements and we are given the given input array, we would be able to basically swap their values. So depending on the index values, we would be able to make that adjustment. Now the second helper method we are going to create is going to be the reverse method. Now for this reverse method, we are going to again give the given array as the input, and we are also going to give the ith value as like the starting index from where we need to start doing the reverse operation. We are also going to create a jth value as sort of like an end value, and that is going to be the length of given array. Now all we have to do is just run a while loop that while I is less than j, basically we are just going to call the swap method, and for the swap method we are going to provide the values of nums j and I, and after that we are going to increase the value of I and we are going to decrease the value of j. And this basically concludes our 2 methods that we have been trying to create. Now let's go on the main method. So from the main method, first of all we are going to we will have to run a loop from the reverse end to find the first value where the increasing order does not match. So we are going to initialize a variable called I, and we are going to assign it to the value of nums.length minus 2. Why we are doing it nums.length minus 2? Because we do not want to be in the out of bounds, because we will always be comparing 2 I values at the same time. Now let's initialize our while loop that while I is greater than or equal to 0 and the number of current I plus 1 is actually less than or equal to the nums of I. So we are comparing 2 adjacent values each time. While this is true, first of all we are going to decrease the value of I. So the moment this loop ends, basically we would be at the correct place where the ith value is actually not the correct value and needs to be swapped. So then we are going to check that, okay, if the given value of I, if that is greater than or equal to 0, if that is the case, which means we will have to do our swap operation, and we haven't found like the greatest value possible. So if that is the case, we are going to initialize a j variable, and we are going to assign it to like nums dot length minus 1 again. Okay, again we are going to run a while loop. That while we will have to find that whether the jth value, if that is less than or equal to I, if that is the case, we will keep on decreasing the value of j. So eventually we would be at a point where we are at the immediate value of j that is greater than I. This is the case. Basically we are going to do like our swap operation, and we are going to swap the values of I and j. After swapping the operation, we will have to do the reverse operation for the remaining values. So we are going to do we are going to call the reverse method, and we are going to provide the value of the given array, and we are also going to do I plus 1, because from I plus 1 we will have to reverse all the characters. And basically that's it. This should be able to provide us the next permutation. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, and that's why this is like a really good solution, but it's a really tough solution to achieve. I would be posting this in the comments so you can check it out from there. Thank you.
So now we are going to understand the full topic of strings. We will understand that what is the core idea about what strings is, and what are the different kinds of questions can be asked. Now string is a very versatile topic. So I have decided to break it down across multiple different sections of the topics we are going to be seeing. So we would see some string topics in dynamic programming. We would see some string topics and some other problems, but overall this is for you to give you the basic idea about what string is and what are the different questions. But this is not where the topic ends. This is just where it starts, and it is going to carry on throughout our remainder of the course. Strings are one of the most unique and most versatile kind of a data structure that we can call. And the funny thing is, if you see the broader categorization of all the different data structures, you would not find string in any one of these particular patterns. String is actually unique in a nature because it is the combination of all the characters put together, and that forms any particular string. Because characters on their own are pretty mundane, because you cannot do much of the task. For most of the things that we usually do in the real world, we need to deal with different words, different characters, different serial ID, different numbers, different phone numbers, all sorts of bunch of different items. And for that we use character as the underlying implementation, but only character using is not going to be sufficient. And for that we need to use a way to store the combination of different characters, and that's where the majority of string application comes into place. Strings are defined in all the different popular languages. They have vast amount of uses. Like you can use string for word processing, for HTML, for artificial intelligence, machine learning, data storage, storing the encryption certificate, storing the first name and last name of person. So all sorts of things can be done using different forms of strings. But the thing is, in terms of the perspective for DSA problems and DSA algorithms, we need to understand that how to perform different operations on strings, what are the different ways we can do it, and what are going to be the common scenarios. Because remember, you are always going to encounter where you are using string as programmatically, or in your interviews, or in real world application. So now let's talk about some of the basic operations that we usually follow, and that we are going to learn more about in all sorts of 15 lead code problems. So one of the most common things that you can do with the string is the creation and destruction of the string. So if you want to create a string, basically how it works is that in the memory of the computer,
we are given a continuous block of memory is provided where you can store any particular characters. Now these characters can have multiple meanings. You can store simple values like A to Z characters. You can store some special characters like percentage, plus, minus, these kinds of operator signs. You can also treat numbers as different characters as well, and many times they are also being stored inside the string, or it could be combination of every single one of those. And that's why you have these strings that contains all of this jumbled information in a particular format that computer can understand and humans can read, and then we will have to do multiple different operations. So first operation, that where we are creating a string, can be typically done in big O of n time, because we don't know how many number of characters are going to be there, and initially we just start with one character, and if we need more space we will assign 2 characters. If we need more space we will copy all the contains into 4 characters, and so on and so forth. This is going to be the most basic type of implementation, but lucky for us, most of the problems are not required for us to do that, and they are typically handled by the language of our choice, be it Python, Java, .NET, C#, whatever it can be. Next thing is, because strings are the combination of multiple different characters, so we need some way for us to identify or fetch each of the character. So fetching individual characters can be done in big O of one time. Let me give you an example. Let's say I create a string and I put down the value as parth. Now I say that what is the character present on the first index position or the second position inside this given string, then it can immediately return value A in constant time, because this is a continuous block of memory, so it is very fast for us to store or retrieve values from any particular cell. Next common operation that you can see is the length of the string, and once again the length of the string can also be done in big O of one time. Now next operation is concatenation. Concatenation means that if we are given string 1 s1 and string s2, then if we are combining these two strings to create a new string s, let's say s3, that is going to be combination of s1 plus s2 in some form, then this process is called concatenation, and this can be done in big O of m plus n time, where m is going to be the length of s1 and n is going to be the length of s2. Same way, opposite of concatenation is substring. And in order to create a substring, basically, let's say if we are given a string that contains 10 different entries or 5 different entries, and we only want a certain portion of this size. So this process is called creating a substring out of the given original string, and this can be done in big O of k time, where k is the total length of any substring that you are trying to create. Same way, we can split an existing substring, and this splitting is typically done in big O of n time, because overall the total number of characters remains the same. Finding any particular character can be also done in big O of n time as well, because we need to iterate over every single value in order to make sure that whether that character exists or not. So these are some of the common operations that we usually do with strings. There are some more advanced operations as well, that is pattern matching and understanding or finding the meaning from any particular given string, and there are a lot of different algorithms.
Hello friends, hope you are having a fantastic day today. So in this session, we are going to do one of the easiest and most common problems in technical interviews. This is the Fizz Buzz problem that we all have heard of in the first year of computer engineering. And funny enough, this question has actually been asked in companies like Google, Apple, Amazon, Microsoft, and TikTok. So without any delay, let's get started. And you can see that this has been a very well-liked problem and also a lead code easy problem. Basically, we are simply given an integer n, and for this integer n, we need to return a string array called answer, and we are being told to return one index array. These are just all of these things to make it slightly more complicated, but this is a very easy problem. So what we need to do is we need to iterate over until this n values, and for every single value we need to check that if that value is divisible by 3 and 5, we need to return Fizz Buzz. If it is only divisible by 3, we need to return Fizz, and if it is only divisible by 5, we need to return Buzz. And if none of these cases apply, then we need to return the value as it is, but instead of integer we need to return the value as string inside the string array. So let's try to understand this with a couple of examples. Let's say that if we are given number input n is equal to 5, in this case we will need to iterate over values from 1, 2, 3, 4 and 5.
and for each one of them we will have to create a string array. So let's assume that this is our array. Now this value number 1 is not divisible by 3 or 5. So in this case we are going to return 1 as the string value as it is. Same way 2 is also not divisible, so we are simply going to return 2 as it is. Now at value number 3, if the value is divisible by 3 and not divisible by 5, this is the condition met over here. In this case we can check, we need to return Fizz as the answer. So over here we are going to answer Fizz because this value is only divisible by 3. Same way 4 is not divisible by 3 or 5, so we can just simply return 4 as it is. And for the value number 5, since it is only divisible by value number 5, we need to return Buzz as the answer. And this is what we need to return. All we need to do is we simply need to create a for loop for the given n value, and then we need to iterate over every single value, and we need to create the conditions in such a manner that if the value is divisible by 3 and 5, in this case we need to add Fizz Buzz for the new list we have created. If that is not the case, once again we can have an else if condition, and again if the value is divisible by 3, then in this case we need to add Fizz. If it is else if it is divisible by 5, then we need to return or add the word Buzz into our array list. And if none of the case is there, then whatever the value of I is, we need to add that value of I into our array list or array, and that's it. So this is the whole solution. If we see the time and space complexity, time complexity is simply going to be big O of n, where n is the number of inputs that we are given, and space complexity is, you can debate this with your interviewer because we are being asked to return a new list. If we consider that an extra space, then it would be big O of n. But if that is not the case, then in order to run this code, we don't need any extra space. So we can just complete this whole solution in big O of one time. So for the problem, first of all, we are initializing a new array list called result, where we are going to store all the values. Then as mentioned, we are iterating over every single value inside the given input, and the starting value is 1 because we are being told that this is a 1 index array, just a small tweak. Then we are having bunch of our conditions, and first condition is if the number is divisible by 3 and 5, we need to add word Fizz Buzz. If that is not the case, and else if it is only divisible by 3, then we add word Fizz. If it is only divisible by 5, we add word Buzz. If none of the case is there, then we simply add the value as it is, but we add the string value of I, and then in the end we simply return the result. So let's try to run this code. And as expected, our code runs successfully. Let's submit this code. And our code runs pretty fast compared to all of the other solutions, and also pretty efficient in terms of space complexity. But I don't even think that this matters that much. This is a really easy problem. Now, as promised, let me show you some of the important resources that you can use in order to prepare better for your upcoming technical interviews. I have actually created some resources. I have also stored all the code that I'm doing in a GitHub repository, and also some of the important YouTube channels that you should always check out if you want to gain much more insight into how IT technology works, what are the new things happening in the IT industry, and any of the thing that you want to learn. So without any delay, let's get started. So the number one thing I want to show you is this document that I have created, where I have posted some of the full courses that I have created on various topics like data structure and algorithms. Funny thing is, I have actually solved the entire blind 75, and I have already put it in a single video. So I have mentioned that over here, and also some of the other important items that you should learn if you want to prepare better for your technical interviews. Next, we have this list of 125 or I think 130 questions. Amongst these questions, I have sorted these questions based on the difficulty plus based on the topic. For most of the videos, most of the problems, I have created video solutions. So if you are not able to find it, you can go to the video solution. Also, these questions are actually lead code links for any particular question. And the important part is that I have actually divided it by the number of times it has been asked by different companies. Now, I know that not everyone wants to get a job at FAANG company or some other company, but needless to say, if you are preparing for a tech interview, this would be very much helpful because it would give you an idea that how popular that particular question is, at what frequency it has been asked, and if you are directly preparing for those specific companies. Say for example, if we see this problem, race car, so this problem has been asked by 92 times at Google, which means if you are
preparing for Google, you should understand that these are the type of questions that you are going to encounter. So it can be really helpful with your prep journey that you are doing. So this is the list of all the questions. Next, I have also portrayed down the experience of all the technical interviews or all the major interviews I have had in my career. And I have also provided that which are the interviews I got selected, which are the ones I got rejected. And actually I got rejected at hundreds of companies, but I haven't put all of them. I just put like some of the popular ones where I had some good experience. And then we have this GitHub repository. So if we go to this GitHub repo, it contains a lot of important information about all the problems that I have solved so far on the LeetCode. So many times I can understand that on the LeetCode, if you need the information, you might need to have like a paid version, and readily the items may not be available. So for most of the popular questions, you can actually go here and you should be able to find appropriate solution for that. So this would be really helpful to a lot of people. Now, the important resource that I was talking about, if you are preparing for your tech career or your interviews or your journey, I would really encourage you to go and check out this channel, freecodecamp.org. Now, for sure, they don't need any introduction from my side. Like, as you can see that they have like millions of subscribers and also thousands of videos on their channel. But good thing about this is that all the videos are actually full-fledged courses. So if you are interested to learn any new technology, they probably have a course for that. Funny thing is, I actually created and uploaded a couple of courses on this channel as well. So first one is Master Behavioral Interviews, and second one is, I think it should be popping up soon. And yeah, second one is Master Technical Interviews. I am also in preparation to create more courses for this channel because I personally feel that this is much more advantageous and it reaches to a lot of broader people. And this is like few of the resources, and let me know in the comments if you want to see more resources related to different type of stuff, like maybe technical system design concepts and system design interviews. So I can also share that in the upcoming videos as well. Hello friends, hope you are having a fantastic day today. So in this video, we are going to solve a very popular LeetCode problem that has been asked in tons of companies. So without any delay, let's get started. So the LeetCode problem we are going to solve is called longest common prefix. And you can see that this is a LeetCode easy problem and also a very well-liked problem on LeetCode. Now the problem statement is very simple. We simply need to write a function to find the longest common prefix of string amongst an array of strings that we are given as the input. And if we cannot find any prefix, we need to return an empty string. So let's try to understand this with a couple of examples. So in this case, what is the common prefix that we are able to find that is common for all the 4 strings that is currently given? The answer is quite simple. FL is the common entity or common prefix that we can find. So in this case, we will return FL as the answer. Now let's take another example. So in this case, what should be the answer? Well, first, it seems like this RA is going to be the answer, but RA is not present in this string. So in this case, since we cannot find any common prefix, so we need to return an empty string as the answer. Now to solve this problem, we are going to use a very simple logic. Input we are given, we are going to treat as if the string 1 that is currently present, this is the longest prefix that can be possible, because any other values, they have to have all the characters that are present in the string 1. How can it happen? Let's assume that in the example, currently the substring 1 is the value like XYZ, something like this. Now, even if all the other values like XYZ, A, B, C, something like that, and then XYZ, and then all the long values, still the longest common prefix has to be the first substring as its whole. So it can never be longer than the first string inside the given array. That is a given fact. So using this logic, we will try to treat that what if the first string is the longest common substring, and by treating this, we will try to compare this string with all the remaining strings that are currently present inside the array. And that's how we will be able to reach to the solution. So let's try to understand the approach that I'm suggesting. Suppose this is the input we are given. So now, based on our approach, we will try to see that, let's assume that this is the longest current prefix that we have. So we create a variable and we are going to store that as if the prefix currently is going to be the whole first string, because we just proved that it cannot be longer than this one. And now we will try to compare this string
with the remaining, all the other remaining strings to see that till what point we are true or we are correct. So first we will compare it with the word flower. So if we see that whether the flow is part of the flower, we only need to compare the first 4 characters. If they are equal to each other, we can simply say that this is still the longest common substring, which is the case in this case because this flow is part of this flower. So far the longest prefix we have found is going to be the first string in itself. Now we will repeat the same process once again. Now we will try to compare flow with float. Now flow is not part of the substring float. So what we can do is we will try to get rid of the last character because we are trying to check for the prefix. We are now only going to check for the first 3 prefix. So now we will compare flow with float. And we can see that this flow is actually a prefix of this float, which means so far the longest prefix that we have been able to find is FLO. Now we also get rid of this one and now we will move on to the next value. So once again we are comparing flow with flight. Now currently flow is not a substring of flight, which means we will once again get rid of one character and try to check if FL is the part of the substring. Currently FL is actually part of the substring. So in the answer we found, and since there are no more strings left, we compared every single string and we found out that FL is the common substring amongst all 4 strings, and that's why we are going to return FL as the answer. Now let's assume that for some reason this last character is something random. Let's say that this last character is ABC. Now once again what we will do is at this step, once again now with this FL is our prefix that we have been able to find, and we are going to compare this with ABC. Now since we cannot find FL as part of this ABC, so once again we will get rid of L and we will only compare F. F is also not a prefix of this ABC. So in this case, since we cannot find any value in the inside the prefix, so we will simply return an empty string. So this is the simplest logic to solve this problem. And if we see time and space complexity in this case, the time complexity is actually going to be the sum of all the strings big O of S. Also every single character inside the string would be the total worst case scenario time complexity, which is pretty reasonable because these are very quick operations, and this is still like big O of n time complexity if we consider n to be the total number of characters. And space complexity is actually going to be big O of 1 because apart from using like few variables, we are not using any extra space, so which is wonderful. Now let's see the coding solution for this one. So now first of all we are going to check for the edge case that if the given string is equal to null or strings.length is equal to 0, then we can simply return as an empty string. If that is not the case, we are going to mark the very first element inside the strings array as our by default prefix, and then we will start comparing prefix with all the other remaining strings inside the given array. So we are notice that in our for loop that we are iterating over the strings array, we are actually starting with I is equal to 1 because I is equal to 0 has already been taken care of. And then after iterating over it, now we are simply going to check for every single string compared to our prefix. So we are only going to check that whether this given prefix is actually an index of the given string. If that is not the case, if that is not equal to 0, which means we will have to subtract one character from our given prefix and once again recheck this possibility. So we will keep on iterating this process. And if at any given moment we identify that the given prefix is empty because continuously we are subtracting one character, if that is the case, we can simply return as the empty string. If that is not the case and we get out of the loop, then we can simply return whatever the value we find inside the prefix variable. So this is it. Now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions. Also, it is excellent in terms of space complexity as well. And once again, I'm going to be submitting this inside our GitHub repository. So this is the GitHub repository that I'm talking about, where I have solved hundreds of lead code problems, and all of these are some of the most popular lead code problems that has been asked at bunch of different companies hundreds of times. So if you feel that you are stuck with any of the lead code problem, I would highly encourage you to come over here and check for the solution. Also, I have created this document on Google Drive, where in this document, first I'm providing all the full courses that I have completed so far. But the most important point for this document is actually this list of all the 130 questions. If you see, these questions are divided based on the topics, the difficulty level, and also how many times they have been asked by separate companies. So this is very important information for any single one of you who is currently just trying to improve on the data structure and algorithm related lead code problems, or actually preparing for different interviews, because I know times are tough, companies are laying off people left and right. So it never hurts to be interview ready and always be on your best game.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do encode and decode strings lead code problem, and as you can see, this is actually a lead code premium problem. If we see some of the companies who have already asked this question, where I want to get a job, there are companies like Facebook, LinkedIn, Google, Square, Uber, Microsoft and Apple. So all of my favorite companies have asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given a list of strings. Now we need to design an algorithm where we are actually encoding this given list of strings into a single string. Then we are told that that single string is supposed to be sent over a network, and then when we get back to the second machine, we need to decode that given string into the original list of strings. So let's try to understand this with an example. So suppose we are given a string S, where we are given bunch of different strings that looks like this. So after this, we will actually create an encoded string. Now this encoded string is combination of all of these four items, and it is just a single string. So let's say that this is the encoded string we have created. Now after creating this encoded string, we need to write a function to decode the string as well. And after we decode the string, we should get a response that exactly looks like this, and this would be the original decoded string we would get. And this is what we need to return. So we need to return the algorithm to encode the string and also an algorithm to decode the string. So let's see that what would be the different approaches we can take. Okay, suppose this is the original string we are given, and we need to encode the string and decode the string. The idea is we are actually going to use an extra character, and where we are going to use an extra character, we would put it where one string ends before other string starts, and we will keep on repeating the same process. And all we have to do is, so that would be the way to encode the string. After encoding the string, when we have to decode, we will just simply take that character, and the moment we reach that particular character, we would know that okay, this is the place where one string ends, so we would create a new string for that, and then we will repeat the same process. So let's see that in action. So first of all, suppose we take this character that looks like this hash, right? I'm just taking any random character. The idea is you can discuss with your interviewer that what kind of character you can take. So suppose I take this hash. Now I do encoding string. So the encoded string is going to be AB. Then the moment I identify that this strings ends over here, I would put a hash and I would keep a continuous string. Now I realize that okay, this is a new string B, so I would add a value B. Again I would put a hash. Now again this value is C, again I would put a hash, and again at the end I would find this value ABC, and that would be the end of the string. So now I have created an encoded string. Now if I want to decode the string, the decoding would work like this. So first of all, I'm iterating until I find that this is a valid string. So valid string is AB. Now I realize that okay, this is the hash, and hash is the character that I put it as an extra character as an encoding mechanism. So I would remove this hash and I would treat this as a single string. Now I would again start creating a new string. So again I find this value B. The moment I encounter the string hash, I would treat this B to be a separate string. Again I would encounter this value C, and again I would encounter this value ABC, and this is the way we are going to encode and decode the string, and this solution would work as expected. If we see the time complexity in this case, the time complexity is actually going to be big O of n. Why? Because we will have to iterate over all the characters that are present inside this given string S to first of all
encode and then decode. So overall it would be 2n, but we can generically write it to be big O of n. Now if we see the space complexity in this case, the space complexity is actually not that much, because we anyways will have to create an encoded string and decoded string, and all we are doing is just using an extra space to solve this problem. So this is pretty simple to me. Okay, suppose this is the string we are given, and the idea is we are actually going to add 4 bits that are going to store the length of any given substring, and then we are going to keep on repeating the same process, and we are going to create the encoded string. So let me quickly show you what I am suggesting. First of all, we would have an encoded string where first 4 character is actually going to store the information that what is the next length of substring that is coming that we are going to iterate over. So in this case, this is actually length 3. So if we add it in binary, it's represent as 0 1 1. So we are actually going to have 0 0 1 1 to be the length, and then we are going to store these 3 characters as A B C. Okay, now we are done with that. Again, now this ends the first substring, so now this is of length 2, so length 2 becomes 0 1 0. Now we are going to do the same thing, and then we are going to store this value AB, and now this is also of length 2, so again we will repeat the same process, and we are going to store the value of x and y, and this is the encoded string. What we have done basically is we have actually created block of 4 bits that keeps the information that okay, in the next subsequent value these are the 3 characters that you will have to iterate over, and that is how we are going to decode it. So let's see the decoded string in action. In the decoded string, first of all we are going to iterate over this given encoded string. Now we iterate over these 4 characters, and we find that okay, value is actually 3, which means that next 3 characters are the characters of one of the substrings that we will have to separate. So we will iterate over these 3 and put it in a substring, and we will get a substring like ABC. Again we will iterate over these 4 characters, and we realize that the value is actually 2. So because 2, we will have to iterate over these 2 elements, and we would get the value AB. Now again we would iterate over this next 4 bits, and we find that value is actually 2 again. So we will iterate over 2 more characters, and we will get the value XY, and then we would have a decoded string. So this is also another way to store all the values. Now this solution also works as expected, but I don't think that anyone is able to come up with this in the interview. So I just showed you this approach just for the explanation purposes, but actually I'm going to, in the coding, I'm going to show you the first approach that I solved earlier. So first of all, we are going to do the encode function. So let's take care of some edge cases first. If that is not the case, we are actually going to take a random variable that is not part of this original given string. So we are given the condition that there could be 256 characters inside the ASCII character for this given string I. So what we are going to do is we are going to take the 257th character as the character that is a separator between any 2 strings. So first of all, let's just create a string called a separate, and we are going to assign the character 257 to it. Now we will start building our string. Now we will iterate over this given list of strings. So first of all, we are going to append the value of whatever the string we are iterating over, and the moment this string ends, we are going to add the separate character. Once this loop ends, basically we should have done with encoding our string. Now all we have to do is just delete the last character because that would be an additional room. And once that is done, all we have to do is just simply return this new string builder we have created. So now we are done with encoding our string. Let's decode our string. If this given string s is actually of size whatever the located at 258, which means we are dealing with an empty string list. So in that case, we will simply return a new array list and we should be done. If that is not the case, which means that we have a separated string, so let's just assign a new character. All we have to do is just return an array list where we are going to separate based on this given separate character. And that's it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our solution is actually pretty fast compared to a lot of other solutions. It's not most optimal because I did not choose the approach 2. And let me know if you want to see the code for approach 2 as well. Thank you. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do palindromic substrings lead code problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Twitter, Google, Microsoft, Uber, Goldman Sachs, Apple, Bloomberg and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given a string s and we need to return the number of palindromic substrings that exist inside this given string s. Lucky for us, we are given the definition that what a palindrome is. Basically a palindrome is a string that reads the same from backwards and frontwards. So suppose we are given a string like this GG. If we read it from the backwards or frontwards, in both the cases the answer remains the same. Also one more example, ABA. This is also an example of palindrome because in either case we read it, the answer remains the same. Now a quick question for you guys, that whether this character B, is this an example of a palindrome or not? And the answer is yes, this is also a palindrome. Why? Because if we read it from the left and also read it from the right, we get the same result. But if we are given a string that looks like this AB, this is not a palindrome because if we read it from the left and from the right, the answer is not the same. So these are some of the examples of a palindrome. We are also given the definition of a substring, but I don't think that it is necessary to define. It is actually pretty trivial. Now let's try to understand this problem with an example. Suppose we are given a string S that looks like the CABA. Now in this case, we need to find that what are the number of palindromic substrings that exist. So we can clearly see that we have a palindromic substring that are these four characters are actually palindrome in itself, because as I mentioned earlier over here, that even a single character is also a palindrome in itself. So we already have four palindromic substrings so far. But if we notice over here, we also have one more palindrome, that is this ABA, and that is also a palindromic substrings, which means that in this case we need to return 5 as our answer, that we can actually make 5 palindromic substrings for this given string S, and this is what we need to return. So let's see that what would be the different approaches to solve this problem. Suppose this is the S we are given and we need to find that what would be the brute force solution for this problem. Well, we have to understand that we need to find all the existing palindromic substrings that are present inside this given string S, which means we need to find the substrings. So what we can do is we will make all the possible substrings that we can make from this given S, and then we will check that whether that substring is a palindrome or not, and simply we will get our desired answer. So if we see that in action, for this particular string, we can actually make substrings that looks like these. So these are all the substrings that we can make from this given string S. Now all we have to do is check that whether any given string is a palindrome or not, and in this case we will find that these 4 strings are palindromes, and also this string is a palindrome. All the other strings are not palindromes, and then in the end we can return 5 as the answer for this problem, and that would be a valid answer for this problem. But what is the issue with the brute force approach? Well, the issue with the brute force approach is that the time complexity in this case is actually going to be big O of n cube. Why n cube? Because it takes n square time just to make these substrings, and then it takes n time to check whether a substring is a palindrome or not. So cumulatively this is a very bad time complexity, and we will have to find a better approach. So before we move for the optimal solution, first of all we will have to build some intuition behind it, that how to identify a palindrome. Well, in the palindrome there could be two possibilities. The palindrome could be of odd length or it could be of even length. First let's see that what would be the scenario in the odd length. So suppose we are given this character O. This is a palindrome in itself. We have already identified that, because if we read it from left or right, we get the same result, right? Now if I decide to add 2 more characters XO, XX at the edges, this still remains the palindrome, which means that because both of these x's were same, and this middle value was a palindrome in itself, this whole thing actually became a palindrome. Again, if I take it even further, if I add 2 more characters BB, again this whole thing still remains a palindrome. And if I keep on adding same values, as long as they are same, this will always remain the palindrome. But the moment I add a value that likes A and B, now this whole thing is not a palindrome because these two values are different. But this portion is still a palindrome, and also the smaller portion still remains the palindrome, which means we can define that the palindromes are like an onion, where the middle value remains the same, and because of the middle values, all the other subsequent values where the values are actually same, the palindromic property is sustained. Why I'm giving so much explanation for that is you will see it in the optimal solution. And in the odd cases, we only have one value as the middle character, but inside the even character, suppose we are given a value like BB. So this is a palindrome in itself, and both values are same. Because both values are same, this is an even length and this is an even length palindrome. Now again I decide to add two more characters XX. Because they both are same, this still remains the palindrome. Again I add value AA, this is also a palindrome. But the moment I add a value that is different like X and Y, now this whole thing is not a palindrome, but this middle portion still remains a palindrome. So that is the important property, that in case of odd length, we have a middle character of the palindrome that is a single character, and all the other characters has the same value. In case of the even length palindrome, we have two characters that are same. So that is important, two characters, they are both same, and then all the other characters, they are also same as well, and a smaller palindrome is forming a larger palindrome. And let's see that how can we use this property to find an optimal solution. So suppose this is the example we are given and we need to find the optimal solution for that. The idea is that at any given character, we are actually going to see that whether could this be a middle of any palindrome, and if it is the middle of the palindrome, we are going to keep on expanding our palindromic search and we are going to keep adding our answer result. First of all, let's see for this character number C, that can this C be part of any middle of the palindromic substring or not. Well, we already know that this C is a substring in itself, because if we read it from left or right, we get the same result. And we are also going to have a variable called answer, so initial value was 0. Now because this C, because the C is a palindrome in itself, we are going to add the value to our answer as well. Now we are going to see that whether the C is a middle of the palindrome or not, which is not. Why? Because if we see the left of the string and right of the C, this is actually a null value and this is A, which means both are not same. So because both are not same, this is not part of any middle of the substring. Now we are going to have this value A. Again we are going to repeat the same process. Well, A is a palindrome in itself, so we are going to add the value to our answer first of all, so this becomes 2. Now again we are going to check that whether this A is the middle of any palindrome or not. We also have to check for both the cases that could this be of odd length palindrome or an even length palindrome. So for odd length palindrome, like the both left and right value would be same, and for even length palindrome, the value would be same with that itself. So first of all, we are going to check with this A. So the left value is C and right value is actually B. So both are not same. Also, they are not same of this A and B, which means this is not an odd length palindrome and even length palindrome. So we are good to go. Now we will move on to the next value B. Now this next value B is a palindrome in itself. So we will update the value inside our answer to 3. After doing that, we are going to check that could this be the middle of any palindrome or not. So we will check the left and right value. Left value is A and right value is also A. So because these two are same, we can define that this B is actually part of the middle of the palindrome, which is of odd length, and we are going to keep on expanding our palindrome. So now this B, A, B, so sorry, now this ABA is also a palindrome, so we will update our answer immediately. So answer becomes 4 now. Now again we will keep on expanding our palindrome. So if we do a left and right over here, the left value is C and right value is actually null. So these two are not same. Because these two are not same, we no longer have a palindrome, so we will break out of the loop. Now again we still have one more character left to check. So again we will check for this value number A. So A is a palindrome in itself. We will put the answer as 5. Then again we will check that whether this A is that a middle of any palindromic string or not. So we check left and right value. Left value is B and right value is actually null, which means these two are not same and they're not same of this A as well. So immediately we will break out of the loop and we can return, and the next value over here is actually null, which means we don't have anything. We have reached to the end of the string. So this is the answer we need to return in this case, that 5 would be the answer, and we will return that. Let's see one more example S, where we will find the even length palindrome. So over here again we are going to repeat the same process. So first of all, we'll take this character number C. Can this C be part of any middle of the substring or not? So this is not part of any middle of the substring, and we will have an answer variable. So first of all, we'll initialize it to 1 because C is a substring in itself. Now we'll move on to the next value A. So where A, if we check the left and right pointer, left is C and right is B. So these two are not same. So immediately A is also not the middle of any new palindrome, but it is a palindrome in itself. So again we will update the value to 2. Now again we are at this position number B. Now at this position number B, if we compare left and right values, so left value is A and right value is B. So these two are not same, but these two are actually same. So we can define this BB to be a middle of a palindrome, and this is the property we are going to use, right? And by the way, for this B, first of all we'll update the value to 3, and now we have this BB, that is a middle of the palindrome. Now immediately we will check the left and right value. So left value is A, right value is also A. Again, these two are same, so this is also palindrome, so we'll update our answer again. So this becomes 4. Now again we will check the left and right value over here. So left value is C and right value is actually null. So in this case these two are not same. Because these two are not same, we will break out of the loop and we will say that okay, so far we have found something decent. So right now again we are at this position number B. Now remember that this becomes a little bit tricky, that it becomes easy for us to, if we check over here, this left value is actually B and right value is A. So again these two are same, but we should not fall for this trap because we have already concluded this BB to be a middle of the palindrome. So we will not consider this one, and this is also not a palindrome, which means that the answer we will only update by 1, and that this value by itself is a palindrome. And at the end we will check for this value number A, and A is a palindrome in itself, so we'll update the value to be 6. But in the left and right there is nothing, so we won't do anything with that, and in the end we will return this answer 6 to be the final answer. And this is the solution we are going to use to find all the palindromic substrings inside any given string S. This is the final optimal solution. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n square. Why n square? Because it takes us n time to iterate over all the values, and for any single value we might have to iterate over all the remaining values, so that takes n square time. But this is still a big improvement compared to our brute force approach, which had the n cube. If we see the space complexity, in this case the space complexity is actually going to be big O of n, because at any given point we might have to store all the values of n. First of all, we are going to initialize a variable called answer, and we are going to assign the value as 0. Now we are going to create a for loop and iterate over the given input. Now we have two possibilities. Any single character inside this given string S could be the middle value of any odd length palindrome or an even length palindrome. So we are actually going to make two calls to our check palindrome method, where we are going to return a value that whether this given string is a palindrome or not, and we are going to add that value to our answer variable. And inside this method we are going to pass the value of our string S, and we are also going to pass the character position of the middle variable. So the odd length palindrome would have the same middle value, so we will pass on that. And for even length we are going to pass two values. So over here we will pass I, and we will also pass I plus 1 to be the middle characters. Basically after we get out of this loop, we should have our answer ready, so we can simply return that. Now let's create this check palindrome method, and we will initialize a variable called count to count the number of palindromes we encounter. Now we are going to run a while loop, that while the left and right pointer are in bounds and not out of bounds, and while their character positions are same, so which means they satisfy to be the palindrome. If that is the case, we will keep on updating their values, and we will keep on adding our count variable, and in the end we will return the count variable. So let me quickly type that. So this condition defines that whether this given string is a valid palindrome or not. If that is the case, we will decrement the value of our left pointer, we will increment the value of our right pointer, and we will increment the value of our count variable. And once that is done, once we get out of this loop, we simply need to return the count variable, and that's it. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently, and I would be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest palindromic substring lead code problem. And if we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Google, Adobe, Apple, Bloomberg, Goldman Sachs, TikTok, Uber, ByteDance, LinkedIn, Tesla, and eBay. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a lead code medium problem and also one of the very well liked problems on lead code. Basically, we are given a string s and we need to return the longest palindromic substring that is present inside this original given string s. So in order to understand this problem, first of all, we'll have to identify that what is a palindromic string. And a palindromic string is basically, as the name suggests, any string that forms a palindrome. And we know that palindrome is any string where if you read it from left to right or right to left, the number of sequences is same. So in this case, ABA is actually an example of a palindromic string. Also ABBA is also an example of palindromic string, because in either of these two cases, whatever side you decide to move along, the number of character occurrences remains the same. So that's why they are palindrome. And now our aim is to find the longest palindromic substring inside this given original string s. This is not a very good example to understand, so let me create a custom example. In this case, we need to find that what is the longest palindromic substring. So if we see the string s by itself, it's actually not a palindrome. But if we see these three values a, b, a, and we get rid of this b and d, we can actually create a palindrome, which means in this case, we can return the answer as a, b, a to be longest palindromic substring that is present inside this given string s, and this is exactly what we need to return. So now let's see that what would be the different approaches to solve this problem. In order to understand the brute force way, we will have to identify that what is the thing we need. We need the longest palindromic substring that is present inside this original given string s. So the aim is that we need to find a substring. So why don't we just use the brute force method and we find every single possible substring that we can make out of this given example s. So we can make bunch of different substrings. Let me just draw some substrings over here. So these are some of the substrings that we are able to generate from this original given string s. Now our aim is to find that what is the palindromic substring. If the substring is palindromic, we will find its length and then we will try to find the longest palindromic substring in that way. So we can clearly see that in this case, this ABA is going to be the answer for this longest palindromic substring, and eventually we would be able to find the solution using the brute force method. But what is the issue with this? Like, issue is actually pretty evident that even for this 4-character string, we actually had to create bunch of different substrings, and out of all of those substrings, we will have to find some effort and resources to find that what is the longest palindromic substring. So that is just waste of time and energy. If we see the time complexity, in this case, the time complexity is actually going to be big O of n cube. Why m cube? Because it takes n square time just to create these substrings, and after doing that, we will also have to identify that whether those given strings are actually palindromic substrings or not, and which is the longest amongst all of them. So that also takes n time. So that's why the overall we can write it as big O of n cube time complexity. So let's see that what would be the better approach to solve this problem. Well, before we come to the optimal solution, first let's build some intuition behind achieving that optimal solution. The idea is that we need to find the longest palindromic substring. Now there are two possibilities. We could have an odd number of string that is a palindrome, or we could have an even number of string that is actually a palindrome. Now in each cases, the middle value is actually providing some interesting results, and the thing is that in both the cases, the palindromes are actually built around these middle values. How? Let me quickly show it to you. Well, if we just take this madam for an example, over here we can actually conclude this D to be a substring in its own, and because this is a single character substring, we can actually conclude this to be a palindrome as well, because if we read from this left direction or right direction, in each cases we are going to get the same result. Now if we add these two A's to this D, we will also get the substring that looks like this A, D, A. Now in each cases, this D remains common, but the left value and the right value, because they both are same, we can conclude this string to be a palindrome as well. Now again, if we repeat the same process and we add this M and M, again because they both are same and we are adding at the corners, so if we add them, we will get a value that looks like this. Now this D originally was a palindrome. After adding this AA, it remained palindrome because both character had the same value. And again after adding this MM, again the whole thing remained the palindrome because they both had the same value. Now in this case, if I extend and if I add a value that looks like X and Y over here, so this X and Y is actually not same. So this whole thing will not be a palindrome, but this middle portion will actually be a palindrome. And in this case, because we had odd number of characters that are forming a character, we actually have just one value that we can consider as middle value, and all the other values from this middle value are actually just a bunch of set of characters who both have same values. Let's take an example for this even number case. Now in this case, actually we have two middle values, and the two middle values are BB. Now if we were to consider this BB, this is actually a palindrome in itself, because again by definition, even if we go from left or right, in each cases we are reading the same value. Now again, this A, both are same value, and they are actually same value that corners our original given middle values. So if we form a value that looks like this BB was already a palindrome, and the two values we added, they are also same. So because they are same, this whole thing actually becomes a palindrome. And again, just like this case, if we add an X and Y over here, this whole thing will not be a palindrome, only this ABBA would remain palindrome. So now after knowing this solution, actually it becomes really easy for us to identify that what would be the optimal solution. Suppose this is the example that we are given, and we are trying to find the optimal solution for that. So what we are going to do is we are actually going to expand on the corners, and we are trying to see that whether the left and right value of any middle value, if they are actually same or not. If they are same, we can consider the whole part to be part of any palindrome. If they are not same, then we will move on to the next value and start doing the same process. Now there could be two possibilities. We could have an odd length palindrome where we will only have one middle value, or we could have an even length palindrome where we will actually have two middle values. So in each cases we will have to take care of them. So I'll be showing you the odd example first, and then I'll show you the even example. And basically it's slightly different idea, and I'll just show you when we go there. So first of all, we are going to take this value X. Now we are going to expand upon the corners. So we are going to see that whether this X could be the middle of a longest palindromic substring. If that is the case, then we will expand upon this X. So we will try to see its left value and right value. The left value is actually null and right value is actually M. Now this left and right, they are not same, and also this middle value is actually not same with this right value, and it's also not same with this left value, which means in each cases this X is actually not part of the middle of longest palindromic substring. So we will get rid of it, and we will move on to the next value. Now we are at this value number M. Again we try to see the what is the left and right value. Left is actually X, right is actually A. Again they both are not same, and none of them are same with this M. So which means that now we will move on to the next value. Next value is actually A. Again the left value is M, right value is D, nothing is same. So we will move on to the next value because this is also not a part of the palindrome. Now we are at this position number D. Now if we take the left and right value, the left value is actually A and the right value is also actually A. So because this left and right value is same, this D could be a middle of any palindrome. We don't know if it is the longest palindromic substring or not. Now the longest palindromic substring that we have found so far is actually of length 1. Why length 1? Because any character in itself is also a palindrome, remember that. So that's why now we have this new substring that looks like this ABA. This is also a palindrome, and we will try to see that whether it is longer than whatever the existing palindrome we have, which is true that this ABA is actually longer. So we will have to update the value of this AB over here, saying that this is the longest palindrome we have found so far. We will keep on expanding on its corner. So far the values we have is ABA. Again we will move on the left and right pointer. So this is M and this is also M. So because they both are same, again we can consider this to be a palindrome. And the previous longest palindromic substring we had was ABA, but this is actually greater than that. So we'll update its value, and now the longest palindromic substring we have found so far is Madam, MADAM. Now again we will go and repeat the same process. Repeat the same process. Over here we will have the value Y, and over here we will have the value X. So these two are not same. So because these two are not same, now we are no longer forming a palindrome. So we will have to get out of it. So we will just move on to the next value. And if we move on to the next value is actually A. So again this A, the left value is D and right value is M. So this is not a palindrome. We will go back to M. M is also not part of any middle of any palindrome, and this Y is also not part of any middle of the palindrome. So now we are done for our example so far. And in this case, whatever the answer we have found over here for the longest palindromic substring, which is MADAM, we will return this as our answer, and this solution would work as expected. Now this was the case of odd number of palindrome that is being the longest. Let's see the even number of palindrome. So in this case, again we are going to repeat the same process. First of all, we'll take this x, we take the left and right value. Again we don't find anything interesting, so we'll move on to the next value. Now next value is a. Again we check left and again we check right. We don't find anything, right? So we'll move on to the next value. Now again we are at this position number b. Now we are at this position number b. If we check the left value, we find a, but if we check the right value, we actually find another b. So because these two are same, actually the combination of these two b's could be the middle of the longest palindromic substring, and that is going to be true in this case. So we are going to expand on a little bit differently now. Now we are going to have this bb as the middle of the longest palindromic substring we have found so far, and we will repeat the same process. So we will try to find that what are the left and right values. So left value is a and right value is also a. So again this is a b b a, because these two are same, and this middle portion we are just consider it to be the middle. So this is also forming a palindrome, and the longest palindromic substring we had so far was only of length 1, and then when we found this bb, it become of length 2, and now we have this ABBA, so this is of length 4. So because this is of length 4, we will have to update the longest palindromic substring we have found so far to be ABBA. Now again we will repeat the same process. So if we again go left and right, this is actually x and this is y. So now these two are not same. Because these two are not same, so now we will just get out of it. We will again check with this a and y, we don't find any palindrome, and we would be done with this one. So in this case we would return this ABBA as part of our answer, and that would be the final solution. So the time complexity in this case is actually going to be big O of n square. Now why n square? Because we will have to iterate over every single value to see that whether that is the middle of the longest palindromic substring or not. That takes n time, and if we will have to iterate over all the values on the left and right side to see that whether it's the longest palindromic substring or not, which means that in the worst case scenario we might have to iterate over n square times to find the answer. In terms of space complexity, we might have to keep track of big O of n characters at any given moment, where n is the number of characters present inside the string. Now this is actually a much bigger improvement compared to our brute force approach, which had the time complexity of big O of n cube actually. And now let's move on to the coding. First of all, we are going to check some edge cases. If that is not the case, we are going to run a for loop across the given string. For the any value we are iterating over, we don't know that whether it is the middle of the longest palindromic substring of an even length or of an odd length. So at any given time, we are actually going to have two variables that call a function, where we are going to check that whether the odd length or even length palindromic substring, can it be the middle of any palindrome. And so first I'll create two variables and we'll name it as len1 and len2, and we are going to call a function called check palindrome. Inside this function, we are going to provide the value of given string s, current position of I, and we are considering this to be an odd length, so that's why we are considering I to be the middle element. Also, we are going to create a variable called length2. So we are again going to call the check palindrome function. We are providing the value of string s, we are also providing the value of I, and we are also providing the value of I plus 1. Y plus 1, because remember that in the even length palindrome we actually have two middle entries, and that is how we are going to do it. And also we are going to have a variable called length, where we are going to keep track of the maximum length of palindrome we have found so far. Remember that amongst these len1 and len2, at any given moment, if we identify that there exists some valid palindrome and we have found the maximum value, we might have to update the value of the maximum variable. So we are going to check for that condition as well. For that, we actually need two pointers called left and right, and we are going to check that whether the given length we are getting, if that is greater than the left and right length we have already found so far. The thing is, we haven't declared these variables yet. So first of all, let me quickly declare these variables, and we are going to initialize their values as 0. We are going to update the value of the left pointer, and that will be decided based on the value of I. So we are going to do I minus whatever the value of current length we have found. We need to do it divide by 2. But thing is, we don't know that whether that length is odd or even. So we will subtract it by one value and then we will divide it by 2. So in any case, we will get the correct result for the left pointer. And for the right pointer, we are actually going to do I plus whatever the length we have found divided by 2. And this should give us left and right pointer to create the desired substring. And after we run out of the loop, we will simply return the substring. So now we are done with most of the logic in the main method. Now we'll just have to create this check palindrome method. So let's assign the value L and R for the ease of our use. Now we are going to run a while loop that until the point when we have a valid palindrome, we will keep on reducing the value of left and updating the value of right, and we will check that whether both values are same or not. We'll also take care of some edge cases. While the existing value is a valid palindrome, we will reduce the value of left pointer and we will update the value of right pointer. This while loop, we will return the whatever the length we have found so far. This should do it. Let's try to run this code. We will have to update the value of this right pointer by 1. Let's try to run the code again. Okay, seems like our solution is working. Let's submit the code. And our code works as expected. I would be posting this in the comments so you can check it out from there. Thank you.
So today we are actually going to solve very disliked and yet very popular lead code problem that has been asked at tons of different companies. So let's get started with the question. So the lead code problem we are going to solve is called text justification. Now you can see that this is a lead code hard problem and also a very controversial problem because it has more dislikes compared to likes. But the thing is, the only reason I'm solving this problem is because this has been asked at tons of different companies. So let's try to understand the problem statement. Basically, we are given an array of string called words and we are also given a number called max width. Now we need to format the text such that each line exactly has the max width character and is fully justified from left to right. Now there are some conditions that we need to follow in order to complete this exercise. So we should pack our words in the greedy approach, that is, pack as many words as you can in each line, and every single word or between two words we need to have at least one extra space when there is necessary. Also, we need to make sure that every single line exactly has the max width characters. Now we are also being told that whenever we are dealing with extra space between the words, they should be distributed as evenly as possible. But in case we realize that the number of spaces on a line does not divide evenly, in that case, we need to divide it between the words. And if there are empty slots on the left, we are going to be assigning more space on the characters on the left hand side. And the last condition is that for the last line of text, it should be left justified and there should not be any extra space inserted in between the words, and that's it. Now there are a bunch of different conditions, so let's try to understand this with some of the actual examples for this problem. Now we are given a string or string of words such as like this, where it says that this is an example of text justification, and we are being told that the maximum width in every single line we can have is 16 characters including the spaces, nothing more than that. So let's try to see that how does the solution for this problem should look like. Now the thing is, first let's see that how many characters this needs. This has 4 characters, then this has 2 characters, and then this also has 2 characters, and this example has 7 characters. So let's try to sum up, and we are trying to root for or find the greedy approach and trying to find as many words as possible within the boundary of 16 characters, plus we will have to consider at least one space between any single 2 words. Which means what I'm suggesting is that instead of treating this as like 4, 3 and 2 by its character size, we are actually going to add one more value to it. So let's assume that this is 5, then this is 3, this is also 3, and this is 8. Okay, so now let's try to do the sum and see how many characters can we fit in. So
for this one, maximum is 16. Now if we do sum of these three characters, then we get the value as 11, and then 11 plus 8, if we try to do, it goes 19. So 19 actually exceeds the value we are trying to find, which means we cannot include this character example. Okay, so after realizing that we are only going to be working with these first three words, so we have this first word, that is this, second word is, and third word is n. Okay, and we need to put this in one line such that the first word starts with t inside this given line. The last word has to be n because we don't want to have extra space after the last character for this particular line. Okay, so this has to be first word, this has to be last word, and we need to have in total 16 characters. Now the thing is, originally we saw that we were considering 5 and then 3 and then 3 in terms of characters, but now let's not consider these spaces, let's only consider the values of the characters, which means this is currently 4 characters long, this is 2 characters long, and this is also 2 characters long, which means in total we are working with 4 plus 2 plus 2, so total 8 characters we already have, which means we will have to add 8 spaces inside this first line that we are trying to create, which means we can put 4 spaces over here and we can put 4 spaces over here, because remember, there should not be any space after this character n. So in this case, we are going to build a string like this. So first is going to be this, then there are going to be 4 empty strings, then there is going to be character is, and then once again there are going to be 4 empty strings, and then we are going to have the character n. And this is going to be the first part of the answer, where we have created a string that contains exactly 16 characters, and we will still have to iterate over these remaining files. So let's try to repeat the same process once again. So let me just write down this answers at some place. Now let's try to find the second line, and let me also clean this up a bit. Now let's repeat the same process for the remaining characters. So how many number of characters this example has? It has 7, but we also need to consider space. So there are going to be 8 characters. This off is going to have 3 characters. This text is going to have 5 characters, and this justification is going to have 14 characters. And since this is the last character, we are not adding an extra space. And remember, there is also a dot or the full stop behind this line, that this is also considered as an extra character. So now let's try to do the sum. So if we do 8 plus 3, we get 11, 11 plus 5, we already get 16, which means we are by default at the 16 character mark, which means we cannot add this justification. So now let's try to deal with just these 3 words. And once again, we are dealing with example and then off and then text. But now we are not going to include spaces for now, because we will have to do that calculation. So now this is 7 characters, this is 2 characters, and this is 4 characters. So if we do the sum, we get the value 13, which means in total maximum width we need 16, which means we still have 3 extra spaces that we have to distribute. But the thing is, now this is not an even number of spaces, this is odd number of spaces. So we will have to divide, if we try to divide this by 2, we get like 1.5, but this is, we cannot divide 1.5 spaces. So we are going to divide 2 spaces between here, and then we are going to put 1 space here, because remember, there has to be at least 1 space. And also if we divide 3 by 2, we get like 2 options, 2 plus 1. So this is how we are going to distribute the spaces. So second answer is going to look like this, where it's going to be example, then we are going to have 2 spaces, then we are going to have off, then we are going to have 1 space, and then we are going to have text. So this is going to be the second line of the answer. So let's also mark this one as well. Okay, and now in the end, we are only dealing with just single word, or in the last line, and this word contains 14 characters. So we are going to have it justified completely on the left side of the portion. So the answer is going to be quite simple, that we are simply going to create an answer with justification, and whatever is the remaining value, or in order to make it 16, we are just going to add extra spaces, and this is going to be the answer. This is the total 3 strings that we will have to return, and this is the whole explanation of the problem. Now how to solve this problem? Well, actually I was also solving this problem along with explaining the problem, because we don't have to use any extra specific data structures, we don't have to use any extra characters, nothing like that. The simple logic is that we are simply going to run an algorithm. The purpose of this algorithm is that, let's assume that currently we are given the word string, and this are given like X number of words, okay, and each of them are in the different length. And let's assume that the width we are given is, for some example, 10. Now the logic is, first we are going to keep on iterating across every single word plus adding a space with each word until the point where we run out of the number 10. The moment we run out of the number 10, we will have to identify that what was the last character that would not be included, or the last character that we can only include. So let's assume that we can only include up to this point in just one line, which means for the next line we can consider all the remaining items. Now amongst these lines, we are going to forget about this one space for now. We are only going to be concerned with the size of the characters and see that what is the size of the characters we get. So let's assume that we get the size of the characters as 6. So if the size of the characters is 6 for each one of them, which means we will have to deal with 4 extra spaces. So now in this case, if we are dealing with even number of extra spaces, so we can simply put it between these two words or all the remaining portions between any number of words. And then we once again mark it as the part of the answer. So these 3 X are going to be part of the answer. So X, then 2 spaces, once again X, then 2 spaces, and then X. And then we are going to repeat the same process for this remaining item. So this is the whole solution. And in order to build the string, we need to use string builder class or some sort of that functionality. Every single language has the way in order to build the string. And this problem seems hard, but it is only hard because you will have to iterate over this logic, and there are a lot of different edge cases that we need to cover. What is the importance of this problem? Well, this is how actually the tools such as like Word and Google Doc, they actually do the text indentation. So that's why this problem has practical implication. There are no questions in that. But this specific problem does not deal with data structure as much as it deals with iterating over different strings and trying to find the reasons. And that's why this is such a highly unliked problem on LeetCode. But it is what it is. I just explained you that how to solve this problem. When we do see the coding solution, things will make much more sense. If we see time complexity, it's pretty simple that the time complexity is going to be big O of S, where S is the total number of characters that are present inside this word string. So sum of every single character. So first of all, we are going to initialize an array list called lines to store our answer. Then we are going to have an index value starting at 0, and we are going to have the condition that while index is less than the total words that dot length, we are going to first of all do the count of all the words, length of all the words, and then we are also going to keep track that what was the last value of that we have been able to identify, and we are going to put it as index plus 1. Then we are simply going to iterate over that while last is less than the current words dot length, we are simply going to keep on adding the value and keep on checking that if the adding the next word exceeds the max width or not. If it exceeds the max width, we simply break. If it does not exceed, we increase our counter, and we also increase the last pointer as well. Now, once we are at this stage, we are at a position where we have the values of the words that can be included in one single string or one single line for the answer. So we are going to initialize a string builder. Now for this string builder, we are going to append the words that are currently present at the index. And then we are simply going to check that if we are on the last line of the line and it has only just one word, we are going to do a left justify, which means we are going to put all the words that are currently present, and whatever the difference is, we are simply going to append that for our existing string builder. If that is not the case, then we are going to calculate that how many spaces do we need to do. So we are going to calculate the spaces based on the maximum width minus the count divided by the difference of the number of words. And then we are going to check that what should be the extra spaces divided amongst each entity. So for that, we are actually using the modulo function by diff. And then we are simply going to run a couple of for loops in order to generate the string that I just explained. And then in the end, we are going to add all the strings that we have been able to create inside our string builder and return lines that we have initiated originally the array list as the answer. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. Our code runs 100% faster than all the other solutions, which is pretty awesome. And once again, I will be posting the solution in the GitHub repository. Link is in the description. Thank you. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do Palindromic Substrings lead code problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Twitter, Google, Microsoft, Uber, Goldman Sachs, Apple, Bloomberg and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given a string s and we need to return the number of palindromic substrings that exist inside this given string s. Lucky for us, we are given the definition that what a palindrome is. Basically a palindrome is a string that reads the same from backwards and frontwards. So suppose we are given a string like this gg. If we read it from the backwards or frontwards, in both the cases the answer remains the same. Also one more example, ABA. This is also an example of palindrome because in either case we read it, the answer remains the same. Now a quick question for you guys, that whether this character B, is this an example of a palindrome or not? And the answer is yes, this is also a palindrome. Why? Because if we read it from the left and also read it from the right, we get the same result. But if we are given a string that looks like this AB, this is not a palindrome because if we read it from the left and from the right, the answer is not the same. So these are some of the examples of a palindrome. We are also given the definition of a substring, but I don't think that it is necessary to define. It is actually pretty trivial. Now let's try to understand this problem with an example. Suppose we are given a string S that looks like the CABA. Now in this case, we need to find that what are the number of palindromic substrings that exist. So we can clearly see that we have a palindromic substring that are these four characters are actually palindrome in itself, because as I mentioned earlier over here, that even a single character is also a palindrome in itself. So we already have four palindromic substrings so far. But if we notice over here, we also have one more palindrome, that is this ABA, and that is also a palindromic substrings, which means that in this case we need to return 5 as our answer, that we can actually make 5 palindromic substrings for this given string S, and this is what we need to return. So let's see that what would be the different approaches to solve this problem. Suppose this is the S we are given and we need to find that what would be the brute force solution for this problem. Well, we have to understand that we need to find all the existing palindromic substrings that are present inside this given string S, which means we need to find the substrings. So what we can do is we will make all the possible substrings that we can make from this given S, and then we will check that whether that substring is a palindrome or not, and simply we will get our desired answer. So if we see that in action, for this particular string, we can actually make substrings that looks like these. So these are all the substrings that we can make from this given string S. Now all we have to do is check that whether any given string is a palindrome or not, and in this case we will find that these four strings are palindromes, and also this string is a palindrome. All the other strings are not palindromes, and then in the end we can return 5 as the answer for this problem, and that would be a valid answer for this problem. But what is the issue with the brute force approach? Well, the issue with the brute force approach is that the time complexity in this case is actually going to be big O of n cube. Why n cube? Because it takes n square time just to make these substrings, and then it takes n time to check whether a substring is a palindrome or not. So cumulatively this is a very bad time complexity, and we will have to find a better approach. So before we move for the optimal solution, first of all we will have to build some intuition behind it, that how to identify a palindrome. Well, in the palindrome there could be two possibilities. The palindrome could be of odd length or it could be of even length. First let's see that what would be the scenario in the odd length. So suppose we are given this character O. This is a palindrome in itself. We have already identified that, because if we read it from left or right, we get the same result, right? Now if I decide to add two more characters XOXX at the edges, this still remains the palindrome, which means that because both of these x's were same, and this middle value was a palindrome in itself, this whole thing actually became a palindrome. Again, if I take it even further, if I add two more characters BB, again this whole thing still remains a palindrome. And if I keep on adding same values, as long as they are same, this will always remain the palindrome. But the moment I add a value that likes A and B, now this whole thing is not a palindrome because these two values are different. But this portion is still a palindrome, and also the smaller portion still remains the palindrome, which means we can define that the palindromes are like an onion, where the middle value remains the same, and because of the middle values, all the other subsequent values where the values are actually same, the palindromic property is sustained. Why I'm giving so much explanation for that is you will see it in the optimal solution. And in the odd cases, we only have one value as the middle character, but inside the even character, suppose we are given a value like BB. So this is a palindrome in itself, and both values are same. Because both values are same, this is an even length and this is an even length palindrome. Now again I decide to add two more characters XX. Because they both are same, this still remains the palindrome. Again I add value AA, this is also palindrome. But the moment I add a value that is different, like X and Y, now this whole thing is not a palindrome, but this middle portion still remains a palindrome. So that is the important property, that in case of odd length, we have a middle character of the palindrome that is a single character, and all the other characters has the same value. In case of the even length palindrome, we have two characters that are same. So that is important, two characters, they are both same, and then all the other characters, they are also same as well, and a smaller palindrome is forming a larger palindrome. And let's see that how can we use this property to find an optimal solution. So suppose this is the example we are given and we need to find the optimal solution for that. The idea is that at any given character, we are actually going to see that whether could this be a middle of any palindrome, and if it is the middle of the palindrome, we are going to keep on expanding our palindromic search and we are going to keep adding our answer result. First of all, let's see for this character number C, that can this C be part of any middle of the palindromic substring or not. Well, we already know that this C is a substring in itself, because if we read it from left or right, we get the same result. And we are also going to have a variable called answer, so initial value was 0. Now because this C, because the C is a palindrome in itself, we are going to add the value to our answer as well. Now we are going to see that whether the C is a middle of the palindrome or not, which is not. Why? Because if we see the left of the string and right of the C, this is actually a null value and this is A, which means both are not same. So because both are not same, this is not part of any middle of the substring. Now we are going to have this value A. Again we are going to repeat the same process. Well, A is a palindrome in itself, so we are going to add the value to our answer first of all, so this becomes 2. Now again we are going to check that whether this A is the middle of any palindrome or not. We also have to check for both the cases that could this be of odd length palindrome or an even length palindrome. So for odd length palindrome, like the both left and right value would be same, and for even length palindrome, the value would be same with that itself. So first of all, we are going to check with this A. So the left value is C and right value is actually B. So both are not same. Also, they are not same of this A and B, which means this is not an odd length palindrome and even length palindrome. So we are good to go. Now we will move on to the next value B. Now this next value B is a palindrome in itself. So we will update the value inside our answer to 3. After doing that, we are going to check that could this be the middle of any palindrome or not. So we will check the left and right value. Left value is A and right value is also A. So because these two are same, we can define that this B is actually part of the middle of the palindrome, which is of odd length, and we are going to keep on expanding our palindrome. So now this B, A, B, so sorry, now this ABA is also a palindrome, so we will update our answer immediately. So answer becomes 4 now. Now again we will keep on expanding our palindrome. So if we do a left and right over here, the left value is C and right value is actually null. So these two are not same. Because these two are not same, we no longer have a palindrome, so we will break out of the loop. Now again we still have one more character left to check. So again we will check for this value number A. So A is a palindrome in itself. We will put the answer as 5. Then again we will check that whether this A is that a middle of any palindromic string or not. So we check left and right value. Left value is B and right value is actually null, which means these two are not same and they're not same of this A as well. So immediately we will break out of the loop and we can return, and the next value over here is actually null, which means we don't have anything. We have reached to the end of the string. So this is the answer we need to return in this case, that the 5 would be the answer and we will return that. Let's see one more example S, where we will find the even length palindrome. So over here again we are going to repeat the same process. So first of all, we'll take this character number C. Can this C be part of any middle of the substring or not? So this is not part of any middle of the substring and we will have an answer variable. So first of all, we'll initialize it to 1 because C is a substring in itself. Now we'll move on to the next value A. So where A, if we check the left and right pointer, left is C and right is B. So these two are not same. So immediately A is also not the middle of any new palindrome, but it is a palindrome in itself. So again we will update the value to 2. Now again we are at this position number B. Now at this position number B, if we compare left and right values, so left value is A and right value is B. So these two are not same, but these two are actually same. So we can define this BB to be a middle of a palindrome, and this is the property we are going to use, right? And by the way, for this B, first of all we'll update the value to 3, and now we have this BB, that is a middle of the palindrome. Now immediately we will check the left and right values. So left value is A, right value is also A. Again these two are same, so this is also palindrome, so we'll update our answer again. So this becomes 4. Now again we will check the left and right value over here. So left value is C and right value is actually null. So in this case these two are not same. Because these two are not same, we will break out of the loop and we will say that okay, so far we have found something decent. So right now again we are at this position number B. Now remember that this becomes a little bit tricky, that it becomes easy for us to, if we check over here, this left value is actually B and right value is A. So again these two are same, but we should not fall for this trap because we have already concluded this BB to be a middle of the palindrome, so we will not consider this one. And this is also not a palindrome, which means that the answer we will only update by 1, and that this value by itself is a palindrome. And at the end we will check for this value number A, and A is a palindrome in itself, so we will update the value to be 6. But in the left and right there is nothing, so we won't do anything with that. And in the end we will return this answer 6 to be the final answer. And this is the solution we are going to use to find all the palindromic substrings inside any given string S. This is the final optimal solution. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n square. Why n square? Because it takes us n time to iterate over all the values, and for any single value we might have to iterate over all the remaining values, so that takes n square time. But this is still a big improvement compared to our brute force approach, which had the n cube. If we see the space complexity, in this case the space complexity is actually going to be big O of n, because at any given point we might have to store all the values of n. First of all, we are going to initialize a variable called answer, and we are going to assign the value as 0. Now we are going to create a for loop and iterate over the given input. Now we have two possibilities. Any single character inside this given string S could be the middle value of any odd length palindrome or an even length palindrome. So we are actually going to make two calls to our check palindrome method, where we are going to return a value that whether this given string is a palindrome or not, and we are going to add that value to our answer variable. And inside this method we are going to pass the value of our string S, and we are also going to pass the character position of the middle variable. So the odd length palindrome would have the same middle value, so we will pass on that. And for even length we are going to pass two values. So over here we will pass I, and we will also pass I plus 1 to be the middle characters. Basically after we get out of this loop, we should have our answer ready, so we can simply return that. Now let's create this check palindrome method, and we will initialize a variable called count to count the number of palindromes we encounter. Now we are going to run a while loop, that while the left and right pointer are in bounds and not out of bounds, and while their character positions are same, so which means they satisfy to be the palindrome. If that is the case, we will keep on updating their values, and we will keep on adding our count variable, and in the end we will return the count variable. So let me quickly type that. So this condition defines that whether this given string is a valid palindrome or not. If that is the case, we will decrement the value of our left pointer, we will increment the value of our right pointer, and we will increment the value of our count variable. And once that is done, once we get out of this loop, we simply need to return the count variable, and that's it. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently, and I would be posting this solution in the comments, so you can check it out from there. Thank you.
So in this section, we are going to learn about two most important coding patterns. This one is searching and sorting. They have been extremely popular in lots and lots of different type of questions because they are so versatile, and they work pretty much with all the different data structures, whether it's array, string, or queue or tree. No matter what, you are always trying to searching for the different elements on how they are presented, and you are also trying to sort the existing set of elements in order to find some meaningful information. And I'm pretty sure that you know what they are. So we are just directly going to dive deeper into the questions associated with searching and sorting. Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome lead code problem that is extremely popular, and you are guaranteed to encounter this question in one of your interviews. So without any delay, let's get started. So the lead code problem we are going to solve today is called binary search, and we can see that this is a lead code easy problem and also one of the most liked problems on lead code. Now the thing is, you are always going to be using binary search in your interviews, but this is never going to be the direct question, because this is a technique that you have to master. So let's understand that what the problem statement is asking us to solve. We are given an integer array nums which is sorted in ascending order, which is great, and we are also given a target value that we need to find that whether it's present inside the given array or not. If it is present, then we need to return the index position of the target. If it is not present, we need to return -1. And we are also being told that we must write this algorithm in big O of logarithmic and time complexity. So let's try to understand what is being asked us to solve. Suppose we are given an input array like this. We are given the target value to be 9. So in this case, we can see that 9 is currently present inside this given array, and it is located on index value number 4. So in this case, we need to return 4 as the answer because 9 is present. Now in the same problem, suppose we are given that 10. So 10 is currently not present inside the array. So then we need to return -1. So this is what the problem is asking us to solve. It is very simple to understand. So brute force approach is quite straightforward. Suppose we are given the values like this, and we are being told that we need to find value number 4 inside this given array. So all we need to do is we can simply start iterating over this given array one by one and keep on going until we find the value or we reach to the end of the array. So in this case, since we did find value number 4, we can return the index position of this value. And we can see that brute force approach works as expected. But the thing is, if we see time complexity for this brute force approach, this is simply going to be big O of n, and we need to do things smartly. And for that, we need to take care of the property that is currently given to us in this array, that this given array is actually sorted. So if we use the sorted portion property of this given array, we can actually solve this problem in logarithmic time. So let's quickly see the optimal solution. So we can see that 9 is currently present inside this array. Now how we are going to use the sorted property of this is by doing binary search. So what binary search means is that we are going to take this entire array as whole. We are going to find the middle pointer of this array, and using the middle pointer, we will compare that whether this middle pointer is smaller than our target array or is it greater than our target array. If this middle pointer is smaller than our target array, which means the target array has to reside on this portion of the given input array. So we can basically eliminate all of these three characters because they are no longer relevant. And if it is the other case, then in that case we can eliminate these three characters as well. So we will keep on doing that until we either reach the target value or we run out of the values to search for. And in this case, we are going to initialize our array with having a starting pointer and ending pointer. So currently starting and ending are going to live at the edges, and this is going to allow us to find the middle pointer. So in this case, we can see that the target value is 9. The middle pointer we are able to identify is located at value number 6. So we need to check that whether this value number 6, if that is greater than or less than. So we can see that 6 is less than our target value. So because 6 is less than our target value, we can say for certainty that the target value can never reside on the left hand side of our given value 6, which means we will have to migrate our start pointer once again back to 6 and repeat the same operation. So now our starting pointer is going to live over here, ending pointer is still going to live on the same place, and now we are trying to find the middle pointer. Okay, so we in just one single iteration we eliminated 3 characters, and this is the pure definition of logarithmic time complexity. So once again for this we are going to find the middle pointer, and middle pointer is going to be find at value number 11. So now the next middle pointer is value number 11. 11 is actually greater than target value, which means that the target value can never reside on the right side of the this 11. So we can eliminate this character, and now we only have these 3 values, 6, 9 and 11, and we are going to mark 11 as our ending pointer.
So now once again we repeat the same operation and try to find the middle value. The middle value is 9 in this case, and 9 is actually equal to target, which means the index location of this 9, I think it's 4. So this is what we can return in the answer. And you see that we were originally given 7 different elements, but within just 3 iteration we were able to find that where does the middle point, where does our target value is present inside the array or not. If it was not present, let's assume that maybe this was value number 10. So we realize that we find the middle pointer, and now this is also not the target value we are looking for. So now we are going to have starting pointer and ending pointer living next to each other. And once again, if we try to find the middle pointer, we would not be able to find it. So we could have concluded that now the target value is not present. So in both the ways, using binary search is extremely efficient. You are going to be seeing the binary search in a lot of different problems across your entire technical interview journey, and also across a lot of lead code problems. So you must master this technique. If we see time complexity, in this case, the time complexity is going to be big O of log n, because that's what we just did. And space complexity, well, we did not use any extra data structure or any extra space apart from storing a couple of variables. So this is going to be a constant space complexity as well. Now let's quickly see the coding solution for this one. Okay, so very first thing we are going to do is initialize couple of variables. First one is the left pointer and second one is the right pointer. Then we are going to run a loop that while left is less than or equal to right, we are first of all going to calculate the middle pointer, that is going to be the sum of left plus right divided by 2. And then we are going to check the conditions that if the given middle pointer is equal to the target value, then whatever the index position is, we can simply return that. If that is not the case, and we find out that the given middle pointer is smaller than the target, then we need to update our left pointer to come to the middle pointer. If that is not the case, then we need to update the right pointer, and that's it basically. In the end, we should have find the target in this loop if the value is present. If it is not present, we can simply return -1. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions. That is because our code actually runs in constant time, or the number of test cases are very small. So that's why. And once again, the solution of this code is actually pasted in our repository, GitHub repository. So let me quickly show you that where all of the solutions are present. You can see on this GitHub repository, we have over hundreds of different lead code solutions. These are the most popular, most asked and most important lead code questions. And if you are preparing for your technical interviews, for sure, this can be a great resource for every single one of you. So you can go ahead and check it out. Also, I want to show you one more extra resource. That is this sheet that I have created. So you can see that over here, I have a couple of lists. First list is 130 most popular and most liked technical interview questions of all time. Over here, all of these questions are separated based on topic. And I have also included that how many times these questions were asked at any particular company and what is their difficulty level. Is it easy, medium or hard? And for most of the questions, you can see that there are solutions available as well. So if you want, you can go and check it out. On top of it, Neetcode 150 is one of the most best resources for technical interview preparation. So I also started working on solving Neetcode 150 so I can get better at lead code, and also I can create videos that might help other people as well. So over here, once again, these are all the questions separated based on the topic and difficulty level. Majority of them are solved and the rest would be solved soon. So you can go and check it out. So both the links are in the description. I hope you find this resource helpful. Hello friends, I am a cloud solutions architect at Microsoft and I like making lead code videos. So today we are going to solve another very popular lead code video, which is find first and last position of elements in a sorted array. And if we see some of the popular companies where this question has been asked, there are companies like Facebook, Amazon, Microsoft, Bloomberg, Google, LinkedIn, Apple, Uber, Instacart, Twitter and TikTok. So that's why I am paying my utmost attention making this video. I hope you also find it informative. So this is a lead code medium problem and also very well like problem on lead code. Basically, we are given an integer array that is sorted in non-decreasing or ascending order, and we are also given a target value. Now, in this sorted array, we need to find out that what is the starting and ending position for this particular target value. If the target value is not present, we need to return -1 as the answer. We are also told one more condition, that this has to be running in big of log n time, which is like a logarithmic time. So definitely this is the big clue that we need to solve this using binary search tree. So over here, I have actually taken these two examples and enlarged them over here. So this is the input array we are given. We can clearly see that all the elements inside the input array are sorted in ascending order. We are also given the target value to be 8. Now in this case, we need to return the first and last position of 8 that is present inside this given input array. And we can clearly see that the first occurrence of 8 is here, where if we see the index value is 3, so that is going to be part of the answer. And the last position of value number 8 is at index number 4, that is also going to be part of the answer. And in this case, we need to return the first and last positions of this target value number 8 that is present inside this given array, which is going to be 3 and 4, and this is going to be the answer we need to return. Same way, if we are, suppose we are given the same input array and this time we are given the target value to be 6. Now 6 is not present inside this entire given array. So because 6 is not present, we are actually going to return -1 as the answer, and this is what we need to return in this case. So basically this is what the problem is asking us to do, and as the name suggests, that find first and last position of elements in a sorted array. So basically that is what we need to find. Now let's see that what are going to be the different approaches to solve this problem. The first approach that comes to our mind is a brute force approach. So in the brute force approach, suppose this is the input we are given and we are told that the target value we are trying to find, okay, let's not put 5, let's put 1. Okay, so suppose we have the target value 1 we need to find. Now in this case, we can clearly see that 1 starts at position number 1 and ends at position number 3, and in this case the answer is going to be 1 3. So because this is a brute force, we are going to apply the most simple logic, and most simple logic is we will start iterating from the beginning until the point where we reach the target value. So over here this is not the target value, so we skip to the next element. Now this is a target value that we are expecting. So because this is the target value, we are going to note its index position as the answer. So okay, this is the first value we find as the answer. Now we will keep on iterating to the next element until either we reach to the end of this array, because it could be possible that all the other values are the target value, or we reach to some value that is not 1. Definitely. So in this case, okay, we reach over here, this is also 1 and this is also 1. The moment we reach to this value, okay, this value is not 1. So because this value is not 1, which means that one value before that has to be the last occurrence of 1. So in this case, okay, index value for this is 4, so 4 minus 1 we will have to do 3. So in this case 3 is going to be the last occurrence of 1, and this is the answer we need to return. Like somehow we keep on iterating and we don't find the target value, so in that case we need to return -1 and the solution would also give us the correct answer. But the problem with this solution is going to be that if we see time complexity, the time complexity is actually going to be big O of n, and we are explicitly told that we need to solve this problem in logarithmic time in big O of log n. So that is not being satisfied in the brute force approach, so we will have to find a better way. Now the question comes that how we are going to use binary search and how we are going to apply that here. We know using the binary search, it becomes pretty easy for us that we actually have a starting value, we actually have an ending value, we try to find a middle value. Now depending on the middle value, we either remove all the elements on the right side or we remove all the elements on the left side, and we update our starting and ending position, keep on repeating this process until we find the middle value. Now in this case, the logic is not quite simple as just finding the target value. Why? Because it could be possible that there are multiple target values, and what we are trying to find is to try to find the first occurrence and also try to find the last occurrence. If we just apply the simple binary search tree over here, things won't work. Why? Let me quickly show it to you. So suppose in this case, okay, starting position is 0, right? So starting position is 0, ending position is currently 5. So ending position is 5. We set up 2 pointers. Now we try to find the mid value. So mid value in this case is going to be 0 plus 5 divided by 2. So 5 divided by 2, if we take the floor value, we get the value as 2. So 2 is the middle value, which is this in this case, right? Now if you see for this array, the target we were searching for is 1, and immediately we find the target to be 2, but that doesn't give us any meaningful value because this middle value is already a target, but it is of no use of us because this is neither the starting value neither the ending value. So you must be thinking, okay, there is one simple logic we can apply over here, and that simple logic is that the moment we find the middle value, we start on traversing on one direction, and eventually we would be able to find a place where the value by itself is going to be like the first occurrence. So in this case, what happens? Okay, this is the middle value we found. Now we will start iterating on the left side. So on the left side, we will find, okay, again this value is 1, so still we don't know whether this is the first occurrence or not. So again we are going to take one step on the left hand side, and again this is value 0. So the moment we find a different value than 1, we can clearly determine that the previous value was the first occurrence. So in this case, okay, we can mark this answer as 1, so that is like the first occurrence, and same we are going to repeat the same process from this middle value to the right hand side to find the last occurrence. So if we search right hand side, okay, this is also 1, so we don't know that this is the last occurrence or not, but the next we check, okay, this value is not 1, so definitely this was the last occurrence. So last occurrence in this case is going to be 3, so we mark 3 as the answer as well, and we get the answer, bingo. So this solution would work, and you would argue that, hey, in average case this works in like big O of log n time, right? But the thing is, we are not concerned with the average case. Why? Because say for an example, you take a scenario where we are given an input array that looks like this, and all the values are actually the target value. So suppose target value we are trying to find is 7, and all the values are 7. So what would happen in this case? Like we would have this starting value, we would have this ending value. Eventually we found a mid value. The mid value in this case is going to be 7. So now we keep on iterating on the left, again on the left, and we reach to the first position, and this is still 7. So we would identify that, hey, this 7 is actually the beginning point. Okay, so 0 has to be part of the answer. Again we keep on repeating on the right side and keep on doing the same process until we reach to the last element, which is still 7, which is still the target value. This is 5. Okay, so this is the answer we need to return. But if you see time complexity, in this case the time complexity would become big O of n. Why? Because we keep on iterating to the next element, and that is not what we want. We want a strict big O of log n time, logarithmic time. So what is the logic we are going to apply over here? So the logic we are going to apply is that definitely we are going to use the binary search, right? That's a given fact, but we will have to make some tweaks. Okay, now I'm going to show you a rough blueprint of the solution we are going to apply. So suppose this is the array we are given. Now what are the things we know? We know that this array is going to be sorted in ascending order, which means everything on the left hand side is guaranteed to be less than everything on the right hand side. I mean less than or equal to. We are also given some target element. So now we are going to first apply the binary search to find target element somewhere. So the logic we are going to use is that, okay, depending on the starting and ending value, we would be able to find some middle value. Now we will try to see that whether this middle value, if that is less than this target value, if that is the case, which means that the target lies somewhere over here. If that is not the case, and if we find, okay, that whether this middle value is actually greater than target value, if that is the case, then the target lies somewhere over here. If both are not cases, which means that the middle value by itself is equal to the target value. So that is great. But the thing is, our job doesn't end over here. We are actually trying to find the first occurrence of this target value and the last occurrence of this target value. So first we are going to be focusing on the finding the first occurrence of the target value. How we are going to do that? Okay, that if suppose for example this middle value, if that is equal to the target value, right? But the thing is, we are not sure whether it's the first occurrence or not. We can only define that this is the first occurrence if the value before this is not the target value, or this somehow we keep on doing like binary search, and we find that okay, the middle value that we were searching for was by itself the first value inside the array, and that was the target value. Either of these two conditions are true, then only we can say that that is the first occurrence. So what we are going to do is, okay, suppose say for simplicity we find okay this first value to be target value. Okay, so now we will try to see one value before that. We again find and now because we find this middle value to be target value and we are trying to find the first occurrence, we are guaranteed one thing, that the first occurrence has to be in between these values and not over here. So we can simply ignore these cases and we can update our end value to come over here and then repeat the same process. So now what we are going to do is we are going to bring our end value over here, again try to find the minimum value, the medium value, and depending on the value of the medium value we will be able to find that what is like the first occurrence. Same logic applying, we would be able to find the last value, and for the last value logic we are going to use is that if the middle value is equal to target value, then if that is at the position where the next value of that, if that is not the target value, then we can say that this was the last occurrence of the target value and we put it in the answer, or we somehow find the target value to be the last element by itself. In either of these two cases this goes in the answer as the last occurrence. So let's try to understand this with an example, and then it would make more things more clear. So again we are continuing with the same example we are given. Now let's mark starting and ending value. Currently the starting value is equal to 0, the ending value in this case is 5. So if we try to find the middle value is going to be 5 divided by 2. We are going to take the floor value, so which is going to be 2. So this is currently the middle pointer we have. Now if we compare the middle point, lucky in this case middle point by itself is the target value. So now because this is the target value, we are trying to find the first occurrence. So because we are trying to find the first occurrence, we will try to see one value before this target value. So one value before this target value is also 1, which means that amongst these places there exists the first occurrence of this target value 1. So because of that, now we are going to update our end pointer. So now our end pointer position becomes midpoint whatever we find -1. So now this becomes the new end pointer. Okay, so currently the end pointer position is 1. So if we do like 0 plus 1 divided by 2, we got 0.5. So basically mid pointer is going to be 0 because we are taking the floor value. So now this is the mid pointer. If we compare this mid pointer with the target value, this mid pointer is actually less than target value. So because this is less than target value, we will have to update our start pointer. So now start pointer, we are actually going to update one position to the right, and we are going to keep on repeating the loop until the point where we find like either the start value crosses end or either end value crosses start. So currently both are at the same position, that is acceptable. So currently the starting pointer is also 1, ending pointer is also 1. In this case middle pointer is going to be 1 definitely, and because this is going to be 1, okay, this value is actually the target value. Now we compare this with its previous value. The previous value is not target value. So because this previous value is not target value, we can say one thing for sure, and that is that this is the first occurrence of this target value. So first occurrence of the target value, we are going to mark the index number. So index in this case is going to be 1, and that we are going to store. Okay, now we are done half the work. Now we are trying to find the last occurrence. Now for the last occurrence, again we are going to repeat the same logic, and we are going to do everything from the beginning. So let me clean this up a bit. Now we are trying to find the last occurrence. Now for the last occurrence, okay, we find the middle value is equal to target value. We compare the next element to the middle value. This is also target value, which means that the last occurrence exists somewhere over here. So which means we will have to update our starting pointer. So when we update our starting pointer, we get the new values as, and also we can ignore all of these cases. So now, okay, this is our values. So in this case, if we try to find, okay, we find the middle value to be 3 is actually greater than our target value. So because of that, we will again have to shift our end pointer on the left hand side. So if we shift our end pointer on the left hand side, our end pointer is going to end up over here. So currently starting and ending value both are located at position number 3. So obviously middle value is also going to be located at position number 3. So now this is the middle pointer. Okay, this is exactly the target value. So that solves one part of the problem.
problem.
And now we will try to compare its very next element, and that value is not the target value, which means that this is the last occurrence of 1. So the value is 3, so 3 we are going to mark as the answer. So now we find, okay, f is equal to 1 and l is equal to 3, so we find both the values, and that is what we need to return as the answer. And this is the whole logic we are going to apply over here. If you see the time and space complexity, in this case the time complexity is actually going to be big O of log n, and it's pretty self-explanatory that in every single equation we are eliminating half of the values on one side to find the correct occurrence position. So this is a very good example of using binary search to solve the problem in a little bit different manner. Like the thing is, definitely underlying concept is a binary search, and everyone knows that, but still this is doing things a little bit differently. And I would be jumping to the code now.
Okay, so before we actually start implementing the search range method, first we'll have to define that we actually need to find like the first and last position of any given element, right? So we are actually going to create a helper method for that. And for this particular helper method, I have named it as find bound. And this helper method is actually going to return the integer value of whatever the bound we need to find. Like now the thing is, over here we need to find the first and last positions. So rather than having two separate methods, we are only going to have one method where as an input we are taking the nums array, we are also taking in the target, and we are also taking in a boolean character that is first. So this character would define that whether we are trying to search like the first occurrence of any particular target element or the last occurrence. So that's settled now. Now we are going to create some helper variables. So first we are going to create two pointers, start and end, and we are going to assign their values as 0. And we are also going to create a while loop, that while start is actually less than or equal to end. Now inside the loop, first of all, we are going to calculate the mid pointer. Now with this method, there could be two possibilities. It could be possible that we are trying to find like the first occurrence. So which means in that case, the value for this is first would be true. So first we will calculate for that scenario, and then we will make the calculations for the second scenario. So what could be the condition that we actually find the correct value? And the condition is that if the mid value, if that is equal to the starting value, so if that is the case, or we found out that the nums of mid minus 1 is not equal to target. If that is the case, we can also define this to be true and simply return the mid pointer as the first occurrence of the value. If that is not the case, basically we will have to shift our search. So every single time we are going to update our end pointer to go one position left of mid, so mid minus 1. Now that takes care of the scenario where we are trying to find the first element, right? Now for the last element, we will also have to do some calculations. So in order to find the last value, basically the condition is that if either the middle value is equal to the end character or end pointer, or the nums of mid plus 1 is not equal to target. Either of these conditions are true, we can simply return the mid. If that is not the case, this else condition is trying to find for the last case. So in that scenario, we are actually going to update the value of our start pointer. Now we have taken care of most of the things. Now we need to also make changes depending on the position of mid value. So if that is not equal to target. So if that is the case, basically we are again going to make some changes. So first we are going to have the condition that else if the nums of mid, if that is greater than target, which means that we need to update the end pointer. If that is not the case, we are simply going to update the start pointer. And somehow we get out of the loop and we don't have the answer yet, we can simply return minus 1. Now from our main method, we are actually going to call the helper method that we have created, and we need to find like the first and last bound. So first we are going to create the first element, and for that we are going to call this find bound method. We are also going to keep a condition that if say for example we get the answer as minus 1, we can simply return minus 1 as the answer. And if somehow we do not get -1 in the return, which means that first element exists, so last element also has to exist. So we are also going to create another parameter called last to find the last occurrence, and again we are going to call the same method, but this time we are going to keep this parameter as false, and that way it would be able to calculate the last value. And simply we need to return the new array and add these two entries of the first and last. I think that should have taken care of all the scenarios. Let's try to run this code. So over here, I actually forgot to enter one critical condition, that if the given mid value, if that is equal to the target value. So if nums of mid that is target, then only we need to proceed over here. Okay, now it makes sense. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And seems like our solution is working as expected. Our runtime is actually beats 100% because it's the runtime is 0 millisecond. And even in terms of space complexity, our calculation is pretty efficient. I think LeetCode changed their UI, so that's why we are seeing it differently. And I would be posting this solution in the comments, so you can check it out from there. Thank you. Hello friends. So today we are going to do an awesome interview question that has been asked in companies like Facebook, Microsoft, Amazon, Apple, LinkedIn, Google, and bunch of more. So without any delay, let's get started. So the LeetCode problem we are going to do today is called merge sorted array. And you can see that this is a very well like LeetCode problem and also a LeetCode easy problem. Now we are simply given two values of two arrays called nums1 and nums2, and we are being told that these are sorted in non-decreasing or increasing order, which means we already have two sorted array called nums1 and nums2. And now from the name we can judge that we want to create an array that contains values from all the values that are currently present in nums1 plus all the values that are currently present in nums2, and this array also needs to be sorted. That is the whole ask of this entire problem, nothing much. So first let's try to understand this with an example. Suppose we are given nums1 array that looks like 1, 3 and 5, okay, and we are given nums2 array that looks like 2, 4 and 6. So obviously we need to create a sorted array that is going to be combination of these two arrays, and we just need to make sure that this is also sorted. So answer is going to be 1, 2, 3, 4, 5, 6. This is going to be the sorted array that is combination of these two. But for this problem, just to make it like a little bit spicy, a little bit tweaky, they gave us like few weird combination. So what they have told us is that we do not need to create this whole new or brand new array. What we need to do is we need to combine these two values, but we need to put all of these values in just nums1 array. Now the first question comes to our mind is that, hey, this nums1 only contains 3 elements. How can we put 6 elements inside this nums1 array? If we have to do that, we will have to basically just expand the array and create a new array and do all sorts of migrate operations. But the thing is, what they have actually done is that in this kind of problem, instead of giving us the input like this 1, 2, 3, 1, 3, 5, they are also given us 3 zeros in the trailing end of 1 or nums1 array, and nums2 array is going to contain values like this. On top of it, they are also providing us 2 extra values. So first value is called m and second value is called n, and both these m and n represents is the number of values that are currently present inside this nums1 array. Now by looking at nums1 array, we can see that there are actually 6 values present, but for our case, we only need these 3 values. These 3 are just simple placeholders that are currently present inside our array. They actually don't serve any purpose. So for this nums1 array, this value number n would be value number 3, and for this nums2 array, this value number n would be value number 2. This would say that nums1, this would also be 3. So this would say that nums1 array contains 3 elements. This would say that nums2 array contains 3 elements, and if we see the total size of this nums1, it is able to store 6 values, which means this stored array would actually be stored in this nums1 instead of creating a separate array like this. And that's it. I know understanding this problem is actually more complicated than solving this problem. So let's try to see how we can solve this. And yes, we can exactly solve the way you are thinking, the way we would logically do, but we are just going to use pointers in this case to solve this problem. And we are also going to do a couple of things here and there in like different order for the ease of simplicity for our problem. So what we are going to do is, let's assume with the same one, let's say that we are given this nums1 array, and this contains three elements, that is 1, 3 and 5, and the rest elements are zeros. Okay, so it contains, let's say 3 zeros. Okay, and we are given this nums2 array, and this contains 3 elements, and these 3 elements are 2, 4 and 6. Okay, and we all know what the answer is going to be. But what we need to do is, at this particular position, the value needs to be the highest value that is currently present amongst both of these arrays, and the highest value can only be present at the end of this location or at the end of this location, because we are told that these are sorted values. And because these are sorted values, so these two are the maximum values present amongst each array. So the value that goes in the last element would be the maximum value amongst these two values. And then all we need to do is, whichever value we put over here, we need to take care. So let's assume that we decide that we need to put value number 6 in this case. Okay, so let's update value number 6 over here. And we can say that, okay, because we are putting 6 over here, now this 6 is under no consideration. So now we need to check for the second largest value. We need to check the second value in this array and the very last value in this array. Whichever is greater, we are going to put that. So we are going to put value number 5 here and get rid of 5. And same way, if we keep on repeating the same process, we can simply fill out our array and we can put all the values in nums1. Now the question would come to you that, hey, why are we starting from the back and why are we not starting from the beginning? And the only reason we are starting from the back is because we don't have to do a lot of overwrite operations, because we are being told that these 3 values are already 0. They are not going to be part of our conclusion, and we can simply update the values rather than thinking about changing the values and then storing the temporary value. Because imagine if we have to make changes over here, imagine that instead in this case, let's assume that this first value is value number 2 and this value is value number 1, and now we are trying to find the smallest value. In this case, we will have to put 1 over here, and then we will have to store this 2 somewhere else, and then we will have to repeat the same operation for these 2 values and so on and so forth. So in order to make sure that we don't fall into the scenario of making updates, we are simply doing that. And now let's see that what is going to be the actual way. I just explain you the method. The only thing we are going to do is we are going to have 3 pointers, and the first pointer is going to be the last value that is currently present for nums1. So for this, our example 1, 3, 5 and then 0, 0 and 0. Okay, so our first pointer is going to live at this point and we can just name it as I. Now for this second pointer, that is going to be our value of m and n. Okay, so let's say that these are the values we have. So this is where the m pointer is going to live, and this is where the n pointer is going to live, and this would be the same value that we can get from the values m and n. And now for the ith location, we need to check that whichever value is greater compared to m and n until these values reaches to the very first element. So this is going to be our loop condition. We first check, okay, so currently n is greater. Because n is greater, we are going to move value number 6 in this place, and we are going to migrate this pointer number n to come over here. Once again and we are also going to migrate value number I. So now I is currently present on this pointer. Once again, we are going to repeat the same same process. Now 5 is greater. So we are going to update the value of pointer m. We are going to add value number 5 over here, and we are going to again repeat the same process. So now this is our m and this is our n once again, and we also update the ith pointer to come at the one location on the side, on the left side. And if we keep on repeating the same process, eventually we would have our n1 that looks like 1, 2, 3, 4, 5 and 6, and this is going to be the answer. This is a very simple problem, so that's why the answer is also very simple. If we see time and space complexity, time complexity is going to be big O of
n, where n is the number of total values that are present in both n1 and n2 items. If we see space complexity, well, space complexity is going to be big O of 1, because apart from storing couple of pointers, we are not using any additional values. To solve this problem, the very first thing we are doing is initializing 3 pointers. Then we are running our while loop, that while pointer 2 does not reach to the very first index of the nums1 array, we are going to keep repeating the same process. So first we are going to check that whichever value is greater is going to be placed on the ith location, and whichever value that we picked out, we are going to reduce that pointer. At the same time, in either case, we are always going to decrease the pointer of ith location, and eventually we would have all the values sorted in the nums1 array. And this is the code. So let's try to run the code. Okay, seems like the solution is working. Let's submit this code. And our code runs 100% faster than all the other solutions, which is pretty good and pretty awesome. So I would be posting the solution in our GitHub repository, and the link is in the description, so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So in this video, we are not only going to solve a very popular LeetCode problem, we are also going to learn a brand new Dutch national flag algorithm. And this algorithm has actually been developed by Dijksters, our very own god of shortest path algorithm. So without any delay, let's get started. So the name of the problem is called sort colors, and you can see that this is a very popular LeetCode medium problem, and this problem has been asked in bunch of companies like Amazon, Google, Microsoft, all of them. So let's try to understand the problem statement. Basically, we are given an array nums with n objects, and each of the object has been marked as one separate color, red, white or blue, and we need to sort these in place, which means in big O of 1 space complexity, in such a manner that the same colors are adjacent to each other, and the order of the color has to be red, then white and then blue. Now we are being told that because we are given an integer array, each integer is represented by a color, and this is actually the flag of Dutch nation, Netherlands. Now let's try to understand this with some of the real life examples. So suppose we are given an integer array like this. Now we need to sort this array in such a manner that each number is next to each other, like its color type, and also we need to follow the sequence of 0, 1, 2 or red, white and blue color sequence. Okay, so first is going to be 0 because we only have 1 0, then we have 2 1s, so in the answer we are going to mark 2 1s and then 2 2s. So this is going to be the solution that we need to return. Now you must be thinking that, hey, this is a very simple problem. Why is this even a LeetCode problem? Because in this given array, if you just apply like sort function or a sort library that every single language has, like Java, Python, you name it, then it can generate this answer pretty easily in like big O of n log n time, and you don't have to do anything. But there are a couple of caveats to that. Number one, we are being told that we must solve this problem without using the library sort function. So that is number one. Number two is that the library sort function actually solves this problem in big O of n log n time. But I'm going to show you how to solve this problem in actually even faster in big O of n time using the Dutch national flag algorithm. Now first, if we want to see the brute force approach, or if we want to see like some more inefficient methods, there are all there. Like in the brute force, you just iterate one by one and find each values and then start sorting them. So brute force is going to yield in big O of n square time complexity. The better or more efficient approach is using the sorting function or merge sort or quick sort, that is going to yield big O of n log n time complexity. But now let's just see that what is going to be the optimal solution for this problem. So what we are going to do is, instead of taking advantage of any of the existing library functions, we are going to take the advantage of the fact that we only need to sort 3 distinct items, which means in either cases, the number of possibilities that, let's say that if this is the first section and this is the second section, the third section has to be only this much amount,
right? There is going to be a very clear distinct boundary. It can be anything. It can be like the first value is only just one value, the second value is only these 4 values, then also all the middle portion or all the remaining values are going to be value number 1. So we are going to take advantage of this fact. In order to achieve this fact, what are the information we need? Well, number 1 information we need is that where does 0 end? So because currently we are trying to sort 0, 1 and 2, 3 values, right? So we will know that where does 0 end. We will also know that where does 2 start, and all the portion in between has to be 1. And using this fact, we should be able to solve this problem in big O of n time. So let's try to see the example of what I'm suggesting, and then it would make things much more clear. So let me just clean this up a bit. Let's assume that currently we are given this array, and let's add some random values, right? So let's add values like 1, 2, 0, 0, 1 and 1. Okay, suppose these are the values we are currently given. Let me just add a couple of more values to make it more like longer, and let's just add like 2, 1 and 2. Okay, suppose these are the values currently we are given. Now what I'm suggesting is that we leverage 3 pointers. So first pointer is going to be called left pointer. This pointer is going to keep track that where does the initial zeros needs to be placed, or where do they, so if we encounter 0 at any moment, this is the position where the 0 has to be entered in the existing array. Next, we are going to keep track of the right pointer or a high pointer. So this is a low pointer. Now let's just mark this as high pointer. So next we have an H pointer, and this H pointer is going to take the index position where if we at any given time encounter value number 2, it has to go on that place. And then third, we are going to have a current pointer. So this current pointer is going to help us iterate over the given existing array. Now this is the logic. Now let's try to understand what I mean. So initial position would be that currently left pointer is located at the very first position, because imagine at any given moment we encounter a 0. That 0 has to be at the very first index location. So this value has to be 0 if there exists 0. If there does not exist 0, then that's fine. Same way, if there exists a 2, at least the 2 has to be here, or if it is not here, then there should not be any 2 in the entire array in the sorted position. So for the H, we are going to place at the end. And since for the current array, we are just taking its help to iterate over, we are going to have initial position for current array at the very first location. Now the logic is we will first check, okay, whether this value is 0 or 2. Okay, if currently this value is neither 0 nor 2. So we are simply going to move our current pointer one step forward. Moving current pointer one step forward, now currently this value is 2. Now because this value is 2, we will have to update into, or we will have to swap values with current H pointer. Okay, so I think this, let's just make this value something else. Let's just make this value 0. So because I didn't want it to have H value at pointer number 2. Okay, and now let's just, so we realize that this value is 2. Because this value is 2, we will have to swap it with the position of H. So current position of H is 0. So we are simply going to do a swap operation. So let's just swap these two values. Currently this value is 0 and this value is 2. And now once again, we will, because we know that this is the position where we already have a 2, which means next time if we encounter 2, 2 has to be placed one step before that. So we are going to update the value of our H pointer. And we are going to keep on repeating the same process. Now notice that we haven't updated the C position at this moment, because we did not know what value could be coming from this H side, and if the value was 0, we would have to iterate it over. So because in this case, this was the same case because this value was 0. So now we realize that current is located at the 0th position. So if we encounter 0 position, we will have to place it where current L stands and then update the value of L in the same manner. So now we are going to swap these two values. This value is 0, this value is 1. Now we know that this first value is guaranteed 0. So we are going to update the value of our lower pointer. And when we do that,
we are going to have encounter L over here. And now since we already processed this node, we can move forward to the next node, because we already know with C that this value was not 0. So the only position was that this could have been 1 or 2. If it is 1, then we just move forward. If it is 2, then we would have replaced it with the last value. Okay, so now let's just once again go to this position, and currently this is our C. Repeating the same process, we've identified that this value is 0. So now we will have to swap it with the current L value. So we are going to replace like that, and we are going to update the position of L, and we are also going to update the position of C. So now we have our C located at the 0th position. Once again, we are going to repeat the same process, and we are going to swap operations. So 0 and 1. Now L comes over here and C comes over here. So let's just update these. Okay, now this value is 1. So we don't care, we just move to the next value. This value is 1. Once again, we don't care, we just move on to the next value. And now our C is currently located at this position. So now this value is 2. Because we find a value that to be 2, we will have to replace it with the value of H. So we are going to do that replacement, and we are going to have our H value be located over here. And we still have our C value over here, because what if this value could have been 0, though it's not, but if it was 0, we would still have to process it. And once again, we are going to, in the next iteration see, okay, so this value is 1. Because this value is 1, now we are going to move to the next value. And the moment we identify that either the given current location and the location of H is equal to each other, then we can end the loop. Or we've identified that this L and H are like equal to each other, then also we can end the loop. And now if you see the final answer, you can see that this array is completely sorted. So first 3 values are 0, next 4 values are 1, and next 2 values are simply 2. And this is the sorted answer that we need to return. Now you see that how beautiful this solution looks. And if we see time and space complexity, in order to solve this problem in terms of time complexity, we are simply solving in big of n time, which is excellent. And in terms of space complexity, apart from storing few pointers, we are not using any extra space. So we are also solving this problem in big of 1 space complexity. This is so great, because typically whenever we see sorting, we always solve sorting using n log n time. But for distinctively purpose of sorting just 3 distinct variables, we are being gifted this by Dijkstra, this Dutch national flag algorithm. And this is how we can solve this one. Now let's try to implement this using the code. Okay, so here is the solution for our code. So first we are initializing 3 pointers. First pointer is low pointer, next pointer is high pointer, that is located at the very last of the given array. And then we have the current pointer that we are going to use to iterate over all the values. Now we have the condition that while current is less than or equal to high, we are going to keep on repeating the same process. First we are checking that if the given current position, the value element is 0. If the current value is 0, then we will have to swap it with whatever the location of this low pointer is. So we are going to have a helper method swap that is simply going to allow us to swap 2 values. So we are going to swap the current value with the position of low. Then we are going to increment low, and we are also going to increment current. If that is not the case, and for some given moment, if the current value is equal to 2, then we are going to swap number of current with the high value at the very end, and we are only going to reduce the value of high. We are not going to increase the value of current, because that number could be 0. So we will have to repeat and redo the same operation. And last, if both of these are not case, which means this given current value is value number 1, so we can simply update the value of the current pointer, and this is the whole solution. Now let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is pretty awesome. And in terms of memory usage, we are also much more efficient compared to a lot of other problems. So once again, I would be posting this solution in our GitHub repository, so you can check it out from there. Thank you.
Hello friends, I'm a cloud solutions architect at Microsoft and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting lead code problem called majority element. And if we see some of the popular companies who have already asked this question, there are companies like Amazon, Bloomberg, Adobe, Google, Apple, Microsoft, Uber, Facebook, ByteDance and Flipkart. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a lead code easy problem and also a very well-liked problem on lead code. Basically, we are given an integer array of the size n and we need to return the majority element. Now we are given the definition of what a majority element is, and basically any elements that appears more than half of the times in the given array, we can consider that to be a majority element, and we are guaranteed that the majority element always exists inside any given array. So this is the whole problem statement. If we see a couple of examples, in this case, the given array is of size 3 and the element 3 actually appeared twice, which means more than half of the time. So basically 3 is the answer we need to return. If we take a look at the second example, basically the element 2 appears 4 times and element 1 appear 3 times. So since 2 is appearing like more than half of the times, we are going to return 2 as the answer. And this is the whole problem statement. This is very simple problem to understand, and basically the answer is also going to be very simple. Suppose we are given an input n that looks like this one. We are going to use the same example. So if the given input is like 2 2 1 1 and 1 and also 2 and 2. So in this case the answer is quite simple. Whichever element is occurring more than half of the times or most of the times is going to be the answer. We already know that what is the size of this given n. In this case, the size of this given n is actually 7. Okay, so we already know that the size is 7, which means any element has to appear more than 7 divided by 2. So 7 divided by 2 is going to be 3.5. So if we use like the floor value, basically the element has to appear more than 3 times, which means any element that appears 4 or more times is going to be the answer. Now the logic is quite simple. We are simply going to, using this n, create a hash map. Now inside this hash map we are going to use two elements, two items. First item is the key and second item is the value. As the key, we are going to use the unique values that are present inside this given input. So if the value has not appeared, we will create a new entry inside the hash map. If the value has already appeared, we will just use that value, and as its subsequent value we are going to basically count the number of occurrences. So that is going to give us that how many times any particular number has appeared. If we just keep iterating for this particular example, first we will see value number 2 does not exist. So we will create a new entry over here called 2. And currently we have only received one occurrence of 2. Then again 2. So 2 already exists. And since it already exists, we are going to update the number of occurrences. So currently 2 has 2 occurrences. Now the value is 1. So 1 does not have any occurrence. So basically we are going to add one more entry 1 over here. And current occurrence is 1. Now at this particular position, currently 1 appears 2 times. So again we are going to have 1 appearing 2 times, and then eventually 1 would appear 3 times. So basically 1 is going to appear 3 times. Now we are done with all of these elements. Now currently we are at this particular position. So basically 2 is appearing again. So now 2 is going to appear 2 more times, which means eventually the hash map is only going to have 2 values, which these entries, and we can clearly see that 2 is the value that appears 4 times. So 2 has to be the majority element, and we are going to return 2 as the answer. And this is a very simple problem, so that is why this is an easy problem. And if we see time and space complexity in this case, basically the time complexity is actually going to be big O of n, and the space complexity is also going to be big O of n, because we will have to create this new additional hash map. So now let's move on to the coding. So today I'm running short on time, so basically I'm just going to explain the code rather than spend time entirely writing it. So in this code, basically we are using a separate helper method called countNums that takes in the any input integer array, and then we create a new hash map, and basically we return a hash map that contains the number of occurrences of any particular numbers input array. So what we are doing is, first of all, we are initializing a counts hash map. Now inside the counts hash map, we are iterating over the given input nums, and we are checking that if the if it contains the key, basically we create a new value and add its occurrence as 1. If the key already exists, we simply update the number of count, or like basically we update the number of occurrences inside the hash map, and then in the end we return the counts hash map that contains the values of all the unique values inside the nums array and also their occurrences. After that, from our main method, majority element method, basically we initialize a new hash map and we call our count nums method with the nums as the input. So this is going to populate our counts array. Once the count array has been populated, our aim is to find the value that contains the most occurrences. So basically we are simply going to create a new majority entry array, and we are going to run a for loop for the given input array, and we are going to check that which element contains the most entries, and whichever it is, we are simply going to add that, and in the end we are going to return that particular element. And that's it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently compared to other solutions, because for this particular solution there can be like at least 10 different ways you can solve this problem, and some ways are much more efficient. So you can, if you put some thought to it, you can also find the solution. Now as always, I'm going to post this in the comments so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome lead code problem. So without any delay, let's get started. So the lead code problem we are going to solve today is called search in a 2D matrix. Now we can see that this one is a lead code medium problem and also an extremely well-liked problem on lead code, also really popular amongst top tier IT companies. Basically, we are given an m cross n integer matrix and we are told that it contains two important properties. First property is that each row is sorted in non-decreasing order. And next thing is that the first integer of each row is greater than the last integer of previous row, which means even the columns are also going to be sorted in an increasing order. Now we are given an integer target and we need to return true if the target exists inside this given matrix and false if it is not present inside the matrix. Also, we are told to solve this problem in big O of logarithmic m cross n time complexity. So now let's try to understand this with an example. Suppose this is an m cross n matrix we are given where m is equal to 3 and n is equal to 4, and we are told that target value is 3. So now let's first quickly assess the properties. We can see that every single row is in sorted order, and we are also being told that the last element of any particular row is smaller than the next element inside this next row, and so that eventually makes the columns sorted as well. Okay, and we can see that in this case this 3 is clearly present inside this given m cross n matrix, so we need to return true. They're saying that the 3 is present, but if we are being asked the target to be like something like 37, then that is not present, so we need to return false. Okay, so let's try to quickly see that what are the different approaches we can take to solve this problem. For the brute force solution, we don't need to do anything. Since this is an m cross n matrix, all we can do is just simply iterate over the given matrix one by one in a normal sequence, which can be done using two loops, and then try to see if the target value is present or not. If the target value is present, return the true immediately. And if we don't find and we reach to the end of this given list or given matrix and we don't find the target value, then we need to return false. This brute force solution would work as expected, but the thing is the time complexity is going to be big O of m cross n, because we are iterating over all of these 12 characters that are present inside the matrix. So we need to speed things up. Number one thing I'm suggesting is that we know the target value we are trying to find is 3. We also know that the entire rows are for sure sorted. We also know that all of the columns are also sorted. So one approach we can take is that we compare the columns, and based on the column values, we check that under which row should this target value be present at.
So we can clearly see that when we compare the first element in this column versus the first element in this row versus the first element in this row, we can see that the target value 3 lies somewhere between column 1 and row 1 and row 2, which means if the target value is present, it has to be present inside this first row. So once we find that information, after that all we need to do is just simply do a binary search in this operation. So now we only have one row that we need to worry about. So now we can actually solve this problem using a simple binary search where all we have is a starting pointer and ending pointer. The target value we are given is 3. So we first try to find the middle pointer. Middle pointer in this case is going to be 5. So this is not the target value, and the target value is less than the middle pointer we find, which means target value has to reside somewhere over here. So once again we repeat the same operation. We update our end pointer, and then once again we do the binary search. We find the middle pointer, and then we simply return saying that yes, true, the given target value is present inside the given list. So let's try to see that what is going to be the time complexity in this case. So time complexity would be inside the given corresponding row, we will have to do and log n cross m work. So this solution would give us the desired result. But the thing is, we are doing an intermediary step in between to solve this problem. So let's try to see that do we have a more optimal solution than this one as well. And yes, we actually have a better optimal solution. The idea is we already know that every single rows are sorted. We also know that every single columns are sorted, which means the last value of any row is always going to be less than the first value of the subsequent row. So logically, instead of treating this as a 2D matrix, if we just try to understand this in a one-dimensional direction, we can actually see that this is a perfect example of completely sorted 1D array that is currently represented inside the 2D environment. And we can plot all of these 12 values inside this given graph. This is just a one-dimensional representation of this 2D array, and we can see that this is a fully sorted array. Now if we have to find the target value, let's say 3 in this case, the solution becomes quite obvious. All we need to do is just a normal binary search, and we should be able to find the result. But the thing is, we don't want to create an additional array. We want to do the binary search, treating as if this 2D array was 1D array in this one. So once again, we can also do that. For that, all we need to do is just we might have to play around with the starting and ending pointers. So initially our starting pointer is going to reside over here and our ending pointer is going to reside over here. We will need to find the middle pointers. So now if we have to find the mid pointer, the 16 is going to be the mid pointer. So compare 16 with our target value, and we can see that the target value is actually smaller than the mid pointer we find, which means we will have to update our end pointer to come one value before the mid pointer, because this is also not the target value. So once again, now we have our new starting pointer. Starting pointer is the same, and we have our new ending pointer. Once again, we are going to find the mid value. Mid value in this case would be value number 5. Once again, we can see that because this value number 5 is greater, so once again we are going to update our end pointer. So end pointer is going to be over here, start pointer is going to be over here. Once again we do the binary search, and we should be able to find the target value to be value number 3, and that's it. This is what we need to do, and this is the much better approach than brute force approach, and also a step improvement on our better approach that we saw. Time complexity, for sure it is going to be big O of log n m cross n, and we are not using any extra space, so space complexity is going to be constant space, which means this is a really good approach. And now let's quickly see the coding solution for this one. So first of all, we are going to define our m and n based on the given matrix value. We are also going to initialize two variables, left pointer and right pointer. Left pointer is going to be at the very first position inside the given matrix. Right pointer is going to be on the very last position of the given matrix. Then we are going to run our while loop. During the while loop, first thing we are going to do is to find our mid pointer. After finding the mid pointer, we will also have to point that mid value inside our given matrix, because remember the mid pointer is a single 1D value. Meanwhile, we are given the 2D matrix. So that we can do by doing the division of mid pointer with the value 9 and doing the modulo or with 9 or finding the remainder value. So this is going to give us the exact value of the what the mid pointer should be in a 2D array. And then we simply do our binary search, and based on that we update and manipulate the left pointer and right pointer values. And in the end, if we do find the target value, it should have been returned through here. If it is not present, then we can simply return false. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is pretty awesome. This is also an excellent use of space complexity as well. So once again, the solution is present in the GitHub repository that we have created, and the link is in the description. You should be able to find it from there. Today we are going to do find minimum in a rotated sorted array. And if we see some of the companies where I want to get a job who already asked this question, there are companies like Microsoft, Amazon, Uber, Facebook, Apple, Bloomberg, Google, and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we need to find the minimum inside a rotated sorted array. Now you will ask that what does a rotated sorted array means? We are actually given some definition of what a rotated sorted array is. If you want, you can iterate over this definition. The thing is, let me quickly show it to you by an example. Basically, we are originally given a sorted array. Now for this sorted array, if we take the rightmost element and put it on the leftmost position, and all the other subsequent elements we flip it one side on the right side, we can determine this to be rotated one time. So if I take this original sorted array and if I rotate one time, so one time rotated array is going to look like this. You can see that this 5 that was originally at the rightmost position has been flipped to the leftmost position, and all the other values we shifted them one position on the right. Now if I rotate this one more time, so eventually I would have rotated this array to 2 times. Basically the result I would get is going to look like this, there where the first two values are 4 and 5, and then we have 1, 2 and 3. Now over here, this 4 that was originally over here, that came to this place. Now we can rotate it like 3 times, 4 times, as many times as we want. Like we can only rotate it up until 5 times, because there are only 5 elements. Now basically in any rotated array, we need to find that what is the minimum value that is present in it. So if we try to understand this with an example, over here we are given some array where the original version of array was 1, 2, 3, 4, 5 that got rotated 3 times, and we were given this as the input. Now if we see the minimum value in this case is 1, so we need to return 1 as the answer. We are also given one key important detail that we have to find, that we must write an algorithm that runs in big O of log n time. So that is the key part. First, let's see that what is going to be the brute force approach to solve this problem. Well, the brute force approach that comes to our mind is that why don't we start iterating over the given array. We have a variable called min or answer or whatever you want to call it, and then we start iterating over all the subsequent elements one at a time, and whenever we find a lower value, basically we update that in the min variable. So eventually when we start iterating, when we would have completed iteration, we would find the value 1 to be the lowest value that we can find inside this array, and that we are going to return as the answer. This solution leads us to the correct answer. There are no issues with this one. But why this brute force solution does not work in your interview or anywhere else is because this solution actually happens in big O of n time, because we are iterating over all the n elements. And we were explicitly told that we need to solve this problem in big O of log n time. So that's why this brute force solution won't work. Now, whenever we see log n solution, immediate thing that comes to our mind is that we are going to use binary search, right? And that is true that we are going to use binary search in this case. But before we do that, let's make some logic clear. Well, the key part of the logic we have is that if we compare the left and right element for any given array, if the array is completely sorted, which is the case in over here, that the entire array has been completely sorted, there are no mismatching pairs, right? So because this array is completely sorted, if we compare the leftmost element and rightmost element, or any element with its left element, basically we would find that the value at the left element is always less than whatever value at the right element we have. Like if we compare these three variables, and if we compare the right variable to be over here, basically again in this case the right is 3 and left is 1, so we can conclude that this whole portion is sorted. If we have the right variable located at this position, basically we have the value of left to be 1 and right to be 5. Again left is less than 1, so we can conclude that this whole portion is actually sorted. So the lowest value that we can achieve in this whole portion between this left and right is going to be whatever value that is located at the leftmost position. Now whenever we compare the left value and right value and we determine that left is actually greater than right, if we find that left is actually greater than right, we can determine that the minimum value exists somewhere between left and right. We don't know that at what position minimum value exists, but the thing is we need to achieve to the direction where we can actually find left is less than right. Because remember, over here currently the value of left is 3 and value of right is 2. So in this case left is actually greater than 2. Whenever we have to find the minimum value, we will have to move in a direction where we will reach to a conclusion where left is less than right. And in order to achieve that, what we are going to do is we are going to compare the value of the left to the middle pointer that exists, and depending on the value of the middle pointer, we would determine that the minimum value, if does it exist on the left side of the middle pointer or on the right side of the middle pointer, and depending on that we will update our value of left pointer or right pointer. So let me show you with a broader example what I'm trying to say. So I have drawn a big example over here, and first let's assign our initial values of left and right. So we have the values of left and right set up for us. Now we know that we need to reach to a position where left is less than right. If that is the case, then we will have some interesting results, right? But currently if we see, the value of left is 2 and value of right is 1, so left is actually greater than 1. So now we will have to move in some direction. So now what we are going to do is we are going to find the mid value, and also remember we are going to have an answer variable that is going to store the lowest value we have been able to find so far. So currently the value of left is 2, value of right is 1, right? So we are not going to do anything in the answer yet. Now we are going to find the middle pointer. So the current middle pointer is going to be at position number 4. Why? Because left position is 0, right position is 8. So 0 plus 8 is equal to 8 divided by 2. That gives us the middle value, and middle value in this case is going to be the 4, right? So the value that is located at the 4th position is 6. Now we need to compare the values between left and mid. Left and mid, if we compare, left is 2 and mid is 6, so 2 is less than 6. Now remember, whenever we identify that the left value is less than whatever the value we compared, we can dictate that every value in between is actually greater than the value of the left, which means that no value amongst these values can be the answer or can be the minimum value, because remember, we already know that on the right hand side the value is actually less than left, and because of that we will have to update our migration on the right side. And also remember, whenever we compare the value of left value with the mid value, whatever the lower value is, we are going to store it. So currently the lowest value we have been able to find is 2, so we are going to store 2 as the answer, right? Now we are going to switch our left pointer to go on the right side of the mid. So now let me clean this up a bit. So now this is going to be our new left pointer, and this is going to be our new right pointer. Again, we are going to compare the value of left and right. So left is actually greater than right? So now we will have to find the mid pointer. Mid pointer in this case is going to be left plus right divided by 2. So the current value of left is 5, right is 8. So 13 divided by 2. If we put it floor value, we will get the value of 6. So 6 is going to be the middle pointer in this case. So now we have this 6 to be the middle pointer. Now we are going to compare left with the middle pointer, and now in this case left is actually less than middle pointer, which means that answer cannot lie between left and middle pointer, and again we will have to update the value of the left pointer. Also for this leftmost value, we will compare that whether we need to update the answer or not. So answer currently we had was 2 and this is 7, so we don't need to update the answer and we are good up until this point. Okay, now again we determine that this value is not the answer. Now our left pointer comes at this position, our right pointer comes at this position. Again we are going to compare the values of left and right. So currently left is actually less than right, and that is the ideal scenario, that we found that left is like actually less than right, which means that now left is at the correct position to be the lowest position that it can be before it iterates or it takes over right. And now because of this one, we are going to update, we are going to see that whether we need to update our answer or not. So current answer we had was 2, and because left was less than right, we are going to compare the left value with this answer value, and the left value is actually 0, so we are going to update the answer to be 0. And in this case, this is the correct answer that we are able to find, and we are going to return that. Let's try to understand the same thing with another example. So in this case, left is over here, right is over here. Currently left is actually greater than right, so because of that we will have to find the middle value. So middle value is going to be this one. So now if we see, currently the left is actually greater than middle value as well, which means we cannot determine that the left and middle portion is actually completely sorted. We can only determine that the middle and right portion is completely sorted. So in this case, we are actually going to update the value of the right pointer, and we are going to determine that these are all the values that are not part of the answer. So we can just simply ignore them and we will not do anything for these values. So now currently our right pointer comes over here. Now because of that, we are again going to repeat the same process, and we will try to find the middle value. Middle value in this case is going to be 8, right? So we are going to compare left with the middle value. So left with the middle value, if we compare, left is actually less than the middle value. If that is the case, we can determine that no value over here is the minimum value, so we can simply ignore that. And now our left value becomes this one, our right value becomes this one. And now if we compare, left is actually less than right. Left is less than right. That is the ideal scenario that we were looking for, which means that now left is at the correct position where the value is actually minimum, and in the answer we are going to denote the value to be 0, and that is going to be the answer we are going to return. Now if we see time complexity, in this case the time complexity is actually going to be big O of log n, because remember, during any single iteration we actually removed the half of the candidates that we were trying to search for. And that is why we are actually using binary search in this program to solve this problem, and that is the logic we are going to use. And now let's move on to the coding. So first of all, we are going to initialize 3 variables, left, right, and answer. Now we are going to test for an edge case that if the nums array only has one element, basically we can return that as the answer. Okay, if that is not the case, we are going to run our while loop, that while left is less than or equal to right. First, we are going to check that if the current left and right position makes the array completely sorted or not. And that can only happen if the value at number of left is actually less than whatever the value of nums at right we have. And if that is the case, we are going to see that whether we need to update our answer or not. If that is not the case, we will have to calculate the middle pointer. So first, we are going to initialize a value called mid, and we are going to calculate the middle pointer. After calculating the mid pointer, we are again going to check that whether we need to update our answer or not. Now we are going to see that which way on the mid pointer do we need to take the jump. So if we find out that the current value of left is actually less than or equal to mid value, then we will have to update the value of left pointer to the right side of the mid. And if that is not the case, which means we will have to update our right pointer. Basically, that's all we have to do for our binary search operation. After this loop ends, we can simply return whatever we have stored in the answer. And now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code is actually pretty fast compared to a lot of other solutions. And I would be actually posting the solution in the comments so you can check it out from there. Today we are going to do search in a rotated sorted array, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Facebook, LinkedIn, Bloomberg, Apple, TikTok, ByteDance, Google, Goldman Sachs, Uber, and eBay. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem on LeetCode.
Basically, we are trying to search an element inside a rotated sorted array. Now, if you notice, this is very similar to one of the previous videos we solved recently, and you can check it out that over here. Now, we are basically given an array called nums, and we are also given a target value, and we need to check that whether this target value exists inside this nums array or not. If it does, we need to return the index of that target value. Now, the special part about this question is that the nums array we are given is actually a sorted array that has been rotated certain times. So it sounds confusing at first that what does a rotated sorted array means. So you can either read this definition that has been provided over here, but let me make it a little bit clear for you. Basically, a rotated sorted array is that initially an array is a fully sorted array, which is the case over here. You can see that all the elements are sorted and they are all in ascending order. And the thing is, whenever we rotate one time, basically we take the rightmost element, we put it on the leftmost side, and then we flip all the elements one side or one position to the right. And that is how we rotate and rotate a sorted array. So if we consider this to be the original array, suppose we rotate it one time, we will get a result that looks like this, where this 5 that was originally on the rightmost position came on the leftmost position, and all the other subsequent value we jumped it one step on the right side. If we rotate it 2 times, again the 4 and 5 would come on the left side and all the values would be shifted 2 times on the right side. If we rotate 3 times, basically all the values would be rotated 3 times, and we would get an array that looks like this. So the idea is we are given a form of a rotated sorted array. The thing is, we don't know that how many times it has been rotated or whatnot. We are also given some target element, and we need to see that whether this target element exists inside this array or not. So suppose this is the array we are given as the input, and we are given target is equal to 3. If that is the case, then in this case 3 exists inside this array and its index value is 0. So we need to return 0 as the answer. And this is what is being asked for this problem. So now let's see that what are going to be a couple of different approaches to solve this problem. The first approach we have is a brute force approach. In the brute force approach, what you can do is, suppose this is the array we are given and we are given the target value to be 0. Well, if we see, what we simply do is we start iterating over this array one by one, and every single time we iterate until we find the value that exists. If the target value exists inside this array, whatever its index position is, which is 3 in this case, we return that as the answer. And if we somehow reach to the end of this array and we do not find this target value, we simply return that, okay, the target does not exist, right? The thing is, this solution is not the most optimal solution. Why? Because the time complexity for this solution is going to be big O of n. Meanwhile, if we read the problem statement, we are explicitly told that we need to complete this in big O of log n time complexity, and this big O of n is just not good enough. Okay, before we come up with the optimal solution, first let's understand a couple of concepts regarding the sorted arrays, right? For the sorted arrays, if we compare any left element with any right element, if we at any point identify that left is actually less than right, and we know that this given array is a sorted array, right? And this left is actually less than right. So if that is the case, all the elements between this left and right will be sorted in ascending order. That is one of the properties of a sorted array. We already know that. Now, the tricky part we have is that the array we are given is actually rotated. So the thing is, we will have to take care of this rotated part as well, and we don't know that how many times it has been rotated. So suppose we are given an array like this. This has been rotated few times, right? Now, whenever we compare the left element with the right element initially, we can clearly see in this case that left is actually 3 and right is actually 2. Which means left is actually greater than right. And remember, we already know that when left is less than right, we already know that all the elements in between, they are actually sorted. And if we are trying to find some target value that falls between this left value and this right value, we can immediately find that target value. Suppose we are given the target value to be 3. We know that left value is 0 and right value is 5. So because of that, this target value has to be somewhere between this 0 and 5, because it can only exist between 0 and 5 because this portion is sorted. 3 cannot be outside of the scope. The thing is, we cannot say that for certain in this case, because over here currently if we see, left is actually greater than right, which means we can determine one thing, that this whole portion is not sorted. But the thing is,
we already know that a chunk of this portion is sorted, which is this, that 3 4 5, this is sorted in ascending order. Again, same way, this 0 1 2, that is also sorted in ascending order. Why? Because this was a rotated array, right? So the thing is, what now we are going to do is, we are trying to find some target value, right? So our aim is that, suppose we are given the target value to be 4, right? Now we are trying to find the value 4. The thing is, for this rotated array, the idea we are going to use is that when we determine that left is actually greater than right, which means that this whole portion is not sorted, right? That is the key part. This whole portion is not sorted, but some chunk of this portion has to be sorted, and that we can determine by defining some middle value. So in this case, suppose we put down a middle value. So suppose we have a middle value that is 0, right? Now with this 0, what we are going to do is, we are actually going to compare this left with this middle value. If we compare this left with this middle value, left value is equal to 3 and middle value is equal to 0. So if that is the case, left is actually greater than middle value. So since that is the case, we won't be able to do much over here. And basically what we will do is, now again we are going to compare this middle value with this right value. So currently middle value is actually 0. The right value is actually 2. So middle value is actually less than right, which means because this was the rotated array, we can determine that all the values between this middle value and this right value is actually completely sorted. This is the important property that we have to define, that this whole portion is completely sorted. Because of that, now we will see, okay, our target value is actually 4. The current middle value is 0, current right value is equal to 2, which means 4 does not fall between 0 and 2. Because it does not fall between 0 and 2, we can concretely say that 4 cannot be part of this particular chain. So immediately we can ignore all of these cases, and now what we'll do is, we will shift our right pointer to one step before mid. Why? Because we were certainly able to say that this sorted property of this rotated sorted array help us determine that 4 is not part of this one. All the elements between these portions were between 0 and 2. Now we are going to move our right pointer over here. So let me clean this up a bit. So now currently our left pointer is here, right pointer is here, right? Now if we see, left is equal to 3, right is equal to 5. If that is the case, left is actually less than right, and this is what the golden thing we wanted. Now we can clearly determine that this whole portion 3 4 5, that is completely sorted. Because this is completely sorted, all we will have to do is just use binary search in order to find the target value. So what we are going to do is, we are going to compare the middle value. So middle value in this case is 4. 4 is actually exactly the target value we are looking for. So we will return the index position of 4, which is 1 in this case, as the answer, and the answer over here is going to be the one that we are going to return. Now after explaining this whole thing, let me quickly go over one of the examples to see that how we will solve optimal solution using binary search. Okay, so now as mentioned, we are actually going to do the binary search operation on this rotated sorted array, right? And the target we are trying to find is the value number 0. Now we are going to use our 2 pointers. So first pointer we have is left, that is located at this position number 3, and right pointer is located at this position number 2. In this case, currently left is actually greater than right, which is not what we want. So now we will have to determine that which portion of the array is sorted, and based on that, where this target value could lie. So we are going to compare with the middle value. So in this case, the middle value is going to be 7, right? So now we have this value number 7 that is located as the middle value. Okay, now for this middle value, we are going to compare it with left and right value. So currently, if we see, left is actually less than middle value, and this is what we wanted. The moment we identify left is actually less than middle value, we can clearly determine that this whole portion is completely sorted. Okay, now we will compare the target value we are looking for with the values of left and mid. So if we see, the target value is actually outside the scope of this left and mid, which means that target value cannot exist between these places. Immediately we can determine that. So we will ignore all of these cases, and now we will have to update our left pointer to go on the right side of the middle pointer. So we will do that. So now we will have our new left value located at this position, and the new right value located at this position. Now we are again trying to find the value 0. Okay, now immediately over here we can see that left by itself is actually 0. So that makes our life much more easier, and we can simply return the index value of this left to be 5 as the answer. And in this case, we are going to return answer as the 5, and basically all we are doing is, we are actually using the middle value to determine that which portion of the array is sorted. Depending on that and based on the target value, we decide that which way we will have to make the jump, and then we get our desired answer. If we see time complexity, in this case the time complexity is actually going to be big O of log n only. Why? Because remember, in a single iteration we were able to get rid of all of these elements immediately, which means every single iteration we are doing like half, we are getting rid of half of the elements. So that is why the time complexity is log n, and that is what we wanted. If we see space complexity, in this case the space complexity is actually going to be constant space, because we are not using any additional data structure. First of all, we are going to define a couple of variables, left and right. Okay, now we are going to initialize our while loop, that while left is less than or equal to right. And inside our loop, first of all, we are going to calculate the mid pointer. Now we are going to check for the condition that if the given value of mid, if that is equal to target, if that is the case, we can simply return the index at mid. Okay, if that is not the case, now we will have to first of all define that which portion of the mid pointer is actually completely sorted. So first let's put the condition that if the given value of left, if that is less than or equal to whatever the value of mid is, if that is the case, we can define that the values between left and mid is completely sorted, right? So now all we will have to do is we will have to see that where target lies. Does it lies between left and mid value, or it lies somewhere else? So first we are going to see that what if the target lies outside of left and mid value. If target lies outside, basically we will have to update our left pointer to go mid plus 1, and we will continue with our journey. If that is not the case, which means target lies between left and mid, and if that is the case, we will have to update our right pointer to come between left and mid. So we will do right equal to mid minus 1. Okay, now we take care of the scenario that the numbers of left is not less than or equal to mid, which means that the values between mid and right is actually sorted. And if that is the case, again we are going to repeat the same process. First we are going to check that whether the target value is outside the scope of mid value and right pointer. So if the value is outside of the scope, which means we will have to update our right pointer to search on the other portion of the array. So right is going to become mid minus 1. And if that is not the case, which means that the values lies between mid and right value. If that is the case, we will update our left pointer to search between mid and right. So left would become mid plus 1. And basically this loop should take care of the scenario, and we would be able to find our answer. And just for the sake of putting something outside so we don't get a compilation error, we are going to return -1, but our answer would have been returned by this. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. And I would be posting this solution in the comments, so you can check it out from there. Thank you.
Hello friends, hope you are having a fantastic day today. So in this video, we are going to solve an awesome lead code problem that has been asked in tons of different companies. So without any delay, let's get started. So the lead code problem we are going to solve today is called sort list, and you can see that this is a lead code medium problem and also a very well-liked problem on lead code. This has been asked at tons of companies, and that's why you really need to pay attention. Now the problem statement is really simple to understand, that we are given the head of a linked list and we need to return the entire list in sorting ascending order. So if we see an example over here, we are only given the head of the list, that is this value number 4, and then rest of these values we need to iterate over using the linked list, and in the answer we need to return a sorted linked list that looks like this. And you need to do this problem. Now this is not specified over here, but in the follow-up definitely the interviewer is going to ask you that they are going to ask you to solve this problem in big O of n log n time complexity and also big O of 1 space complexity. So this becomes a little bit tricky in order to how to achieve both of these values in terms of time and space complexity. So we will try to target these things and think that what is going to be our thinking like in order to solve this problem in this much value, this much time complexity, and also without using any extra space. Now logically, let's assume that instead of this being a linked list, let's assume that we are given a simple array.
and this is an unsorted array that we need to sort, and we need to sort this in n log n time. How would we solve that? Suppose we are given the values like 2, 4, 7, 1 and 3, something like this. Okay, so this if we have to sort this unsorted array, there are actually bunch of different methods that solve this problem in n log n time. We can apply like quick sort, or we can apply merge sort. Both of them are going to be really popular. We can also use like heap sort. But good thing about array is that in order to access any single variable, we can do this immediately by knowing that what is the index value, and then we can simply access this value. We don't have the same luxury to do so in our linked list. So that adds a bit of complexity, and that's why many companies love asking this question. Okay, now let's try to do the merge sort for this given array. So the logical thing is we are going to first find the middle pointer and break the array into two pieces. So first piece is going to be values 2, 6 and 4, and second piece is going to be value 1 and 3. Now we will check that are they sorted. Now in this case, this array is already sorted, so we don't need to do anything further. This is a good candidate for us. But now for this portion, this is not sorted, so we are going to again repeat the same process. So once again, if we break this down into two pieces, we will have one piece with value 2 and second piece with value 6 and 4. Once again, so currently we only have one value, so this is already sorted. We can't do anything much with this. This 6, 4, is it sorted? No, it's not sorted. So if it's not sorted, what we will try to do is we will try to sort this. But since there are only two elements, if we break them apart, it's going to be one element each, that is going to be 6 and 4, and then we can simply swap these values and it would be very simple to sort this one. So after completing this operation, what we will be left with is we will be left with a value like 2, and then this is going to be 4 and 6. So now currently this portion is sorted, this portion is also sorted, and this portion is also sorted. So now we have three different arrays that we are trying to sort, and this is going to be very simple to do. So what we will do is first we will take these two arrays 2 and 4, 6. So first we will compare the very first element with the very first element, and that's the only thing we need to do. And this operation can be done in log n time because we already know that both of these are sorted. So whichever value is smaller is always going to append first. So in this case, since the value number 2 is smaller, so we will be left with a piece 2, 4 and 6 as one piece, and second piece is already 1 and 3. So once again, now we are going to compare these two values, and we can see that this value number 1 has to go first. So we are going to put this value number 1 over here. Then once again, we are going to compare this value number 2 with value number 3. So since 2 is smaller, so once again, we are going to put 2 over here. Next, we are going to compare this value number 4 with value number 3. So since value number 3 is smaller, so we are going to put it before. And then for whatever the rest of the values are remaining, since this array is already completed, done, we can simply append all the values that are remaining as it is. So we are going to add values 4 and 6 as it is. This is how merge sort typically works in an array, and for that we actually have to use extra space because we need to store the array and do all of these manipulations. Now the target is we will try to replicate the same thing. The good thing about linked list is that we don't have to worry about this extra on space because we are working with linked list. So we can actually use pointers to just point to the any particular value that we are trying to do, and we can just manipulate the nodes in the easiest manner. Now let's try to see that what the solution is going to look like. So number one thing is that in the linked list, we are only aware about the very first element. We don't know that what rest of the elements looks like, and we have no way for verifying. So let's assume that the values currently given are like 4, 3, 1, 2 and 5, something like this, 6. Okay. Now what we need to do is, in order to apply the merge sort, first we will need to find the mid pointer. And we don't know how many elements are currently in the linked list. We only know the head element. So we know that if we have to find the mid pointer, all we need to do is use fast and slow pointer method. And by doing this, we would be able to find the mid pointer quite easily. For those who don't know how fast and slow pointer works is that we are going to have two pointers, fast and slow pointer, start at the very beginning of the linked list. Fast pointer is going to jump 2 hops and slow pointer is only going to jump 1 hop every single iteration. So the moment we encounter that either fast pointer is at the null location or fast.next is the null location, then we have reached to the last node for the fast pointer. And the moment fast pointer reaches to the last node, whatever the position of this slow node is going to be the mid pointer. So this is how we would be able to identify the mid pointer. Now let's try to apply the same logic. So for this one, we are going to have two halves. First half is going to be 5, 3, 1 and second half is going to be 2 and 6. Now 2 and 6 is already sorted, so we don't have to do much. But for this half, once again, we are going to find the mid pointer. So one half is going to be 5 and second half is going to be 3 and 1. And once again, this half is not sorted. So once again, we will sort this one 1, 3 and then we will have 5, 1, 3 as one half. Once again, these two are not sorted, and again this is not array, these are linked list pointers. So once again, recursively we are going to repeat the same process and we will have 1, 3, 5 as the sorted arrays, and then we will have another sorted linked list and another pair as 2 and 6 as the sorted linked list. We will merge these two together and we will find the values 1, 2, 3, 5 and 6 as the final sorted linked list, and we can do this in place using the pointers. So when we see that in the code, we should be able to find or understand how it works. So this is the whole approach. What we are going to do is, for the linked list, we are going to use the merge sort approach, and in order to find the mid pointer, we are going to use the fast and slow pointer method. So you see, in this problem, we are applying multiple concepts that are really important for many different things, and that's why this problem has been really popular in many different companies. Time and space complexity, we already know. Time complexity is going to be big O of n log n, and in terms of space complexity, it's going to be big O of 1 because we are not using any additional space. We are actually going to manipulate the pointers, and the whole thing, because it's a same operation being done repeatedly, it's a recursive approach, and we can just solve this problem using recursion. So now let's see the code for this. So if we see the solution, first what we are going to do is, we are going to have our sort list method that we are going to recursively call for the different linked list head. So first we are going to have our terminating or base case, that if the current given head is equal to null, we return head. If head.next is equal to null, then also we return head. Next, we will have to find the mid pointer. In order to do that, we are actually going to use an extra helper method called getMid. So first let's see the getMid method, where this is very simple. We are just simply using two pointers, fast and slow pointer, in order to find the mid pointer, and the moment we get the mid value, we simply return the mid value. So we have the mid value over here. Then we also have the left node, that is going to be the start node, or the very first node that we are given in the input for the sort list method, and the rightmost node, that is going to be the mid pointer node or the second half. And then we simply need to apply our merge sort method. So we are going to call another helper method called merge. And in this method, we are going to have, first of all, couple of nodes, dummy and tail node, in order to keep track of different pointers. Then we are going to simply check that while list 1 and list 2 are not null, we are going to compare the values. If we find out that the values are not correct, we are simply going to swap the values, and then we are going to keep on iterating till we reach to the next element or the very last element. And that's it. So this is how we are going to do our merge sort operation. And this is the whole code. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs very fast compared to a lot of other solutions, and it is also very efficient in terms of memory usage. So once again, I will be posting this code solution into our GitHub repository, and link to that GitHub repository is in the description. Hello friends, hope you are having a fantastic day today. So in this video, we are going to solve an amazing LeetCode problem called largest number. And this problem has been asked in companies like Amazon, Microsoft, Google, Facebook, Bloomberg, and bunch of others. So without any delay, let's get started. So as you can see, this is a very well-liked LeetCode problem, and also this is a LeetCode medium problem. Now let's try to understand that what the problem statement is asking us to solve. Basically, we are given a non-negative integers nums array, and we are being told that we need to arrange this in such a manner that we get the largest number from combining all the numbers that are currently present inside the given array. So let's try to understand this with a couple of examples. If we see this first example, we are given an array with two values, 1, 0 and 2. So if we combine these two numbers, what is the largest number, possible number that we can get? So in this case, we cannot break apart this existing number. So 1, 0 has to remain 1, 0 in all the cases, but we have the option to select from 2, 1, 0 or 102. So because currently we only have two values, so we only have two possibilities, and in this case 210 is the largest number, so we need to return 210 as the answer. Let's try to understand the same problem with few more examples. So suppose we are given the values like 3, 5 and 10. If this is the value given to us, what is the largest number we can make out of this? So one option is we can make a value 3510. Second option is we make a value like 5310. Next we can make a value of 5103, something like this. But in either cases, amongst all the possible values, this is going to be the largest value we should be able to make. So in this case, we need to return this as the answer. So I hope my explanation makes sense to you and you can understand that what we are trying to return. Now, if we see the problem statement, we are given a couple of other things to make our lives easy. Number one, they are saying that the result could be very large numbers. So we need to, rather than returning integer values, we can simply return string as the answer. And all we are doing in this problem is that we are actually treating these values as string values, so string 1 and string 2, and then we are seeing that how can we concate string 1 plus string 2 in such a manner that we get the largest number. So we have two options because we currently only have two values, string 1 and string 2 in this case. So either we can concate string 1 plus string 2, which would result in the value 102, which is this value combining these two numbers, or second option is we concate string 2 plus string 1, and in this case the answer we get is 210. So because 210 is larger than 102, we are going to return 210 as the answer. Now this is a very clear hint on how we are going to solve this problem. Basically the idea is that we could have been given bunch of different values inside the given array, and somehow we need to sort this array in such a manner where the very first element is the largest value, and we are not talking about largest in terms of like pure numerical value, but the largest first value, and this we can only determine compared to rest of the other values. And I know what I just said might have gone over your head, so let me give you try to give you a simple explanation. Okay, let's just go back to our example of values 3, 5 and 10. Now in this case we know that the answer is going to be 5310, and this has to be the largest number. But how can we come up with this largest number? And if we have to make this number, what should the sorted array should look like? So the sorted array should be that very first value should be value number 5, next value should be value number 3, and the last value has to be value number 10. Now if we just take the example that in this given input array, we are simply trying to make the largest value as the numerical sorting order and then present that largest value as the sorted array, then it would not work. Because if you see in this case, if we just have to sort all of these values based on their value preposition, we would get a value like this 10, 5 and 3. But in this case, if we combine these letters in this sequence, we would get value 1053. So 1053 is clearly a smaller value compared to value 5310, which is what we need to return. So what I'm suggesting is that whenever we start sorting the array, the logic we are going to use is that let's assume that we want to compare two numbers. So currently the two numbers we are comparing is 5 and 10. Okay, these two numbers. So what are the options we can have? Number one option for this array is that either 5 can come before value number 10 or 10 can come before value number 5. But in either case, how we are going to determine? We are going to determine by combining these two values as if they are string concatenation, and let's see that what approach we come up with. Okay, so now currently the premise is we only have two values 5, 10 and another value is 10, 5. So which sequence should be the correct sequence? So we are going to combine the values. So if we combine this, we get the value 510. If we combine this, we get the value 105. And in this case, 510 is clearly greater. So when we are sorting our array to generate the largest number, 5 has to come before value number 10 somewhere. And this is the logic we are going to apply to solve this problem. So I'm going to show you two examples of solving this with like a simple problem and a complex problem, and that would enable your mind to come up with the answer. And if you are having any issues or if you are not able to comprehend what I'm suggesting, all I say is that you apply this logic to sort the array and you should be able to find the answer. So this next portion is for anyone who got confused. So that then just look at the example. But if you already understood what I'm trying to say, then you can basically conclude this video. So now let me just explain my theory with a couple of examples. So number one example is, once again, let me take three values. Okay. So 7, 2, and 9. Okay, these are the three numbers we are taking, and we know the biggest number we would be able to make is going to be 972. Okay, let me take a little bit more complicated value because this is very simple. So instead of 2, we are going to take the value 20. Okay, and now the largest value we should be able to make is 9720. But let's see the approach. So first what we are going to do is we are going to apply the same logic that when we are comparing two values A and B, we are going to compare A plus B and we are going to compare B plus A. And this is not plus as in like mathematical plus, but you can consider this plus as a concatenation of two numbers. Okay, so now currently the two values we have is 7 and 20 we are trying to compare. So what are the two options? Number one option is that we have 720. Second option is 207, because this 20 has to remain together. So amongst these two values, we can clearly see that 7 is greater value and 20 is lesser value. So after comparing these two elements, we can conclude that 7 has to remain first and 20 has to remain second. But now we still have to make sure that where we are going to put this value number 9. So once again, let's compare this value number 9 with this value number 20. So if we compare 9 and 20, we have one option is 920 and second option is 209. So clearly 920 is greater, which means 9 has to come before value number 20. So let me make this adjustment, and currently 9 has to come before value number 20. But is 9 at the correct place? No, because we still have to check with value number 7. So once again, we are going to compare the value 79 and 97. Once again, 97 is greater, which means 9 has to come before value number 7. So let us also adjust the value of this 9. So now currently this 9 is very first element and this 7 is the second element. Now since we ran out of elements over here, which means we can't do anything in this case. So this has to be the correct sequence of numbers that are sorted in ascending order such a way that combining these is going to result the largest number possible. So let's combine these values and the answer is going to be 9720, and this is what we need to return. Let me give you just one more example really quickly, just for the explanation sake. And let's take some larger example. So the values are 3, 50, 20 and 9 and 1. Okay, this is the number. So let's start comparing. So first we compare this value 3 and 50. So one option is 350 and second option is 503, which means definitely 50 has to come before value number 3. So okay, now currently we are comparing this value number 3 with value number 20. So once again, if you do that, 203 versus 302, oh sorry, 320. So once again, 320 is going to be greater. So we are going to put 3 before value number 20. This is correct sequence. Now 20 compared to 9. So once again, the one option is 209, second option is 902. So definitely 9 has to come before 20. And once again, if we keep on repeating the same process with 3, once again 9 has to come before 3 as well, and same way 9 has to come before 50. So the value is going to be 9, then 50, then 3, and then 20. Okay, and last value is 1. So 1, okay, if we compare 20 with 1, the answer is going to be 201 and 120. So 201 is greater, so value has to be 1. And if we combine all of these values, this is the correct sorted order. And I really quickly glance over it because I just wanted to explain how the method is going to work. And the answer is going to be 9503201, and this is going to be the largest number we should be able to make from given this input, and this logic would work perfectly fine. Now for most of the languages like Java, Python, C++, they already have a sorting method in order to sort the arrays, and we can sort them in any order. So even for this one, we should be able to take or utilize the sorting method in order to generate the array. And this sorting usually works in n log n method, where we use comparator method to compare any two elements in order to sort them. What I showed you over here was a very slow approach. This would work in big O of n square time, But since we already have a sorting method that is built in that runs in n log n time, we should be able to use that, and that is going to yield us very good result in terms of time complexity. If we see space complexity is going to be big O of n, because many cases this sorting algorithm usually takes big O of n space, and that's these are the time and space complexity. Now let's try to see the coding solution. So very first thing we are going to do is create a new string array, because we will have to convert all the numbers into the string, and then we are going to iterate over our given nums array into simple for loop fashion and convert all the values into the string values. Once we have our string array, now all we need to do is use the pre-existing arrays.sort method, where we are comparing two elements in such a manner that we are concatenating the strings a and b, and we are comparing a plus b and b plus a and seeing that which value is greater compared to the other value. Once this is done, the array should have been sorted. Now we are just taking care of one of the edge cases, where if the given value has the largest value or the very first element as 0, we can simply return 0. If that is not the case, we will simply run a string builder operation, where we are going to concat all the values that are currently present inside our string array, which we have already sorted in ascending order in terms of completely larger values, and then we can simply return the largest number that we have been able to build using our string builder method. So now let's try to run this code, and seems like our solution is working as expected. Let's submit this code, and our code runs very fast compared to a lot of other solutions, and it is also very efficient in terms of memory usage. So I would be posting this solution into the GitHub repository that we have created. And if we see, this GitHub repository contains hundreds of different lead codes, code solution questions and answers, and I will be posting there, and the link to this GitHub repository is currently present inside the description of this video. So I hope you like it, you enjoy it, and till then, take care. Hello friends, hope you are having a fantastic day today. So once again, we are going to do an awesome lead code problem that has been asked at tons of companies, and it's actually a pretty fun question to solve. So without any delay, let's get started. The problem is called Koko eating bananas. This one is a lead code medium problem and also a very well-liked problem on lead code. Basically, we are being told that Koko loves to eat bananas. Now, Koko is a very famous gorilla, and we are given two items. We are given a piles array which contains that every single element in this array represents the number of bananas that particular pile has. And we are told that there are guards who are typically protecting the bananas, but they have gone out for 8 hours. So we are given these two items as an input. Now Koko decides to eat her bananas per hour eating speed of k, and each hour she chooses some pile of banana and then she eats k bananas. So whatever the speed we decide, she tries to eat that. If the pile has less than k bananas, then she eats all of them and will not eat any more bananas during this hour. And the most important thing is, we need to return minimum integer k, such as she completes all the bananas within each hour, and we need to make sure that this k is the smallest element possible, because Koko likes to eat slowly. So let's try to understand this problem with an example. So over here we are given piles. This represents that pile 1 has 30 different bananas, next one has 11, and next one has 23, and so on and so forth. And we are being told that the guards have gone for 6 hours. Okay. So now we need to figure out that in this 6 hours, what should be the speed of banana eating for Koko in order to complete every single banana in each of the pile, and also at the same time make sure that she tries to eat in the slowest speed possible. Now, one important detail is that at any given moment, Koko can only eat bananas from only one of these piles. She cannot jump around between the piles from hour to hour. So let's say that currently we have the speed of banana eating at 50 per hour. Then let's assume that in the first hour, she decides to eat 30 bananas, which means she still has time to eat 20 more bananas, but she would not go to the next pile to start eating them. She will only eat 30 and then wait for 1 hour, and during the next hour she will go to the next pile and once again start eating bananas. But once again she still has room to eat 39 more bananas, but she would not move to the next element. Okay, so maximum hours we have is 6. That is number one thing. Now let's see that what are the some of the options that we can consider. For assumption, we take the largest number in this pile, that is 30, and we say that Koko eats 30 bananas per hour. So then in how many hours will she complete eating all the bananas? So during the first hour, she would complete this pile. Then during the second hour, she would complete this pile, and so on and so forth. In every single hour, she will complete each of the piles, and then she would have still completed her banana eating in 5 hours. So less than 6. But the thing is, question is, can we go smaller than 30? That is also a question. We need to find the minimum number. So let's say that we try the second smallest element, that is 23 per hour. Then how many hours will it take for Koko to complete all the bananas? So if we do 23 hours, so k is equal to 23, then logically in the first hour she will complete 23 bananas. So she would still have 7 more bananas left in this pile to complete. So during the second hour, she will also complete 7 more bananas. Then during the third hour, she will complete 11 bananas. Then during fourth hour, she will complete 24. Then fifth, then 4, and then sixth hour, she would complete these 20 bananas. And then by the time of 6 hours, she would have completed all the bananas in every single pile, and her speed would be 23, which is significantly less than the previous speed that we were considering, that was 30. Let's try to consider one more speed. Okay, let's say that instead of 23, can we go smaller than 23? So let's try 22. Okay, so if we try to do 22, then this pile would take 2 hours, this pile would take 1 hour, this pile would once again take 2 hours, and then these two piles would also take 1 hour. So if we do total sum of this actually becomes 7. So that is greater than 6, which means speed 22 is no longer feasible for Koko to eat bananas. So minimum speed she can use in order to complete all the bananas, and at the slowest speed possible, would be 23. And this is what the problem is actually asking us to solve. Well, brute force approach is actually quite simple, because we know for sure that the maximum value has to be the maximum value that is currently present inside the given piles, because we are being told that the inputs are valid and legitimate, which means that if she eats the speed at the maximum number of bananas that are present inside all the piles, then by that limit she should be able to complete every single one of them. But that is not going to be the ideal scenario. Maybe it might have been ideal if instead of over here, instead of this h being 8, we only had 4 hours to finish. Then we have to eat at the speed of 11, but that is not the case. So what is the minimum range? Okay, so maximum range that Koko needs to eat bananas is going to be the maximum value, so 11. The minimum range can be value number 1. Okay, that let's say that in this case we actually have sum of all of these values. We have 28 hours. If we have 28 hours, then if she eats 1 banana per hour, then also she can complete this entire pile. But that is also not the case. So we find our maximum and minimum ranges. So logically what we can do is we can simply take every single range and then try to go over to see that if that range satisfies the property of completing the banana eating, and then we can come up with the answer. So we already know the logic. Let's say that with 1 we can complete, it would take us 28 hours to eat all the bananas, but 28 is greater than 8, which means 1 would not work. So we try to do it with 2. If we have to do it with 2, once again it's gonna take, let's say 15, so it's gonna take 15 hours, but this is also greater than 8, so 2 is also not going to work. So on and so forth. If we repeat the same process, we would find the answer 4 in this case, that this is the number of bananas she needs to eat in order to complete the entire pile. So logically this solution works as expected. Okay, that is number one thing, brute force approach. But the thing is, the time complexity in this case would be big O of n, where n is the number of the sum of all the bananas that are currently present inside the combination of all the loops. But we will try to do things slightly faster. So let's try to see that what would be the optimal approach in this case. Now For this given example, I have actually calculated the speeds from 1 to 11 for every single hour, the banana eating speed, and I have marked that at that particular speed, how many hours will it take for Koko to complete eating all the bananas. And the important thing in this case is we need a value where we reach value number 8 at the very first time. The moment we hit very first time, that is the minimum speed Koko should eat bananas at in order to complete all the bananas within the given hours for which guards are away for. So logically, we can make a very important distinction over here, that with increase in the value of k, we can see that the our value of h reduces significantly in a sorted and descending order, which means we can see that there is a descending property over here that is being maintained. Now the question is, we need to find the minimum value, but the lucky thing for us is that we actually can use the benefit of this property of this value being sorted to our advantage. What we can do is, instead of using the brute force approach where we were starting from k is equal to 1 and then just going in the linear fashion for every single bananas until we hit value number 8, we can actually use binary search in this case in order to complete this problem. Now let me show you that how doing binary search would be the greatest thing since sliced bread in this approach, because we have our minimum range, we have our maximum range, which means we know for sure that our answer has to lie somewhere between this, because any value above 11 will always yield us the result as 4. We can go even with a speed of 50 and still it is always going to give us the result as 4, which means the important thing is that once we have our left and right pointer or the minimum and maximum values, so let's mark them. So currently we have our left pointer and we have our right pointer located at these two positions. Our aim is to find the minimum value in this k that represents that h becomes 8 for the first time. And the logic is quite simple. We take L and R, we try to find the mid pointer. So we check that for this particular one, what is going to be the mid pointer? I think mid pointer is going to be this value number 6. So for value number 6, what is the total number of hours that we can use in order to generate the answer? So we can see that this value is 6. 6 is actually less than value number 8, which means this is one of the legitimate scenarios. But the question is this the minimum value we can reach 8? No, because we will need to find the value that equals to 8 at the very first moment. So then once again, now we are going to bring our right pointer one step before this one and we will have a right pointer on this location. Once again, we will try to do the mid operation. So now if we do the mid operation, we realize that mid pointer is actually this one. So this is actually hours is equal to 10, which is greater than the target hour we had, that was value number 8. Which means we will have to increase the speed in this case. So since we have to increase the speed, we will have to update our left pointer. So we will update our left pointer to come over here. Now we have two values left and right located adjacent to each other, but still we will try to find the mid pointer in this case. So in this case, if we try to take the advantage of the ceiling value, we will find mid pointer to be value number 4. Okay. And then this refers to value number 8, which means this is exactly what we are trying to find. But the thing is, we are not sure if this is the smallest value or not. So for that, what we can do is we can simply check one value adjacent to it before it to see that if that value is actually greater than or less than value number 8. If that is less than 8, which means we might have missed some values where 8 started forming, which we did not. So in this case, we know for sure that this has to be the smallest value of banana eating speed that we can use in order to finish all the bananas within the given 8 hours. Now we all know that how to calculate hours for any single pile. For that, we simply have to iterate over the given array, see that what are all the bananas are, and at that speed, how many bananas can be completed in that particular aisle. So that for that calculation, we can simply use a helper method to complete that. And basically this would yield us the complete result in order for us to find the answer. So now this is a beautiful solution for an awesome problem, and it contains one of our very near and dear species. So that's always pretty good. So now let's try to find the time and space complexity in this case. Time complexity is quite simple. It's going to be big O of log n in order to complete the binary search. And if we will also have to do some computation in order to find that how much time it takes to eat all the bananas. So let's say that becomes big O of h. But the thing is that calculation is always going to be finite. Why finite? Because we know that the number of given input size n is going to be finite, and we will have to iterate over all the elements in order to calculate that. So that operation in itself is going to be big O of n. So in this case, the total time complexity is going to be big O of n log n, because for every single pair that we can make up until this log n time, or till that optimal period, we will have to find that how many hours it takes to calculate the results, which is going to be much faster than our brute force approach, because in the brute force approach, we had to do this big O of n work, but we had to do it for every single possible value of k. So we were actually getting big O of n square result. And if we see space complexity, well, in this case, I just draw this additional data structure for your understanding. But actually, apart from storing few variables here and there, we don't have to use any extra space. So this is also going to be big O of 1. So this is a beautiful time and space complexity to solve this problem. Now let's see the coding solution for this one. So here is the solution. So first we are going to initialize two variables, left and right. Now for the right pointer, we will have to find the maximum value inside our given piles. So we are going to do that with using a for loop. Then we are going to run our binary search logic, where we are going to check that while left is less than right, we are going to find a mid pointer, and then we are going to call our helper method to check that whether we can finish finding the given piles using the given mid pointer or the speed that we have been able to find with the given h hours in the input. Now let's understand the logic for the can finish helper method. First, we are going to mark that the initial hours are going to be 0, and then we are going to compare that in order to complete this piles, how many hours it's going to take. So we are going to check that if the number of speed is going to be greater than any particular pile, then we can finish it in 1 hour. If not, then we need to increase the hour. If the number of hours are less than or equal to the given value h, we can determine that speed can actually finish all the bananas. Then we need to check that whether the right pointer is equal to mid. If that is not the case, we need to find that left pointer is going to be mid plus 1. And in the end, whichever is the left pointer has to be the answer. So this solution would work as expected. And now let's try to run this code. Okay, seems like our solution is working. Awesome. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions in terms of time complexity. It is really good in terms of space complexity as well. So once again, the solution for this code is presented in our GitHub repository, so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So once again, we are going to solve an awesome lead code problem, but now we are also going to learn a very popular advanced data structure in this problem. So I'm going to pay my utmost attention. I hope you also enjoy the video. So the lead code problem we are going to solve today is called time-based key value store. We can see that this one is a medium problem and also a very well-liked problem on lead code. The problem statement is actually quite a long. Basically, we need to implement a time map class, but there are a lot of conditions in order to implement this time map class. So we need to design a time-based key value data store that can store multiple values of the same key, but based on the timestamp. So depending on at what timestamp, what key value we received, we need to store that. And we also need to retrieve the same key value pair depending on the certain timestamp, the value that we have been provided. Now, number one, we need to initialize the object for the time map data structure that we are trying to create. And we also have to set two methods. First one is a set method, where we are providing three values. First one is the key, second one is the value associated with that key, and third one is the timestamp associated with both of these keys and values. Now next one is a get method, where we are providing the key for which we want to get the value, and we are also providing the associated timestamp. So based on using the combination of these two, we should be able to find the value associated with this particular key. The other thing is, if say for an example for this timestamp we don't have the value associated with the key, then we need to find the closest value that was present at that particular timestamp, and for some reason we don't find any value for the key, then we need to return an empty string. So let's try to understand this with an example. Basically we need to create a data structure, and that data structure needs to store 3 items. First item is the key, that is going to be the unique pointer. Second value is the associated value with that key plus the timestamp. Now the other thing is that typically we usually see that keys tend to remain common in data structures like hash map and other like hashing based algorithms. But in this case we can have multiple keys with the same value, but the only difference would be timestamp. So in this case the value would not be truly unique, because the entire value portion is actually combination of value plus timestamp. So let's try to understand. Currently we have an empty data structure. Now let's try to enter the values, parth as the key and the vyas, that is my last name, as the value, and we are also providing the timestamp at 1. So at timestamp 1 we enter these values, which means in our data structure we should have the key as p, and we should have associated value as vyas, and the value this was located at value number 1. Now let's say for some reason during the timestamp number 2, once again I provide the value parth. I also provide the value as, let's just say j, and that's it, the timestamp is 2. Now once again I'm going to store the value p, and this time the associated value is going to be j, but this is located at timestamp number 2. Now once again I have another value parth. Once again the value is k, and once again the timestamp is 3. So once again I'm going to have another entry in my data structure for parth. The value associated is k and the timestamp is 3. Now say that I do a get operation. For the get operation I provide the value as key parth, and I also provide the timestamp to be 2. So in this case the answer I should be receiving back would be value number j, because j was the value stored for this parth key at timestamp number 2. So this should return a j as the answer. Let's say once again I do another get operation. This time I provide the value parth as the key, and as the timestamp I provide value number 7. Now you must be wondering that, hey, we don't have any value stored at value number 7 as part of the timestamp, because we currently only have 3 timestamps, that is 1, 2 and 3, and for each one we have a subsequent values stored inside our data structure. So in this case the idea would be to find the closest value for this particular one. So the floor value associated with this timestamp, which is going to be value number 3, because 3 is the first value we can reach from timestamp number 7, and for this the value associated was k. So we are going to once again return k as the answer for this one. Now let's say that for some reason I do a get operation for, let's say, John, and I provide the timestamp to be 5. So once again I don't have any entry for John, so this should return us an empty string. And once again I can do a set operation. I can add value number John, I can add the associated value as Sina, and I can associate the timestamp to be 6. So now in this case the value once again we are going to have a new entry called John and associated value Sina. So this is the whole idea of the type of data structure that we are trying to design. Now let's try to see some of the possibilities with this type of data structure that we are trying to convey. Now think for a scenario that if we only had to design a data structure where we are simply dealing with a key and its associated value. There is no such concept of timestamp. Let's just say that if this is the case, how would the things might behave? The idea would be quite simple. We can simply implement a hash map. Inside the hash map, we typically store values based on the key and its associated values. And we can store all of these values one by one based on the distinct key values. And we can simply complete all the operations in big O of one time, like insertion, deletion, searching and whatnot. So this is a very easy way for us to store the values. Now in the same example, what I'm suggesting is that instead over here as part of the key, once again we use hash map, but now for this hash map, in part of the value, rather than storing just the value as it is, we actually store an instance to another hashing solution, and this hashing solution should have another block like this that contains two values. First one is the value and second one is the timestamp, and based on this it should be able to store all the values that we need, and we should be able to find particular timestamp on that particular value, and we can return all of those values. And this is actually the whole solution that we need to build up. The idea would be that we are actually going to use the combination of hash map to store the standard key and its association to store another hashing solution. And we all can understand that why are we using hash map to do that, because hash map does all the operations in big O of one time, plus it's a hashing solution. If we identify at any point that there is an existing key, we can do that operation in big O of one time. And also for the associate value, we can actually directly have multiple values, but in this case we don't need multiple values, we need a separate hashing solution. For that I'm suggesting to use a tree map. Why are we using a tree map? Well, first, before going down deeper into understanding that why are we using tree map, first let's understand that what a tree map is. So tree map is actually built on top of a hash map. That is number one thing. Tree map contains a very similar property where once again we can have a key value pair operations and we can store bunch of different values. But the other thing is that tree map is actually contains a property of a binary search or logarithmic time valuation storing property. So how does it do that? Well, actually tree map is built based on red black trees. Now let me know in the comments if you want to understand more that how does red black trees work, because in itself it's a very interesting topic to learn, and it has many practical use cases and applications. Basically what red black trees allows us to do is that instead of normally having a single hash map where we are only dealing with simple key value, in tree map we are dealing with three values. We are dealing with a key, we are also dealing with a value, plus we are dealing with an extra bit that stores the value of a color. And storing the value of this color actually allows us to identify at any given moment whenever there is a conflict, this color has to be the difference maker, which we can actually use to find that what was the value associated at that particular time. So I know it sounds confusing, but it's actually very simple to understand, because this property actually allows us to store all of these values in a binary search manner. And we all know that how does a binary search work, that typically we can go in any particular direction to find the value we want, and in this case the particular direction or the color would be dependent based on the timestamp that we fetch the value at, and that's it. This is the whole solution. So let's try to run the solution with some example, and then it would make more sense to you. We know that we need two items. We need our hash map and we need our tree map. Now the thing is, for hash map we are simply going to have key as part of the key that we are coming in as an input. As part of its value, we are actually going to store the subsequent tree map instance. So as the tree map instance would be unique for every single value, and inside the tree map instance, the unique part is that we need two items. One is key and second one is value. So as part of the key, we are going to store the timestamp, and as part of the value, we are going to store the associate value that we are given in the input. So let's say that first input we have is key is parth. So I'm just marking it as P. Associate value is Vyas. So once again, I'm just marking it as V, and the timestamp is value number 1. So in this case, currently we don't have any entry. So we are going to create a new value P. Associated with parth, we are going to have associated tree map that we have to consider. So this instance of the tree map would be marked over here. Okay. So let's just say that this is the instance of tree map. Okay. And inside the instance of the tree map, we are going to store 1 as the value that we have, or as the key, because this is the timestamp, and its associate value, we are going to store value number vyas. Now let's say that once again we received the value for the same key parth, and now this time the value is h and the timestamp is 3. So once again for this same parth we already have the entry, so we already have this one. Now all we need to update inside the existing timestamp. So for this one tree map, once again we are going to have another entry 3, and now this time the value is going to be h. So we store the value h over here. Once again we get another entry parth. Once again the value is, let's say, x, and the timestamp is 5. So once again we only have one entry inside our hash map. We have the timestamp to be 5 and we have the value x associated with that. Now let's say we receive another value John. Now the value is Sina and the timestamp is 7. So we don't have entry over here, so we are going to create a new entry John. Now we also have to create a new instance of the tree map, so we are also going to do that for the John. And over here we are going to have our timestamp and value. Timestamp in this case is going to be 7 and value associated is going to be Sina. And this is how the whole solution would work. Now let's say at any given moment I want to do a get operation. If I try to do get parth at timestamp number 7, so currently I will go over here because this is the key for parth. Now once again this would take me to this tree map. For this tree map I don't have value number 7. But I have something closest. Now the thing is, all of these keys inside the tree map are actually stored inside some sort of a binary search tree or a red black tree, which means finding that where does value number 7 exist should only take us logarithmic n time and not actually n time in a normal hash map it would take. So in this case, we can find out that 7 is not present, but 7 is not present. We can also find out that what is the largest value present, that is value number 5. So associated value is x. So for this operation, we can simply return x as the answer, that, hey, this is the value associated closest to this particular timestamp. And same way, if we get another entry, let's say get John. And for John we also get timestamp to be 9. So once again we can just go to John, we go to its a subsequent tree map. For this tree map the largest entry is 7, the associate value is Sina, so we can return Sina as the answer. And that's it. This is how we can use the combination of tree map and hash map to store all the values. Now let's try to calculate the time and space complexity. In this case the time complexity is going to be big O of log n for the set operation and also big O of log n for the get operation. And why log n? Because tree map operates in logarithmic n time complexity because it's a red black tree, and I'm also repeating because this is a very popular concept, so that's why. Space complexity. So space complexity is actually unique to calculate. It's going to be big O of k. So k presents number of unique keys multiplied by number of total values that we are being given. So k multiplied by n, because we only need one hash map to store all the unique keys, but per unique key we also have to create multiple tree maps. So that's why space complexity is a little bit higher, but time complexity is extremely fast. And this solution actually is being used in many applications such as cache or some sort of like high time functioning time based data structure that you are trying to design. So that's why this question remains a good amount of popular. Okay. So let's see the coding solution for this one. First of all, we are initializing our private hash map where we are going to store the value of the key and its associated tree map as its subsequent value. Now let's initialize our tree map with a new hash map. Now for the set method, we are given 3 values as an input. First one is the key, second one is the value associated, and third one is the timestamp. So for that, we are actually going to store the value inside our hash map, and we are going to check that if the key is not present, so then in that case, we need to create a new entry for key and its subsequent tree map. If that is not the case, then we are going to simply put down the value inside our time based on the timestamp and the value inside the tree map. Okay, after creating the new instance. So this is the set method. For the get method, we are simply checking that if inside the what is going to be the key portion for the tree map. For that we need to do map.getKey. So that is going to give us the value of the value that we are looking for inside the tree map.
and we are going to check that if the tree map is equal to null for that particular entry, then we can simply return null. If that is not the case, then we need to check that what is the floor timestamp associated with the current timestamp that we are given. And we can check that if we don't find any entry, we can simply return null. If we do find an entry that is closest to that particular timestamp or that timestamp exactly, then we can simply return that value. And this is how the solution works. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. Okay, our code runs pretty good in terms of time and space complexity. There can still improvements be made, but this is going to be good enough solution. So once again, the solution is present inside our GitHub repository. So if you want, you can go ahead and check it out from there. Thank you.